Welcome back, everyone. It's Mike Gibbs, and we are here for day 5 of the Go Cloud Careers AWS Solution Architect Associate 2024. This is to prepare you for the AWS Certified Solution Architect Associate exam, and it is the SAA-C03 certification number. So hopefully you're here. Hopefully you've seen some of the previous few days, and if you haven't, don't worry about it. You can go back and watch the videos. I encourage you to share this video with friends and invite others so we can truly help more people around this world with this free AWS full course. So we're going to have some fun today. So let me know where you're at. I see some people in Cameroon, which I'm totally excited to see. Of course, we actually have our teammate, Eddie, who works for us, who's a great cloud architect living in Cameroon. I see somebody in Zimbabwe. I love that. I see some people in Colorado Springs and some Phoenix, New Jersey. My wife's actually, she was in New Jersey this morning. Now she's in Philadelphia, and she's hopefully coming home to Florida if that allows. George over there in Miami, fantastic, so close to me. Hey, everyone, you're just joining. That's okay. Welcome, welcome, welcome. And you can go back and watch the other ones. It's great. Mark, it's always so good to see you over there in San Francisco. Ben over there in New Jersey. It's wonderful. And Adrian's there in Phoenix. Fantastic. Welcome, George. I see Adeyemi's in Nigeria. I love that. Preb, I know he's over in there in the U.S., but I know where Preb's from. And hi, everyone. It's good to see you as well. So welcome. That's right. You're in Sacramento. And Eddie over there is in Bamenda, Cameroon. Hasnat is in Cypress, Texas. Cypress, Texas is good. Cypress is real good, too, as well. And saw that one coming from Nigeria. I love this. And another person in New Jersey. And so we will have some fun today. So we're all here. Let me tell you, in case you just joined, if it's your first day. So in order for us to really give you a good AWS Solutions Architect Associate course, where you're going to learn something, we have to focus on the concept. So I've interviewed about 6,000 technology professionals to find them, and I can always find somebody that can click a few buttons or write a Python script. That kind of thing is easy to find. What is near impossible to find is someone that understands the technology, knows what the technology is, know how the technology works, know how to apply that technology to solve problems. Those people are worth their weight in gold, diamonds, and platinum. They're impossible to hire, and when you've got those skills, you've got good earnings. So I want to spend a lot of time on that. But accordingly, I still want you to get hands-on. So sign up for the completely free hands-on labs for you to do them at your own time. If you just got here and you're enjoying the content, please hit the like button. And if you're not a subscriber, please subscribe and hit the bell to be notified of new videos for you. So, we've talked a lot so far. We've talked about the way the cloud was organized. We spent a couple days on cloud networking. We talked about databases, and we got pretty deep in databases. I had fun with it. We talked about Kubernetes. We talked about container, other forms of container orchestration. We talked about virtual machines. We brought you into our data center and brought you into a VMware environment so you can see what enterprises are using, so you could truly understand what is a virtual machine. And we talked about some other things. But now we're going to talk about serverless computer functions. So we're going to start with that today. So make sure you've got it. And also, we've got a guide on how to look at certifications. It's completely free, and it's in the description of this video. And we've got a lot of other free stuff in this video. So description of this video. Webinars on how to become a cloud architect, which is different than getting certified. Webinars on how to earn more in your career. Free ebooks on for example, how to win the interview. So all this stuff is free. Go get it in the description of this video. So now we will begin with serverless functions and Lambda. Before we begin, Lambda and serverless is a tool. The difference between a great technology professional is being fair, being unbiased, and evaluating all the situations before you make a decision. Serverless is just that. You will see people that are all in for serverless. They are dangerous. You will see people that are all in for never serverless. They're also dangerous. What we actually need are people that are going to look at the problem and then select the right tool to solve the problem. A carpenter doesn't use a hammer for everything. They use a nail gun, they use a hammer, they use a saw, they use a screwdriver. There's all kinds of tools that they use. Same thing. So serverless is a tool. Now, each cloud provider has their serverless, and we're going to talk about AWS Lambda, but I want you to understand the way these things work is you basically give it your code, and every time it runs, they charge you. So when it comes to thinking about using serverless, if you're not going to use it a lot, serverless is going to be very cheap. For example, you may have an event-driven architecture where if this happens, then something happens. So maybe a user puts something in S3 or the object storage, they make it public when it should be set to private, and a serverless function either sends a message to you or it fixes the permissions. For something like this, it's excellent because you're not paying for a virtual machine to be running, and you just pay every time you need to fix a problem, which is great. But what if that problem happens all day, every day? It may be far, far cheaper to put the application on a virtual machine. So when we talk about serverless and you think about cost, I'd like you to think about taking a taxi versus buying your own car. If you live where I live in Florida and everything is 10 miles away, and I had to go to 4 places per day, and that would be 4 10-mile round trips each day, it probably wouldn't make sense to pay $200 a day for taxis. Probably not. But where I live, it would probably make sense to buy a car, even if it's $1,000 a month, and pay the $1,000 a month for the car by the time you're all in with your car costs, your fuel, your repairs. It might be cheaper to pay $1,000 a month for the car than it might be to pay $200 all day, every single day of the month, which would be $6,000 versus $1,000. Likewise, if I'm in New York City and I can walk everywhere, but I only need to take a taxi twice a month, it's probably cheaper to take the taxi than it actually is to go out there and buy a car and figure out how to park the car. So same thing with serverless. And that's why you'll find companies like Amazon that went all serverless for Amazon Prime, realized it was way too expensive, and they came off of serverless and went back to the old-fashioned monolith. You'll find other companies that are on a monolith that probably could go to serverless, but it's based upon the way they use the data. So make sure you don't ever recommend any technology without understanding the point and the purpose. So now we're going to talk about AWS Lambda. And AWS Lambda is a serverless computing service that lets you run code without thinking about the servers or managing the servers. I'm going to make it very clear right now that it still runs on a server. So it's not exactly serverless. You don't think of the serverless. So kind of keep that in the back of your mind. So AWS Lambda will help typically with event-driven architectures. If this happens, do this. It's a good way for businesses to leverage some form of automation across their infrastructure. And that is something pretty great. So I always looked at it this way, is basically you take the code that the developer wrote, they push it and upload it to the Lambda function, and it runs when it's needed, and each time you use it, you pay. So the less you use it, the less you pay. If you use it too much, it's going to get real expensive real fast. So some things to know about Lambda is stateless. So what does this mean? It means that as soon as the function is performed, and as soon as that code's run, that's it. So if you need to have a step 1, and a step 2, and a step 3, and a step 4, you're going to need 4 different Lambda functions, and they'll all need to be scheduled in a way that's going to work. So Lambda is going to be very useful along with an Azure function, along with a function as a service on some of the various private clouds, because it can be fairly efficient. Because we can use it to decrease things that require manual intervention, thus enhancing productivity of our staff. We can use Lambda sometimes to help us process data across multiple systems, remediate security events, patch an operating system. So lots of things that we do as people, we can run with a Lambda function. So very common use case is somebody puts something into S3 and it does something. So let's say I had a video editing business here, and I'll draw it out for you, but let's say I was in the video editing business, and maybe I made commercial movies or edited videos for another company. I could have the user upload their video, right? And they're going to upload it into, say, object storage, otherwise known as AWS S3. I can immediately have a Lambda function kick it off to be transcribed from Amazon Transcribe, which we'll talk about when we get into the AI section of this course. I could have that same video sent to a video server. The video server could take my uncompressed video, which could be 5 terabytes of it, and it could potentially turn it into a web-optimized MP4 video using, say, an H.264 and H.265 codec. And I can even have another Lambda function kick off a notification that says, Mike, your video is ready. So that's where we use these kind of Lambda functions to kind of automate things. So Lambda is basically in your entire system. Now, there is also the option to run Lambda at the edge of your network. So as soon as somebody hits your content delivery network, assuming you're using CloudFront, you can run one of these little mini Lambda functions. So by doing so, it's going to be out closer to the user, which will mean lower latency and higher performance, should this need to occur. So when we think of Lambda, some things to think about is that it's serverless. It's running on servers, but Amazon manages the servers for you. So patching the servers, scaling the servers, etc. So you don't have to think about the need to provision or manage your infrastructure, but they do it for you. Anytime somebody does something for you, they lose control. You lose control. So lots of times event-driven, lots of things you can do here. You can have a lot of event sources, something in object storage, maybe something in DynamoDB if you were using it, something in Kinesis, SNS, SQS, API gateways. So lots of ways you can integrate this into other things. And, it runs many programming languages. So if your developers code something in Node.js or Python or Java or Ruby or C# or Go or any of these custom runtimes, you can upload that. The Lambda functions will understand it. So you can bring your preferred language, or I should say your developers could write their preferred language. So because generally speaking, these Lambda functions can just grow and scale, if you need to use it a lot, it will tend to scale, which is great. So it can handle thousands of concurrent running or executions, if you will. But you got to remember, each time that thing runs, you're getting charged for it. So is it the right way? That only you're the people that are designing the system, that understand the system needs, can determine if this kind of Lambda thing is a good thing, a bad thing, or somewhere in between. So one of the features of Lambda is resource management. It gives you the ability to allocate a certain amount of memory and control the execution time per function, how fast it needs to occur. And the charge every time is based on how long it runs and how many times it runs. So think about that. From a security perspective, and IAM is only a small component of security. There's many more things that go into security, but Lambda is well integrated into the AWS Identity and Access Management system. So it enables you to take care of that through the systems you have, which most likely will be Microsoft Active Directory federated into AWS Identity and Access Management. So there's some new features. For an example, now .NET 8.0 runtime actually runs with Lambda functions. Ruby 3.3 is now actually available. And there's also some new integration tools that are there. Some enhancements that can get into the AWS serverless application model. There's an AWS toolkit for Visual Studio. So they're trying to make it easier to develop, deploy, and manage these Lambda functions, especially with .NET. So I had mentioned real-time file processing would be a use case we would use. We could use a Lambda function to kick off an ETL system where basically we extract, transform, and load something from one system into another. Typically, you might do something like that with like a Kinesis string on the way to, say, a DynamoDB or something like that, or an Apache Kafka on the way into, say, an Apache Cassandra, which would be more optimized for multiple cloud providers. We can use Lambda functions as the back-end logic for a web application through an API gateway, and it can handle authentication, authorization, and other back-end services. We can use Lambda functions with our Internet of Things devices, like an IP-enabled refrigerator, your IP-enabled TV, a weather sensor, those kind of things, or IoT devices. So again, we can process data from those devices with Lambda, filter it, trigger alerts, that kind of thing. But really, it's for automation. So how do we set these things up? Well, we go to create the Lambda function. So we're going to go to the management console, navigate to Lambda, and click Create Function. Then we'll choose an authoring method. Either basically write one from scratch, basically, your developers write it, or in many cases, there's actually a blueprint or a serverless application repository that you can pull from. You'll configure your function settings like the name, the runtime, and the role. Then the developers will write and upload the code. Write the code and you'll upload it. And it can be written in, let's say, an inline editor or uploaded as a zip file that will contain all the code and the dependencies. You can store that code in an S3 bucket and store it and upload it from there. Then you have to configure the triggers. The Lambda function will run inside when what occurs. So what causes it to kick it off? So you have to configure the triggers. Maybe it's something in object storage like S3. Maybe it's something in DynamoDB. Maybe something hit an API gateway and you want it to respond instead of that. Then you'll set your necessary permissions to make sure it actually runs. And then like anything else, you test it. You just don't deploy it. You test it and make sure that it works and functions as designed, and ideally stress test it before you put it out there. And then you just monitor the system. And you look for things like how often it's running and is it the right thing to still do? How long does it run? Is it running right? What are the error rates? And are things getting throttled because we're coming in too hot and we can't handle them? So we should be able to look at this, look at the logs, and make better decisions based upon it. Now, when it comes to these serverless applications, they don't perform, generally speaking, as well as a monolith when they're not running. Because a monolith is always running. You got something on a server, it's always running. These serverless components, basically, unless they're running, they have to start. So there's a cold start time. So there's a latency in these things. They don't feel or perform as well as an older school application would be because they're not running all the time. Now, it's a strength that it's not running all the time if you don't use it a lot because it's cheaper. But if it runs all the time, it's more expensive. So you got to think about this. But can you tolerate the latency in this application? Now, how you minimize the performance hit you get with these Lambda functions to make them feel closer to normal? Well, you can keep your function packages small and the dependencies minimal, and that'll reduce the cold start latency. You can use, say, provision concurrency for functions where you need predictable traffic, and that way you're going to have the resource you need when you need it, so it'll perform better. Some other best practices with regards to Lambda are making sure you've got some kind of error handling and retry logic built right in. You can try catch blocks and implement retries, the kind they use this exponential backoff or transient errors, so they don't all try at the same time. You may want to configure a dead letter queue to analyze any things that were failed and even capture that information, just like you might do in a database. You're going to want to monitor these things and monitor them very closely because they can get real expensive real fast or be perfect. So you have to monitor the invocation metrics, optimize the function time so it runs in less time to make it less costly. They say you can use AWS Explorer to analyze your costs and usage patterns, and you can to a degree, but you're also going to have to do the planning and really to know what you need and analyze it and really think about it architecturally. So that's the end of our Lambda functions. Let's briefly talk about some data warehouse stuff. And then after the data warehouse stuff, what we'll do is we'll take a break and answer some questions. A data warehouse is going to be used in the big data environment. And it's really a database of some kind. But it's going to be a centralized repository that's designed to store, manage, and analyze huge, ginormous amounts of data. Structured data, semi-structured data, and coming in from all kinds of sources. They enable businesses to really perform these complex queries, generate reports, and derive insights from their data. So if you've got good data, you can understand the business better. You can make better business predictions like how much stuff we need, potential do we need inventory, what's our time to manufacture, what are our customers looking for, what are their buying patterns, what's the sentiment with the customer products, how do we price their system, all that a business decision has to do. They need to make informed business decisions. Better the information, the better those decisions are. Better the information, the less mistakes. The more the mistakes they have, and as part of the process sometimes, the more cost they're going to have and potentially can lose money or even go out of business. So good information is absolutely critical. Typically speaking, and I've drawn a proprietary environment here. I wouldn't necessarily recommend this in life, but keeping it in theme with just an AWS Solutions Architect Associate, you see what I can do here. I can take information on my object storage buckets. I could take it from databases. I could take it from anything, and there's typically some form of a mapping and reduction process which basically normalizes the data. Typically, it's via PySpark. Amazon has their own managed service to do it. They call it Elastic MapReduce. And what they do is you take that information and it gets popped into the database, and Amazon Redshift is their version of a data warehouse. There's other options like Postgres that you could use or other commercial data warehouses. And then Amazon QuickSight is a visualization tool. People tend to use Power BI and tools like this because they can use it across all their clouds. But the point is, you're going to look at that big data warehouse and you're going to be able to visualize your data, look at it, analyze it, use it in the future with machine learning or other things as well. So that's what you're actually talking about. So let's talk about some key concepts in data warehousing. You know, one of the things that often has to happen is businesses have a lot of different kinds of databases. They'll have the relational databases, their NoSQL databases. They may have some graph databases, which are forms of NoSQL data. They're going to have a lot of different databases. Data warehousing databases. You walk into some enterprises, they could have 50, 100 different databases or more. So lots of databases. Now, when we get the information out of the databases, we need to make sure that it fits and it's cleaned up and then it can go work in another database. And, there's two kinds of things we'll do. We're doing some mapping and reduction, which is like taking Mike Gibbs. Mike Gibbs could be spelled with all capital letters. Then I could have Mike Gibbs spelled with all lowercase letters. Then we could have a Mike Gibbs with a capital M and then lowercase IKE, and then a capital G and a lowercase IBBS. And, mapping and reduction, we've got to normalize that so it's all the same Mike Gibbs, because we don't want three different records for the same person. This extraction, translation, and loading is how do I go out of MySQL into Postgres, or how do I get out of MySQL into Oracle or something like that, or in and out of databases and in and out of anything. So we're going to be dealing with a lot of extraction, translation, and loading tools. And maybe we pull data out of a database, a flat file, an API, and these tools are going to help us do this, and then potentially clean the data, transform the data, and then load it into another system. So under the transformation these systems do, we're talking about cleaning the data, aggregating the data, and formatting the data. Now, the loading is taking the transformed data and sticking it into the data warehouse. Some key things to think about when it comes to data warehouses are this online analytical processing. And that's going to be a category of data processing that's going to enable these complex queries so you can perform some fairly significant analysis, basically going through a lot of data from a whole lot of different sources. They're also here with regards to online transaction processing, and that's going to focus on managing transaction-oriented applications and real-time data processing. So there's lots of applications that are transaction, like when you purchase something, when you buy or sell a stock, that kind of thing. Now let's talk about schema design. The logical structure of a data warehouse is going to be often organized in, say, a star manner or a snowflake schema. And star schemas are basically a central fact table that's going to be connected to a bunch of dimension tables. And the snowflake schema is going to be an extension of the star schema, where the dimension tables are going to be normalized into multiple related tables. So we're not all data warehouse experts, and a lot of this is way above what's needed to be known, but just thought we'd give it to you for some extra background. When it comes to the data warehouse, we've got to get our data from somewhere, right? So we're going to have various sources of the data, like databases, flat files. It's going to be coming from everywhere. And, sometimes we need a staging area. So we may have to clean up the data and pop it somewhere before we load it into the data warehouse. But at the end of the day, the core of the data warehouse is going to be the storage, which means if you're on the cloud, for the most part, it's going to be block storage. In a data center, it could be file storage or block storage. Now, one of the things when we're dealing with data and big data, and we'll be using a tremendous amount of object storage in these big data environments, especially with regards to data lakes, is the more information we have about the data, the easier it is to work with the data. So ideally, there's some metadata here. which may identify your schema definitions, where the data comes from, like the data lineage, if you will, and your business rules. Of course, we're going to need query tools, which are going to be the interfaces used to query the information, to get the data. And we typically need tools to be able to visualize the data, like Power BI. Now, businesses have a lot of data, and they're usually located in a million and one places, but with a data warehouse, it gives us the ability to centralize it in one place, into a single repository. And it gives us, it helps us enhance our data quality. Because we have to standardize and clean the data, it's going to ensure some consistency and accuracy of our data. And data warehouses are designed to deal with read-heavy operations. Because what are you going to be doing? You're going to be pulling. The whole point of getting the stuff in there is gradually put it in there and then pull it out when you need it. It's going to give you great historical data analysis. Think trend analysis and forecasting from a business perspective. And these things typically scale to handle very large volumes of data. And that's why it's a data warehouse. Now, data or anything else, we really should have a good governance policy. So an organization will need to establish policies and procedures for data management because they want to ensure the quality of the data and the security of the data. And of course, under best practices, we have to think about scalability planning. You know, you can't just design it for today. We have to design it for the future and as things change over time. Now, these things are going to get big. So we're going to have to optimize the performance somehow. So whether we use indexing, partitioning, or any other techniques, which we talked about to enhance query performance, that's an option. Robust security measures. You probably should have good security on your database. Make sure that you know who can access the system. You should have some good network filtering so only the right people can access the system. Probably should encrypt your data. You should be auditing these systems from time to time to make sure that they do what they're supposed to. We're going to maintain these systems, some routine maintenance tasks. Things like data archiving, data cleanup, and data optimization we're typically going to be involved with. So where are we going to use this? Well, we're going to use these data warehouses for business intelligence, meaning making data-driven decisions through a report or a dashboard and being able to look at what we've seen in the past. Customer analytics. So you may want to find out what your customer's buying behavior is, what their preferences are. If you know what your customers like, you know which products not to stock and which products do stock for them, or how to make recommendations for them to purchase additional products. Kind of like if you go to the restaurant and you'd say, I'd like a cheeseburger, they would like to say, would you like fries with that? No, I don't want fries. I'd like broccoli instead. Although my wife likes fries and lots of people like fries, but they try to upsell you into something else. That's really what we're talking about here. Financial reporting. There's so much data out there, and many businesses need to file financial reports. I mean, everybody has to file some form of financial report, every company or person at the end of the year with the tax authority in most cases. But big businesses, they've got to file all kinds of SEC things, and it needs data, and more data. So this can help with that. How about business operations? Sometimes you don't know whether their business is working well or not until you start looking at it. And because we can perform deep analysis, we can get some information about the health of the business and make changes as necessary. Supply chain management. We can analyze the supply chain, figuring out who's getting us what we need, when we need it. Is it coming in too expensive? Is inventory spoiling? And we can optimize that because the supply chain is really critical for business. So that's a data warehouse. And what I'm going to do is I'm going to stop there and take questions. And then afterwards, we'll talk about various data warehouse options. But I wanted to at least make sure everybody knew what a data warehouse was before we talk about, hey, let's talk about AWS Redshift. Because if you don't know what it is or how these things work, it doesn't even matter if you know the name of the brand these people are at. So bring us your questions. If you have any questions related to the content, please let us know. And we'll take them for a few minutes. And while we're waiting for us to see, if you're having a good time, please hit the like button, subscribe to the channel, and hit the bell to be notified of new videos to help you in your career. And if you've not downloaded the labs or at least signed up for labs, please do so. Hi, Mike. AWS has a run command. Can the AWS turn on equipment? So Yes, AWS does have a run command, and that can turn on an instance. But remember, these servers are running 24 hours a day, 7 days a week. It's just they're all running, and the software enables you to turn or turn off that virtual machine or that virtual thing. So, not going to turn on your physical equipment as a rule, but it can definitely do your virtual equipment. What kind of precaution would you have taken to avoid the issue of the outage today? So, well, first, we need to completely understand the issue, and we don't completely understand. But I'll give you some examples in high availability situations. Generally speaking, no single points of failure, but here's what goes into high availability. First, no single points of failure, which means redundancy everywhere. Very good change control processes. Very good change control processes. And testing, and more testing. So, generally speaking, and here's one of the differences between people that know how to design a five nines network, and people that say they don't, is it takes 6 to 12 months to design an architecture. And part of that is designing what the needs are and the current technology and future technology, etc. But it also means looking at the business. So when I was designing systems for banks, specifically the trading floor, we made sure that the trader to the left of me and the trader to the right of me were plugged into different switches. And they were on different subnets. And why did we do that? Because if one of the switches failed, the trader on the left would go down, but the trader on the right could process that user's trades and vice versa. So, in generally speaking, having a single pane of cloud in most cases is reckless for high availability systems like a bank or an airline. But more than one cloud wouldn't have solved today's problem because today wasn't a cloud failure problem. So we have to test the information that we put on our systems, and we also have to we have to determine what applications we're going to allow to access our kernel level or get high up in our applications. Today's issue is a lot of people went to a security provider that was able to push new things which could brick or damage people's computers. Now, the question is, architecturally, should that have been allowed? Well, there are some advantage of having security providers do what they did in this particular case where they can push stuff to your systems, zero-day attack prevention. But the architectural trade-off is by doing that right then and there, they're pushing stuff on your system, which isn't tested on your system yet, which is considered reckless in most high availability environments. So there's a couple of things. One is they could have chosen a security option where it didn't automatically push the stuff out there. That would be one way. Another way would have been put 50% of your users on CrowdStrike and the other 50% of your users on something else. And that way, if CrowdStrike had an issue, the other company would do it. But if they thought about it and didn't let the systems just push that to their systems ahead of time, they would have had a harder zero-day approach should an attack occur that they didn't know. But let's be fair. We can look at an environment where they could have had 2 and 3 different next-generation firewalls. Typically speaking, there's a lot that could be done with regards to network security that people don't do. So there's a lot of pieces and places and tools where we can actually design our security. Now, I don't have a full understanding of exactly what happened today because I'm not there. And a lot of times where we're getting explanations, they don't sound completely real or completely comfortable. And I hope my power doesn't go out. It sounds like there's a hurricane outside. But there is that. But that would have been something that could have worked. And that's something we did when we traded with traders and the training floors. We could have done this. They could have potentially had Windows user, Mac user next to each other, or Windows user, Linux user.
Right, everybody. So looks like we lost Mike there as soon as that thunder hit. Uh, Sorry, you do not get me with a camera today. I am working from home, not in the office, without my camera set up. So Mike is going to be reconnecting to his battery backup here and connecting to his backup internet as well. So uh, hopefully you guys do not mind having a blank screen talking to you for a few moments. But please feel free to put in any questions that you might have, and and we will get to them when Mike returns. So let's see if I can take this question down. All right. All right. Mike is absolutely safe. Just waiting for him to reconnect here. All right. All right. All right. All right. Well, in the meantime, let's see here. Okay. So in the meantime here, let me know what day has been your favorite, or what subject has been your favorite so far. Let me know in the chat box. I always like to know what everybody's liking about these boot camps. I'm glad to hear that you're loving the teaching style. That's one of the things that we really try to differentiate ourselves with, is the way that we teach this. We don't just teach the technology of what it is and how to use it, but we actually try to teach about the actual understanding of the technology. So, Amos, let me find the link for the book here for you. So let's see here. Got there's the link to the exam guide. I'm also going to put the link to the lab demos here as well. Mark's favorite is the Q&A portion. Let's see here. We got Adrian's is the virtual machines, containers, and Kubernetes portion. Good section there. Ben likes that it goes into a lot of depth on each topic. Absolutely. That's exactly what we try to do here. Ben still needs to brush up on Kubernetes. Well, definitely rewatch the content there, and then you know where to get the best information about Kubernetes? Kubernetes. So let me bring Mike back in here. There is Mike. All right.
I am so sorry about that. I am happy to be back. I've you get a power outage, and unfortunately, the UPSs in my house aren't necessarily as strong as I need to for some of the things. I'm actually on my third internet connection right now. Hopefully, my video looks okay because it's my backup to my backup to my backup. If we need to, we'll go back to my primary connection. So let's have some fun. So anyway, we were talking about eliminating single points of failure, not putting all your eggs in a single basket. So instead of buying one stock, you buy two. And when it comes to multi-cloud, it's not more expensive. When it comes to multi-vendors, it's not more expensive, because imagine you had to buy 1,000 eggs. If you bought 500 eggs from one supermarket and 500 eggs from the other supermarket, it's not, generally speaking, almost the same price as if you bought 1,000 from the same supermarket. So I know we got cut off on when we're discussing high availability, but architecture designed for the client and the client's needs and goals. Understand the business, understand the challenges, understand the pain points, and really game these situations ahead of time. What happens if this fails? What happens if this fails? What happens if this fails? What happens if that fails? And then test it. And then you'll find out where your weaknesses are. But I am back now, and hopefully the weather will hold, because I love doing these kind of things, and thank you so much for waiting for us. So, Chris, was there any other questions? Otherwise, I will get back to the. Okay. Can I explain the use of data warehouse tiers from an architect point of view? So, you know, I don't have a lot of expertise in that, and I don't want to really misguide you. It's a great question you had, George. And one of the things is, typically when I build my team, I bring both a big data architect, I bring a database person, and I also typically have some data scientists in my architecture. But I actually haven't really covered that much of some of the data warehouses that we're going to be using yet. We've got other content we're going to talk about. Who configures Lambda to do the automation? It's the cloud engineer, James. So cloud architect designs the solution. Cloud engineers build the solution. Potentially DevOps engineers will build the solution. Once it's built, it will go to a team of maintenance people that are called sysops. And when it breaks, it's going to go to the tech support team in the business. So these jobs are highly specialized. And why do I say this? Because a lot of time people want to become cloud architects and then they learn how to build it. And that's great, go learn how to build it. But learning how to build a building won't teach you how to design that building. And that's why they don't hire the construction people, generally speaking, to be architects. So this is usually done by the cloud engineer. But to be fair, the cloud engineer is most likely going to be, James, taking the code that is written by a software developer. And it's not going to be uncommon to have a developer or a DevOps engineer actually upload their own code too, because this is really, really simple. So there's that. And the reality is, no matter where it's at, it's going to take a collaboration. Cloud engineer is the fixer, the builder. Go in there and go do it, right? But they're not a software developer. A cloud engineer may write a little code like an automation script, like a Python script or a Bash shell script or a Windows PowerShell script. But they're not software engineers. You're going to go to that software engineer to write these things if it's an application. And who's going to design that application? That's going to be an application architect who will then go to a cloud architect that kind of oversees everything, because the cloud is the network, the data center, all the compute, all the storage, all the data, it's everything. So I kind of hope that makes sense. If I answered your question, great. If not, please feel free to ask it again and I'll take care of it next time, because that's an important question. All right, so now let's go back into more of this data warehouse content. So the next one we're going to talk about is Amazon Redshift. And if you're just on AWS and you're not using any other clouds, or you want your data warehouse to be on AWS, this is where you're going to put it. And Amazon Redshift is going to be a fully managed petabyte scale data warehouse. And it's based on Postgres SQL. You could just use Postgres SQL on as many clouds as you needed, but it's based on Postgres SQL. So it enables you, the user, to perform SQL queries, that sort of thing. And it works with applications that tend to perform SQL queries. So let's talk about it from a scalability perspective. It's going to scale really well. Redshift is based on Postgres. Amazon manages it for you, which is a convenience, but there's the challenges with being managed by someone else. Just like the CrowdStrike thing today, if it's managed by them and you don't have insight into what they're doing and they push something to you, you're at the mercy of the provider themselves. So think about that when it comes to managed services versus managing your own. And think about who's a higher target, statistically speaking, for a hacker. A big provider or you. Hack the big provider, get access to the customers. Hack you, only access to your data. So all these things to think about. So when it comes to scalability, these things really give you what you need. So think about that. You can start small, and it can progressively grow as the business's data grows. Tends to perform wise because it's designed to be a data warehouse. It's optimized for high performance storage. Redshift uses columnar storage. It uses data compression and parallel processing, so you get good responses to your queries. Because it's a fully managed system, Amazon Redshift is going to be easy to use because they handle the setup, the operation, and the scaling of the data warehouse. Now, you lose control But you can also focus on your more of the business. So there's ups and downs of everything. Architecture is just a process of trade. So let's talk about the architecture of Amazon Redshift. Well, it's based upon clusters for the most part. And the warehouse itself is going to be considered a cluster. And the cluster is going to be based on one or more nodes. And you're going to have a leader node and you're going to have a compute node. So the leader node is going to manage the connections and receive the queries. And it'll pass the queries on and develops the execution plans. Now, where's the work done? Well, the work is done on the compute nodes, and it's sent back to the leader node. Are we seeing this pattern? We have in anything else, we've got a routing protocol that determines how the path goes, called the control plane, and then we've got a forwarding plane that does the work. In container orchestration, we've got an orchestration platform. And then you've got a work platform, control plane, data plane. In this environment, you got a leader node that's kind of the control. The compute node is the plane. You go to the cloud provider, the management console you go to, all that stuff that you're feeding into that's orchestrating stuff that's going on, is the control plane. The worker plane or the data plane are all the servers and storage that Amazon has. So I hope you're starting to see these patterns. Almost everything is almost the same. It's just how you look at it and understand it. So when it comes down, and that's why if your fundamentals are good, you'll understand new things very easily. So when it comes down to Redshift, there's different kinds of nodes. There's what's called dense storage nodes, and they're designed to handle a lot of storage. And there's called dense compute nodes, and they're designed to have lots of CPU and memory resources to do the compute. And there's also something called an RA3 node, and that's going to provide the capability to decouple your compute and storage costs to enable more optimization. So instead of just trying to scale everything at the same time, you can figure out what you need and do it as needed. So let's talk about loading data in to Amazon Redshift, because it's a data warehouse. It does us no good if the data is not there. So the data can be loaded into Redshift from various sources, such as Amazon S3, DynamoDB, RDS, or any other commercial databases you could load stuff into it. You can use the AWS Data Pipeline, the AWS Glue, or a commercial extraction translation loading tool, or a self-organization makes their own script. Whatever, it's going to work. It's going to support the copy command to efficiently load data from, say, any of the AWS sources like S3, DynamoDB. And it can handle lots of files in parallel, so it's going to load relatively quickly. Now, remember, Redshift uses is based upon Postgres. And Postgres SQL is a relational database. So you can run SQL queries on Amazon Redshift just like you could Postgres. And it also enables you to do some advanced query optimization. So there's techniques that you can use. Predicate pushdown, late materialization, data skipping. And these are tools that you can use to optimize your query for those people that would need to do that in their jobs. Materialized views will basically store pre-computed resources of queries, and that's going to really speed up frequently accessed queries. So let's talk about some best practices. Data distribution. You should use appropriate data distribution keys to ensure that data is evenly distributed across nodes, and that's going to optimize your query performance. The use of sort keys to improve query performance, and this is going to be very beneficial if you're using a very large data set. Compression is something that can also help here. You may want to enable compression to reduce your storage costs and potentially improve your input-output operations performance. Concurrency scaling. We can set it up to automatically add capacity to handle spikes in your queries, and that way you're going to have somewhat consistent performance. And it's database, so maintain it. Regularly analyze and vacuum tables to reclaim storage space and optimize performance. Redshift, where you're going to use it the same place you would use it like in any other data warehouse. Business intelligence to make better business decisions with potentially a tool like Power BI or Amazon QuickSight. You could be looking at huge logs and trying to gain some insights for your logs, although it might make more sense to use a SIEM system in today's world. We can use this, Amazon Redshift, to integrate into, say, a data lake. And potentially if we can integrate it with S3, it makes it very easy to run queries or provide a data analysis on it. Customer analytics. We can ask, again, just like any data warehouse, customer buying patterns, preferences, and trends to come up with, say, maybe sales or marketing strategies. So how do you set this up? Or how does the engineer that builds this set this up, I should say? You can go to the Management Console CLR API and just create a Redshift cluster. You're going to load your data. So you're going to use the copy command to load data from S3, DynamoDB, or other sources. You're going to run your queries and ideally connect your business intelligence tools to it so you can see what's going on. Like any other system, you'll monitor it, you'll optimize it, and you'll look at what's going on. Because it's an AWS thing, you can look in CloudWatch, but also use other tools to monitor the performance of your databases. So that's about data warehouses. So next we're going to talk about data lakes. So data lakes are kind of cool. And in the machine learning environment, they're becoming very popular along with databases and other forms of big data, but they also are there to really enable the organization to do some pretty cool things. So the data lake is going to be a centralized repository that's going to allow you to store all of your structured and unstructured data together at any scale. So as much stuff as you can possibly imagine. Petabytes of data. Now you'll be able to store the data as is. And that's different than, say, in a database where you got to make it look a certain way before you put it there. And it's going to enable, as we get to talk more about this, visualization, large-scale analytics, artificial intelligence, machine learning, because we're going to have a good source of data if we build it right. So I like to think of it as a repository. That's where my data goes. Raw data. So let's talk about the differences of other options here. Unlike a database, a data lake can store anything. Structured, semi-structured, unstructured. With databases, we talked about, read replicas and caching and queuing and other things for relational databases. We talked about partitioning and other options for NoSQL databases. We also talked about partitioning for our relational databases too, but they're not going to go to petabytes, most databases. This stuff is petabytes of data and beyond, so big amount of data. Data lakes, unlike a database, are extremely flexible. You can invest lots of data natively, simply, and easily, and either use it now or use it in the future. They tend to be cost effective. I mean, if you consider cloud object storage to be cost effective, you could call it cost effective, but here's the key. You're putting in object storage, it's got metadata on it, and it's going to be cheaper than other forms of storage you might use, like block storage. And it's the concept of schema on read. So the data is going to be stored in raw form. And a schema can be applied when the data is read. So you can put it in easily and then pull information out a lot in a more sophisticated manner. So how do you build this thing? How do you design this thing? Well, the first part is we've got to get the data into the data lake. And this could be via a batch processing manner. It could be streaming data, like coming in from, say, an Apache Kafka. It could be real-time data ingestion. But we've got to get it. So the first part is getting the data or ingesting the data. No. After we ingest the data, we got to store it somewhere, right? So raw data is going to be stored in a scalable storage. And that's typically going to be object storage. Object storage scales, and object storage has metadata. So it's usually going to be object storage. The next thing is that data needs to be cataloged and it needs to be indexed. So the metadata is going to be created to catalog and index the data. And that's going to make the data more easy to discover and understand. And then somewhere along the line, we need to process the data. So data processing is typically done with something like a PySpark, an Apache Spark, Hadoop MapReduce, that kind of thing. And then there's the analysis and consumption. So we've got all this data. Now we can run machine learning on this data. We could use a business intelligence tool on this data. We can run an SQL query on the data. So let's talk about what goes into it. I'll summarize. Ingestion. We got to get it. So it could be batch processing, streaming, a REST API, real-time data ingestion like Kafka. And we store it. Then we catalog it and index it. Then we process it with a big data framework, like typically Apache Spark or Hadoop MapReduce. There's some mapping and reduction, which is typically done via something like a PySpark. We analyze the data and make some decisions on the data. So that's basically where they're at. So where would we use this? Let's talk about some use cases for data lakes. So big data analytics. Businesses have a tremendous amount of data and things that they can analyze that data and make better business decisions. Machine learning or any kind of artificial intelligence. The better and more accurate the data is that a machine learning model is trained with, the better the outcomes will. Garbage in your generative AI models data, garbage out. Quality data in, impressive things out. So, machine learning. Data archival. Maybe we just want to stick all the data we have in some place and figure out maybe we want to use it later. Let's think about getting data from all kinds of wacky things, like Internet of Things devices. And we might use it as a staging area to maybe either extract, transform, and load from one system to another, or we might extract, load it, and then transform it into another system with an ELT process. So, there's lots of tools we can use. But the key here is centralized data, better analytics, enhanced accessibility of data. Here is an example of a AWS 100% proprietary kind of data lake. There's much more that goes into it like this, but this is kind of, I think it'll help. You take the data out of your databases, like your NoSQL database, which is DynamoDB in this case, your relational database, which is our Amazon RDS, your data warehouse, your Redshift. We pull that data out, some kind of mapping and reduction function like a PySpark script. We pop that into object storage, and we'll have to do a few things in object storage, like we'll have to catalog the data and create a landing zone, typically speaking. But something like this is basically what goes into building a data lake. Coming from multiple sources, data is smoothed out, manipulated, and normalized along the way. Indexed, cataloged, that sort of thing. And then poof, you got a data lake. And then you can do lots of cool things with it, like run machine learning tools, etc. So let's talk about some challenges with the data lakes. Because when it comes to tech, nothing is free. Everything's got its trade-offs, complexities, and it's about, is it right for you or your organization? Data governance. We're going to have all this data. We're going to need somebody to ensure data quality, the data's security, and that the data is in compliance. You don't want to just take like a hospital's data, stick it in object storage, and have the person's personally identifiable information in there. That could land you in a lot of trouble. So it's a matter of what you're doing with the storage. You don't want to create what's called a data swamp. And if you're not careful, and you stick all this data in a place because the people that are designing it don't understand data and data architecture, and that's why data architects are a specialty that a cloud architect would use on their team. The cloud architect would design anything, and they would ask the data architect for the data piece because this is such a specialty. But if it's designed wrong, you get what's called the data swamp, where you can't find anything. Anybody have a junk drawer like that, where you just throw stuff in a drawer because you don't have any time? If you know what I mean, give me a hashtag drunk drawer, where you got one drawer where you throw your pens and a pencil and this little thing and that little doodad, and the next thing you realize you want to go for something and you know it's in there, but you can't find it. So think of data swamp as a junk drawer. At least that's how I always saw it in my head. So let's talk about complexity. Managing and maintaining a data lake, like anything else, can be complex. So it's going to require good, skilled people. I love it. Junk room, as Chris said. Yeah, I know what that's like too. And then performance. So ensuring the performance of your data processing and analysis workloads. So the next is going to be some of the technologies and things we need to think about for our data lake. And one of it is, where are we going to store it? Got lots of options. AWS S3, Azure Data Lake Storage, Google Cloud Storage, a Hadoop file system. Where are we going to process it? Apache Spark, Hadoop, Presto, Apache Flink. These are places where we could be storing things. How are we going to ingest the data? Are we going to use Apache Kafka, which is going to work anywhere, any cloud, anytime? Are we going to use Apache? I want to call it NIFI. It's N-I-F-I, but, sounds like a Greek word, NIFI. Especially if you're here, Yogos, let me know. And we could also be ingesting our data from AWS Kinesis. And from a management and governance perspective, there's other software we can think about, like Databricks or Apache Atlas or AWS Glue. So let's talk a little bit about AWS Glue. What is AWS Glue? It is a serverless technology that's going to automatically provision and scale its resources. There's a data catalog, and it's going to be a centralized repository to store metadata and make data searchable. It's going to support, say, schema, discovery, versioning, and partitioning. And it's here to automate ETL processes, where you extract, transform, and load from one system, pop it into another. That's what it's there for. It's an Amazon managed ETL tool. So some features of Amazon Glue include something called job authoring. And basically that provides a code base using Python or Scala. And then what will happen is Glue will actually generate the code to transform the data, which you can customize. There's the concept of job scheduling. So you can schedule your jobs to run on a regular basis using AWS Glue Schedule, or trigger it based upon events. This happens, then this happens. Amazon Glue is pretty helpful for data preparation because it offers tools for cleaning, enriching, and normalizing the data. And it enables developers an opportunity to create and test scripts interactively in their integrated development, like a development environment. It automatically will discover a schema. So it's going to look at the data and try and infer a schema and then store that in a data catalog. And of course, it's going to integrate with the AWS tools for things like monitoring, logging, and setting up alarms. This is a totally fine ETL tool. However, if you're dealing with 3 clouds, you might want to use a commercial tool that you can use in all 3 clouds. But what's the architecture? What's the business needs? So what happens is you first have this data cataloging. And what happens are these things called crawlers that literally go out there and scan your data sources. And that's where they guess your schema from. And then they populate the Glue data catalog with that metadata. So then there's the manually defining the tables and schemas within the data catalog space. Next, the ETL job needs to be created. So the Glue is going to generate the code to run the job. Of course, you could write your own code if you wanted. And then the job's going to run, and you schedule it. Do you run it on demand when you want it? Do you want to run it every Tuesday night at 2 o'clock in the morning in a scheduled environment? Or do you want to run it every time something occurs? Something's dropped in an S3 bucket, poof, run the job. So regarding the data transformation and loading, you're going to use this to transform data, so you can apply transformations such as data cleansing, data enrichment, or normalization. And then you're going to load the data into the target system, whether that be S3 or Redshift or RDS or anything else. So where would you use Glue? Well, anytime you would use an ETL tool in the creation of a data lakes, because it would maybe catalog and transform and organize your data. A data warehouse, taking your information and sticking it in your data warehouse. Data preparation, because it's going to clean and normalize and transfer your data before you look at it with like a Power BI or an Amazon QuickType, some kind of data visualization tool. You might use an ETL tool like this for any kind of machine learning environment, because you've got to clean up your data before you use machine learning tools, whether they be things like AWS SageMaker or any other machine learning library that's out there. And any kind of data integration, because you're often going to have to integrate and transform data from lots of different databases and data stores. And in some way, that's going to be clean. Chris, I think it's probably been about 20 minutes, so maybe I'll stop there, see if anybody has any questions. This is a very good question. So how might grade training, what are the fundamentals to learn? And B, it all is based upon your goal. If you give me your goal, I will happily tell you on the next break, unless you respond very quickly. The fundamentals to learn for a cloud architect are very different than the fundamentals to learn for a cloud engineer, which are very different than the fundamentals for a DevOps engineer, which are different than a network engineer, which is different than a software developer. The same way an airplane pilot and a lawyer need to know different things. So I will happily give you the fundamentals when I know which career you're actually looking for. Because learning to code will not make you a better architect. Because we don't code. We also don't look at code in our job. We design systems to optimize business performance, including networks, data centers, security, all of it. So there's that. But that learning to code would be critical. Oh, so you want to be a secured security cloud. So I still don't know what you mean. Do you want to be a security architect? Do you want to be a security engineer who defends the systems? Do you want to be what do you call it, an ethical hacker that breaks into systems? Because if anyone gives you any information without knowing your goals, it's going to be very dangerous. Just like designing an architecture, we need to know the business goals before we design it. So if you tell me, I would be getting honored to determine what you need to do. Security Cloud Architect. Okay, so I'll give you the fundamentals for that. That becomes easy. So the first thing to remember is this is a job where you have to design systems to optimize business performance. And my team is going to give you an ebook that we wrote for this. So you will need to develop your business acumen, your leadership skills, your sales skills, your executive presence, your emotional intelligence, your presentation skills, and your writing skills. If you don't have these skills, you will not be considered as an architect. So there is that. Next, what is it you really need to understand as a security architect? It's not how to set up a firewall. We don't do that. It is how to design the end-to-end security for an organization. So what does that mean? It means first understanding the organization's assets. What is it that they actually have? Is it intellectual property? Is it the formula for the new next generation GPU, a life-saving drug for cancer, for example? Because if you don't know what it is you're protecting, you don't know the type of protection you would actually need. Same way as if you were doing executive protection, you would take a dignitary like a president and you would give them a whole lot better security than you would for a person that's a CEO of a business that's got less than 50 people, because the risk is higher and you might spend $1 million a day to protect a dignitary like a prime minister, or 2 million or 5 million a day, but you wouldn't do that for the regular person. So we need to know the value of what they're protecting. We also need to know the risk of them being hit. You know, what kind of adversaries do they have out there? What's the statistic likelihood? And we need to quantify the actual assets they have and the risk that would occur, which means we need to understand the cost of downtime. We need to understand what happens to that business when certain things occur. We need to understand the brand value, because we need to quantify it into the actual number lost, and we need to quantify that as to actually non-quantifiable things like brand and how people see that company. For example, how do people feel about CrowdStrike tomorrow versus today versus the day before? Because you can see one little security incident can have a big impact on someone's brand. I think it's too early to tell or make any decisions about anything. But the point is that's the quantify is that. And when we know what we're protecting, then we can build a business case for security. If an organization has an exposure of $100 million a year, which could be nothing for a big business, then we need a security solution that costs us less than $100 million to protect it. So first we have to know what we're protecting. So that means some business acumen. After that, we need to look at the global business. What is the business goals? What is the business pain points? What is the business challenges? Where are they moving? How do these business processes work? Which is why I gave you the business things first. Now, when we know what we're trying to protect, then we need to be able to create a policy with our customers. So what do I mean by a policy? What is that overarching security policy that says this is what they do in an incident? These are the people responsible for an incident. Physical security will have this. All information shared on a wire will have this. These are how we do this. So we're going to need to help that organization create a security policy. We're also going to have to work with that organization to determine how they manage risk. Do they mitigate the risk, which is what we could do? Do they transfer the risk to an insurance company, in which case we can talk about that and we can help that with them. Then let's go. Then I'm just giving you some other things to think about. We need to think about the organization's network security. Where do we place our firewalls? Where do we place our intrusion detection and intrusion prevention systems? Which means you need to understand these technologies and how they work, not how to configure them. What kind of encryption in transit do we use? Do we use IPsec? What is the overhead of IPsec versus TLS? So we need to determine encryption. We need to determine how and where people will need to access inside the systems and create the right level of demilitarized zones. We need to determine what kind of storage encryption. We need to determine the type of endpoint encryption and protection. We need host-based anti-firewalls. What kind of services do we enable? So for the security architect, you're going to need to understand the network to a big degree, the data center, applications to some degree, the weaknesses and vulnerabilities that an organization has, and then how to design a plan to mitigate it. But we don't configure firewalls. We don't configure IDS systems. We're not going there in Linux doing a user ad, that kind of thing. So those are your skills. I'm going to run a webinar next week on how to become a cloud architect. And we've got lots of people that we've trained that have become cloud security architects out of that program. So I'm going to drop a link for that. And also my team will drop a link for that book. I want you to read the book. It's completely free. The webinar is free. We'll go over the architect role and you can ask us questions. We'll have a live face conversation with you. You want us to mini interview and see if you're ready for a job. I'm happy to do it. So whatever we can do to help you, and it's completely free. So I just wanted you to understand that's kind of the basic skill set. Which is more outsourced between cybersecurity and cloud computing? Well, we have to understand it's not cloud security versus cloud computing. It's the role that you're in. So if I have a sales rep, I can't really outsource that sales rep. And the reason I can't outsource that sales rep, if I have a rep that's in New York City that needs to sell to global financial businesses, I can't outsource that. Because it's human, manual, person-to-person kind of thing, based on entertaining clients, taking people to dinner, that sort of thing. So kind of keep that in the back of your mind. So a security architect is very hard to outsource because since a real architect isn't doing any configuring and they're meeting with clients and they're talking to people and they're building relationships, you can't outsource that job very easily. Now, there's still a remote work from home architects, but and that's fine, but it's still harder to outsource an architect job. Now, a cloud engineer, that is the easiest outsourceable job in the world. If I have a choice of hiring a cloud engineer, do I care if they're in California, Cameroon, the Cayman Islands, Cambodia, Cape Town? It doesn't matter because they're going to sit behind a desk and configure things. Now, the cloud engineering could also be done by AI because AI can write the Terraform script. AI can write the Python script, the Bash shell script, the CLI. But AI can't do architecture because it can't meet people. It can't talk to people. It can't build the relationship. It's not going to build a business case. It's not going to take your client playing golf. It's not taking your client to dinner. So it's not either one of those things. It's the career you pick in that which determines whether it's outsourceable or not. Engineering, easily outsourceable. Architecture, impossible to outsource. Engineering, where you need to be in the same room as people because you're part of some super special team where they've got the best and brightest and you're all in the room and you're writing on whiteboards all day long until you try it out. That is not outsourceable. Engineering of a job where I don't need to go to the office to, easily outsourceable. So kind of hope that helps. Good questions. Can I explain the sequence of the interaction between a web application and storage database? And you mean like in a typical three-tier app architecture? Absolutely. So realistically, what you're actually talking about is the following. So the way you're going to come in is the web server. That's going to present the website to you. So let's say I've got a website with Cindy the cat, my cat. And she's out there and she's got a wet hand pointing to a tuna, and we sell tuna, salmon, and other forms of cat food on the website. On that website, you got pretty pictures of the cat, you got all this text, and that's what you interact with. It's serving, say, an HTML page that you access via a web browser. That is the web server layer. Now, behind the scenes, there's a business logic that's running at the application layer. And that's going to be related to, how you buy the stuff, where the stuff is in our systems, who are you, what you're allowed to do. And that's going to be what you're actually talking about is going to be at the application layer. So you come in, you go to buy something, you get sent into that application layer, and then the purchase goes through. I bought, say, 20 pounds of tuna from the specialty Cindy the Cat Tuna web store from my cat Cindy, and it gets stored in a database that stores the structured data. So realistically speaking, that's what's going on. Now, the storage, the database will obviously be a virtual machine, and that will have, say, a virtual hard drive in it or a physical hard drive, and it could be block storage hard drive or a physical hard drive. So I hope that kind of answered you. Mike, do we have similarities between AWS, Azure, Alibaba? Yep, they're all the same. Now, what if I told you you can buy water at Albertsons, water at the store called Carrefour, and water at Walmart? You bought water. So all cloud computing is, Mario, is renting space in someone else's network in a data center. So you get a virtual machine in AWS, Elastic Compute Cloud. You get a virtual machine in Google, Compute Engine instance. You get a virtual machine in Microsoft, and they call it an Azure virtual machine. You go to Oracle, and they just call it a virtual machine. Same stuff. We've talked about object storage in depth. You can get object storage, and you can call it object storage from Dell EMC. AWS could call it S3. Google could call it cloud storage, and Microsoft can call it blob. Same thing. Okay. Well, I want to know you're awake, you're alert, you're oriented. So give me a hashtag AWS SAA. And we will take it from there. And I want to actually end with this last question because it's very important. You're not going to find more opportunities on AWS. You're not going to find more opportunities on Azure. 98% of organizations are multi-cloud. It's how good you are. It's what your skills are that matters. That's the secret. How good are you? How deep can you get into the underlying infrastructure that the cloud provider has? How innovative can you be to solve business problems? That determines your opportunities. Not whether you've got a Cisco certification or a Juniper certification or an Azure certification or an AWS one. It's all the same. Okay, I know you're awake, alert, and oriented. I'm loving this. And I know where lots and lots and lots of you are from. But I'm glad you guys asked these questions because these are the kind of questions which keep people going down the wrong path. And that's that wrong path that keeps people from getting to their end goal. So I'm thrilled you guys asked it. So let's talk about the AWS Data Pipeline. So in business, we're going to have these data pipelines, how we get data in and the things we can do with it. Businesses will build their own data pipelines, and business could use the ones that are built by built by the cloud providers. Each has their strengths and weaknesses and architectural trade-offs. So AWS has a way to make this easier if you use their service. And they have this service called AWS Data Pipeline. And that's going to be a service that will enable the automation, scheduling, and management of data workflows and data processing. It's designed to move and process data at scale from a whole bunch of different sources till it ultimately gets to its destination. So some features of the data pipeline are data workflow automation. That's what it's made for. So gives you the ability to automate your data, automate the movement of the data, automate the transformation of the data. It supports relatively complex data processing workflows, and then you can schedule multiple steps and dependencies. It's fairly flexible in the way you schedule it. It allows scheduling of data processing tasks based upon the time or external triggers, and it's going to support both periodic and one-time tasks. Data transformation. So Another big feature here. So it enables the transformation of the data as it's going through the pipeline. And it supports lots of different transformations, meaning, say, like an SQL query, you can run it into a custom script. You could turn it into Amazon's version of a mapping or reduction script, the Elastic MapReduce, which I'm sure we'll talk about. Data integration. And Data Pipeline is going to integrate with lots of different AWS services. So if you're just using AWS proprietary stuff because you're just on AWS, these proprietary enhancements make it easier. So think about that. So it's gonna help with error handling, because you can set it up and it's gonna have error handling and retry mechanisms. So not everything works the first time, something you need to retry, and this can support that as well. So fairly robust service. It actually has a graphical interface, so it makes it easier to design, configure, and manage the pipelines. You can visualize it. You can see what's dependent upon what. And it is very customizable. So where would you use Data Pipeline? Well, when you need to do some kind of data ingestion, and your data ingestion also needs some form of extraction, transformation, and loading, this is a great tool to use if you're going to be stay in the AWS ecosystem. Otherwise, use a more industrial tool. It also works well with data migration, because it can help you take data from a lot of different stores and then move it to, say, AWS. It can also be fairly useful for backup, because you can use it as a way to constantly pull information out of your database and maybe store it to object storage. Quite good for taking all this data and putting it in one place and then creating reports from it. So aggregate your data from multiple sources, transform it, generate reports. You might want to, for example, you might want to collect sales data from all different databases, aggregate it, and use it to produce a daily sales report. So when you set up an AWS Data Pipeline, there's some things you need to think about. Pipeline definition first. So a pipeline definition is going to be how you communicate your business logic into the data pipeline. And it's going to include the following kinds of information: data sources, and you're going to need maybe the name or the location or the format of your data sources; activities or tasks that will transform your data. Obviously, there's going to be a schedule, right? The timetable and when you want to execute this data pipeline. And it's going to include some information. You'll include the resources, like what amount of computational resources do you need. You can specify any preconditions that may be met. Maybe something needs to occur before something else can be scheduled, for example. It'll provide some notifications that can alert you with a status or an update during your pipeline execution. So I like to think about it this way. From a pipeline definition perspective, the AWS Data Pipeline is going to determine the tasks, it's going to schedule them, and it's going to assign it to something called the task runner. And if the task were to fail, the pipeline will retry the task based upon the instructions you gave it. And if necessary and you specified it, it'll allocate it to another task runner. And then at some point, if your task fails repeatedly, you can configure the pipeline to notify you. So sound anything different than anything else? In a routing protocol and a health check, it tries again, it may try again, and at some point, it just doesn't try anymore. It's the same thing. So I want you to get these similarities between one tech and another. They're all so similar. They all use the same principles. When your fundamentals are good, you'll be able to learn anything really fast. So I mentioned the pipeline, but I really want you to think about what it's going to contain. This is the business logic of the pipeline. Where's the data sources? What are the activities going on? What are the schedules? What are those preconditions? And, it can inherit properties from the parent components in like those nested environments we talk about with IAM. It's the same kind of thing, where we define data management rules and relationships will occur through the references. One of the things we need to do is related to instances. How many actionable units are going to be created from the pipeline when it runs? And will they contain all the necessary information needed to perform the task as they need to? And this is going to be managed by the task runners. I had mentioned attempts before. So attempts are going to be, keep track of failed operations. How many times do you want to try it? And you're going to have to put in several retries if you want some robust data management, because sometimes you need something to try a few times before you determine it's failed. And if it failed, then maybe be notified so you know how to go fix it. A little bit about the task runner. The task runner is going to be an application that's going to pull the AWS Data Pipeline, and it's going to look for tasks, and it's going to perform these tasks. The default implementation provided by AWS Data Pipeline is called Task Runner. So some other thing you need to think about. When it's installed and configured, it's going to pull the data pipeline for tasks, and it's going to activate these pipelines. It's going to perform their tasks, and then it's going to report the status back to the AWS pipeline. So let's talk about data nodes. In our AWS Data Pipeline, the data node is going to define the location and type of data that's going to be used to say as an input or an output by a pipeline activity. And AWS Data Pipeline can store information in lots of places, and they're probably going to be what you would think of the usual suspects: S3, RDS, data in SQL, data in Amazon DynamoDB, data in Amazon Redshift. AWS tool stores data and enables you to get data into AWS data storage places. So I hope that kind of makes sense. I'll add a little more on preconditions. I know I mentioned it before, but a precondition is going to be a component that contains conditions. So this needs to occur and this needs to occur before this occurs. So maybe you check the data source, make sure that it exists before you try to copy it and move it over. So there are basically two kinds of preconditions. There are what's called system managed preconditions. And this is going to be run by the AWS Data Pipeline service, and it's not going to require computational resources. But there's going to be some user-managed preconditions where you may need to run on a certain system or server or virtual machine before you get it to run in the pipeline. All right, so talked about some data pipelines. We talked about extraction, translation, and loading tools, specifically AWS Glue, but they all kind of work that way, where they take data from, say, one database, they extract it, they transform it, and then they load it into another system. Well, we also have to map and reduce data as well. So if we were going to create a data lake, and I know I introduced this a little earlier, we're going to be pulling the data out of the NoSQL databases and pulling the data out of the data warehouse and pulling data out of our relational databases and pulling data out of standard object storage buckets. So we've got a lot of data. We've got to normalize that data and smooth that data and make sure that the data is consistent. And that's called mapping and reducing. So lots of big tools people use like PySpark to do this, but AWS also has their own managed tool to do this. Now, if you're in a multi-cloud environment, you might want to have the same tool you use in both clouds. But if you're just in AWS, they've got a nice tool that actually does this and integrates so seamlessly and smoothly with other AWS services. And they call it Elastic MapReduce. And Elastic MapReduce is going to be an application made by Amazon that's going to be used for processing and analyzing large amounts of data. It is going to be a managed cluster, not a service, if you will, and it's designed for managing a big data framework. It is a pre-built system that will facilitate data analysis and processing without needing to basically create your own servers and manage the servers and install your mapping and reduction software on these servers. So AWS Elastic MapReduce is built on a lot of these big data tools that you would think of, like Apache Spark, Apache Hive, Apache HBase, Apache Flink, Presto, that sort of thing. And it's going to offer good performance, and it's fully managed, so we can think about it. And in cases where the organization needs custom, heavy-coded mapping and reduction function, there's a possibility that using a pre-made tool like Elastic MapReduce is cheaper. There's a possibility it's not. But that's understanding the use case, but there is a possibility it could be. And what it's really like is, we can use it from any data source. It could be, like I said, a relational database, data warehouse. We take the information out of something, we put it into this mapping and reduction system, it's reduced, it's normalized, it's cleaned up, and then we have data in something that's going to look good, it's going to look clean, and it's going to look consistent. Let's talk about some key features. So it's a managed cluster. So it's going to automate what you would normally do, which would be the provisioning of these clusters. So you're not setting up, Hadoop clusters, Spark environments, and it supports the use of multiple types of instances and configurations, but it's managed. It scales, thankfully. It'll scale up, it'll scale down, based upon the processing needs. It will support temporary clusters, long-term clusters where you need these things running a long time. If you're using AWS stuff, it integrates so beautifully with other AWS stuff. So it'll iterate so nicely with object storage or S3, any of the Amazon relational databases, DynamoDB. You'll get CloudWatch information, so think about that. If you're using, say, Redshift or Amazon Athena or CloudTrail or Kinesis or any of these things, it's going to integrate so smoothly because they're all AWS proprietary things, which integrate very nicely with AWS proprietary things. That is one of the benefits and elegances of a single vendor. There's lots of downsides, but that's one of the upsides. It would also work with, say, AWS Glue for extraction, translation, and loading. So from a security perspective, it's going to, work well with AWS security things like IAM roles, encryption at rest, in transit, Kerberos authentication, that type of thing. It could integrate with AWS Lake Formation for access control as well. The Elastic MapReduce, is going to have secrets, right? Secret things that you need to do. So it's going to let you store information with AWS Secrets Manager, which we'll talk about when we get to that as well. But that's a place to store secret information in AWS. So it's got support for a lot of the big data frameworks like Hadoop or Spark or Apache HBase or Apache Flink or Presto, that kind of thing. So because of it, it's going to enable fairly custom software configurations for the users that actually need it. And we use it for data processing, realistically speaking. Data analysis and machine learning, because we might want to normalize that data. Maybe we do our data analysis and machine learning with Apache Spark. There's some machine learning libraries there or any other learning framework. The point here is we're going to smooth the data, clean the data, and then we can analyze bigger data sets with it. We may have real-time streaming data, like click streams coming from web pages or IoT devices or something like that. And this mapping and reduction with EMR can process and analyze streaming data relatively in real time, which is great. And that kind of uses like Apache Spark streaming or Apache Flink. And that will integrate with, say, Apache Kinesis, Amazon Kinesis if you wanted the AWS proprietary streaming tool, or Apache Kafka if you wanted real-time ingestion. We might use it with lots of interactive SQL queries to enable our data analysts and maybe data scientists to perform ad hoc queries and get good information. So how do we set this up? Well, how do the engineers that actually build this stuff set this up? They launch the EMR cluster. How do you do that? You go to the AWS Management Console, you navigate to the EMR section, and you create the cluster. In that cluster settings, you set up the software, the instance type, and the networking. Now, if you take these systems and you need to install any Bootstrap software, you just write a custom Bootstrap script. You'll configure your security and your access. Things like your IAM roles, your VPC security groups, that kind of thing. And you're going to just submit your jobs. You'll submit your jobs using the AWS Management Console or the CLI or the API through a software development kit or maybe a Hadoop or a Spark interface to submit your jobs. And then it'll monitor the progress. And you just monitor it, determine what's working, and then make decisions thereafter. And then obviously with anything, we try, we test, we learn, we optimize, we fix, and we grow. So that's the whole point here. So with mapping and reduction with Elastic Map Reduce, let's think of some other best practices. We may want to store data in like object storage for durability and cost efficiency, but we want to have some kind of good storage. We may want to use data partitioning and compression to maybe optimize our storage cost and performance. We want to make sure that when we're dealing with data, we've got, say, good encryption of data at rest and in transit. We want to make sure that we apply to the principle of least privilege. And that we monitor costs. We look at what's going on. Is this working? Is it not working? Should we use something different? So don't just turn it on and pray that it does everything you want. Manage this. Okay. So we talked about what is a data lake. We talked about today what is a data warehouse. We talked about extraction, translation, and loading, to some degree extraction, loading, and transformation. We talked about mapping and reduction. We talked about data pipelines, and we talked about data lakes. So now let's talk about AWS Lake Formation. And AWS Lake Formation is going to be a fully managed service. It's going to make it easy to build and secure and manage a data lake. And we talked about a data lake, but in case you just joined, it's going to be that centralized repository that's going to enable you to store all your structured and your unstructured data at any scale in this environment. So you don't have to structure it first. You can put your data as is. You can run some analytics on it. You can visualize your data with the right tools. You can push it into machine learning for some understanding and for predictive analysis, that kind of thing. So lots of options we can do with data lakes. So the AWS Lake Formation is making it easier and removing some of that manual intervention from you. And it can take your information from AWS services like AWS S3, RDS, DynamoDB, etc., or your on-premises database. And you can use what Amazon Aurora or Redshift as well and data streams for ingestion compatibility. Now, part of that data lake creation is the data cataloging. Well, using AWS Lake Formation, it does a lot of that stuff for you. So it automates the data cataloging, making the data easier to access, searchable, that kind of thing. It centralizes your security management to a degree, because now you're setting up the control policies to access these sort of things. And you're using your systems inside of AWS to do it. It's got in that it's got built-in extraction, translation, and loading. So you define the workflows, prepare your data, and it gets done for you as part of this. So it's a managed service for a data lake in every way. It tends to integrate fairly nicely with certain analytics tools and big data tools, especially the AWS ones, because it's an AWS product. It even has some blueprints on different types of data lakes. Predefined templates to create a data lake quickly. Now, using the blueprint for somebody else's business is good if you're in the exact business and everything is the same between your business and someone else's business. But all no two businesses are the same. So when you use a predefined blueprint, you really need to look, is this going to work for me? And if not, is it worth creating your own? It's a trade-off. So how's it work? Realistically speaking, the data is going to be ingested. And it's going to simplify that. Then the data is going to be cataloged. Then the data is going to be transformed with the ETL tools. And then you're going to basically speaking, determine, your IAM policies, etc., for who's allowed to access what. And you're going to access your data. And you can catalog it, transform it, analyze it, do anything you want. Okay, so where are we talking about? We'll briefly go through part of Kinesis, or maybe all of it. So we'll see how we do time-wise before we take our next break for questions. So let's talk about Amazon Kinesis. So in many organizations, we're going to have a lot of data coming in. Lots and lots of data. And imagine a world where you have access to information. And when you take in this data, in real time, you can make a decision in real time. See, normally, previously, what businesses did is they took a ton of data, they stored all this data, and then years later they analyzed it. Well, if my wife is coming home and she says, I want to buy my 580th pair of shoes right now, and I'm able to say right then and there, yes, or because if I say no, it's going to be a lethal situation. It's not going to be pretty. She loves her shoes. Everybody loves something. I've got the own things I love. But if I know to say yes right then and there, if she asked me, but she would just buy it, she'd leave super happy, come home, be very happy, probably bring home treats for our cat, gifts for me. It would be a nice thing. But if I didn't know how to react to that, and if she were to say, hey, let's get shoes, not that you would ask, but if she were, and I came back 6 months later and said, of course you can get your shoes, that wouldn't be good. So the better business decisions we can make, wait, we got a whole bunch of things buying on right now. Okay, what do? Do we add more inventory? What's going on? So we need to have sometimes better access to information in real time. And generally speaking, we're going to need some way to take in the streaming data and do something with it. Now, in 98% of organizations that use multi-cloud, which means Kinesis will work across AWS, Azure, Google, Alibaba, Dell's cloud, IBM's cloud, or any other cloud in the world or your data center. So that is your open source standard. It is Apache Kafka. And if you were just in AWS, and again, almost nobody's just in AWS, but if you were just in AWS, or only had streaming data pipelines in AWS, and you didn't want to manage your own Apache Kafka environment, and there's good reasons to do so sometimes, you would use Kinesis. And Kinesis is an Amazon proprietary, AWS managed suite of services for real-time streaming and data analytics. And it is very cool. It enables you to ingest, process, and analyze streaming data in real time. So that's the difference. Kinesis, Apache Kafka, you can pull in your data in real time and you can do something with it. Kind of like having a live conversation with your data. So I like it. So there's a couple of versions of Kinesis, and we'll talk about them. There'll be something called Kinesis Data Streams, Kinesis Data Firehose, Kinesis Data Analytics, and of course, Kinesis Video Streams. So think about real-time data, real-time processing. Now, what's very cool is this is a managed service. And it's going to scale real well. So you just simply adjust the throughput of your streams by increasing or decreasing a unit of measurement called shards. I didn't make it up. Shards are the side of the stream. You need more of them, you get more shards. So when Kinesis pulls in its data, it typically puts the data and stores it in a couple of different data centers. So it gives you some availability of your data. It typically also has a built-in error handling and retry mechanism to make sure that it works and you get what you need. And because it's AWS, it tends to integrate real smoothly with other AWS things. So smoothly with Lambda, smoothly with S3, smoothly with Redshift. So, and even if you were going to use Elasticsearch, it was smooth with that. So on AWS and only AWS, it's going to make life really elegant. But functionality-wise, it's going to be a lot like Apache Kafka. It supports security, meaning things like data encryption and at rest, which is very important. And it also integrates with your identity and access management strategy. So we'll briefly discuss each one of those. So we'll talk about Kinesis Data Streams first. That's going to be a real-time streaming service that enables you, for the most part, to build custom real-time applications. So coming in right now, looking at real-time analytics. Maybe logs are coming in and streaming in right now, and you've got some AI that's looking at those logs in real time. Maybe you've got stuff going on right now, and you've got AI looking at it and making recommendations. That's your Kinesis data stream. By comparison, next is going to be Kinesis Data Firehouse. And that's about taking your real-time streaming information and storing it somewhere. So it comes in streaming. Maybe it puts it in S3. Maybe it sticks it in Redshift. Maybe it sticks it in Elasticsearch. Maybe it puts it in Splunk. And that's going to automatically scale to match the needs. So streams come in real-time analysis. Firehose come in real-time and store it. Now let's talk about Kinesis Data Analytics. So here, it's coming in streaming, and we're going to process it and analyze it with, say, standard SQL or Apache Flink. And it's going to enable you to gain actionable insights on your data, and you don't need to start learning programming languages or processing frameworks because it's kind of built in and fairly smooth. So, because people have a hard time with this. Kinesis Data Streams comes in, analyze real time. Kinesis Data Firehose comes in and stores. Kinesis Data Analytics comes in and it's being analyzed in real time. Then the last is Kinesis Video Streams. So that's a service for streaming video and coming in a secure manner to run analytics on it or machine learning. So what if you had 1,000,001 cameras going on of the country and you could see what was going on in different parts of the world? Maybe because you were expecting bad weather and you've got all these cameras in and an AI could scan it and say, hey, there's a hurricane in Florida, that kind of thing. You know, think about how you use these. So I hope that makes sense. Streams, real-time, analyze. Kinesis Data Firehose, store. Kinesis Data Analytics come in and analyze real-time. Kinesis Video Streams come in video and maybe analyze that in real time. So where would you use this stuff? Real-time analytics. Data ingestion for a data lake or a data warehouse, because you can stream data coming in to, say, S3 or Amazon Redshift. Machine learning. So we can take real-time data, stick it into a machine learning model, find anomalies, maybe make recommendations to people, get some predictive analytics because we see something, we think we know something. So, you know, that's going to be really great. It's going to support training FX and inferences based upon real-time data. We may have a lot of Internet of Things devices, like IP-enabled weather sensors or all these airplanes flying through the sky, or your refrigerators that are spewing out information, or medical devices that are connected to the network. IoT devices are becoming very big, and there's lots of them, and they're streaming lots of data. Think about video analytics. Think about security surveillance. You're doing a high-risk thing, and you have machine learning pulling these Kinesis video streams and look and notify security people or something. Think about, you know, giving a presentation and looking at the audience and having machine learning pull this information and say, people don't look happy, change this, do this, or make recommendations to the speaker. A brand could do that with their brand message. Or being able to pull information and see, okay, there's a process when those cars are being manufactured that's wrong. We found it. Let's go fix that before a car comes off the assembly line wrong. So let's talk about some best practices with Kinesis. You want to optimize your shard count. So shards are a measurement of how much data you can send. You want to make sure you get the right amount. If you don't have enough, it's not going to perform well. And if you have too much, you're going to pay for too much. So either use the Kinesis scaling activity or auto scaling to automate shard scaling, or know what you need. You may want to think about data compression, because you could compress the data before sending it, which will reduce the amount of data that's transferred and stored. You may want to take a whole bunch of smaller records and pop it into a bigger record to optimize performance and reduce cost. So some other things we should think about from a best practice perspective. Make sure we encrypt the data at rest and in transit. So use like a TLS security for in transit. Use the AWS key management system to store your data when it's, encrypt your data when it's stored. Add a good, strong IAM policy to make sure that only the right people can access it that need to. And of course, set up any monitoring alerting. You really want to know when systems aren't doing well. So set up CloudWatch alerts, and based on key metrics like maybe incoming data rate or outgoing data rate, or anything that just doesn't feel right based upon your utilization of these systems. And then test your systems. Regularly test their system, validate to make sure they're actually working, that the data is coming in accurately and the data is complete, and nothing broke along the way. Now, I mentioned Kinesis Firehose. Let's talk a little bit more about it. Again, this is more about storing the data as we talk. So, because we're going to capture it and store it, and it scales, that's where we use Kinesis Data Firehose. Now, like all the stuff I talked about throughput in shards, a shard's going to be 1 megabit a second, or megabyte a second. It's not going to be a lot of data, but in streaming data, it's a lot. Things to think about, whether it's Kinesis Data Firehose or other things, is that you're paying on those shards. So you really need to determine what you need. Regarding Kinesis Data Firehose, which is where we take it in and we store it, we can have up to 10 shards per region, per account. Now, that doesn't mean you're going to be not need more than 10. But that's the default, what you're given. If you need more, you can request them from AWS, and you can usually get some. They're happy to sell you more if you need it, but there's that. And you can set up a policy to auto scale based upon utilization. So you reach a certain level, add more. You can set up Kinesis Firehose from the console. Here's the way that I always looked at Kinesis Firehose in my head. We had our data coming in. We popped it into a bucket. And after it's in the bucket, we run an analytics tool like Power BI or something like that. Gives you the opportunity to look at your data, visualize your data. These analytics tools could have been machine learning or anything like that as well. Let's talk about some key concepts for Data Firehose. The underlying, I want you to think more about the data record. The data that's produced, the data of interest, is going to be considered a data record. And the records themselves can be as large as 1,000 kilobytes. So not that big, but relatively big on something where we're typically talking about text data, or could be text data. Now, the data producer that's going to send data can also only send it up to 1 meg. Now, a little more about a data producer. So I want you to think about, with Kinesis, the data producers. So it could be a web server that's constantly sending its log data, could be its data producer. It could be, clickstream data that's a data producer, like who's clicking on what boxes on a website that a company might track. So you may have to have the engineers that set this up set up the buffer size and the buffer interval, because the Kinesis Data Firehose is going to buffer the streams to catch a certain size or for a certain period of time. Buffer size will be in megabytes and buffer interval will be in seconds. Now let's talk a little bit more about Kinesis streams. Pretty much every connected device in today's world has an IP address. Cars, smart cars, smartphones, security cameras, your refrigerator that for some reason needs to tell you which foods to buy and text you when you go to the supermarket. Everything now has an IP address, which makes security a lot harder. But, Kinesis video streams can take all these streams. And by getting all this information, businesses can look at it and analyze it. So I wanted to talk about the application first, and then each one of these a little bit. Here's the way you kind of look at this. Here's one possible way. You could take 3 video streams in and then send it over for media processing. You could be taking these video streams in and sending it to AI. You could be taking these video streams in and sending it to multiple people to go look at the video streams or some semblance of what these things are so they can make decisions on it. You can be sending these streams in and having software that will alert certain people when it sees patterns of behavior or anomalies that don't look right. So lots of cool stuff you can do with this stuff. Bear with me a second. You know what? I think that's a good time for us to take some questions. So while we wait for some questions, if you're having a good time, hit the like button, subscribe to the channel, and hit the bell to be notified of new videos. Amit, is AWS Data Pipeline the same as Azure Data Factory? Yes. AWS calls their data pipeline. Azure calls it the Azure Data Factory. These are just two manufacturers that have their own different versions of basically the same thing. So definitely one is functionally equivalent of the other. Can we say an application for AWS Kinesis is Netflix? Well, yes, Netflix definitely uses AWS Kinesis. And why? Because it can capture real-time data, and they could use it for processing and analytics. They can leverage Kinesis to collect and analyze real-time information based on, say, user behavior. They can monitor the streaming quality with it. They can detect and resolve issues. And if we have to look at Netflix and we look at it, for example, they're a very interesting use case. So yes, they typically use Kinesis for real-time processing analytics, and it's perfect for their use case. But let's think about that use case. If Netflix goes down because the entire AWS cloud collapses, what's going to happen? People won't watch TV. Is that life-threatening? No. Can AWS then be on a single cloud, potentially tolerate a couple hours here and there of downtime, and not have a horrible impact on their business? Yes, they really can. So by being on a single cloud and leveraging some of the proprietary services, Netflix, by comparison, can use this service and be great. Now, let's say by comparison, we have an airline that's all on that single cloud. And they're using all those single cloud proprietary things. And we've got planes in the air, or better yet, not an airline, air traffic control. They're all in a single cloud. And that cloud provider has an outage. Can we deal with airplanes being up in the sky for a couple hours without air traffic control being able to determine where the planes are so they don't crash into each other and be able to determine which airports people can land at? Probably not. So AWS is an example of a wonderful business that is using technology in an incredible way that completely understands their business requirements. Likewise, a hospital, which could be doing surgery on a patient, probably doesn't want to be taken down if they were on a single cloud. So, because people could die. So we have to look at every business. But the example you gave in Netflix is a very special use case. For the most part, they can be down. Their subscribers typically don't go away if they can't watch TV for 2 hours. And there's no major earth-shattering things that occur. And in that example, using things like proprietary services is so awesome because you can make your design more simple and more elegant. So kind of keep that in the back of your mind. Yes, we can definitely say that AWS Kinesis is good for Netflix. Quite frankly, AWS Kinesis could be good for a lot of businesses that only need to do real-time data processing on a single cloud and can use higher availability for other systems as well. Great service to take in real-time data and analyze it. So are the templates talked about in services today in YAML or JSON templates we see in CloudFormation? Mark? I am honestly not sure. Let me think about that for a minute. I'm just not sure, Mark. I don't want to give you bad information. Mr. Dominic, could we say that when we cloud services, we trade convenience for flexibility? Oh, can you? I'm going to translate that, Mr. Dominic. Are you saying that when you use serverless, you trade convenience for flexibility? Well, when you use serverless, here's what you do: you get flexibility. Well, I'm sorry. When you use serverless, you get convenience. What you do is you lose control. So today, a lot of businesses enabled a company to push updates to their Windows computers, automated. And we've had a global outage today because somebody else was able to do stuff to their systems. Businesses that manage their own security and didn't allow that were not affected today. That you're the people that use the different vendors. So here's what happens when you go serverless. You have to create code, typically speaking, that's optimized for one cloud provider, which means if you have problems with a cloud provider, it's going to be very hard for you to leave without redoing everything you have. The second thing that happens when you go with a proprietary anything is all of a sudden there's a desire to innovate. And this person has a better tool than you currently have. Innovation becomes very difficult when you use proprietary tools because other devices can't connect them. So you lose innovation potential. When you use a serverless thing on one cloud, it's going to be very hard to have a backup system running on another cloud. And sometimes it's better, and at the same price, to put 50% of your eggs in AWS and the other 50% of your systems in Azure, as opposed to buying 100% and 100%. So you also trade performance and availability gains as well. So there's a lot that you lose when you go serverless. And there's a lot that you gain. It's simple. It's elegant. You don't need as sophisticated people. I mean, the people that truly understand high availability, high security systems are expensive. People that typically come from that networking background where they're designing this stuff all the time are much more expensive than somebody else. So you can use less expensive people, generally speaking, when everything is managed for you. But it's not the same. You know, my mother-in-law, boy, she makes me a hamburger, and boy, is that thing good. Because she knows exactly the right amount of garlic and salt and pepper and oregano, and she makes it exactly the way I like it. If I were to use a pre-made service by like going to buy Burger King, for example, I don't have control over the grade of beef. I don't have control over the spices. So it's not going to be as customized. But maybe that Burger King hamburger is perfect, and maybe it was cheaper and easier to do. So what is it that I really want? Personally, I'm very careful with what I eat, so I don't do managed service anything. But, you know, equivalent of that, I don't outsource like my food. But, you know, everything is a trade, and it's about choosing the correct trade based upon what the needs are. You know, Mark, here's the thing about being 50. Sometimes you have to think about it. So templates for Kinesis are typically written in JSON. They're often written in YAML as well. And they often use these templates to define or deploy resources and say something like CloudFormation along the way. So templates can be deployed in lots of different ways. But like think about a Terraform script or a CloudFormation script, the AWS CLI. Sorry about that, Mark. Sometimes you got to really think about something for a minute or it slips your mind. Is Kafka considered an ETL tool? No, it's more of a streaming messaging type tool to basically push the messages to its end destination. Mark, I always forget that you had that operations perspective where you actually built this stuff, so I can see why you're asking that question. You're a great architect, too. Okay, well, since we talked about Kinesis, let's talk about the other options. So, not every organization could or necessarily should use Kinesis. Some people should use Kafka. And guess what? There's a couple of ways you can do Kafka. You can set up your own Kafka systems, which is option 1. Or option 2 is AWS has a managed system for you. So they have something called Amazon Managed Streaming for Kafka. And what is it? It is a managed Apache Kafka service. So it makes it easy to build and run these applications using Apache Kafka. And Apache Kafka is widely used because it's a popular open source platform to build real-time data pipelines or any kind of application that uses data streams. But here, it's fully managed. So you don't think about setting up your virtual machines, patching your virtual machines, monitoring your virtual machines, running these systems. So it's done for you. And, it provides, good availability and durability of your data. And it's properly managed and done by AWS. So it tends to scale by, if you're familiar with Kafka, you can either add or remove brokers. So it's going to support both vertical and horizontal scaling based upon the workload that you have. It's going to integrate with, it's an AWS tool, so it's going to integrate seamlessly with the AWS Identity and Access Management System. It'll support encryption in transit and at rest using the key management system. That's going to enable you to do some network isolation using your VPC, for example. It's going to give you good monitoring and good metrics, and it's an open standard. So where might you use Apache Kafka? Real-time analytics, streaming data, event-driven applications. You can build applications that respond to something. All this stuff comes in, then do something else. You can integrate it with ETL tools to load your data, say, into a data warehouse or a data lake. Works great with all those IoT devices that are spewing information constantly. So how do you set this up? And it's a little easier than setting up a traditional Apache Kafka setup. You basically create your cluster in the management console. And you can choose between a custom cluster or a quick create cluster. You'll specify your configuration needs, such as the number of nodes you'll need, the type of instances or systems that you'll use, your storage. You set up your networking and security. You'll create the topics and you'll produce the data. So you'll use Kafka clients or libraries to create topics in your managed cluster. And then you'll produce your data to the Kafka topics using the Kafka Producer API. You'll consume the data. You'll monitor the data and manage the data, manage these systems. And, best practice-wise, what are you going to do? You're going to look at your cluster. Is it the right sizes? Is it too big? Is it too small? So you typically want to use multiple nodes in different availability zones, so that way you've got higher availability in case one data center fails. You're going to want to implement good security best practices like IAM roles, permissions, that kind of thing, encryption at rest, encryption at storage, and of course make sure the rest of your systems are locked down. You're going to monitor your systems and you're going to scale them appropriately. You're going to try to ensure data availability and consistency and data durability. So configure replication factors. Make sure you've got your minimum and sync replica settings done to make sure you've got your data durability. Maybe use AWS Private Link to enhance security and connect to where the service you need. So that was streaming. Now that was the Amazon managed one. You could still use in a business an Apache Kafka environment where you just put them on virtual machines the same way you did in every other data center. And you might want to do that if you need more control. Let's talk about another AWS data service. And this is the AWS Data Exchange, and I'll explain what this is. It's a service that enables organizations to share data. So maybe I want to share my data or sell my data to somebody else. Maybe I'm in the business of data and I sell data to a lot of people. Or maybe all these hospitals want to work together, exchange data in a secure manner to do medical research together. So that's the point of the AWS Data Exchange. Kind of cool, actually. So if you're in the AWS cloud and there's third-party data in the AWS cloud, this is it. So what happens is you get a data subscription, and the user will be able to browse between a lot of data products from lots of different third-party providers. You can find a data product on financial market data, health data, retail data. There's going to be data, and lots of people selling data. I think of it as a data mart in my head, honestly, like when you go to the store and you buy something. But the data providers can easily list and manage, store, and monetize, meaning sell their data products. And it's pretty good for the providers as well because they're already on AWS. You've got AWS infrastructure, AWS network, so it's pretty simple to make this work. So you subscribe to this service and you get your data delivered via an object storage bucket, typically in S3. The data is updated every time the provider updates their data or publishes an update. And it's really easy to use. I mean, this is pretty cool. You can go and search and discover other people. It's kind of like going to Amazon.com and saying, I want to buy data, or putting your data there. And because it's an Amazon tool and it's stored on Amazon, it's going to integrate really nicely and beautifully with things like Glue or Redshift or Athena. So very nice system. And you'll still be able to use it in other databases as well, but it's a very nice service because lots of people are in AWS. So maybe in financial services, somebody wants to buy market data or economic indicators or gets other data for decision making. In healthcare, data is everything, especially now. Maybe we can get a lot of data which could help with drug discovery. Medical errors are kind of one of the largest causes of death. It's kind of horrible. It's the third or the fourth. Goes in and out whether COVID is up there or not, but it's like the third leading cause of death in the U.S. Maybe the fourth. It goes kind of in that range. So we get access to the data. We can actually mine the data and see the mistakes we're making, which are killing people, and which ones are saving people to make healthcare better. In a retail environment, the better a retailer understands their consumers' behavior, the better information they have or market research, the better marketing campaigns they can make and product customization, that kind of thing. So there's that. So we'll talk about the concept of a data grant. What is a data grant in the AWS Data Exchange? A data grant's like a unit of exchange, like $1 or a Bitcoin, what have you. And it's going to allow the sender to grant the data receiver access to a specific data. So somebody grants it and somebody receives it by caching this thing in. So how's this kind of thing work? You've got the creation and request. The data is going to send, the data sender is going to create the grant, which will generate a grant request, which will be sent to the receiver's AWS account. The data receiver will then accept the data grant to gain access to the data. What's the data set? Okay, so a data set is typically going to be a curated resource by the data sender. That's going to include all the data assets that the receiver will get upon accepting the grant. You go to the store and you want to see what it is. So AWS Data Exchange supports 5 different types of data sets: files, an API, Redshift, S3, and Lake Formation. The data grant will have details like the name and the description of the data grant, then visible to which data receivers. There will be a component of recipients details will be there as well. What'll be there will be the recipient's AWS account ID, and it'll specify how long they have access to the data. So what's a data product? The product is going to be the unit of exchange. A data product will be a product that has data sets. So it's the main thing that's going to be exchanged. So when it comes to the data exchange, we have to talk about publication and listing. The data provider has to publish the data as a product. And then it gets listed in the AWS marketplace as a product in its catalog, like buying something. And each product will be uniquely identified by a product ID. There will be details on the product, which will include its name, a short description, a long description, maybe a data sample, a logo type image, contact information for support, and data about the provider. Okay, so manage Grafana. So Grafana is going to be a service that organizations use to enhance productivity because it helps take away some of the burden of analytics. It's an open source analytics tool. Today, visualize, query, and understand the data. And by being managed, it does that big data analytics. And it kind of helps because you don't have to set up the systems. You don't have to think about it. Grafana is a widely used tool. But with managed Grafana, it's going to be serverless. And by doing so, it's not going to be something that you have to manage. Not thinking about setting up the virtual machines where this runs, what have you. So with a managed Grafana environment, users will be able to easily query, correlate, and visualize operational metrics, logs, traces from a lot of different data sources. It scales well, so you don't have to think about upgrading the systems if you built your own managed system. It gives you a single dashboard where you can look at your tools. Highly interactive for, say, data visualization, and effective for looking at real-time monitoring. Because it's managed, and it's managed by AWS, it typically integrates very easily with AWS data sources. But it also, because it's Grafana, which is open source, tends to work very well with many other open source tools, third-party tools, and common cloud data sources. Now, Grafana kind of supports that SAML, that security or social markup language, so it's going to integrate really nicely into IAM systems. It's a secure environment, and it's going to take away the stress of periodic renewals and licensing. And so it's not open source. Sorry. So Amazon managed the Grafana. The key to remember, it's Grafana, but it's managed for you. So no patching, no updates, no backups, none of that. So thinking about where you're going to use this, some of the features and functionalities are going to be under collaboration and sharing. It'll enable you to share dashboards with, say, team members and maybe collaborate on certain visualizations. It will help you control access with fine-grained permissions. Some other thing that is typically is from a security perspective, think about it in encryption. It provides encryption at rest and encryption in transit, so when it's stored and while it's in motion over the network. How do you set it up? You set up a workspace in the management console, CLI, what have you. Usually the management console. You'll set up your basic settings, such as your workspace name, your data source, your permissions. You'll add your data sources. You'll create your dashboard. And you'll set up your alerts. And obviously you'll manage your permissions, what have you. But let's talk about some best practices from the managed Grafana. You want to make sure it's going to perform well. So you want to regularly view and optimize your queries to make sure you're going to have efficient data retrieval. You're going to want to use Grafana's built-in caching mechanisms to reduce the load on the data sources. You're going to want to secure your environment. So, look, there's less security we can do here than in other places, but obviously make sure that traffic is limited by access control lists, firewalls in places where you need it. And inside of your systems, you're going to implement the principle of least privilege. So regular review, your IAM settings, what have you. It's a managed service, so keep track of your costs. Is it working for you? If not, is there an alternative? Is there a cheaper alternative? And now we will talk about AWS OpenSearch. So you may have heard of Amazon Elasticsearch. This is pretty much the same thing. It's the same product with a new name. And organizations use it for real-time searching and analytics and visualization capabilities from their data. Maybe logs, maybe other environments. So one of the features with OpenSearch is these are managed clusters. So it's automated provisioning, setup, and maintenance of your clusters. Automated backup, automated patching, automated recovery should something go wrong. Because it is automated for you and it is managed, it's going to scale well. It's just about adjusting the number and the type of instances. It's going to support, big environments, petabyte scale data across multiple data centers, availability zones, whatever you want to call them. So as long as the cloud's up for the most part, or the regions up, you should be good to go. Let's think about data security under features. It has VPC support, so you can isolate your data, which means you've got access lists and all that other cool network security you can do. It provides encryption at rest and encryption in transit, and it's integrated with your IAM very simply and very easily. So, integrated with data visualization, well, it comes with OpenSearch dashboards, so any kind of plugin you want to put on there. It also has anomaly detection. So if you're monitoring something and you're looking with it, it's got some AI to help you determine anomalies, which is another nice thing. So how do you set this up? You go to the Management Console CLI, use the SDK, and you create a new OpenSearch service domain. You configure the instance type, the number of nodes you'll need, the storage you need, the network settings. You configure your security settings, like your IAM profiles, your VPC access, security groups, what have you. You enable encryption options for data at rest and data in transit. You're pulling your data, either things like Amazon Kinesis or ingestion tools like Logstash or FluentD, that kind of thing, or a custom script. You build and visualize your dashboards, and you monitor. But like anything else, you run it, you test it, you see what's going on, you optimize your performance, you tune your shard settings, your query performance based upon the results of what you put out there. Obviously, keep your data secure. Monitor your costs. If these things are going to be running all the time and they run on virtual machines because they're servers, and you need it for a long period of time, maybe you can reserve the systems using reserved instances to kind of help eat the bite out of the server cost. Okay, so that is going to be a natural break because we are going to go next into some identity and access management. So I think we should pause here. Chris, let me know if anybody has any questions. And maybe there isn't, and that's okay too. All right, so if you got a question, ask it now. We can take 10 minutes of questions. We'll start getting to identity and access management. If you don't, that's okay too. Personally, me, I think I start the day with 10 questions and end the day with 1,000,000 questions, and always try to ask as many as I can from the people that I know that can try to help when they can help. So, just in case, let's talk about a few things. We've got another week next week, although I'm going to try to work a little extra fast so we can go Monday through Thursday instead of Monday through Friday, if that's at all possible. But we've got one more week to go, which I'm totally excited about. I love doing these things. And we've got these labs that I'd love you to do. Love you to do them. Got some free downloads for you in the video of this. So the question came in, you desire to learn more and focus on AWS security. So at the ending, we will be talking a lot more about AWS security coming soon. I want to make sure that you realize that there is no such thing as AWS security. There is cloud security. 98% of organizations use multiple clouds. I also want you to understand, and it's a great question, that the same security problems we have in the network and the data center, we still have in the cloud. So, we will need to get involved with next generation firewalls and IDS, IPS systems and SIEM systems and data loss prevention systems. And in most cases, they won't be coming from Amazon. But we will be dealing with some Amazon security tools as well. And the key to remember is it's not AWS security. It's not going to be about the AWS security. It's going to be the tools that are going to make our clients successful. And we'll start with IAM, and we'll get into security. Truthfully, we'll cover much of what's going to be on the AWS Security Advanced certification in this course. And I'll do that because that's like that's still not enough security, but I wanted to give you more security than you would get in an AWS certification. And I think you can tell we've gone way above what you would normally get in any AWS certification, but I want you guys to have the knowledge. And I'm thrilled that you're here, you're participating. Some of it gets a little dry, and you're still sticking it in and gutting it out, so you guys are going to do awesome. So thank you so much for that. And but we will definitely get to a lot of security, and I love security. Maybe I'll even do some security things out there coming soon. Got me thinking. Love the concept. So since there was only one person responding, I'm getting worried that you're not awake. So give me a hashtag AWS SAA so that I know you're here. If you're having a good time, hit that like button, subscribe, hit the bell, that kind of thing. And make sure to check out the description of these videos for some free resources. So let's talk about some IA. Okay, actually, I think there was one more question that came in from Amit. Hope we can answer. Would Kinesis and managed Kinesis be functionally equivalent? Yes. Would Kinesis and managed Kafka be functionally equivalent? Well, slightly different. They're very similar in what they do. Very similar. But Kinesis is an AWS proprietary product, and Kafka is a product that works on all clouds everywhere. And it's kind of like comparing a Chevy to a Ford. Functionally, yeah, they're the same, but each car might be designed a little different, might be a little better, a little worse, that kind of thing. And the key one is that is better or worse for what? A Mercedes like I have is smoother on my back. It doesn't hurt. It doesn't perform as well as a BMW, which performs better, but my back hurts sitting in it. So it's all about, finding the right thing for you. So I'm seeing that AWS SAA. And Amos, you got Feldman. Oh, awesome name. I know a lot of Feldmans. And, I know exactly what it's like to get your caffeine. And I definitely would do a song of mine. Anybody that sees me drink coffee in the morning plus green tea, they know I have a little bit too much caffeine. So we're now going to talk about identity and access management, and we're going to make sure you understand this because so many people are confused by this. Identity and access management is three things. Who are you? What are you allowed to do? And what did you do? So that's the key. Authentication is, are you who you claim to be? So Mr. Singh Binner, who's in this, I know him and I know him well. He's awesome, by the way. But if I'm trying to have a conversation with him, I want to know that he's him as opposed to Hal the hacker. So the authentication is you proving who you are, you claim to be. Now, next is going to be authorization. So authorization is what are you allowed to do? So I see Mark over there in San Francisco is here. I know Mark. If Mark came to my house and I gave him the keys to the car and the keys to my house and I said, you can come in and do whatever you want, because I know him, he and his family are great, that would be one level of authorization. By comparison, somebody may knock on the door and they might say, I need to use your phone. And I might walk them to my phone and stand next to them. They're permitted to use my phone, but not necessarily to come into my house. That's authorization, and we'll walk through that a little more. And accounting is, what did you do? And that way they can track the things that you've done. So Mark came to my house. Let's say he came over from San Francisco, stayed with my wife and I. When he left, my wife is going to say, oh, wait, we need 3 new bars of soap, a new bottle of shampoo, and she's going to go to the store, Publix, because that's her favorite supermarket locally. She's going to buy it, and she's going to restock the house. That is the accounting. So I hope that makes sense, because there's lots of confusion there. Now, as a rule, and we'll specify all the millions of exceptions here, AWS defines something into users and roles. So for the most part, at the solutions architect associate level, a user is a person. Mark's a user. Mike's a user. Hal's a user. Nico's a user. Vageli's a user. Maria's a user. So a user is a user. Typically speaking, for the solutions architect associate, it changes with the professional. Like my physics teacher said, education is an ever decreasing number of lives. The more you know, the more specific it gets. But at the associate level, a role is for one system to typically connect to another system. So you may have heard of a service account in Linux or a service role in Google. It is the same thing as a role for the most part, in most cases, but not always. So this is identity and access management in action. You got a user. You sign into the management console. They provide maybe a username, maybe a password, maybe a token, and they are now allowed entry. Next you see is authorization. That's where when you try to access the system, and it either allows you to access the system, or it gives you the access denied kind of thing, and it doesn't let you go based upon your authorization. And accounting is keeping track of that. So I hope this makes sense. Keeping track, a log of everything you did. So let's talk about IAM users. They are identities, hence identity and access management, that have the permission to interact with an AWS resource. So who creates these? People with administrative access, or principals with administrative access. I didn't make up the term. And an IAM user can be created on the management console, the thing you go click the boxes on, the CLI, or via the API. And here's something to remember from a security perspective. An IAM user is permanent unless you delete it. So if a user quits the organization, you have to take away their access. Otherwise, they will still be able to access the systems. So here's the way that I would look at it. Somebody logs in and they are given access to specific resources. You can access this thing versus the other thing, but not everything. So I kind of hope that makes sense to you. So let's talk about authentication. How do you know that the person is who they actually claim to be? Well, there's lots of ways to do it. I know Mark, who's on that chat box. If I see Mark, I know who he is because I know who he is. I recognize him. But, we don't typically use that when we log into one of these systems. So we can log into the management console with a username and password. That worked great. Username and password. But it's not the most secure system. Especially we may have a user Sally and a password Cat. So Cat is very susceptible to what's called a dictionary attack or a brute force attack. So please don't create a password called Cat. But that's neither here nor there. So passwords are problematic. The next option we have is we can prove who we say are with something like an access key. And an access key is going to be a 20-character key ID and a 40-character secret key. So lots of long keys here. And the access key will be used to connect to AWS via an API. And this is generally performed with the software development kit over an API call. We can also come in with an access key and a token. For example, when IAM authentication needs to occur under an assumed role. Which is, well, maybe we shouldn't go right here. But what will ultimately happen there is maybe you go in and you're using some form of a federated identity management, or you're going into a cross account and you're assuming a role of something. So you can use a session token with the access key. So now you've got a token and an access key. So it's additional security over the other methods. So that's authentication. Are you who you claim to be? Now, in reality, in our architectures, we can use the iScan for authentication. We can use a thumbprint. We can use something you have and something you know, like a password and your thumbprint. We can use something you are, like your iScan. So there's lots of options that we can use as a rule for identity and access management. But for the AWS exam and for AWS IAM services, those are options to log into at least our AWS account. Now that's authentication. So let's talk about authorization. Authorization will occur by giving you specific privileges that will have been defined by the identity and access management thing. So you write a policy. Alonzo can access this, but not this, or all of this, or what have you. So you create a policy. Now, I can create a policy one of two ways. I can create a policy for Alonzo, a policy for Chris from my team, a policy for Mark on my team, or I could all say they're all C-suite users and create something for the people that are in the C-suite, chief marketing officer, chief operating officer, chief technology officer, and say all of them get access to the same level of things. That's called role-based access control. And in a small company, it may not make sense. In a big company with 100,000 employees, you don't want to manually assign 100,000 different sets of permissions. Now, on AWS, IAM policy documents are going to be written in JSON, JavaScript Object Notation. And the good news is, like any security thing, the default policy should be to deny. So the default policy is to deny access to services. So you're going to have to configure what you want to allow. So you're going to create a policy. And what you're really giving it is a couple options. And in these policies, you're basically going to say, do I allow something or do I deny it? And, what is the service we're going to be able to access? So when you want to give a granular policy and you're going to use a service, you're going to be putting in what's called the Amazon resource, the ARN number, the resource identifier. And that's where you're going to get very specific with what you actually have here. Because you allow certain things like an effect, which is you've got certain things that you can actually control. But what is it access? So you're going to provide actual granular access to what you want. Of course, you could just provide access to allow almost everything, but that would kind of mitigate the need of doing this. You want to be very granular in what you allow. So we're going to specify an action, which is really the permissions of the user. Can they read? Can they write? We can get optional conditions. So we can get even granular, like a specific subnet at a specific time of day will be able to access these systems. See if I can show you this, because here's what a full IAM policy might look like. Never mind, I don't think that's going to be helpful. So here's what I kind of meant about limiting permissions. So we're going to want to limit our permissions to the least amount someone needs. When it comes to security, you don't want to give people more access than they need to know. You're not going to be allowed to walk on a certain part of a military base unless you need access to that certain part of a military base because it's a secure facility. So it's the same thing digitally. Give people access to the least amount of privileges they need to do their job. Why? Because when people have more, they will go out there and they will find some way to accidentally break the system or hurt you. So that's why businesses do this. So here you can see a user wants to access the system. And they go over and, they can access S3. No big deal. They're authorized. They can access DynamoDB. But when they go to that management console, they are not allowed. And why might that be? Maybe the user needs access to the data in object storage. Maybe, just maybe, they need to be able to look at the database and run a query. But maybe they don't need to be able to create user accounts. So, they wouldn't have access to the management console. So let's talk about some key concepts that you should think about as you think about AWS and identity and access management. We have some things we have to define. We have to define what is a principal. And a principal is going to be the IAM entity that we're actually talking about. And that entity is going to be something that has permission to access the AWS cloud. So it could be the root user. That's the king and the queen of everything. And we'll talk about that in a minute. It could be an IAM user, any user that's created. Or it can be a role. one system attaching another system or some form of federated identity. The root user, well, that is the user that can do anything. That's the user that created the account. If you're the root user, you could literally speaking delete your entire account. That would be pretty bad, right? Kind of like when the Google Cloud deleted and accidentally deleted a $240 billion hedge fund. Like that. Well, here's the key. That root user has unrestricted credentials, which means they can damage things even accidentally. So don't log in with root. Where have you heard this before? Don't log into your Linux system with root. It's the same reason. Now, because that root can delete the account, don't give the root access to everybody else, and don't do the user root password cat, because this is the thing that you need multi-factor authentication, super strong passwords, all of it. Hope that makes sense. And don't use root access. I think it probably goes without saying for programmatic access. So don't let this system talk to this system with root access. Here's always been the way I've always viewed root in my head. It's that king or queen that can literally do anything they feel like. Unlimited privileges inside of their systems. So there is that. But if you have to protect the king or the queen, what do? You typically speaking have lots of security. So be real secure with that root account. Now, when it comes to AWS, they use standard concepts like users and groups and access control policies. So a user is a person. A group is a group of users. So we have this concept of role-based access control. Here's what role-based access control is. Option 1, I assign manually to every single person. Do you think that's going to work? Really? What if you're Amazon and you have 1.5 million employees? Do we have somebody sitting there all day long? Hold on, I got to go type in these usernames and accounts. And, 100 people leave and they got to remove them, and 100 people come and they're all day long. Click, 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 click. Okay, no, we're not going to do that. So what might they do? They might have sales reps that get put in one group. They may have cloud engineers, which puts in another group. They may have solutions architects in another group. They may have software developers in another group. And that determines who can access what. They may have network engineers that build the AWS cloud and make sure that it runs in another group. So here's how it works. Create your groups of users, add permissions to the groups, and add your users to the groups. That's it. That's role-based access control. So AWS supports that very well. Now I'm going to talk about IAM roles. And for the most part, for the associate exam, what you're dealing with is users are people and roles are systems. For the most part, for the associate. Now, if you're going to take the AWS Solutions Architect Professional, or actually want to function in the real world, you're going to need to know a little more about these types of roles. So we're going to go talk about it the way we would in the professional exam. So we have a couple kinds of roles. We have what's called a service role. And a service role is when you have one system accessing another system, kind of like a service account in Linux. We also have what's called a cross-account role. So what is that? So let's say I am a car manufacturer and I have a tire dealer. We might want to create some strategy where the car manufacturer can log into the tire manufacturer's information so they could see the type of tires that are available and the pricing of the tires. So a cross-account role is when you go from one account and you get permissions to go into another account. That's a cross-account. Service role, one system to another system. Cross-account, one account to another account. And next is identity federations. Seriously, do you really believe that anybody's going to go in there and start configuring these AWS identity and access management systems at an enterprise scale? Or does the enterprise already have a Microsoft Active Directory structure set up where it's got all of its, 100,000 employees already in Active Directory? So what we're more than likely going to do in the real world is we're going to federate the AWS cloud into something like an Active Directory, where the organization maintains their own identity and access management systems, and they integrate it. So when you log into, say, Microsoft Active Directory, it'll automatically log you into AWS for you, like a single sign-on approach. Now, roles, especially a federated role or something like this, tend to enhance security because we don't need to put, say, AWS credentials on one system that's attaching to another system. We're generally not putting a password in one system to go into the other system. We're going to use temporary tokens, where these tokens periodically authenticate. And that way, if a token's good for an hour, just for example, and a hacker gets access to the token, by the time that hour is over, it'll be gone. They won't have access to the new one. So worst case scenario is the length of the token. But of course, if it's a 60-minute expiration and they attacked it at 56 minutes, that token's only going to be good for 4 minutes. Of course, if they attacked it at minute 1, it would be good for 59 more minutes, assuming the token expires in an hour. And these are configurable settings. So tokens are rotated frequently, and no long-term credentials are stored on the server. So these service roles tend to be very good. And the key to remember is roles are used for either a system to reach another system. They are used for an application to connect to another service. They are used to connect to another account, and they are used under federated identity and access management. And tokens are temporary and expire, and the default expiration time is actually 60 minutes. But you could set that token to 15 minutes for a really high security environment, or 36 hours, for a different type of environment. And typically roles are used to grant permissions for one system to another. So now let's talk about that AWS Security Token Service. So that's going to be a web service that's going to enable you to request limited privilege credentials, so a token, or use federated identity access management users. So credentials will be used to access AWS resources. And the rate when you don't want to use long-term credentials like a password inside of the system. Some things to think about the AWS Security Token Service are temporary credentials. They provide very temporary security credentials that include an access key ID, a secret key, and a security token. And these credentials are short-lived and they automatically expire, so they protect you should a hacker get access to it. There's this concept of the IAM role assumption, and what's going on here is it allows users or services to assume a role or an identity to get temporary credentials. And this is going to enable, say, a cross account where you're at that, again, like at that auto manufacturer trying to get into that, say, tire manufacturer in the least amount of privilege possible. Federated user access. Have you ever logged into a website and it says log in with Google or log in with Amazon or Apple? Your Apple ID, that's federated identity and access management. Or it's logging into the Microsoft Active Directory, which enterprises typically use. And that uses SAML 2.0 typically, or OpenID Connect to identity providers. Security token services give you very fine-grained access control. So where might you use this AWS Security Token Service? Well, with cross-account roles, one role going into another. In any kind of federated access environment, connecting to, say, Active Directory. Mobile and web applications, you might use something like this because you may want to provide temporary credentials for a mobile application or a web application, because that's going to reduce the risk of putting or embedding long-term credentials in your applications themselves. Anytime you want to give short-term access to grant, say, temporary access to AWS resources to maybe a third-party vendor to come in, you want to be very careful about the access you give to third-party vendors. Very careful. So how do you set this up? Well, for the AWS Security Token Service, you basically create an IAM role. And then you'll do that in the management console. You'll go to the IAM section and create a new role. You'll define the trust policy. So meaning who can assume the role, which users can go where. You'll attach the appropriate permissions to the role. And then when it's time to assume the role, what'll happen is, typically speaking, your APIs will do this for you. But if not, what you could do is you could go to the AWS command and you can assume a role. And what's happening when you assume that role is it's going to send a request to the security token service, and that's going to basically use this role learn parameter. And what it's going to do is it's going to specify something like the Amazon resource name of the role you want to assume. And I showed you those Amazon resource names when I showed you the identity and access management policies. And that was that thing with the ARN : AWS : IAM, that sort of thing. Some things to keep around here and think about when you set these things up, or best practices, are to give the principle of the least privilege. You want to really define these roles very granularly and don't give access to more than you need. Use very short-lived credentials. Use the shortest possible duration for temporary credentials because you want to minimize security risks. And you want to regularly rotate temporary credentials, because the longer these credentials are good, the longer the time somebody has to get them and then use those credentials to access your systems against you. Monitor and audit your systems. Enable monitoring and monitoring of your AWS STS APIs. Log it onto CloudTrail. Review those CloudTrail logs and monitor role assumptions and temporary credential changes. Are they ones they're supposed to be? Use secure protocols to connect for federated access like SAML 2.0. Use multi-factor authentications with the identity providers for added security. For example, in a single sign-on environment, or in any one of these roles that we're going to assume, if we get access to the systems and via a weak username and password, we may be able to access everything on the end state, especially with single sign-on, where you sign into one and you get access to everything. So make sure the authentication is strong, maybe like multi-factor authentication. Bear with me one second, I want to think about something. You know what? I will cover cross-account roles, and then we'll get into managed policies tomorrow. So I know I briefly talked about cross-account roles, but cross-account roles basically give you access, and I mean Monday, not tomorrow. Cross-account roles give you access from one AWS account to another. And this can enable businesses to collaborate. So think about this. You allow someone access into your facilities or your systems. They can help you. They can hurt you. If you connect to another account and they get hacked, they can hurt you. So we have to think about all of these security-wise. So it's not just IAM. It's going to be the networking side, the security side, firewalls. There's lots that needs to be done to go from one account to the other. This is just on the who are you, what are you allowed to do kind of thing. What have you done? So when we deal with cross-account roles, we have to be very concerned on security. We at minimum need to focus on that principle of least privilege, but we may need other types of security along the way to connect from one account to another account. So when it comes to cross-account roles, you may hear the concept of an external ID. And an external ID is going to be a secret identifier that is known by you and the third party that you're connecting to. And you need to be able to specify this ID when you specify what's called a trust policy. And a trust policy is related to exchanging of information, typically in identity and access management systems. If I trust you and you trust me and somebody asks me a question, then you trust that I authenticated them accurately enough to let them into your system. That's typically trust environments. So here is a visual example of what this looks like. You've got multiple companies, and you may let them into your VPC or agree to share information with them. So how do these cross-account roles really work? A role is created for the external user. The external is going to connect to their AWS secure token service, and they're going to get a temporary token. And then the user will provide that temporary token and be given temporary access to the end user's VPC or account. Actually, I'm going to just briefly touch on service roles. I know I mentioned them before. So I like to think of a service account because I used to love playing with Linux, and you could have one account that would connect to another account, and they would call it a service account. Never used Linux in my job, but I always thought it was fun and cool, so I always just loved Linux. So, but it's not part of an architect's career. So we may have one system that's attaching to another system and need to be able to do that. And that is going to be called a service role in AWS, service account on Linux. But think about where you may use this. You may have one application that needs to make a secure API call on another one. You may want to be able to post messages into SQS, the queuing system we talked about yesterday, or the day before. It could be yesterday. You may want a virtual machine to be able to store something in an S3 bucket. You may want your application server to integrate into your database. So that's typically where you would do a service role. Let me show you what that looks like. Virtual machine, accessing DynamoDB, definitely a service role. Okay, so we have gone till 5, which is what I promised, and I'm going to try not to get everybody out too late. But do you all have questions? Any questions you want, I'm happy to answer them now. Let's see. And if you're having a good time, hit the like button. If you haven't downloaded any of our labs, please do, or signed up for our pre-labs, please do so. So, Fa has a great question. Who usually creates the IAM users or roles in AWS? So, generally speaking, we have systems administrators that create users and remove user accounts. They're typically the people that do it. So, architects design your systems, engineers build and performance tune your systems. This kind of add user, close user, doing simple install of an application is typically done by a sysadmin. In the cloud, they would call it a cloud admin, but it's really the same job for the most part as a sysadmin. They might be setting up the Linux machines, patching an operating system for Windows or Linux. But it could be the engineer that's actually building it. Or, in all seriousness, it's typically going to be done by a systems administrator. But the reality is this. Most businesses are going to be using some form of an enterprise identity and access management platform like Microsoft's Active Directory. So what will ultimately happen is someone will be setting up the federation between the Active Directory and AWS, and that would probably be a cloud engineer because it's going to need more sophistication in most cases than just the cloud admin, which is more that technician, the add users, patch kind of thing. Good question there, Paul. Can I define SU to root? So, generally speaking, SU, it could mean switch user, but it's really super, like SU goes up to super user, which is how you change into root, for example. So you would do an SU, and then you could change your user. Typically, people might do a sudo, SUDO, and that would enable them to obtain root permissions to actually be able to do things. But SU is just to switch users. But typically, if I'm the user M. Gibbs, the only time I would probably do SU for me is to basically be root to update my system. But I could be logged in. Let's say I had a Linux machine. I used to. And I had lots of Macs. And I could be logged in. And maybe my wife would want to go to my machine and SU and go to L. Gibbs versus M. Gibbs because she's Lisa Gibbs. So that could be a possibility. But SU is more about switch users. But we typically SU. And then we go to root. And then we go to the root password. But sudo is a much better way to do it. Sudo enables us to go to have root permissions to do an install script, access the system, without becoming root where we can accidentally delete the entire system. and be logged in as a different user and not have access to our own data? Well, we kind of could, kind of would. Good question. What kind of directory server on AWS uses? So I don't know what you mean. Are you asking for AWS, the cloud provider themselves? Or are you talking about AWS Directory Service, which we'll talk about, which is basically them having Microsoft Active Directory servers that then they do manage for you? So there's that. Because, AWS has a managed Microsoft AD, which is they manage your Microsoft servers for you. And then there's kind of like a simple AD, which is a standalone managed directory. And then, of course, there's that AD connector, which if you've got your Microsoft Active Directory servers in your data center, you could use that AD connector to connect your Microsoft Active Directory servers and your data center to the AWS IAM system. I hope I can help you become a cloud architect or similar. Amos, I can easily help you become a cloud architect. I've trained people that work at Apple, Amazon, Cisco, IBM, Microsoft, Google, Accenture, Deloitte, Capgemini, PricewaterhouseCoopers, Barclays Bank, JP Morgan Chase Bank, Zscaler, Palo Alto Networks, everywhere. I will tell you right now, becoming a cloud architect is not about certifications. So what I would like you to do is as follows, and I'd love to help you, and I can easily help you. First, get the completely free ebook on how to become an architect. My team will pop it in there right now. And secondly, join me next Thursday. Next Thursday, we're going to have a How to Get Your First Cloud Architect Job webinar. We will go over the role. We will talk about everything we do, all the skills you need, and we will list them. Now, we'll tell you how we typically teach them, but we'll tell you what those skills are, and you can choose to get those skills from other providers as well, universities, presentation skills coaches, but you'll know what is the role, and you can easily get it, and it doesn't matter your background. I mean, it just doesn't care. I don't care if you're Richard Ferrari, who we trained, who got his first job in tech as a solution architect at MUFG. I don't care if you're Lenny Burnett, who was our video editor, who left us with a solution architect job. I don't care if you're Jermaine Houston, who was selling landscaping gear before we got him hired as an enterprise architect. I don't care if you're Jennifer, who we trained and got our hired from a mental health tech to a solutions architect with JP Morgan Chase. I don't care if you're Yvonne Tambor or Coyote or Jordan Kikitko, who were college students who left our program as solutions architects with AWS. I don't care if you're Daniel Bosu, who got hired by JP Morgan Chase. I don't care if you're Al Legister, whose first tech job was a senior solutions architect at Deloitte. And I can give you examples all day long. Yes, you can, and we would love to help you get there. But I want you to know what is the role, and that way it's all about getting the right skills. And you will have a job that you absolutely love, because it's the best job out there. So, I had a good week. I hope you had a good week. I hope you guys learned this week. I hope you learned some things that were in the Solutions Architect certification. But I hope you learned a lot more. I hope you learned about some best practices and things. I hope you learned about what some of those virtual machines were by coming into our data center. I hope you learned a lot of things. Maybe learned something about Kubernetes, which is not even covered in this exam for the most part. I hope you learned some things about networking, and specifically in the cloud, because we went way deeper than we could have. So if you had a good time, please give it a like. If you've not done the labs, please go sign up for the labs. They are 100% completely free. And I had some fun. Give me a hashtag, AWS SAA. I'm proud of you all for hanging around here all day, all week. Well, we got pretty geeky diving into the stuff. We'll leave the content here if you want to go through it again. Keep that out, right? We're going to add, obviously, much more security and many more other things networking. So I hope you're having a good time. I'm honored and privileged to be with you. So have a great weekend. I see those SAAs are popping up. I'm so happy to see that. And I will see everyone on Monday. Welcome, everyone. This is Mike Gibbs, and welcome back to week 2 of our free AWS Solutions Architect Bootcamp. And this is the Go Cloud Careers AWS Certified Solutions Architect 2024 program to help you pass that AWS Solutions Architect Associate Certification, otherwise known as the exam SAA-C03. So we've had a fun week, or at least I had fun. I got to speak with people that were all over the world. We've had lots of interactions so far, and we're now here for week 2. So we're going to continue where we left off, but in case you're new to us, in case you've just joined us, I'll go through a few housekeeping events. So if you've just joined us or just saw this 6th video for the first time, we have 5 more days of videos for you to go back for to make sure you truly understand this AWS Solutions Architect Associate Certification. So go back. You can watch the first 2 weeks anytime you want. Each day will, for the most part, stand alone, so you could start now and go back and watch those individual things and be just fine. Because we're basically spending 2 weeks for 3 hours a day just covering the core concepts, we also want to make sure you have the opportunity to get hands-on if you're going to be in a hands-on career like a cloud engineer or a cloud admin or a DevOps engineer. We want you to get that hands-on. So we have about 40 plus hands-on labs for you to do. You can sign up for them. The link is in the description of this video, and my team will pop it in the chat box as well. It's completely free. Go after it. And go do them on your own time. I also wanted to say from a housekeeping perspective that we've written a document on how you should approach your certifications. You know, it saddens me when I see people that have got 10 certifications, but they all show me that I can't hire the person. But if I see 2 or 3 big certifications that point one person down that shows focus and competency, I'm much more inclined to interview them. And they're much more inclined to actually have the right skills in their careers. So we have a free guide on how to get the right certifications and the certifications for your goals. So please download that. It's completely free. While we're at it, in the chat box, we've got a free ebook on how to get your first cloud architect or solutions architect job, and it's free. So go get it. And we're going to have fun today. So tell me where you're from. I see some Seattles. I know some of you are in certain places. I see Bo, Cameroon, which I love. I see people that are in Colorado. I see New Jersey. I see Canada with Renato. Renato, it's always good seeing you. I know Tyrone from our team is in Cape Town, South Africa. I know Eddie from our team is here in Bamenda. And I also know that Alonzo from our team is in Katy, Texas. Where are you from? Or where are you at today? Or maybe a little of both. I also want to know that you, so let me know that. And also, while we're at it, I want to know that you are awake, you are alert, and you are oriented. I'm a medical person, and that's just one of those questions we always ask before we start to make sure everybody's there. So if you are, and you're hearing this and you're listening, give me a hashtag AWS-SAA, hashtag AWS Alpha Whiskey Sierra Sierra Alpha Alpha. Sorry, I was going to go to the exam number there. So wonderful, wonderful, wonderful. Now I will see those pop in, and we will get to the content. And if you're new and you're just catching this or you've been here, invite a friend. It's completely free. Maryland, I saw Pennsylvania. I lived in Pennsylvania there for a little while. Actually, like 20 years. Okay, I'm seeing it. It's almost, the hashtag is almost there, so we're good to go. So we will begin. So if you'll recall, last week on Friday, what we actually did was the following. We talked about at the end of the day, identity and access management. And if you haven't been here, we talked about identity and access management, which really is authentication. Who are you or who you to claim to be? So in other words, if Cindy knocks at the door, I know it's Cindy, I might be willing to let her in. But if somebody knocks at the door and it's not Cindy, maybe it's Sally, and I don't know Sally, and Sally's pretending to be Cindy, if I know it's not Cindy, I won't let her in. Cindy's my cat, and she walks in and out of the house all day long. So authorization is what are you allowed to do? So do you have the privileges to access something? So, that's the authentication piece of it. I'm sorry, the authorization. Authentication is who are you? Authorization or what are you allowed to do? Are you allowed to access the whole house? Are you allowed to access all the systems or just a subset of them? And then accounting is keeping track of what you've done. So go back and see, we talked a lot about role-based access control and other things, and federated identity access management. I thought it was kind of fun. Token services we talked about, but today we're going to talk about creating and the identity and access management policies. So when it comes to this, you're going to have a few options in how you do this, but the IAM policy is going to be the policy that's created to allow it to determine who users are, what they're allowed to access, and keep track of it. So I talked last week about when you create an IAM policy, you can get very specific, and you're going to assign permissions to specific resources or all of them. And when we write these policies or create these policies, we want to provide access to the specific resources that we need and not to the resources that you don't need. That's the principle of least privilege. And I also talked about when you provide access to a specific resource, you do it based upon the Amazon resource name. And we walked through it last week where it was that ARN colon, and we walked through so you could see what they looked like. Now, you could, instead of accessing one specific thing, put what's called a asterisk or a wildcard, kind of those Boolean expressions, if you will, or regular expressions, if you will. And the wildcard means anything. So you could do that. Basically, you could permit everything, but why would you permit anything when it comes to security? So there's two main policies around, and they're going to be AWS managed policies and customer managed policies. So let's talk about an AWS managed policy. When you deal with any type of vendor's identity and access management system, chances are they've already made pre-made roles for you based upon common business use cases. So there'll be a use case for, say, a systems administrator, or a use case for this kind of user versus that kind of user. And you can use the standard policies that were created by your identity provider. And if you're going to be using the AWS system, you can easily use the AWS managed policy. And they're optimized for common use cases. There's typically two major predefined roles. And there's administrator, which can access everything and do everything. And then there's the power user, who can basically do everything, but they don't have access to identity and access management systems or organizations, which are a way to basically divide an account into multiple accounts and then use IAM between them. There's a lot better ways to secure your data in between organizations than just identity and access management. But some of them get expensive to use, and some add some complexity. So it's a way that you can segment your system if we talk about organizations. So administrator, everything. Power user, everything but IAM or anything that be IAM based, like AWS organizations. So there's an alternative. And regarding managed policies, what you realistically do is you're going to sign into the IAM console with a user account and administrator privileges. And from there, in the navigation pane, you'll just choose policies. And then what you'll see is there's a list of AWS managed policies, and they're simple to use, updated by AWS, and it can avoid, major configuration errors if you're not very skilled. And it's going to work for most use cases anyway. Now, what if you need a custom policy and you've got users that need lots of different specificity, or maybe you have something called separation of duties where you have a team of people and each one of them can only do certain things separately, and that way one person can't do too much damage if they're a problem, so which you may see in high security environments. So there you're going to need a customer managed policy, and this is a policy that's going to be created and managed by the company for their own unique needs and their own account. The policies the customer create will not be visible outside the organization, and they're going to be custom tailored, so they'll be attached inside of the AWS account. So how do you create a customer managed policy? Well, if you've got someone great that's good at programming, they can just write their own policy in JSON. It's easy. It's no big deal. But what if don't have someone that's familiar or very good with JSON? You got a couple options. One is you can use the AWS policy generator, and it's a web page where you go to and it asks you specific questions and it generates a policy for you. The alternative is you can basically use an AWS policy and open it up and edit it to tune it to your needs. So that's how you would do something. Policy generator is a pretty easy kind of page to go to. I'll show you what it looks like. So you go to this policy generator, and basically you tell it what kind of policy you want. And you go allowing something or denying something. That's your effect. To which AWS service, which is where I talked about that Amazon resource name. And what do you want it to do? What's the action? So pretty easy, pretty simple. They do try to make it relatively easy for you. So that's, how you would create the policy. So you've created the policies. How do you apply them? And typically speaking with AIM, you create a policy and then you either add users to the groups or what have you, or you apply a policy to a subset of users or what have you. So how does it work here? So for the policy to work after you've created it, it needs to be associated with something called an IAM principal. And an IAM principal is anything that can use the identity access management system. Now, you can apply this to a person like Cindy. You could give a special policy direct to Cindy and only Cindy. And that's totally fine. But let's say you've got 1.5 million people working for you like Amazon. It's going to be pretty hard to create too many of those policies and give them to just one person. You may want to do it for the C-suite, a very small number of people or a few special scientists that are there. But you're not going to do it for most. So for most, you're going to divide it into this role-based access control, finance users, systems administrators, what have you. And you'll apply that policy specifically to the groups of individuals or systems that you would use. And that way, and in role-based access control, I'd say group, systems admins. And then I would add the users, Billy, Sally, Joey, Hal, they get all added to the group. That's role-based access control. So another diagram we do, I hope this kind of makes it easier. So you may have an account. It could be the Cindy the cat account. And under the Cindy the cat account, assume she's a famous cat and she's got her own website and she's got her own business and she's selling memorabilia and tuna. I got a very innovative cat, who knows? So Cindy would be the owner of the account. She may have some administrators, some software engineers making Cindy the cat websites. They may have another people that are actually testing the websites, maybe a group of cats that are trying to see if the cats like the website and they're going to be interested in using their paws to click buy on the keyboard, somehow figure out how to manipulate their owners to get their credit card from them. It's not that hard. A cat can get anything at once just by looking at you. So there's that. So we might create this big account. Then we've got our groups and then we add users to the group. So the testers are Mark, Joe, and Ben, and they're added to the group test, and test has its own unique policy that's applied to it. Likewise, the developers, would be Dave, Jake, and Emma, and they will get the policies that you assign to the group developers. And the group admins, John and Grace, they get admin policy or what they need to do their job. And the key to remember here is never give more privileges than are necessary for people to do their job. So what other ways can we improve our identity and access management system? Well, a username and password is not the best. And, it can be broken with a brute force attack or a dictionary attack. And, the better computers we have, the faster it is to break passwords. So typically speaking, a two-factor authentication is going to be better. And we should use two-factor authentication to secure our IAM accounts whenever possible. Two-factor is something you have, typically speaking, and something you know. So if you want to pull money out of the bank and you get your ATM card out and you stick it in the cash machine, you have the card, right? That's something you have. Something you know is your PIN number. So somebody steals your card and they don't have your PIN number, they can't access your account. Something you have, something you know, two-factor authentication. Now, two-factor authentication can be done a lot of ways. It can be done typically with a one-time password that's going to change every few seconds. And there's commercial things that are out there where basically you see it, the key will be a key fob and it'll constantly give you a one-time password. You can also use things like a Google Authenticator app where basically you give it a seed and then it will create the it will know exactly what kind of one-time passwords we're going to create based upon the seed, and it'll change periodically every few seconds. So I'm sure you guys deal with this every day, but this is called multi-factor authentication. Try to log into your console. It sends you a challenge or sends you a text or something like that. And then you provide your one-time password, and Bob's your uncle. You have access to the system, assuming you've got the right password. Done it, and it is simple. So, talk a little bit more about identity federation. It's not going to make sense in an enterprise environment for someone to be creating IAM accounts in AWS and then have that company create IAM accounts for Active Directory for all the systems to access the systems which they're typically using. And then another IAM system, maybe for this system and that system and the other system. So what organizations do is they create what's called identity federations. And they store all their identities in a single place. Usually Microsoft Active Directory in the enterprise. Now, there are other ways you can do this as well, which we'll talk about in a minute. But the key components of an identity federation are an identity. That's the user, like Cindy the cat. The identity store, which is where the identities are stored. Typically, Microsoft AD in the enterprise environment. But in the non-enterprise environment, you ever see somebody say log in with Facebook or log in with your Google account or your LinkedIn account or your Apple account? They are an identity store. So identity is the user, like Cindy the cat. An identity store is where the identities are actually stored. And then as part of identity federations, we also have to have an identity broker. And what is this? It's going to be that thing that goes in between the AWS IAM, and it's going to go to that Microsoft Active Directory or Facebook or what have you. And then it's going to come in and provide temporary credentials to access those AWS resources. So users, Cindy the cat, identity store, where Cindy the cat's access information and her pod directory is sitting inside of Microsoft Active Directory. And the identity broker is going to go check with that Active Directory and then provide whatever is necessary to access the AWS system. So what's really going on under the hood when you try to make this happen? So the user is going to log into their identity broker with their corporate credentials. It's going to feel very familiar, like when they normally log into work each day. Now, that identity provider will basically authenticate the user, and it's going to be based against that, typically an LDAP-based identity store that they have. The identity provider will generate something called the SAML assertion, which is going to have all the required user information, and it will send that assertion to the identity broker. Then the identity broker is going to get that SAML assertion, and it's going to call the assume role, the SAML, and that's going to hit the AWS Security Token Systems API. And it will pass that SAML assertion on to the role for the whatever is needed to be assumed. And then if the API response is going to be successful, it'll issue temporary AWS security credentials with the appropriate permissions. And then you've got those temporary credentials. The client application can perform whatever it needs to or wants to on AWS. So identity federations means scalability, because identity is that last line of defense. I mean, don't want you thinking that identity and access management is really good enough security in and of itself. And I want you to think about it. Identity and access management is someone knocking on your door that's saying, I'm here. So if you think about that being enough security, it's not. Wouldn't it be better to have a giant, 100-foot fence around the building, and then maybe a moat that's filled with sharks and alligators and then scary things, and then maybe another something to protect your house long before people could knock on your door, if you're truly building security? And in cybersecurity, we do the equivalent of these giant walls. You could call it a firewall, and a moat would be like an IDS IP, and I would be in a next generation firewall with the intrusion detection, intrusion prevention capabilities. We might use a network-based IDS IPS system behind those firewalls, which is like having guards behind them. But there's the point. Identity is not enough security, but it is part of security, and it matters a lot. But it's not going to scale if you've got users that have to click on everything. So federations are going to be the way to go. And the way it works is there's what's called a trust relationship between AWS and the identity provider. How does that work? What do you mean by a trust relationship? So Alonzo works for me, with me at our company. He's awesome. I trust Alonzo. So if Alonzo says, Mike, I heard this or I did this, I trust him. And then I might tell someone else on my team, Alonzo saw this, go act on it. And they'd see yourself and I say, I don't care. Alonzo told me and I trusted him. So that is a trust relationship. And that's what's going on with the identity and access management system. If you say that this is a trusted Active Directory, AWS will believe you. So there's going to be a connection that needs to be made between these two providers. And that connection is going to be either made with an OpenID Connect or something called Security Assertion Markup Language 2.0. SAML is typically what you're usually dealing with. And that external identity provider can be anybody you choose it to be. You could choose to trust Google. You could choose to trust Amazon. You could choose to trust Facebook or Apple or Twitter or LinkedIn. That is up to you. There are lots of identity providers that are out there. So with this federated environment, AWS identity and access management functions are done and performed by the identity provider. The user will attempt authentication. They will go to that identity provider, and then the identity provider will get the IAM authentication, give the IAM authentications and the privileges to the user. So gives you scalability. Now imagine connecting with 3 different clouds. Imagine connecting with network devices that are used for remote access VPNs. Imagine you've got users and accounts with third-party providers. This is why people need some form of federated identity access management system. Here's another thing to think about. And in some ways, this enhances security, and in some ways, this reduces security. Single sign-on. And this is something we typically do with federated environment. In a single sign-on, it's an authentication method that's used to securely authenticate users to multiple things by logging in once. So AWS single sign-on is a service that will let you sign in one place and then access a lot of things. So sign in on that Windows server and then access anything you want inside of AWS. Typically used there. So why do I say it can enhance security? Well, if you've got too many sign-ons and you force passwords that are too complicated, what you see is users will effectively put little sticky notes with passwords on their desk. Sadly, I've seen this in way too many high security enterprises. So that's going to be a backdoor. But you want to make it easy for your people to sign in and use good secure passwords. So if they have less of them to remember, you're good. Here's the problem with single sign-on. Get access to that compromised account or password. Now you've got access to everything. So it's a trade. Everything in architecture is what do I gain versus what do I lose? Is it better based upon the business needs or is it better based upon this? So architecture is never really a technology conversation. It gets to technology, but it's all about which has a bigger impact on the business in which way, shape, or form. So this is what it's going to look like. Basically, the company is going to have their on-premise Microsoft Active Directory system for IAM. You connect in the single sign-on environment, and now you can access the systems on AWS because AWS trusted your Microsoft open-premise Active Directory service. And then you told your Active Directory service to trust that AWS IAM, and therefore the trust works, and therefore this single sign-on can work by logging into one system and be given access to another. Oops. All right, so next, let's talk about Amazon Cognito. And Amazon Cognito is going to be a managed service that's provided by AWS that enables you to add authentication, authorization, and user management, for the most part, to your web and mobile applications. And it's going to make it relatively quick and easy. So Cognito is going to support sign-in with all your identity providers using SAML 2.0 and your federated identity providers. And it's going to enable you to have an easy approach to the system. And what you're going to see is the user is going to access the system. They're going to go to that Cognito user pool and they're going to get there. They're going to authenticate and say, I am Cindy the cat. And yes, this is my paw print. So you verified me. And then Cindy the cat's going to be given tokens from the Cognito user pool. Then Cindy will use that token that she got, which she provided, they say authenticated her baby or paw print. She'll give it to Cognito and then she'll have access back to pretty much any AWS service she's allowed to. So that's going to be the way Cognito works. So let's talk about some features of Cognito. It lets you set up a user directory for, say, single sign-on. And because it enables that, and it's a managed service to help you with these types of sign-on systems and identities, what happens is you're going to have multi-factor authentication, account recovery, those types of things. You're going to be able to create what's called identity pools, and these are really federated identities. So it'll enable you to grant users access to certain AWS services, and users can be authenticated via identity providers like a Facebook or a Google or SAML into an Active Directory. Now, Cognito is pretty robust. So it connects to your identity providers, your big ones like Facebook and Google, but also Active Directory. It allows for multi-factor authentication. It provides just use temporary tokens using a secure token service so that you're getting a token versus a password, and tokens expire. So should a hacker get access to a token, the token's length and how long that hacker will have access will be very minimal because the token will expire, unless you chose a long time. Cognito gives you the ability to really customize that user interface, and you can store user profiles and their attributes securely and simply. So some key things to think about is we have to create these user pools, and users are going to sign up for the application, potentially using email or a phone number or an identity provider. The users are going to be able to sign into these user pools using their credentials, and Cognito will handle the authentication process. From a user management perspective, under user pools, you can add and manage user accounts, forms of verification, password recovery, and profile updates. Now, let's talk about identity pools. And these are where, so federated identities, this is where it's going to authenticate users via external identity providers. And it's also under the identity provider is going to provide these temporary tokens. And it's going to issue temporary AWS credentials to any user that's authenticated through the system, giving them access to AWS. But it's a token, not a password. So how do you set this up? You create a user pool in the Amazon Cognito console. And you'll click that user pool and you'll name the pool. And then you'll configure the full settings. What kind of attributes do you want? Do you want multi-factor authentication? Do you not? And then you review and create the user pool. Then you have to create the client app. So after the user pool, you have to create the app that's going to generate the client's credentials. You'll have to configure the settings for this, how you want the application to flow, for example, when you want the tokens to refresh or expire. And then you're going to integrate that into your identity provider. So the app can actually be integrated to the provider, so of course it can be authenticated. Then you're going to create an identity pool in Cognito, and that'll be in the identity pool selection, and you'll create one. You'll link that identity pool to your user pool and any other identity providers you want. You'll configure those IAM roles for authenticated and unauthenticated users, and then you integrate it with your application, typically via Cognito software development kit. So think to do this. And here's where you're going to implement your sign up, your sign in, and even your user management features. Okay, so let's talk about Actually, let's take a few minutes to see if there's any questions, and then we're going to get into Microsoft Active Directory. And if you have some questions, Tyrone will pop them in the chat box for me. And if you don't, we'll keep going, and I'm happy to keep going. I'm actually going to try to make sure that we go, but maybe if we go a few minutes each day, I'm going to try and finish by Thursday this week, by 5 p.m. instead of running all the way through Friday. I'm going to try, but if you got lots of questions along the way, we'll keep going. How to recover lost browser bookmarks after running an AWS AMI, patching and reboot of EC2 instances if those bookmarks get lost accidentally. So I'm a little confused with the way you're asking what you're actually asking, but typically speaking, you would restore your backups from the snapshot, log into your browser, make sure if I understand what you're asking correctly, and then you'll click for your browser's backup files, and you'd use your data recovery tools. Typically speaking, if you're trying to deal with browser, but you might actually be asking something else. You might also be asking, okay, you changed the system and you've got these systems you've been using these systems for a while, And then potentially they've come up with a new IP address, and now you've got them stored as an old system that doesn't exist anymore. And that would be you and your end browser kind of doing that. So I'm not sure what you're actually asking. AWS provides its own policy. Can we also create a customized policy? Absolutely. We talked about how you could use an AWS managed policy, and we also talked about how you could create your own policy. We talked about how you could just write it in JSON. We also talked about how you could go to the AWS Policy Center and create a customized policy there. We also discussed how you could take an AWS managed policy, bring that into an editor, and then tailor that to make it your own policy. So absolutely you can. You may not have been here when we talked about it, and that happens all the time. Hi, Mike. You talked about SAML when explaining the concept of federation. Please, how does OAuth tie up with this? So OAuth is typically used for authorization, allowing third-party access to user data and sharing passwords. It can complement or work with SAML in that it provides secure access to resources across different systems. So SAML is kind of the language which this could actually be done. But there is that OpenID as well. But OAuth is much more for authorization and authorization into another system. So I hope that answers your question there, Tundi. Like in case you have 1,000 users, okay, so a small number for generally speaking, how can you add the users to a group created by IAM? Is it done manually by the root user of the? Okay, that's a good question. So I see what you're actually here. So let's say I had a bunch of users. How do you add users to the groups created by IAM? Well, users are typically added to the group manually. So you will create the user. I'm sorry, you will create the group. So you will create the group cats, and then you'll add the cats that you want into that cat group. So typically in IAM systems, I will say this, for the most part, you're going to be using Active Directory for these things or federating into them. And that's typically how that's done on Active Directory and most other identity managed providers. You create the group, you assign permissions to the group or the number of groups you have, and then you add the users to the group. Can you relate single sign-on with the PAM solutions? That's a good question there. So single sign-on is sign in once, and they get access to another things. Privilege access management controls manage access to the resources. So yeah, you're going to want to use something like this together at the same time. Definitely single sign-on will help you log in once and access to the other systems, but you're going to have to track it and how much they've done. So yes, that's important. Now, when you're dealing with privileged accounts or accounts that have access to more stuff, that's where you're going to really want to pull in extra auditing and extra monitoring of those accounts. And that's where those privileged account management controls are really going to help. So yeah, you want to use both. Good thinking. Can Amazon Cognito get turned into an incognito mode automatically? Okay, so now I think I understand why I'm having a hard time with the questions. Because we're talking in one case about an identity provider, and you're actually trying to relate that on the browsers of the end client device. So these are going to be two different systems, and that's why I didn't understand the first one. So Amazon Cognito is not going to be naturally able to turn into an incognito browser mode, because Cognito is is a system itself, and your browser is a totally different system. So it's not going to have anything related to Amazon Cognito. Browser is what the user accesses to the system. And that's, an interesting thing that I tend to see with a lot of people as they're new to tech, where the stuff sort of is. So for people that are not familiar with networking, they typically don't realize that if we go to the cloud, we're going to have a wide area network connection to the cloud. And that's how you access the cloud securely through your wide area network. And internet is, public stuff with public addresses and lots of hackers. And inside of your network is typically where your users are. So that's intranet. Internet is anytime you go on the internet. And then, where the client is, that's the other thing that is kind of tricky. And because a lot of us are used to running systems on our desktop. And in this case, it could be a client server environment. You can have stuff that's, thousands of miles away. And what you do in your system is access something that's being done realistically somewhere else and just rendered locally on your system. So that is our last question, and we will go back to the content. And if we need to, we'll obviously answer the questions we did. I want to make sure everybody understands where we're headed. To make sure you're awake, alert, and oriented, please give me a hashtag AWS-SAA. If you're having a good time, if you're learning something, please like the video, subscribe to the channel, and hit the bell to be notified of new videos. And please invite others to see our free training. We've covered a lot of stuff in the last 2 weeks. We're going to our second week. So let's talk about Microsoft Active Directory. And this is a very important concept. It's going to be everywhere. So Active Directory is a directory service that Microsoft created, and they created it for Windows domains. And, in the end of the day, your workers are typically on Windows systems and your servers are typically on Linux systems. But, for the applications businesses need to run, it's not like most people could run around with Linux desktops. I mean, I wish they could. I love Linux, but that's not the case. You're not going to run your business application. You're not going to run your video editing application. You're not going to use your marketing graphics applications. You're not going to use a lot of these systems on Linux as much as I like it. So because Windows is the end user in the majority of enterprises, we have to be really good at understanding how these systems work. So Microsoft developed a directory service for logging in and accessing Windows systems. And if an enterprise has 100,000 users, probably 80,000 of them are using Windows. So they need to manage these systems very carefully. So Active Directory is really a cornerstone of enterprise IT infrastructure. And it has a whole lot of services related to identity and access management. Now, when we deal with Microsoft Active Directory, we've got a couple of things to think about. We've got a domain. And a domain is going to be a logical grouping of, say, network objects, which means computers, users, devices that are going to be inside of that same Active Directory database. And in order to control this, everything needs a control plane. We have what's called domain controllers. And these are the servers that are going to respond to security authorization requests, like when you want to log in, that sort of thing. And they also hold the database. And they manage any changes that are there. So you've got your domain, the entire area. Your domain controllers are the big brains of the system, which are big Windows servers typically. Some components of Active Directory, and this has been going on for a long time, we have this concept of a forest. And the top level container in an Active Directory configuration, and it's going to typically contain one or domains. So you can almost think of a forest as a security boundary. And we have the concept of a tree. So if the forest is going to be the top level container that may or have one or more domains in it, we're going to look at the tree itself as a collection of one or domains that are going to share a contiguous namespace. So gocloudcareers.com or something like that. But they have these namespaces that are created in there. And what happens is domains within a tree, they're going to be linked to each other via that transitive trust policy hierarchy, which, if this one trusts this one, then it's okay. Now, we've also have the components of what's called an organizational unit. And they're going to be containers inside of a domain that are going to hold users, groups, computers, and other organizational units. And it's going to help by managing and organizing the domain effectively. Now, because Microsoft's Active Directory is a database, for the most part, that's got all these identities and records in there, we need to have some form of a schema. And that's going to be a set of definitions for all of the objects and the type of information the directory is going to contain. It'll define which objects can exist in the directory and what attributes those objects will have. So where do businesses use Microsoft Active Directory? Well, user and group management. This is where you create those groups of administrators, the R&D department, the accounting, finance, what have you. And this is where you're going to add the permissions to those groups. Finance needs this. Accounting needs this. Admin needs a lot of this stuff. And business people may only need a subset of these systems, or sales reps, for example. And organizations typically also use it for single sign-on. Active Directory does a lot of single sign-on in the enterprise. They use it for access management. Think about all this tech that's in a business. There's going to be files, right? File servers. There's going to be printers all over the place. And who's going to manage your access to the printers? And of course, now you're an enterprise. And now you've got to be able to look through and see who did what. And you've got 100,000 users. So Active Directory helps a lot with compliance and auditing. And that's why businesses tend to use Active Directory. So if you're on AWS and you don't want to manage your own AWS, guess what? They've got a managed Active Directory system that you can use, and they call it Directory Service. And they are AWS managed high availability servers that are going to be spread across various data centers or availability zones. And if you've got a Microsoft dependent workload and it's in AWS and you don't want to have your own Active Directory services, then you can use this. But think about this. 98% of customers are in more than one cloud. You've got an AWS directory service. It's in AWS and it fails because you didn't create your own Active Directory service in two clouds. Well, then you won't be able to log into any other domains. If you're just in AWS and you don't want to manage your systems, this is beautiful. We just have to look at, what is the client's needs and what are those architectural trade-offs they have. Manage your own, use outsourced. What happens in an outage, for example? Always a trade-off. So this is where you would kind of think of it if you're not used to enterprise computing. You've got your directory service. You create your managed directories. The applications are deployed. Active Directory, knows where these systems are and it says, Mike can access it. Sally can. Billy Bob can. Louie can. So that's kind of what you're dealing with directory service. Managed Microsoft Active Directory servers. And these are, literally speaking, hosted Windows servers on AWS. So let's talk about, three of the use cases, though typically people use AWS managed directory service. So, and then we'll talk about simple AD as well as AD connector. So AWS managed AD, and this way we can compare and contrast them, is actual real Microsoft Active Directory based upon AWS hosting them for you. So what's that mean? It means that you get that Microsoft Active Directory servers and everything they do, but you don't have to manage them. Now, there's another form of a directory service provided by AWS, and that's called Simple AD. And this is going to be a managed directory that's kind of compatible with Microsoft Active Directory, but not full Active Directory, less features. So maybe some small organizations could use this. Maybe it's great for a development and testing environment. So that's where you might think about using Simple AD. And it's got basic Active Directory features, users and group management, some Kerberos-based as single sign-on, but it's light in features and functionality. So we talked about the managed service, the full service, the regular Active Directory servers. We then talked about Simple AD. So let's talk about AD connector. So if a company has an on-premise data center and they've got resources in the cloud, and once in AWS, we want to use those Microsoft Active Directory services, we can simply use something called the AD connector. And that's really going to be a proxy service that's going to connect AWS resources to your on-premise Active Directory environment. So if an organization's got a big established data center, that would be a good place for them to have their own Active Directory servers. And that way they can still work in AWS. Of course, you could put your Active Directory servers in a few different places, and then you've got something that works pretty much in many, many cases. But it's kind of a nice, simple solution, this AD connector. It's a great solution. It basically provides what you call pass-through authentication. Connects you as a proxy and then authenticates you. Gives you group policy management, Kerberos-based single sign-on. Very simple, and it integrates with what most enterprises already have. Okay, so Now we're going to start talking about protecting systems. So when I talked about identity and access management being the person that's knocking on your door saying, here, I'm here, let me in. My name's Mike. My password is this. But what if you couldn't access that door in the first place? And I talked about, if you wanted to protect a castle, maybe you'd put a 100-foot wall around the castle. Well, guess what? When it comes to security here, we're going to actually want to use things called firewalls. So we can restrict network access through firewalls. And what is a firewall really going to be? I'll give you an example right now, and I'll probably get back into a little more about the AWS Identity Center and more things related to this. But I just want you guys to get the firewall and what I mean by a firewall. So in this particular environment, we're going to have the company's internal systems. This is the secure world. Everything in here has private IP addresses, and they're not reachable from the internet. So the only way you can access these systems in a traditional environment is if you're physically in the building or you've securely connected via, say, a VPN, and you're in that secure world. But if this business needs to connect to the internet for certain reasons, maybe it has to. Maybe your users want to go to the internet, for example. Maybe our users need to do some research on the internet, for example. Maybe you want your systems to be able to patch the operating systems from the internet. You need to find a way to make sure people can't get in. And that's really where that firewall is going to come in place. It's going to sit between the users and the internet. And what will happen is anything behind the firewall will be able to go through the firewall, typically to be NATed. Their private IP address will be turned into a public address. The firewall will keep track or state of the connection. Oh, that's Mike. Mike went to www.gocloudcareers.com. It allows it through the firewall out to the internet. And then when www.gocloudcareers.com, it goes from the internet to the firewall to that user Mike. And the way that occurred is the firewall kept track of that I actually requested the information to go through the firewall, and it was allowed back. That's state. By comparison, if Hal the hacker's out here and he's trying to get in, he goes through the internet, hits the firewall, and he's not allowed in. So that's the concept of a firewall. And when we talk security, it's not just identity and access management. For some reason, people are becoming obsessed with that being the form of security. It is the last line of defense. It is very important. But I wanted you to know there were other things that we're going to have to talk about later, because we're going to get pretty geeky, and we've gotten pretty geeky in some of this identity and access management center information. So let's talk about another IAM functionality. And this is going to be what's called the AWS Identity Center. Sorry, it's the AWS IAM Identity Center. And you may have remembered it being called AWS Single Sign-On if you've worked with AWS for a while. That's going to be a service that's going to enable you to centrally manage access to multiple AWS accounts with single sign-on. It'll simplify the process of managing identities because it's a managed service, makes it easier to streamline user access and single sign-on. And it's a simple place to manage authentication and authorization for your users should you not be using Active Directory. And potentially you could use it with it as well. But so the Identity Access Management Center's got some key features. Single sign-on, something that people use it for. Sign in once, get access to the other systems. That way you don't need 10 usernames and 10 passwords, both which takes time. And then how do you remember 10 different usernames and 10 different passwords? That's kind of a problem unless you use a password manager. And what happens if you use a password manager and that password manager gets hacked? Then all your passwords are gone too. So there's lots of things we need to be careful of here. The AWS Identity Center is going to provide centralized identity management because it centralizes the management of user identities and permissions. And that will integrate into AWS Identity and Access Management to give you a good granular control over who's allowed to what. Now, AWS has this concept of organizations where you can basically have multiple different accounts and use identity and access permissions to get information inside of those accounts. And one of the plans is if something bad happens here, hopefully it doesn't go to another organization that's part of your systems. Limit the blast radius, if you will. So it'll integrate into that because it's an AWS product inside of another AWS construct. And of course, the AWS Identity Center is going to support SAML because everything's either going to be SAML 2.0 or OpenID in today's world. And that will support obviously federated identities from external identity providers as well, like Active Directory. So some things to think about is it can help manage access to applications. Manage applications to say, Office 365 or Salesforce. And it's giving you all those SSO capabilities for both AWS and non-AWS stuff. Can also help with user lifecycle management. So it's hard to manage, all these identities. And this can help automate user provisioning and also deprovisioning or removers from the systems of the corporate directory when necessary. And anytime you're dealing with that, you have to constantly think about, you can't just give access to users and not remove it when they don't need it. Let's say you've got a systems administrator that needs access to a lot of the systems. Now that person's a manager. They don't need access to those same systems anymore. So you remove access to those systems. Now that manager probably needs access to a payroll system or a paid vacation and approval tracking system. So constantly migrating these permissions based upon people's needs and never giving people more than they need to do their job, following that principle of least privilege. Another good thing about the AWS Identity Center is it supports multi-factor authentication. So various forms, of methods, tokens, that kind of thing, one-time passwords. So how would you set this up? You go to the AWS Identity Center, that IAM Identity Center. You can access that directly from the management console. You go to Identity Center, you enable the service and configure basic settings. It's pretty simple to set up. You then integrate it with any identity providers you want, like Microsoft Active Directory. You configure SAML 2.0 or the OIDC federation as needed. As we talked about the other approach, you assign user access. You create your users and your user groups. You assign the users to the groups. You configure your user portals. So you'll set up the user portal so you've got centralized access point for your users. You'll customize to fit the organization's branding needs. So it looks the way you want it to feel. You enable multi-factor authentication, hopefully, for better security than you would. Or at least require multi-factor authentication for sensitive resources or sensitive applications, or maybe privileged accounts. You'll monitor and you'll audit access. That's pretty much the way that we're going to get this stuff set up. All right, now we're going to start talking about security, which is one of my favorite topics. And I've trained so many security architects that are working at so many great companies. I love discussing security. Tyrone, how long has it been since the last time I asked questions? Do we need to take a break or are we good? Okay, my team says we've got a few more minutes before we start taking questions, so I'll take it from there. So when we talk about security, there's some oddities of cloud security or anytime you deal with other third-party providers. So we're going to talk about that shared security model. We'll talk about the principle of least privilege. We'll talk about identity and access management. We're going to talk about account strategies. We'll talk about access control lists, security groups, AWS, their firewall like WAF. We'll talk about intrusion detection and intrusion prevention systems. We'll talk about the next generation firewalls that provide optimal security. We'll talk about distributed service, denial of service attacks. We'll talk about the service catalog. We'll get into the systems manager parameter store and so much. First thing that you've got to understand with cloud security is it's a responsibility that's shared between the cloud provider and the user. And in order to think about this, AWS maintains the security of their cloud. Azure maintains the security of their cloud. Google maintains the security of their cloud. And if they get hacked, you get hacked. So when Azure had people access, what do you call it? Azure Cosmos, the NoSQL database, the Azure version of AWS DynamoDB, they managed that. So when Azure got hacked, the users' accounts that were using Cosmos, their managed NoSQL server, a lot of their information was stolen. So now you've got to think about in the cloud, are the cloud providers doing their job? And on their side, and what you need to do on your side. So remember, you've got a lot less control here than you would in, say, the data center. Doesn't mean it's not secure, but now you need to plan for multiple sets of problems that are new problems that you didn't have before. So AWS manages their stuff. You manage yours. AWS manages the network, the routers, the switches, the firewalls. You manage yours. They manage the servers and the hypervisors. You manage your virtual machine. You see where I'm headed from? So think about that. That you've got this shared security model. And all in all, the customer is responsible for their identity and access management, users and roles, patching of their own virtual machines or non-managed virtual machines, their own firewall configuration, their own access list configuration, their own security group communication, physical security to the devices that connect you to the cloud, what your demilitarized zones are going to look like, what your encryption kinds that you're going to use, so you're going to be responsible for pretty much everything except the underlying infrastructure. And you hope the provider does their job managing underlying infrastructure. And if they don't manage their underlying infrastructure, or they test something and it goes wrong, it can take lots of their customers down. Maybe visually, this will help. So the servers, physical, AWS manages them. Their managed databases, they manage them, like DynamoDB. Their storage, they manage those RAID arrays. They manage those. So if a hard drive fails, they go and replace it. They manage the networking, routers and switches, the cabling. They manage their availability zones or data center. They manage their regions. They manage their edge locations. But you are responsible for all your network security that you can do on top of what they've done, all of your data, any encryption or decryption you have between yourself and the cloud, any encryption you have between systems and systems that you have in the cloud, any a service that rolls between one system and another, you are in charge of that. You are in charge of your application. So if somebody makes a bad application, it'll get hacked. If you allow your users to come up with Cindy the cat as a username and Cindy the cat as a password, let's face it, you'll have a problem. If you're not careful with your networking and you let your traffic go to the wrong places and you expose routes that you shouldn't expose, you'll be attacked and it will be your fault. If you have a user and 16% of all hacking attempts are related to misconfigured S3 buckets, not because someone doesn't know how to click a few boxes and configure the bucket, it's because they don't understand which one to use and they set the wrong permissions and then they make company files accessed. So a lot of hacking events are related to misconfigured object storage buckets or S3 buckets. So there's that. And then you need to think about all the traffic, your entry and exit points of your systems. So the first thing to talk about when it comes to security is not giving people access to more than they need. It's that principle of least privilege. If someone doesn't need to plug into your network, don't let them plug into your network. If someone doesn't need the ability to create or delete an account, don't give them that right. This is very, very similar, not completely the same, but very similar to what the military would call need to know. If you don't need to know it, you don't. It's slightly different, and there's some subtleties that if I were to teach a CISSP program, I would talk about it, but functionally, they're pretty similar. So give people the least amount of privileges they need, and when they don't need them anymore, take them back. So I always go back to this. We've got two people. Where it says on the top, that could be a general. And the general needs to access the system, and he's given permission. On the user on the below, that could be what's called like an E1 or an E2, someone that just enlisted that's new to the service. They try to access it. They don't have that kind of clearance, so they're not given it, but the general would be. It could be the systems administrator in the client that needs access to one of the Linux servers. And the regular user tries to log into that Linux server, and they're not allowed. So always think about that. Now, AWS has a concept of a network firewall. And it is a high availability router system. And it is a virtual system. And like any other firewall, it's designed to keep unwanted traffic out of the system. Now, one good thing to think about is when you're dealing with these virtual appliances, they're very highly available. So they are a system that could be on any server anywhere where you can think about it. So you can use the AWS network firewall for, say, perimeter security, and you can set it up because an easy policy, and it's not going to go down like a traditional firewall in a data center. It could have a hardware problem go down, and then the other firewall will take up. This is a logical firewall, which could be across multiple data centers at the same time. So if any of you are familiar with networking and you understand why we put a loopback address on a router, because that's a port that's logical and will never go down, it's really the same thing here. So I hope that can help. Now, a firewall basically blocks all incoming traffic by default, and it allows your outgoing traffic to go in. But what you do in firewalls is you create custom rules. Either allow certain traffic, maybe allow port 443 to a web server in a demilitarized zone, and the firewall only allows TCP port 443 in, and that's it. And it only allows TCP 443 to this one subnet that's got the load balancer of many web servers. So one of the things to think about is because it's a firewall, you get a lot of information. So you'll get a lot of logging and monitoring, which is great, especially if you tie it into a SIEM system to correlate events and that kind of thing. Now, AWS also has another firewall for web applications called the Web Application Firewall. And that's a security system for controlling access to the AWS public cloud. And WAF is a basic firewall. It's not to the degree of a next generation firewall that you'd get from, say, Cisco or Palo Alto or Fortinet. And I can tell you the differences between them. But it is a simple firewall that you can use. And basically, it's something that you just stick on, say, your load balancer or your content or your load balancer or something that uses a virtual firewall. You stick it on an API gateway, that kind of thing. Basic, lightweight firewall that's completely managed by AWS. And it's a layer 7 firewall. So it's going to be able to look at the application layer, meaning it can look at the header, so the country the request originate from. It'll be able to look for strings that appear in the results or text. It'll be able to look at the length of the request. It'll be able to look for if there's some SQL code there that would potentially be malicious for like an SQL injection attack. And it's going to provide the presence of a script. And it'll look for the presence of a script if you're looking for like a cross-site scripting thing. So it's a basic application layer firewall. You're going to use it maybe on a CloudFront distribution. You put it on an API gateway or a REST API or an application load balancer. And the nice thing with WAF is it's going to integrate very simply into Amazon Cognito user pools. It will block the request at the edge location before they even get on your network. And it's going to provide basic firewall-like functionalities. And I'll tell you the difference why I say basic in a minute. So if a system's going on, you'll create a web access control list that is just like an ACL on a router, but firewalls are stateful, so you'll apply them only in one direction. And the rules will be either allow this or not allow that. Kind of like exactly when I taught you how to do an access control list. So the way you'll set this up is you'll enable WAF on the appliance or the device. You'll create a policy filter with access to the device. And then WAF is going to look at it and say, does the traffic conform to policy? And if so, allow it. And if not, it's allowed out. And if, because it's AWS, it'll integrate very nicely with all your CloudWatch, CloudTrail, and all those things. So let's look at what this actually is real quick. It's a basic firewall, and I'll tell you why I say basic in a minute. You put it on an AWS service, and it protects that AWS service. Here's why I say AWS is a basic service. Let's talk about what AWS WAF can do, and let's talk about what a next generation firewall, like those made by Cisco, Checkpoint, Palo Alto, Fortinet, and other companies do. WAF is a firewall, and like all good firewalls, it allows your traffic out and you return traffic in, and it doesn't allow anything in except what you permit. WAF does a beautiful job with that. WAF even has the ability to integrate into a third-party system that will get, that'll also be able to say, hey, here's a new attack that's occurred. Firewall, be smart enough to recognize this new attack. So it doesn't come default, but you can integrate WAF into something else to get some basic intrusion detection, intrusion prevention. Here is what an enterprise-grade next-generation firewall does. Does everything we talked about. Here is, and I'll give you an example so you can think about it from a heuristics perspective. It allows your traffic out to the internet, your return traffic in, blocks all traffic, just like AWS WAF. Can look at it, the application from layer 7, just like AWS WAF. But here's what a next generation firewall will do. The next generation firewall not only has been given the signatures of previous attacks like you can subscribe to with AWS, but it's smart. It's constantly watching the system. So it's looking at the network, it's looking at patterns of traffic, and it says, I don't like this. Let's stop it, even before we know it. And what's the system like? What is heuristics like? Have any of you ever used a credit card? Now, if you're not used to being in 3 countries a week like me, if you go, let's say you're in Tokyo, Japan. If you fly from Tokyo, Japan to Singapore, and you go from Singapore to Sydney, and you go from Sydney to UAE, and the next week you try to go to the UK, I promise you, your credit card company will call you and shut off your credit card until you tell them that I'm on a trip, and then they'll allow it to go through. And why is that? Because the credit card companies have good security, and they're trying to say this is a pattern of behavior that doesn't feel right. So block it. Now, me, when I traveled, I was an architect working for Cisco, and I was in 3 countries a week. Initially, they blocked my card, and I told them this is my pattern of behavior. And then, when I'd leave New York, and I'd go to San Jose, and the next day I was in London, and 2 days later I was in Dubai, and then I was in Sydney, and then after that I was in Hong Kong. It was like, all right, that's Mike Gibbs traveling. The system knew it. So the enterprise next generation firewalls can sense the attacks, and they can actually stop a majority of the attacks by recognizing patterns of behavior that just shouldn't occur, in addition to doing all these same great things. So when it comes to an architecture perspective, do you need a robust next generation firewall? Or can you get away with something by the cloud provider? If you've got multi-clouds, you're going to need similar things that you can use in all 3 clouds. If you've got a single cloud, it's simplicity and elegance, which you're getting, because this is simple and elegant for most stuff. But is it big enough for a big enterprise? Just kind of think about that, and I hope that kind of makes sense. So this is typically where you would use these. And honestly, look at how elegant it really is. You go straight to your load balancer. You pop in the AWS Shield, which is their DDoS protection that comes with the CloudFront. You put on your WAF directly on that load balancer. That's your firewall. Your firewall's got WAF. It's securing the load balancer. Then you put a security group on the load balancer. And you've got basic security for your web application. And then you can still put an access control list protecting the subnet after that, and put a security group on your web servers, and you can lock those servers down, just harden those servers, add some anti-malware protection, disable services. So you've got a very simple and elegant security solution here that is very, very easy to understand with AWS WAF. Okay, so Tyra, let's take a break and see if anyone has questions, because I'm going to get into distributed denial of service attacks next, and I want to make sure everybody is fresh. If you're having a good time, please hit the like button, subscribe to the channel, and hit the bell to be notified of new videos. If you're just joining us, there's about 40 plus labs that I'd love you to do. and you can sign up for them. They're completely free. My team will pop the link to that in the chat box. It's also in the description of this video. And in the description of this video, we've got so many free ebooks and resources to help you in your career. We've got a free AWS networking course that was taught by three CCIEs, as well as a CCNP network architect, and he's a rock star. We put that out there, the free certification. It's all free. So try to look in the description of these videos. You're going to see a lot of good stuff. And it's all free. Tyrone, any questions? If associate search needs such long boot camps, you wonder what the professional will look like. So let me be fair. This is not what we're doing, just an associate bootcamp. I could get somebody through an AWS Solution Architect Associate exam in about 6 hours of training. It's no big deal. What we provided in this bootcamp was the AWS Solutions Architect Associate, 50 or 60% of the Solutions Architect Professional, about 40% of the AWS Advanced Networking, and about 40% of the AWS Advanced Security, all in the same course. And I did that because the Solution Architect Associate alone is not going to be enough for anyone. And I wanted people to have a much better opportunity. I wanted people to get a much better education. In my view, it's better to give you the preparation and give you the knowledge and teach you how stuff works than it is to say, I could help you pass that exam. And it's because passing an exam is not the challenge. That's the easy part. Don't get me wrong, you got to learn how the provider asks their questions, maybe get a good practice test to make sure that when they ask a question a certain way, you know how to answer it a certain way. If you're taking a certification, you've been in the field for a long time, you have to forget two-thirds of what you know to take a certification, because certifications are more at that beginner level, regardless of the certification. So you have to almost try to think like, how would a newbie do it versus how would you do it in the real world? But no, I added a lot more to this. But, let's answer the question in reality. So a CCIE certification is about 2,000 to 5,000 hours of presentation of training time. And AWS Solutions Architect Professional certification, that could be done in about 20 hours of training time if you're just focused on just that. And what is the certification? The name of a service and how to configure that service. I'm more interested in you not only knowing how to pass an exam, but actually having some knowledge in your head. So you know how to think about these things holistically, and you know how to be able to communicate it to someone else. And if you're on an interview and someone asks you a question and they say, where would this technology fit in? And all I teach you is the name of it and how to configure it. You won't know how to answer that. So I'm trying to give you as much as I can for free. Can AWS WAF work in a hybrid environment? Well, yes, it could, but let's talk about how you would really do things more pragmatically. If you've got one provider's WAF on one side and one provider's WAF on the other side, and you've got two web servers sitting, and you have half your web servers in your data center and half of your web servers in the cloud, you're really going to want to make sure that you have the same level of security policies for both web servers. So in that case, you're not going to put AWS WAF inside of your data center, but you could go with a more robust enterprise-grade firewall like a Cisco or a Palo Alto or a Fortinet or a Checkpoint, and you probably would. Now, is there any laws that says you can't use this AWS proprietary thing in AWS and this Azure proprietary thing in Azure? Well, when it breaks, who do you call? Where was the source of the problem really coming from? So how are you going to compare your logs of two different systems compared to using the same logs from similar systems? So you can do it. The answer is yes. The question is, if you're going to go single cloud, why are you going to go in there? For the most part, you're going to go with the synergies and the simplicity and the elegance of one provider stuff all working natively with its own stuff. If you're going to go to the point where you're going to use a hybrid cloud or a multi-cloud, or in most cases, a hybrid multi-cloud, you're going there because you want more performance, more availability, and the ability to take the best each provider has to offer. And by doing that, you're going to lock yourself into a hole by using proprietary things. So by the time you're going to a hybrid cloud, it probably doesn't make sense to use WAF. Could, yes, but should you is the question. But it also depends on what that organization is doing. Are they going to move it all to AWS? Do they need the latest and greatest security? What are they protecting behind that? What are the value of the assets they have? And maybe the WAF is good enough. But for a bank, you might put 2 layers of next generation firewalls from 2 different vendors. Why? Vendor 1's firewall may have this weakness and vendor 2 firewall doesn't. Kind of like martial arts. You may learn jujitsu to learn how to fight on the ground. You might study Kali or Salat to learn how to fight with sticks or edged weapons. You might use karate to learn how to strike or kickboxing or Muay Thai. So it's that kind of thing. Each one of these things has their strengths and weaknesses. So I hope I gave you a good answer there, or I hope I answered your question. Won't the next generation firewall take the good out traffic accidentally and detect in its attempt to direct the wrong traffic? Well, it could. Now the key is, would you rather be more sensitive or less sensitive? Kind of like on a medical test. Is it better to be more sensitive or more specific? So, and I think Leonard's a medical professional. So typically when you're doing a screener, you want some big sensitive tests to catch anybody that might have it. And then you want to nail it down with some level of specificity thereafter. And when it comes to higher security, you might want to be a little extra zealous on security and block something, even if it's not, and potentially lose out on a little bit of business to protect yourself. Or you could go with a more open, and well, we're more open, but we're more susceptible to being hacked. So the way you're going to deal with this is you will fine tune the rules, you'll constantly update the policies, and you'll look at patterns of behavior and anomalies, and you'll adjust it. And this process is really the same way a credit card company would manage you. They've got a process to look for. Okay, well, maybe this pattern of behavior is normal. Maybe this pattern is not. Maybe we classify it as this, and therefore we allow it to go through in the end because we now know that it's not a problem. But sometimes it's better to be safer than sorry. And that's how you set these systems up. But it's a great question. Okay. So let's get back into security. I love security. Give me a hashtag AWS security so they know that you're here. So the next thing we're going to talk about is a distributed denial of service attack. And I want you to see what this is here. So in this particular environment, what you see is an attacker, or that's the hacker. And the attacker is going to get control of a server. And that's going to infect a whole lot of systems and then launch an attack. So it's kind of like bringing a big army to overwhelm one soldier. And in this case, it's bringing a big army to overwhelm one server. So that's really what a distributed denial of service attack is. So if you can handle 100,000 requests per minute, and I send 1 million requests at you, you won't be able to handle it. And let's be fair, there were websites that would accidentally DDoS themselves. They'd say, I have this one thing, and they would email, say, 100,000 subscribers, and it'll be for sale at exactly 9 a.m. and 0 seconds. And at 9 a.m. and 0 seconds, 10,000 people try to buy the same thing, and they take the website down. Well, that was because the company didn't know their own business and they didn't know their client base well. But in this case, it's when an attacker wants to use some other systems to attack and overwhelm a single system. And that is a denial of service attack. Can autoscaling help here? Yeah, it sure can. If you can handle 100,000 requests naturally and you get hit with 500,000 requests, you can autoscale out and add additional servers. Now, that'll be a real costly way to be dealing with the attack, but at least it'll keep you up in business. So that's really what's going on. So how do we prevent these things? Well, you've got a good security posture. Next generation firewalls, access control lists, protecting subnets, end system and endpoint protection, IDS, IPS systems, multiple layers of firewalls, lots of stuff that we can do. But we can protect a subnet with an access control list to reduce the unwanted traffic going on. We can put a security group on that server, which doesn't allow bad traffic into the server. We can auto scale, and we can use really good, strong firewalls, IDS, IPS systems, and many other things. And, if we're going to go on this simple side, we go with an AWS WAF because it knows how to recognize common attacks. And we add something called AWS Shield. And here's what these systems, these DDoS prevention systems that you typically see in a content delivery network, which would be a great place to put Shield. You could also put in a load balancer or a virtual machine or Route 53 or some other things. But you can put it in a lot of places, but it's the recognized patterns of behavior that are not normal and not forwarding them. So when it comes to content delivery networks, they not only cache our information, but they can actually look at the traffic and say, this doesn't feel right. This overly large ICMP ping message coming in doesn't feel right. Maybe I'll block it. I just had 8,000 TCP send connections coming in. That doesn't feel right. Maybe block those half-open connections so you don't get a DDoS attack. And any of these systems do it, whether it be Cloudflares that would do it, or it be Azure systems that would do it, or Google systems that would do it. AWS has their DDoS system on their cloud, on their, what do you call it, content delivery network, and they call it Shield. And it's a great system, like all of these other DDoS systems that are deployed on content delivery networks. Now, AWS has two versions of Shield. Shield Standard, and that's given to you free if you use a web application firewall. And then there's Shield Advanced, which provides more protection to virtual machines, load balancers, and gives you more options. So Shield Standard is free. Now, unfortunately, sometimes you get what you pay for. And it'll protect against the most common DDoS attacks, things like SYNAC attacks, reflection attacks, HTTP slow reads. And what it has is it's got a standards-based policy. And you set up a policy, but it is static. So good if the system already knows about it and if there's been a policy. By comparison, Shield Advanced is a lot better. Shield Advanced comes with more DDoS protection. It's also, you have to pay for it. It gives you much better intelligent attack detection and gives you some ability to mitigate some attacks as they're occurring. It's going to be dynamic, and it's going to look for patterns of behavior that are abnormal, and it can deploy, say, an ACL on demand to block a bad user or something like this. It even gives you a 24/7 DDoS response team for businesses or people on businesses on enterprise support. So this is going to be something that matters for organizations that need real security and real DDoS protection. They're going to go to Shield Advanced, and it's a great service. So let's talk about the service catalog. So if an organization knows what they're putting on their systems, they can be much more secure. When I first started my career in tech, I think for the first 2 months, they were calling me Sniffer Boy. A sniffer was a protocol analyzer, and they literally had me plugging in all over the network to see what I could actually find. Hence the name I earned, Sniffer Boy. I don't want to go back to that. I don't like, plugging into the network and all that other stuff. It was fun, but it wasn't. So after inspecting lots of people's traffic, you would be amazed at what you'd find. People would put these little back doors into your system. This person wanted to run an operating system that wouldn't be patched in the last 2.5 years because that was the flavor they liked. People would set up file and video sharing services on the system. You couldn't imagine what companies were paying for bandwidth and the security holes the employees were created. So organizations do inspect traffic and monitor traffic. But the service catalog enables you to create a catalog of services that are approved. So you don't get that. And that way, when your employees want to add something, they go to the catalog and they deploy what they're allowed to versus anything they feel like. A great way to enhance the security of your systems. Service catalog can manage resources in the marketplace, the AWS marketplace. And what's the AWS marketplace? If you need a reverse proxy and enterprise features and functionality, you get one from F5. You need a commercial enterprise grade firewall to run on AWS. You get it from Cisco or Palo Alto or Fortinet or Checkpoint from the AWS marketplace. You need certain business applications pre-deployed on virtual machines. It's great. You go to the AWS Marketplace, the Azure Marketplace, the Google Marketplace. They all have them. But so AWS Service Cloud can do that. But you can create what you want as your virtual machine images to have a golden build or virtual servers or software or databases to anything you want. That's allowed. You store it by using the service catalog. And that way you can centrally manage your applications that users are allowed to deploy. I mean, it's a really great feature and functionality to use these things. So the way you set it up is users can access this CloudFormation script or this kind of thing to go kick off these features and functions. They go to the service catalog, they're allowed. Then you'd pull that the infrastructure as code script, like the AWS CloudFormation script, and use that to deploy your resources exactly according to the company's standards. So these types of things, any way you can standardize an image or standardize anything, really give you the ability to add a lot of robust security to your system. So this is great. So let's talk about some key features of the service catalog. It gives you the ability to create products. And that's where you create and manage whatever that product is. It could be an EC2 instance or a virtual machine, or a database, a custom application. And they also have the concept of portfolios. So what happens is you can have these products for these things. These are the financial applications, you call them products. And you'd create a portfolio and you'd put these applications, these individual products inside of that portfolio. Same way it is when you go shopping. Oh, let me go look at the outdoor gear. And inside there you see packs and that kind of thing. So basically same thing we're talking about. But in this case, the products are maybe a virtual machine or an application that's going to be launched on a virtual machine or a container, that kind of thing. Now, the other thing this is going to provide for is something called version control. You may have 50 different versions of the application or 1,000 different versions. And you may have found out that version 996 is something you don't want to use. But it'll enable you typically to go back to good versions or avoid old versions and make sure you don't have that old version again in the future. So, version control. It also helps with governance and access control. You can find who can access what product portfolios. So, only the right people are deploying what they should be allowed to do. It gives you the ability to apply what's called a constraint. And you can apply a constraint to enforce, various organization policies, like resource limits or tags or specific configurations. So it gets you real granular at making sure that people put what you want. And obviously you can use like a CloudFormation template or an infrastructure as code template. What's great with these things, especially when you go AWS to AWS or Azure to Azure, because they make these systems, it's very easy to integrate with them. So it's going to be you'll integrate it with CloudFormation or an AWS organization or an AWS IAM any way you want because it's already there. So where would you use something like the service catalog? Service management, IT service management. It gives you the ability to centrally manage the IT services. It provides a self-service portal. So end users will be able to say, these are what I can deploy. And it's quick and easy, and you don't need a million sets of approval because if you've got access to it, you've got access to it. And if you don't, you don't. From a governance compliance perspective, enforcing these policies and compliance is, all about controlling which services are deployed by whom and who can manage them. This really helps with that. And it can make sure that consistent configurations and security practices are applied well across the organization. It can help with resource optimization as well, because if you've got a standardized pre-approved configuration, you can set that to be as efficient as you need it to be. And that'll keep people from over-provisioning and provisioning anything to make sure they've got good use to resources. So how do you set this up? You basically create your product and portfolios. That's going to be in the service catalog console. You set up your access controls, basically your IAM roles and policies to determine who can access what products from the store. You define your user groups and assign permissions to them to make sure that only authorized users can access authorized stuff. You define whatever constraints that you actually need to be, like only these types of virtual machines or regions or tags, and then provision the products. Users access the products from the management console, the CLI, the API, whatever they feel like, and they can, monitor and manage these products. Some best practices with the AWS Service Catalog. Make sure you organize products or portfolios by either organizational unit or project so it's easy to find. Structure the portfolios in a way that reflects the organization structure, maybe by department or project or environment. Use templates for consistency. Look, if you can manage to have one infrastructure as code template that everybody can do, it's going to be a lot easier than if Billy and Hal and Sally and Joey and Maria and Maddie all go in there and do it their own ways. So, think of it that way. Make sure you've got good access control and policies, because if you're giving people can now access this system to do something, and now they're able to deploy units, and they're not the right people, you're going to run into trouble. So make sure you use good identity and access management and monitor it. In fact, that's the secret to everything. Deploy it, look and see what's going, and tune accordingly. That's why companies are constantly updating architectures, because they may have thought this would work, but it didn't. It didn't provide value for the business. Let's not move forward. Let's scrap this architecture and move to something else. We thought we were going to get savings going to the cloud, but it costs 2.5 times more. All right, let's pull this stuff out of the cloud and go back and stick this stuff in the cloud where it's cheaper. So it's all about a tuning process over time. So monitor or optimize. And, you're not going to want the same configurations potentially 5 years from now. So constantly update them, maintain those products in that catalog. All right, so now another one. The systems manager parameter store. So I want you to think about it. When it comes to security, you've got your passwords, maybe these database strings, you got software licenses. That's a lot of secret stuff to keep track of. You don't want to leave that stuff on your desk because, it'll be seen. And at the same time, you put it in a safe underneath your desk, and then something happens and you can't go to work, or worse happens. How does somebody access that, that safe? What do they do? Call in a locksmith, pack into the safe, break it. So the systems manager parameter store is an online way with AWS to store your secret stuff, like passwords, database strings, license codes, API keys. And if you're going to store your stuff, if it matters, encrypted. So the systems manager parameter store enables you to encrypt your stuff. I personally think they should call it the secret stuff store, but I don't work in marketing. So think about it this way. You're able to secure your information in a secure environment. It's encrypted, and it enables you to separate your code from your passwords, because you want that to be in 2 different places. It provides an excellent means to audit access to see who did what. It provides a method to track various password use to make sure that you don't have one employee that's logging in 24 hours a day from different locations because maybe they shared their password. So I think we covered the systems manager parameter store. Now, there is another secrets manager. So we also have the AWS secrets manager. And that is going to be another managed service that's going to be designed to securely store and manage and retrieve sensitive information. Again, database credentials, APIs, keys, and other secrets. Because it's managed, it'll make it relatively easy to maintain and rotate secrets, ensuring they're going to be kept secure and accessible to make sure that only the authorized users and applications. So when we think about the secrets manager, think about secure storage. Secrets are encrypted at rest using the AWS key management service. Think about secret rotation. So those secrets are going to be constantly rotated. And you can do that with, say, Lambda, or integrate it with Lambda to define a logic to rotate your secrets. It provides very good IAM fine grace control. So this user can access what and whom and in which applications. And it provides a great way to audit and monitoring your systems. Integrates with CloudTrail. So remember, CloudWatch as logging and CloudTrail as auditing. And that'll help you monitor the use of your secrets and detect any kind of unauthorized access. And because it's AWS, it's integrated with so many other things, like the databases or the Amazon relational database systems, Redshift, virtual machines like EC2. So Very simple because it's AWS integrating with AWS. Also works with Lambda functions, ECS, the Elastic containers, and other types of services. Secrets Manager works for that programmatic access, so for one system to access another system. So where do you typically use these things? So if you've got database credentials, here's a great place where you can put them. You can store and manage your database credentials for any of the Amazon relational database systems, Redshift, or other databases, and you can rotate those credentials fairly frequently to enhance your security. You might want to use it for API key management. You're going to have to store API keys for third-party services and even internal APIs. And you're going to want to control access to these API keys and rotate them periodically to prevent misuse. And this can help with that. You're going to want to use it for application secrets. So think about application-specific secrets like OAuth tokens or SSH keys and encryption keys. And this can ensure that the applications can securely retrieve and use these secrets at a runtime. Also helpful for disaster recovery because it gives you the ability to back up your secrets somewhere and ensure that your sensitive information is only going to be available when it's needed. How do you set this up? Basically, you go to the control management console or the CLI. You create a secret. You define the secret's key value pairs and specify any necessary what the encryption settings will be. You'll define the rotation settings. You'll configure automatic rotation, ideally for the secret, or you can choose a predefined rotation, or even create a custom Lambda function to rotate your keys and the logic behind that. You can set up your access policies. So there's IAM policies to control who has access and who can manage the secret. And you'll apply these to whatever the appropriate users are, or groups are, or roles are inside of your AWS account. When needed, users can use the AWS Secrets Manager, either the API or the software development kit, to retrieve the secrets programmatically. And you can integrate secret retrieval into your applications to fetch and use these secrets securely. And of course, you monitor it and you audit. Make sure the systems are doing what they're supposed to be, review logs, detect if any unauthorized use is occurring. So we talked about the systems manager parameter store for this, and we talked about the secrets manager. So let's kind of compare and contrast these. The parameter store can store unencrypted passwords and encrypted passwords, where the secrets manager is only encrypted data. If we want credential and secrets rotation, which we probably do, that's going to be more of the secrets manager. So I hope that kind of helped clear some of that stuff up. So let's talk about the AWS Security Hub. When it comes to security, there's a lot of systems that need to be managed. And it typically needs some really good security management software. AWS has a security hub for managing the systems on AWS. If you're in multiple clouds, like 98% of organizations, you may want to use some other software that integrates into these things or is a bigger, more global system. But the AWS Security Hub is an excellent environment in AWS to give you security information in your AWS account. And what it does is it'll help monitor and manage the security of your accounts because it'll aggregate, organize, and prioritize security findings from multiple AWS services or third-party tools that are going to find things. These tools can be checked against, say, databases of, say, best practice standards to help you identify oversights or trends and it'll give you that you might need to fix or give you some insights from what it finds. It gives you a centralized view to look at things, and it'll pull information from like Amazon Guard Duty, AWS Config, the AWS Firewall Manager, and other stuff. And thankfully, it integrates with other third-party tools to give you a good view of your systems in AWS. It can help with automated compliance checks, and it'll constantly monitor your environment for compliance with with industry standards and best practices, or at least what it considers to be them. And it will support frameworks like the CIS AWS Foundations benchmark. It'll support like a PCI DSS framework or an AWS Foundational Security Best Practices framework. Organizations may be using a different framework, but that's something to at least think about. It'll provide some custom insights and alerts. And it enables you to create custom insights and filters to basically prioritize findings based upon the organization's security needs. And it'll integrate with CloudWatch and SNS to send alerts and notifications when necessary. It integrates with AWS organizations. We haven't talked about them yet, but that's where you've got a company that basically has multiple accounts and they get one single company billing, better prices because they aggregate it all together, but they keep these accounts separate and use identity and access management to talk to each other across accounts to limit the blast radius if something goes wrong. It gives you some security findings in an aggregated result and gives you response and remediation. So it's set up pretty easily. You go to the AWS Security Hub in the, say, the AWS Management Console, and you navigate to Security Hub and you enable it. You choose the security standards you need for compliance checks. You integrate this system with various AWS services like Guard Duty or Firewall Manager or Config. And you configure these services to basically send your findings to the Security Hub. You set up whatever you feel are going to be custom insights. And maybe you'll set up some filters to prioritize certain things over other things. And you can predefine these. And then you configure your notifications. Does it go into CloudWatch? Do you want to send off an Amazon Simple Notification Service, text to you, or something like that? You create notification rules. And then you'll automate whatever kind of response you want to do. Maybe an AWS Lambda function. So that's pretty it. And then you're going to monitor and review and just change things. So remember, any of these systems, any of these security hubs, and I'm saying this because I saw someone got a LinkedIn about a week ago and say, you don't need to have penetration testing. You don't need security audits. You just need to go to the security hub. That is nothing further from the truth. Tools are great. Consoles are great, but they miss stuff. So they miss things. That's why you can't just run a code check and deploy code and not expect it to crash. You have to deploy a code check, and organizations have to test it and stress test it. And then at one point, it's like, okay, now let's give this to a percentage of users. And then if it works, we'll give it to everybody. So understand this is just one of those things. It's the equivalent of a code check by looking at your system and saying, looks right. But that doesn't mean it's going to be right. But this is as good as any other system. All these systems have that problem. So let's talk about the AWS Resource Access Manager. And the AWS Resource Access Manager is going to be a service that's going to enable you to share your AWS resources with any account or with either within your AWS organization or any AWS account. So if you've got something and you want to share it with others, this is the Resource Access Manager. And you might do this to facilitate collaboration and resource sharing with other organizations and still keep security and control of your own AWS environment. So maybe you want to share something like a subnet with another organization. Maybe you have servers on one subnet need to talk with servers on another subnet in another organization. Maybe you want to share your transit gateway for routing through your system. Maybe you want to share some license manager configurations, something like that. Maybe you want to share resources with specific AWS accounts or all AWS accounts inside of an organization. And this is where the AWS Resource Access Management is going to come into play. It's going to be very good at giving you fine-grained access control on the basis of identity and access management. So remember, it's identity and access management-based security. Identity and access management is the person knocking on your door saying, I am here. And you're saying, well, welcome, or no, you're not allowed in, or you're allowed in and only access to this. There are other ways using network security to firewall off this and create a greater degree of security between accounts. But if you're going to do it just based on IAM, and in many cases it's appropriate to do so, you're basically using IAM to separate you and another organization, as opposed to taking two different VPCs and then labeling certain routing in between those VPCs. This is an IAM way to do it. And it's a totally appropriate way, but there's lots of ways you can segregate or segment your systems or micro-segment your systems, either in the cloud or the data center. Very useful for cross-account sharing. Remember, cross-account sharing is when you share information with another account. you're a PC manufacturer and you need to share information with a hard drive manufacturer, or a DRAM manufacturer, or a CPU manufacturer, or a GPU manufacturer, what have you. So very simple, easy to set up, centralized resource management. And it ensures that whatever your shared resources are going to adhere to those identity and access management policies. And it'll give you the ability basically to log and see whatever happened through CrowdStrike. So very convenient service. So how do you set this up? You basically enable the AWS Resource Access Manager, say in the management console. You ensure that your accounts are part of an AWS organization if you want to share resources with that organization. You're going to create a resource share. And in the resource share, it's not that different than sharing resources on any other server. You're going to define the resources you want to share, and you'll specify either the AWS accounts you want to share them with or organizational units you want to share them with. You'll set your permissions just like you would on any kind of server sharing environment, and that's going to be your IAM permissions. You'll accept the resource shares. The receiving accounts must also, you'll send them an invitation. They'll send you one. They need to accept it, that kind of thing. And then after they're accepted, whatever resources you allow to be shared are going to be, they'll be able to manage. And then, of course, you monitor and manage. Use CloudTrail, which has auditing, to log it and see what happened. And that's how you'll deal with these things. You don't need a share, you'll revoke it here. When a new share, you'll create it here. So let's talk about the AWS Firewall Manager. Firewalls are very essential for security because, as I mentioned before, identity and access management is someone knocking your door saying, I'm here. But if you really had a high security house and you could put a giant wall over your house with a moat that would be impossible to swim across or near impossible to swim across, you can add some defense and depth to your security. And it's much more robust than just saying, I'm here. So you'll be using firewalls everywhere. Now, managing thousands of firewalls or hundreds of firewalls can get pretty cumbersome. So AWS has something called the Firewall Manager. And that's going to be a security management service to make it easier to essentially manage and configure firewall rules across your accounts, making sure they're consistent. And so in a single place, you'll go to see what's going on with your security policies. It supports, your key things. So if you're using the AWS Network Firewall, or you're using AWS WAF, or AWS Shield, or VPC security groups, this is going to be very helpful to you. It will be less helpful if you're using other non-AWS tools. That's why you got to look at it and see where it's going to help. Might still be helpful in either way. It'll manage your security groups. So if you've got security groups coming into every service, and you should, and you also have a couple of other AWS things, this could be very helpful to help you think about it. If you're using AWS organizations and you've got a firewall between you and somebody else, well, if you're using different VCCs and you've got firewalls, that'll help. But if you're using AWS organizations, which is that IAM segregation of your accounts, to provide centralized policy management, you can use it here as well in the Firewall Manager. One of the cool things is when you've got all these logs coming in and you're in a highly regulated industry like banking or healthcare, you've got to provide some compliance information. And this Firewall Manager, because it's going to aggregate so many pieces of information, it's going to give you good information. And it typically protects resources when they're created and making sure that things are there, so helps remediate things whenever possible. It can also deliver what's called an event-driven notification. So it sees something, it doesn't like something, it can send you a message so you can be brought in to deal with it. So how do you set this up? You enable the AWS Firewall Manager, you define your policies, you apply your policies, and then you monitor for compliance and automate any kind of notifications you want on remediations. And there's going to be a lot of these services we talk about. Let's talk about AWS Config. AWS Config is going to be a service that's going to enable assessing, auditing, and evaluation of your configurations in AWS. From the perspective of AWS, it's going to provide an opportunity to see changes were made. So who made them and where were the changes made? And that's actually going to be some pretty important information to see, Because if you can correlate user A did this and then these logs did this, you can see that what happened and when the change was made. And that way you can say, okay, you might have to train the user and then not make a change like that. You may need to change your change control environment for an organization, or your change control process, or anything, whatever. But the point is, when you get information, you can make better decisions, and that's really what we're talking about here. So config will constantly monitor all these configurations out there. If a change is made that violates an organization's policy, boom, you're notified. Typically, a CloudWatch event will occur, and an SNS event, you might get a text message, that kind of thing, or an email event problem. So lots of ways to assist with change management. You can track the relationships between things. So this happened, and then this sequel of events happened. Now you know how they're related. Did you plan on that kind of thing happening in the future? Do you need to change your architecture or your configurations or your systems? You'll find these things, and this is going to be very helpful to do so. Integrate with CloudTrail, so you can know what change occurred and then go fix it. So it's constantly monitoring. Configuration change is made, boom, config notes the change. It records it in a consistent format so you can find it. Is it allowed? Okay. Is it not allowed? Go notify somebody a change that was not allowed happened to occur. I hope this kind of makes it a little simpler. You got this AWS config in the center, sitting there, hanging out, monitoring changes, seeing what's going on everywhere along the way. Configuration change is made, boom, it hits the config API. It's sent a CloudWatch event. Maybe you store the logs in S3, but you've got access to lots of information. AWS Inspector. So another AWS service, and it's an automated security assessment service that's going to help to secure security and potentially the compliance of the applications that are deployed in AWS. And it's constantly looking around, assessing for vulnerabilities or deviations from best practices, and it's going to give you detailed reports. Now, there may be times that you're supposed to have a deviation from a best practice and you've got some other best practice deployed, and there's a good reason for it. This is not going to be helpful. It's going to tell you made an issue. But even if you didn't. So understand that these types of services can often give you a lot of extraneous false positives, and that might be okay. They also might miss stuff that's actually very important, but it is an automated service. And it's better to have access to this information. So it is a very good tool along with other tools. So it runs these constant security scans. It'll look at the network, it'll look for common vulnerabilities, and it'll give you some configuration best practices. So these kind of tools are great. By the way, you've got a tool like this inside of if you look in your computer, you'll see a security center. That doesn't mean your computer doesn't need more security than what's in your security center, but it'll tell you, hey, maybe you need new antivirus definitions. Go update them. So start thinking about these kind of findings and recommendations that you're going to get from these kind of tools. You can't secure your entire systems for what you find in your PC security environment center, but it gives you a lot of good information. It can make good recommendations, and it can give you stuff to think about. And then you need to make the decisions based upon the findings that your team finds, organization's business needs, goals, recommendations, what have you, and the unique systems you chose. It can assess lots of things. You can look at the security state of your EC2 instances or virtual machines based upon, what applications did you install? Is your system configured properly? Is the network properly open? It can look at your containers, like an Elastic Container Registry, and it constantly can scan for vulnerabilities and unnecessary exposure, network exposure, say, in your container and images. It can look inside your Lambda functions and scan for vulnerabilities or unintended network exposures. It's got some predefined rules packages. So it has a set of built-in rules based upon common security standards and best practices. It can do some benchmarks whenever that is appropriate for securing operating systems. It'll give you some general guidelines and best practices. And it will provide some kind of runtime behavior analysis. So if it sees things that it doesn't like, it can also be indicative of a system compromise. You can get some fairly detailed findings here. Lots of reports, severity levels, impact, and it'll give you some recommendations for what to do. It integrates nicely into any of the AWS security features because it's an AWS proprietary product, which will integrate nicely with other AWS proprietary products. That's the benefit of staying inside of a single provider. So where would you use this? Vulnerability management, here's a good tool. Constantly scanning your systems and giving you some potential vulnerabilities your systems may have, and even some recommendations on what to do about it. It helps with your compliance and auditing. So if you've got to support, say, PCI DSS or HIPAA, and you've got something that's telling you, yeah, you're doing it right, it's going to help your compliance. It can help with your application security because it can make sure that the applications are deployed securely by constantly monitoring. It can detect misconfigurations and vulnerabilities. So it gives you a lot of information. And it can help with consistent monitoring of your systems. Assess your CI/CD system for applications, the DevOps stuff. Monitor new vulnerabilities, misconfigurations, and help you do it. So pretty easy to set it up. Basically, you define the resources that you want to be assessed, like an EC2 instance or a container image. You run your assessments, and you usually use a predefined rules or customized rules, what have you, to run these things, and you schedule your assessments. You review the findings of the assessments, and then you remediate issues as appropriate, meaning you look at their assessments. Is it the right thing to do? Is it the wrong thing to do? If it's the right, go do it. If wrong, it's then you know it. Well, at least you saw it and you looked at it and you choose to do something different, which is totally appropriate in many cases too. Some best practices here are to run some good regular assessments and integrate this into the CI/CD pipeline. So you're going to consistently have some better application security along the way. Prioritize high severity findings. If these findings are accurate and they're right, organizations don't have enough resources, generally speaking, to fix everything. Start with the highest priority ones first. Or organizations can choose what their highest priorities are. Integrate it to the Security Hub, so you've got a good centralized visibility system to be able to look at things. Use it to aggregate findings with the Security Hub. Okay, I think now is probably a great time for us to take some questions and see if there are any. So Tyrone, let me know what's going on the question front. How to integrate application with RDS via IAM or application users. So there's going to be a lot that goes into this, and your question actually could be answered in one of like 30 or 40 different ways because there's a lot of information more to answer that. But realistically speaking, for IAM authentication, you're going to use roles and policies. For the application, you're going to create a user for, say, the database or whatever needs to be in there. But I don't really completely understand. So your databases can go, for example, could go look at the IAM systems, which are going to go back to, which will typically go back to Active Directory via a federated IAM. But you're also going to have one application that's going to connect to another application. So there's going to be typically an API between them that's going to be part of the integrated of the application. So there's a lot that's going to go into that. And to truly understand your question, we need to speak live, and to answer it, we'd need more than 30, 45 minutes to do so, getting into that part of application architecture. So generally speaking, there's an API between your different applications. And all of these applications have the ability to go look into any type of IAM system, such as Active Directory. And whether it's your routers, like the firewall in my house, I have one firewall that I use as a VPN concentrator. I can have a database on that firewall. I can sync back to, say, a Radius, which is a remote access system to find usernames and passwords. Or my firewall can go integrate into Active Directory to see that when Sally VPNs in and Sally enters her username and her password, Sally's allowed access to this one subnet. So typically speaking, any major application is going to have its own way to integrate into IAM. But in many cases, we're going to be dealing with custom applications, like an application server going into a database. And that integration is over an API. But also, you're also going to have your credentials here, which are typically going to be done on the databases themselves, that are going to go from the databases back into either AWS IAM through an API of some function, or they'll be going into Active Directory and it knows how to send those right requests. So typically speaking, there's an API involved whenever you integrate one system to another. But there's a lot more to your question that I can't typically understand based upon the way it was asked. What's the best security practice? So there's no such thing as best, ever. We have to look at the organization's needs, and then we need to find out what they're protecting, and we need to understand the value of what they're protecting, and then we need to find a protection strategy. And sometimes a protection strategy is buy insurance on it and transfer the risk to somebody else. So we need to understand that. So let's say I had a web application for a bank. Just for that web application, I might have a network load balancer in front of two next generation firewalls from, say, Palo Alto, and allowing only port 443 into the DMZ subnet. But on the way into that DMZ subnet, I might have another network load balancer, which is going to go then front end to different next generation firewalls from a different firewall manufacturer. I might actually then have another network load balancer in front of two IDS IPS systems inside of there, and then have an access control as protecting that subnet, and then actually have a security group protecting the load balancer where those servers would be. And then on those servers themselves, not only we harden the operating system by coming up with a hardened operating system by removing unnecessary services, putting some anti-malware protection, putting a host-based firewall on it, really locking that system down. And that system itself, still isn't going to be enough. We're going to have to encrypt the storage on that. And then we're going to need to, when somebody tries to log into that system, hit a good single sign-on, a very good, say, Active Directory database. And then for that particular user, because we're dealing with money, we might actually have to use a one-time password, like one of those RSA secure ID things, a password that changes constantly. That's a bank, and that I didn't even cover half of the security. That's just a percentage of the security. But another business might be different. Another business might be just a small business, and it might be a small business that's got a website. A business that's doing less than $1 million a year would be considered a relatively small business. And that company might just need that web server, and it could be a server where they just harden the operating system and put some endpoint protection on it. It can be behind a load balancer. That load balancer may just need a security group and WAF, and then shield in a content delivery network, because that organization's assets they're trying to protect are very small. And that would still be two appropriate things. And then have a good identity access management strategy. But you can see two different scenarios require two different things that are very different. So I'd like to maybe have you think about it this way. What is the best airplane? Well, if I'm going to go a short distance, they have these Embraer jets that are pretty fast at like 550 miles an hour. They put 50 people on them. They're quick to get on. They're quick to get off. If I'm a fighter pilot, I want a plane that can fly at 3 times the speed of sound and has as many weapons as possible and is still agile. Now I'm taking a long haul flight between New York and Abu Dhabi. Now I want to be in a big, comfortable plane that's got a long range so we don't need to stop for fuel. By comparison, if I was trying to dust a crop, I might want to use a Cessna. So the key is we need to understand what we're doing. That's why there's never a best tech. That's why there's never a best solution, because every business will have unique needs. But it's a great question you asked, Umar. Incredible. CloudTrail and AWS Config. How are they related or different? So CloudTrail logs API calls, whereas Config tracks your resource configurations. So CloudTrail is really for auditing, because it's that auditing side of it. But one is more looking for what happened. Will this system access this system via an API call? It happened 15,000 times. CloudTrail is going to give me that. Config's going to look and say, oh, This operating system isn't the version we think it should be. Wait, you misconfigured this on this server. So it's a really great question, and I hope that actually answered it. A lot of these things are really similar. Like a lot of them are so similar. And when you think about them, it gets pretty challenging, like the secrets manager versus the systems manager parameter store. And typically when you see this kind of environment, we've got multiple things that are pretty similar. You typically had a customer in an environment that said, I like this, but I really need it to be this. And all of a sudden they come up with a new service with a new name. And this is common amongst all kinds of technology vendors. Somebody asks for something, you make them something custom, and it's a brand new name. And it's typically similar, but in this case, the one is on the API and one is on the configuration itself. Great questions. So I want to know you're awake, alert, and oriented. So to do so, give me a hashtag that says hashtag AWS. As soon as I see them come in, I know you're awake, alert, and oriented, because now we're getting deep into AWS stuff. And we're coming to a lot of services, much less architectural discussion here. So it's a little more challenging to get through. So I want to know you're awake. If you just joined us, we've got a series of labs for you to do. They're completely free. There's over 40 of them. Sign up, go get them, and go do them on your own time. We have 3 hours a day for 9 or 10 days to do the course, so we really try to give you a lot. If you're having a good time, hit the like button, subscribe, hit the bell to be notified of new videos. And they're there. And we'll take you from there. So let's talk about the AWS Audit Manager. So the AWS Audit Manager is a tool to assist you with auditing your AWS architecture. So it's going to help assess risk compliance with industry regulations. It'll collect evidence to help you be audit ready. It will audit against a pre-built framework. So there's lots of frameworks like ISO 27001. That's a pretty stringent framework. There's the PCI DSS framework. There's the SOC 2 framework. There's the HIPAA framework. Europe has their GDPR framework. And that enables you to customize various frameworks to or create your own to meet whatever audit requirements an organization needs. The key here is its automated evidence collection. It constantly is collecting information from your AWS resources and your AWS services. It'll integrate into AWS Config, which we talked about. It'll integrate into CloudTrail. It'll integrate into CloudWatch and any kind of AWS services that are going to be necessary to get whatever the necessary information is. It's going to provide centralized evidence storage. So one place you're going to go for stuff that's been collected over time. And that's going to make it easy when the auditors come in and say, I need to see this. You can run custom assessment reports with this. So your organization wants to go look for this, it'll go out there and do it. So you're probably still going to need to have people that are going to come in and do these things, but it's going to streamline it. When people come in and audit, here's all the information we have, as opposed to them trying to figure out along the way. So it's going to reduce and lower cost audits for organizations that need to audit their systems. Kind of helps with workflow management as well. And it's going to support collaboration between different stakeholders that are involved in an audit process. And there's lots of people that come in, typically from a consulting firm, to do this. It helps manage the tasks, assign responsibilities, track progress. Integrates nicely with third-party tools to check for extra functions. It's going to support evidence and exporting evidence and reports to other compliance and risk management systems that you may be using in the enterprise. Now, when you're under a regulatory environment, you have to do a lot of stuff. This makes it a lot easier when those internal auditors come in constantly and the certifications that come in constantly. So that's one place where you would use this. Here's another use case. You're going to do your own internal audits to assess compliance with internal policies or standards or security. It'll help you identify and mitigate risks associated with non-compliance. It'll help with risk management because it'll enable you to constantly monitor and assess risks that's going to be associated with your AWS environment. It helps you implement protective measures because if you understand what's being there, and you understand challenges and risks, you can figure out, oh, I need to do this now. So pretty helpful like that. Now, if you're going to deal with a vendor, you got to audit their stuff. If you allow another vendor into your systems, they can cause you problem. For example, CloudStrike was integrated into the Windows kernel and could make changes to the Windows kernel. Probably part of the system where you really don't want to give access to that away. But they had to legally because of another provider in Europe said you must allow access to the kernel. So a third party comes in, it pushes information to Microsoft Windows systems, and all of a sudden they're all crashed and half of the world is down. So whenever you deal with a third-party vendor, you have to audit their stuff. Are they good enough? Are their processes and procedures good enough? Are their controls good enough? If not, you stop doing business with that provider and you do business with another provider. But the reality is you're generally going to use multiple providers anyway, so you're not stuck with a single one and their vulnerabilities. But that's the key. You can use this tool for vendor and partner audits, and that is very critical when you deal with third-party vendors. Let's talk about another security service, and it's called the AWS Certificate Manager, ACM for short. So lots of times you're going to need certificates, right? SSL, TLS certificates on, say, web pages. And where do you get it? You get it from a certificate authority. So AWS has that certificate authority functionality to be able to give you certificates when you need them. And they can handle automatically, the certificate renewals, and integrated very nicely into your AWS services for your website, your applications. So enter the world of the AWS Certificate Manager. It is an AWS managed environment that enables you to centrally manage and take care of your certificates. Makes it easy to provision a public or a private certificate. Public certificate is stuff you use on the internet. Private certificate is things that you might use internally. Maybe internally, you've got an HR system that's accessed over the private internet over HTTPS. Well, that would need a certificate. Doesn't go to the web, though. So that would be an internal certificate. And Certificate Manager will give you free public certificates to things like AWS APIs or load balancers, but you're going to have to pay for a private certificate. So we're going to use certificates everywhere, but in this particular case, we could be using the Certificate Manager to create certificates. We might put an SSL TLS-based certificate on our CloudFront distribution. We may put it on the load balancer that's in front of our web page, terminate some SSL sessions there. And that's kind of really what we're talking about with the Certificate Manager and where you might use it. Let's talk about some key features of the Certificate Manager. It enables you easily to provision certificates. And it's simple. You go to the management console, the CLI, or via an API call, get your public or your private certificates. It automatically renews your certificates before they expire. So continuous protection over your certificates. And that's going to make it a lot easier than installing certificates. Okay, we've got to go to all 15,000 devices and then remove certificates and add a new one. So big help there. Because it's an AWS thing on AWS, it's going to make it very easy to integrate with any kind of AWS services like a load balancer, CloudFront, an API gateway, Elastic Beanstalk, what have you. And it's going to make it relatively easy to at least provide TLS, SSL, TLS-based security to your applications like your website. You can use it for domain verification as well. And you're going to use domain verification to verify domain ownership before it's going to give certificates to kind of lock that down to make sure they're supposed to be where they're supposed to be, by whom. And it'll offer an email validation as well to make sure that the domain is who they are supposed to be and ownership is exactly accurate and legal and right. Let's talk about centralized management. It's going to provide a centralized interface to manage all of your certificates, whether they be public or private, and that's going to make it easier to track. So where might you use this? Secure web applications. HTTPS needs TLS-based certificates. API security. You may need to secure your APIs with a certificate to guarantee that the receiver is who they claim to be and the API is who they claim to be. So you can use it for API security. You might use it on internal applications. Maybe you've got a database or an internal application like an HR application that you need some security on. So you can use a private certificate internally, accessed over the private network in the internet, not the internet. You can use it with compliance and governance because you can ensure that these certificates are going to meet security standards and that you're using SSL or TLS as needed to maintain compliance with your industry's privacy standards. So how do you use it? Pretty easy to set up. You go to the management console, you navigate to the certificate manager, and you request a certificate by clicking it. You choose whether you want a public certificate or a private certificate. You enter the domain names, for example, gocloudcareers.com. Then you validate the domain ownership to make sure that you do own the domain. It can do a DNS validation by asking you for a CNAME record to your DNS settings. It can do an eName validation, realistically speaking, to approve the verification request by going to a domain registered to the user. You deploy your certificates by putting it on the load balancer, CloudFront, your API gateway, what have you, and you monitor and review. And it's going to automatically renew your certificates before they expire, and it will monitor the certificate status, and you can do so by looking at the ACM console. Some best practices here: use DNS for automation. It's going to be harder to fool DNS in most cases than it will be a simple email. So prefer DNS for validation because it allows for a quick and an easy and a relatively secure validation. You just update your DNS records as needed for automated validation and renewal. Leverage the certificate manager for managed renewals. If it's got the ability to automatically renew them so you don't have any downtime because you didn't renew them on time. Because you don't want people to come to an application and get that this page is unsafe. That's not going to build any trust with your audience. Centralize your certificate management. So if you're all on AWS and you want to use this AWS Certificate Manager, it's going to be very simple. And it's a great certificate manager. And you can use it to track and the audit the certificates across your AWS environment. Make sure you use it to secure internal communication. So if and when possible to use a private certificate inside of your network, do so. And that way, if something's no longer good, you can revoke that certificate and as well. And of course, obviously follow security practices. So use strong algorithms, encryption algorithms, and ciphers. Update your SSL TLS configurations. Make sure you're adhering to the most appropriate security standards. Okay. Now, another AWS security service. I'll try not to spill more water on me. Here's Guard Duty. So Guard Duty, AWS Guard Duty, is a managed threat detection service. It kind of looks around and consistently monitors your attacks, monitors your account, your workloads, any kind of information you stored in, say, S3. And it's kind of this behind the scene things, kind of using machine learning to look for anomalies and things that doesn't feel right. And then it's going to use some threat intelligence to say, this is probably a big deal. This is probably no big deal based on AI. It's a service that'll help monitor your accounts. It'll look at your CloudTrail systems. It'll look at your DNS. It'll look at your VPC flow logs. It'll look for patterns of behavior with compromised systems. And if it sees something, it might send you a CloudWatch event to notify you of something so you can fix it. It's here for threat detection, kind of looking for stuff all the time. It's looking for anomalies and suspicious activities. Now, each day periodically there's what's called threat intelligence feeds. And there are companies that basically like Proofpoint or CrowdStrike that basically provide a feed. Hey, these are all the threats we know about today. So that'll integrate into them. It'll constantly monitor your AWS CloudTrail, your VPC flow logs, DNS logs, that sort of thing. It can look at your CloudTrail. Again, these are your data sources, VPC flow logs, DNS query logs. And then it uses that pattern matching anomaly detection to say, this is not something you think. It's deviating. It could be a problem. So it gives you detailed findings by severity, low, medium, and high. It gives you some context for each finding. And it's going to integrate with the AWS Security Hub. And it can help automate your remediation. And here's the good news. It can connect with your third-party SIEM system. So in a big global enterprise, you're going to be getting logs coming from something. And you're going to be dealing with these comprehensive SIEM systems, these security event monitoring systems. You're going to be constantly looking for these things and potentially across 2 and 3 clouds. But this integrates to those types of systems. And to some degree, it provides similar features and functionalities, maybe a little different. And one good thing that you can say where you might use is it'll help really find if your account's been compromised. It may look for unusual API calls or too many login attempts. It'll look for unauthorized access or attempted privilege escalations where you go from a regular user to, say, administrator or trying somebody with administrator privileges. You might use it for protecting against data loss. So organizations typically have a data loss prevention strategy and systems to do this, but this can help with look at your data as well. For example, it might detect an abnormal data transfer between 2 different locations and send you that maybe this isn't supposed to occur. It can look at unusual patterns of data or access to transfers within S3 buckets. Should this bucket being compromised to somebody else? It can look for malicious activities fairly well. It'll provide alerts on known malware, bots, and other threat actors. Now, it'll monitor for signs for command and control activity. But see, the other thing here is known attacks. Known attacks are good, but some of these more enterprise things can look more closely at unknown attacks as well, meaning that as soon as it happens, something is abnormal. And sometimes you need that, and sometimes you don't. So where might you use this? Well, compliance and governance all day long. Anytime you can tell a regulator, look, we've got all these audit trails and we got constant monitoring, it puts you in a better way, especially if and when things go wrong. Because you can say you followed best practices. Regularly, you should monitor these things. Regularly, constantly look at it. What's it telling you? Is it good at giving you good information, bad information? What can you learn from it? You want to consistently monitor for new patterns of updates and threats from threat intelligence feeds. It's going to help you automate responses, and you're going to use it for this. So implement automated responses. Define clear workflows for incident response and remediation. Integrated into AWS Security Hub or more commercial, more robust SIEM tools and any other kind of security solutions, because security is not about one tool or 2 tools. It's about the entire package, because there could be hundreds of tools going on for security inside of an organization. And GuardDuty could be one that you could use. Now, whenever you use things, in best practice wise, there's always a user training and awareness component. I'm going to go out there and educate users and administrators on common security threats and best practices. You want to make sure you encourage regular security training and go out there, because you can have the best systems in the world. And if you don't train your people, don't click on that button, don't give out this information, or know the CEO did not ask you via email to go buy Apple gift cards, they may fall prey to some of these scams. So how do you set it up? Well, you go to the management console and you select GuardDuty and you select Enable. And right around there, GuardDuty will automatically start monitoring your AWS environment. Then review the findings. Go to the GuardDuty dashboard and look and see what it tells you. If it's got a high severity finding, go look at it. Is it valid? And if so, maybe you need to fix it. Maybe you can't fix it now, but you can soon, and you'll plan to fix it, but do what you can based upon what you see. Whenever possible, set up automated responses. Maybe set up a Lambda function to go remediate it. User put an object in S3 and made it public. Kick off a Lambda function to fix it. It's the most common cloud attack, is somebody did that in S3. So with GuardDuty, it notices, it monitors it, kick off a Lambda function to go fix it. integrate it with Security Hub. So the point is, all these tools are gathering information. If you can aggregate it in one place, you might look at it and be able to do something with it and figure it out. Because it's very, very hard looking at all kinds of stuff all over the world. So now we're going to talk about Amazon Fraud Detector. And that's going to be another managed service. It's going to help you identify potentially fraudulent activities in real time using AI or machine learning. And Fraud Detector really automates the process of building, deploying, and managing fraud detection models. So it helps you detect online fraud more accurately and efficiently than you may be on your own. So how does it work? It uses machine learning. So AWS has these pre-built models which it feels are optimized for various type of fraud detection services, and they've got some experience there. So realistically, these systems are going to work. And that makes it easier because to make a model, because you've already got tailored models to detect fraud based upon the preponderance of use cases. So, you may need custom, you may be able to get away with this. And it's got fairly customizable rules, so it enables you to define custom rules to supplement whatever the machine learning models they're using are. It enables you to provide an ability to look at your business logic and tune this to make sure it looks at your business logic to enhance the fraud detection. And then it will real time go look for problems. It'll integrate with your applications via APIs. It'll look at transactions, and it's going to give you that real time prediction. Enable you to look at it and say, normal, abnormal, big response in the market causing this. So this is normal today, but not normal another time. So good information. And the more of these systems you get, the more you're getting. It enables what you would think of as data enrichment. So you're pulling all this information. If it can make accurate information, recommendations, and insights, it can help you make better decisions. It's going to use metadata so you can look through the data and find it a lot easier. It's going to help with your scalability because it's going to scale automatically to handle large volumes of traffic. And that way you're going to have some relatively good low latency and high performance fraud detection, basically pre-made that you can use with the service. And it's integrated into so many AWS services. So as long as your stuff is all AWS, you've got fairly comprehensive workflows, it's going to be pretty helpful. Where might you use this? E-commerce fraud. In e-commerce, you may detect fraudulent orders or things called account takeovers or payment fraud. And, what happens is businesses will take a credit card. Somebody will buy something, say a $10,000 computer. They send out the $10,000 computer, and then somebody finds out that it was a stolen credit card. And what will happen is the bank will pull that payment from the vendor, but the vendor gave out that $10,000 computer. So that e-commerce would be probably an reason a business might choose this. Financial services. Well, they typically have very good fraud detection, but systems of their own. But this could help there too, because it could look at fraudulent transactions, weird account opening, identity theft. That stuff happens all the time, sadly. And it can enhance an organization's operations, financial-wise, and trustworthiness and security. Insurance fraud. It can detect all kinds of funky claims with underwriting activities and insurance. It can improve risk assessment, and by doing so, reduce the cost of fraudulent payouts. Insurance prices go up and up and up and up because they're paying a lot of money, and then they pass the cost on to the users with insurance rates that in some cases people can't afford. So if they can mitigate fraud, they can keep insurance prices at a reasonable level. How about gaming? Online gaming, subscription services, digital content platforms, another place where you may want to use some fraud detection. So how do you set this up, this Amazon Fraud Detector? Well, you prepare your data. You're going to have to collect historical data and label them as fraudulent or non-fraudulent. Why? This is going to enable the system to look at the data and learn, oh, this is acceptable, this is not acceptable. So your data with any AI becomes your course of truth. Meaning if your data that you give it is bad, your results are going to be bad. So you're going to make sure you've got any kind of good information that you can feed this thing. So the first thing that we do is we prepare our data. The second thing we do is what's called creating a detector. So in that management console or the CLI or the API, we've got to go create a new fraud detector. And we're going to go configure that detector by specifying the data set and defining the model training parameters that we choose to use. We'll then train and evaluate the models. We'll train the fraud detection using whatever prepared data we gave it. We'll look at the model's performance. Is it working? Is it accurate? Is it precision? If not, we may need to retrain it or look at our data and clean up our data to make sure our data is good. Then we need to define custom rules and outcomes. So we're going to have to create that custom logic of what we want it to be. How do we want it to enhance? How do we want it to detect? What actions do we want it to take when it sees something that's suspicious? Do we stop the action, for example, but what do you want it to do? And then we deploy it and integrate the model. And of course, we deployed it, right? So we go back and monitor. So, the Air Force has what's called an OODA loop, where you observe a situation, you detect what to do. So observe. So was it observe, orient, decide, act? I think that's how they observe. Yeah, you observe something, you orient yourself, you make a decision, you act. That could be one kind of thing. But in medicine, we start a treatment. We assess the patient. We bring them back into the office after a couple of weeks. You're getting better. You're not getting better. Here's a new prescription. So anytime we deal with anything, we're going to build a plan. We're going to deploy the plan. And we're going to test and see what worked and didn't. And then we're going to modify and change. So keep this in your mind. Nothing's ever going to be set in stone. Let's talk about some best practices for Amazon Fraud Detector. First, use good data. If your data is bad, your results will be bad. Regularly update your data set with new transactions to keep the model current as things change. You got to bank what, when I was younger, something, gas was $1.25. So it was normal for people to spend $10 on gas. And in those days, if somebody spent $100 at a local gas station, it would have set off an alert. But now, if gas is $3.50, $4 a gallon, and your car takes 25 gallons, you spend $100. Now, if you didn't update your data between then and now, all these systems would be bad. But even 3 years ago, we had $2.50 gas, and now it's like $3.50, $4 based upon where you're at. So that's a big change in a very short period of time. So you have to update these systems because they might not know what's normal now versus abnormal as data changes when they change by a lot or a small amount or even a medium amount in a short period of time or a medium period of time. So combine machine learning and rules. So use a combination of these machine learning models and custom rules to enhance your detection and your accuracy. And then leverage these information for specific business insights to make sure that your rules are effective. Monitor the performance of these systems. So constantly monitor the performance of your new fraud detection system. Use feedback loops to retrain your models or refine rules based upon new fraud trends. Test and validate. Rigorously test long before you deploy them. Don't just deploy stuff at speed just to say you did and figure it out along the way. Test and really make sure these systems work. Conduct some A/B testing to compare the effectiveness of different strategies. Which one works better? Let's talk about another system, the AI-based, AWS Macy. And here's what my plan is. My plan is to go to about 4:50, 4:55, and then take questions, even if we run about 15 minutes late. My wife has some big plans for me on Friday if I can finish on Thursday, and I want to make her happy. So I'm going to try to finish on Thursday by going a few minutes late each day. And if we can't, I will just tell my wife I can't do it, and I'll find another way to make her super happy. So let's talk about AWS Macy. And that is a fully managed data security and data privacy service that, again, uses machine learning. And the goal here is to look for patterns of behavior that are abnormal and protect your sensitive data. So you may actually get notified that you have sensitive data on the system, like personally identifiable information in your S3 bucket. So it's going to do some automated data discovery, and it's going to constantly monitor and scan your S3 buckets to identify your sensitive data. And it's going to look for various patterns of what it sees as private health information and financial information or regulatory data. And that will help you meet security and compliance by identifying your data, security, and it's going to give you some fairly detailed reports and dashboards for compliance reporting purposes. It's going to give you relatively detailed finding and alerts, which, again, it's machine learning, so some of it might be great and some of it might be not. And I can give you an example later if you guys desire. And by guys, I mean everybody, men, women, just general blanket term. So some things to think about is it's integrated with everything that's AWS relatively easily. So CloudWatch, Lambda, AWS services. And it's going to go out there and it's going to look at stuff and look at your S3 buckets, and then it's going to go prevent data breaches and look for unauthorized access. So where might you use this? For compliance purposes, it may look for things like GDPR or HIPAA. It may provide audit trails and compliance reports. You might use it in risk management to identify misconfigured S3 buckets. It's great here. You might give you some data privacy management. It's going to look for things like personally identifiable information. It will support privacy assessments and data protection strategies. And it's going out there and it's looking for what it thinks is sensitive data. And it'll do what's called a data discovery job, and it's going to constantly scan your S3 buckets, and it's going to give you a detailed report. So let's talk about some best practices. You got to constantly monitor this stuff. Constantly look at it, review it, and update it. Prioritize high-risk findings, because some stuff is terrifying and you better fix it immediately, and other stuff you can leave for a long period of time. Automate the remediation. So automate it with the Lambda function and integrate it with Systems Manager. Integrate it with Security Hub, so you've got a centralized view. Look for custom data, set up customized data identifiers. Tell it to look for something specific in its data discovery. Tune it, tailor it. So how would you use it? Well, first, you enable Macy. 2, you'd go to the data directory and configure it to tell it what data to discover. Set up this data discovery. Scan your S3 buckets to how often you want to scan them, that sort of thing. And review your findings. So to give you an example of these types of services, one day I was sent a message from Google that I had ICD-10 diagnoses codes. And obviously, that would be something you wouldn't want to share. And an ICD-10 diagnosis code is a couple letters with a dot and a couple more letters. So I got an alert that I had ICD-10 diagnosis codes in my Google Drive, the corporate Google Drive. And, I was thinking, did I see a patient as a volunteer? Could they have been right? Did I write a diagnosis code or a procedure code on a patient and store it in object storage by accident? So what we did is we scanned it, me and Chris from my team. And we saw that I had an IP address that somehow was broken down, 192.168. And then I had another thing right after it, which was another half of an IP address, but they were separated. And it looked like an IC10 diagnosis, even though it was an IP address that had one accidental space in there. But these machine learning look at it, oh, that looks like an ICD-10 code, and they send an alert. Now, it wasn't there, but that's the thing to remember with these automated systems. They're going to send an alert, and it might be great. It may be horrible. So we're going to have to constantly go through these things. So the next level of content is a big new topic. It is IoT, and maybe I save that tomorrow. So, Tyrone, who has questions for me? Because that's a a lot of concepts. In AWS, can you use one SSL certificate for all services? Unfortunately, not. So the key with an SSL certificate is for me to know that you are in fact FA, as opposed to somebody else. So I'm not part of what part of Cameroon you're at. So I do remember you said you were in Cameroon. So Eddie from my team is in Bamenda, Cameroon. So here's the reason we use these certificates. Let's say I wanted to talk to you and we had a conversation, but I never met you before, like a web server that I've never seen. And Eddie, who's from my team, Eddie's a rock star. He's awesome. I think he's got a degree in law too. He's super smart. He's a great cloud architect. But if I wanted to talk to you, how do I know that you are Fa as opposed to you being Eddie? I don't until I validate, the endpoints of your digital signature or your certificate. So every device that needs to be protected is going to have a different certificate. So, you might need a lot of them. And especially if we're going to use encryption in certain types of zero trust environments. And zero trust is basically identity access management and encryption and micro segmentation. But if we truly wanted to issue a certificate for 1.5 million end devices in an environment, in a pure, heavy, ridiculously great zero trust environment, we might need 1.5 million certificates. So each device, each system is going to, or different service is going to require a new SSL certificate. Great question there. So how can we integrate AI with AWS services like RDS data within the databases? So in reality, it's not just going to be a simple integration. You're going to have to go look at that business and determine what are the business's goals. What are the business pain points? What are the business challenges? What are the current business processes or the way things get done? How do we want that to occur in the future? What does that organization's network look like? What does their compute look like? What does their storage look like? And what is the quality of their data, the quality of the databases? What are the mapping and reduction tools we have? What are the data hygiene practices we are? And from there, we can figure out what we need to do to the data. Then we will need to pick an AI model. We will need to train that data. And there's many other things that are going to go into it. So wasn't planning on bringing this up. So I actually have an AI architect program. And that is a big program taught by someone I have a lot of respect for. His name is David Lithicum, where he actually teaches how to do this because he's been in AI architecture since the 1980s when he first did his first AI program and then was working for NASA as an AI architect. And then he spent, time as chief technology officer and chief cloud architect, where every project has been AI for like 30 years for David. So I have David teaching that in our AI architect career development program. And if you'd like to learn about that or those things that you need and the skills, there's a free video on our YouTube channel, or you can register for a free webinar. So there's that. So the easy answer that I could give you that would be part of the certification would be, here, just use AWS SageMaker. And that's going to analyze your data that's stored on your RDS, and you've got lots of models, and you can pick and choose from your model. But the real answer is it's going to take a whole lot. Do we have the right kind of storage? Do we have the right kind of network performance? What kind of model do we need? And what kind of compute does that model need? Is that model something that can run on a CPU? And many models can. Do I need a GPU for that model? How much DRAM do I need on the compute to do this? How many GPUs do I need for the training data if I do need GPUs? Is it going to be done on CUDA? Most likely, which means I need an NVIDIA GPU. Is it not based on CUDA, where I can use an alternative provider GPU that's a very good GPU if it doesn't need CUDA as part of the compute that we're going to be using? And AWS and NVIDIA GPUs are great. I'm just saying, is it something that can be run on an FPGA because it's standard data? So all that's going to go into that before we can answer that single question. But yes, you can definitely use it. How do you use Lambda functions to automate remediation? So What you can do is it's basically you'll design what's called an event-driven architecture, and what it will do is if this, you will write a little mini application, do this. So if Mike uploads something in the bucket as public, and you've got an event-driven thing that says, as soon as you see something as public, kick off Lambda function 123 that says make private, you can do that. So that's the way these things are typically done for automated remediation. You write a code, or it's a very, very simple script. So we're not talking about fancy code here for these kind of things. We're talking about very simple scripting. If this, do this. So the example I would give you was many, many years ago. You would log into a Cisco router, and then in order to do something, you had to type in, and it would ask you for a username and password, which would go to an IAM server like Active Directory or Radius or TechX Plus or whatever you had. And then when you'd get on that server, you'd click enable. And that would give you the ability to do something. And then it would ask you for an enable password, which was privileged executive password. And then you'd try to do something like configure. So you'd type config T to configure the terminal. And it was a standard set of procedures. So what we did is we had our sysadmins write something called, like, there was a language called expect TCL, expect username and password, send username and password, expect this, respond to this. So it's a very simple script that people are writing that are going to do these things. If public, make private. That's really a great question out there. You're in Colorado. I think it's terrific. What's the weather like today? I was always amazed in Colorado. I'd be freezing and then I'd be hot all in the span of 10 minutes. It was really kind of cool. So there are no questions. So I can kick into, if you want, and we'll probably have Friday off, spend, say, another 20 minutes and kick off IoT devices, or we can finish on time. What would you all like? I'd like to try and get done on Thursday, but that's just me. You tell me, let me know what you guys think. Go a little longer or stop now? You see what you say in the chat box. George Lopez says, let's keep going. He was the first one to say something. I haven't seen any responses. Can go a little longer from Prasad. I love it. Let's go for a few more minutes. Information overloading. I'm sorry about that. So let's get one or two more. I think we go for a few more minutes. And then what we can do in the future is you can go back and look at it and go back and watch the last piece. True about Colorado. So let's go through it. I will stop by 5:20. So let's talk about IoT, or Internet of Things. So Internet of Things are like your little mini refrigerators that are IP enabled. Your TV that's IP enabled. The lawnmower that you have that tells you I need to be managed is an IP enabled Internet of Things devices. So weather sensors that are out there all the time are IoT sensors. So there is so much of these things that are out there. So typically speaking, you've got these little mini devices. These little devices are attached to the IP network. They send beacons, they send their information, and you're going to need something to manage it and retrieve it, and then you're going to need the devices themselves. Did we talk about a control plane versus a data plane before? Did we talk about the control plane that orchestrates the cloud and the data plane being the servers that are there? Have we talked about routers that run a routing protocol like OSPF and BGP, or sometimes both, for example? And then the forwarding plane, which are those links. Did we talk about Kubernetes master nodes versus the pods? Are you getting a theme here? All this stuff is the same. Learn it once under the foundation, you'll be good to go for everything. So we'll begin talking about AWS Web Services IoT cores. So what is that? That's going to be a managed cloud service that's going to enable connected devices to securely interact with cloud applications and other devices. So the IoT devices that are out there, like your refrigerator, which talks to you and texts you when you're in the supermarket that says, buy more broccoli, for example. I don't know. I eat a lot of broccoli, but that's neither here nor there. So that kind of thing. So it's designed to handle a lot of the complexities of IoT, things like the connectivity, things like the security, and things like management. So we'll begin with IoT Core. That's going to be the part that's going to help the building of IoT applications that are going to gather, process, and analyze, and even act on the data that's generated by these devices. And you might have a weather sensor every 5 miles across the entire United States. It could be, lots of these things. So IoT Core is basically the foundation for Amazon's solution for managing, deploying, and analyzing and maintaining an IoT architecture on the AWS cloud with minimal infrastructure support from the system owner. So normally you got some network architects that are doing these kinds of things. Here, it makes it a lot easier because a lot of it's semi-automated, helps you with doing it. So AWS IoT Core is going to provide a scalable and AWS maintained solution that's going to supply secure connectivity from devices and to the devices. It's going to provide some rule-based IoT data traffic manipulation. It can, take command and control of these little devices that are out there by the fleet. So I want you to think about this. You may have tens of thousands or millions or hundreds of thousands of these devices out there. Think about that operational burden. All this stuff out there. So IoT Core can help out with that a lot by providing a platform that's going to support communications and management of these IoT platforms and devices. And it's going to be managed by AWS engineers. So if you don't have those networking people or the sophistication to do it, it's provided for you. And you may choose to outsource this to somebody else so you don't have to think about managing this and can focus on other key business matters or other new products or services to be developed. So IoT Core is going to facilitate communication from the devices to the cloud. It's got built-in authentication and authorization. It can connect to a RESTful API for command and control, for example. It will work and support access control lists and even a device registry so you know which device is in the state of the data connections. So the IoT Core would be a service that's going to be beneficial to any scenario where there's a need to have a lot of IoT devices and you're looking for an easier way to get the information, analyze, and make actionable decisions in a quick period of time. So single device to potentially billions of devices because there's a lot out of it. So let's look at this overall solution. You're going to have these IoT devices all over the place. And they could be connected via the internet. You could be connected. They could be devices that are coming into AWS. And you can send all of that stuff directly to this core IoT. And that's going to expose an API. And then there's going to be a lot of other services we talk to that you can use with this overall architecture. But that IoT core service in the center, that's the component that's going to reach out to it and really be able to help you with these things. So that is your main thing there. That's the core of it. That is the central. That is your control. At least that's the way I like to look at it and help me remember things. So it's going to enable secure device connectivity. So devices can connect to this using a systems-based approach or a standards-based approach. So HTTPS, WebSockets, and it's going to ensure that the data is going to be transmitted with TLS encryption. It's going to help with device management because it's going to give you tools to register, organize, manage, and even remotely manage these systems at scale because there's a lot of these things that are out there. And there's going to be an IoT device management feature that's going to help you keep track of these devices because you also want to make sure they're working correctly. Now, you may have to use a message broker, and there's this MQTT message broker that's available for you to use to facilitate communication between the devices themselves and the application. And this can handle millions of devices sending constant messages. There's also going to be a rules engine. And the rules engine will enable you to filter and process and route data from connected devices, like various AWS services, whether they be Lambda, S3, DynamoDB, Kinesis, and so many more. And you can define rules that are going to trigger specific actions based upon incoming data, event-driven, if you will. So where might you use this? Well, lots of reasons. But maybe you're going to centrally manage and control smart homes. I don't know why anybody would do it, but I have friends that have thermostats that they manage from their phones and lights that they change colors and security cameras. And here you could use something like this. I don't want any of my devices IP enabled because they can be hacked. But a lot of people love these smart homes. Now, I'm more of the industrial use of these things, so think about industrial Internet of Things. You've got a lot of heavy-duty industrial equipment that's out there. When does the backhoe need its oil change, for example, or when does it need maintenance? When does the airplane need to come in for maintenance? When are these trucks that are being used on the road all day, when do they need proactive maintenance? When is some little thing or part going wrong where they need to be coming in and fix it? So think about the industrial uses of IoT. It's everywhere. Tracking equipment, tracking performance methods, metrics, predicting maintenance needs, and you could have all these IP-enabled sensors. And it can in some cases, remediate responses, but you're going to get access to this information. Connected vehicles. So start thinking about vehicles that now have IP addresses. They can give you real-time diagnosis of your issues, enhance your driver experiences, potentially stop you or your car if deemed appropriate. Healthcare. Well, in healthcare, talk about sensors and information overload. But now, one of the things we typically do is, we have patients with congestive heart failure. So we typically weigh them because with a patient with congestive heart failure, if they gain a few pounds, at some point it's fluid weight and it'll go into the lungs and they'll drown with congestive heart failure. So we can have IP-enabled scales where the patient can jump on the scale once a day and it can send a message to the cardiologist that said patient has gained an unreasonable amount of weight in a period of time, which is usually fluid. Make a cardiology office visit or send a nurse to the home to assess that patient to see if they need to come into the hospital. So lots of uses here for the IoT core and IoT devices. Let's talk about device management. So organizations are going to need to figure out what devices they even have and how to manage these things. So you'd be surprised what companies have and don't even know they have. So IoT device management is another AWS service that can easily register device information. So you can pull their information. How many devices do you have? What's going on? And you might want to remotely update the device's software and firmware. Maybe you found a major vulnerability in the device itself, which could be used as a means to hack into the systems. So that's a big issue with IoT devices. This service will help track and monitor and manage your devices or a fleet of devices to make sure they work properly after they've been deployed. So IoT device management will provide a device manager that provides access. So to securely look at device health, defects that it finds, detect anything or a problem so you can fix it. So let's talk about some things that IoT device management helps out with. The remote fleet monitoring. So equipment itself is going to have a lot of data or metadata, and you can set a policy to be informed of key alerts that you need. You may have to perform bulk updates of a lot of IoT sensors. Maybe you need a new feature or function for some new application the business needs to deploy. And they've got a lot of these already out there. So you can create logical grouping of devices like sensors in the South Florida area, for example, and you can do a targeted fleet and update a percentage of them. So lots of things you can do here. So let's talk about IoT events. So that's going to be a cloud-based service that's going to continually simulate data from applications and equipment and changes that occur. If something happens, it'll trigger an event, which will trigger the right response to the event. So one of the keys with IoT events is it's serverless, meaning there's no host for you to maintain. It's just going to be out there and monitor data. And if it sees something, it'll give you information, maybe early detection. So you'll have some information, you'll get some insight from it, and then you can figure out what the appropriate action is to take after you've gotten this data. So that's where IoT events is going to help you. So it'll make it much easier to detect and respond to things. It'll help an enterprise understand the conditions of its equipment, which is really critical. If you're going to trust the equipment, it's better be in good health and accurate. It'll help an organization gain some insights. And that's the key. If you find out that an organization has a fleet of stuff, maybe a global or national construction company, and you find out that their vehicles or tools need some kind of maintenance thing, if you can come in there and maintain them, as opposed to taking them offline for months because they broke, this can help a lot. Find a defect in an airplane before you find a problem, even though you're constantly checking those systems, gives you more information. So we have this concept of IoT Things Graph, which is now called Internet of Things Twin Maker. And what it does is it creates what you would consider a digital twin of a real-world system. So a twin of a building or a factory or industrial equipment and production lines. And it makes it easy to visualize the status and the interactions. What it'll do is it'll integrate data from various sources like IoT sensors, your applications, your data lakes, and it enables you some very good real-time monitoring of the digital twin. So it enables you to simulate various actions and see what happens to predict actual outcomes, which is very cool. And by doing so, you can think about how you can better do things. So the costs here are going to be based on a lot of components like data ingestion, your storage, your processing time, your visualization, what your detection is, and your automation. But anytime you get an ability to have like a twin system, and you can allow a simulation, it can give you an opportunity to game in the system and see what would happen, which is highly useful. Let's talk about IoT analytics. And that is going to be another fully managed service that's going to allow users to connect, manage, and ingest a whole lot of these information from these globally diverse systems. And it's going to provide a complete solution to collect, process, and analyze all this data. And it's going to help enterprises and device manufacturers quickly and easily get information from their data, maybe some insights, and then they can transform the data and analyze the data to do something with it. So lots of benefits from good analysis of data. So IoT analytics will look at stored data and give her a relatively fast response on a query to your IoT devices. It can prepare the data so it's easily processed and analyzed. And it can be a managed pay-as-you-go type service that scales with you. So you want to predict maintenance models in your fleet? Here's a solution. Like also knowing when a service is about to fail or need maintenance. Helps you build applications that can monitor your inventories in real time. And it gives you the ability to monitor different processes and different areas of improvement. There's a couple more AWS IoT systems. There's something called TimeStream. And Amazon TimeStream is really going to be a fast managed time series database. And it's a database designed for these IoT things and the types of operational applications that can be stored and analyze all of these devices because you're going to get lots of information. And the key is that it's time series data. It's data that comes with a timestamp. So you know when it's collected. And here's the reason. If you collect all this data over time and you know the times, you can look at performance metrics or usage data or sensor readings. And TimeStream, is going to be a fully managed, auto-scaling, fault-tolerant, cloud-native SQL relational database because you're storing transactions, you're storing time. For the most part, it's structured data, so you'll use a relational database. But Time stream really specializes in storing, trackable data that changes over time. Time series data. What are the analysis and trends over time? So they can ingest, trillions of events over a period of time interval from various sensors and all kinds of things. So time stream is going to be, a way to look at all your IoT devices, smart devices, motion cameras, light sensors, temperature sensors, health equipment. You could be getting a lot of information, and you're going to be able to look through this. It can notify patterns and trends and anomalies, and that's going to be able to help you make better decisions or better predictions. So the thing to keep about with time stream is it's managed. So no, basically nothing to think about like databases and patching the operating system. It's designed for time series data. This stuff happen over time, so you can get an analysis of it. It scales. It can handle trillions of events per day, and it's kind of that cloud provider build it, and they hope the users come. So lots of capacity here, and it's great with time series data. So what is it really doing? So time stream is helping with data ingestion. It's going to ingest data from a lot of sources, and then it's going to store the data. It's going to manage the storing of the data and time. Recent data will be stored in memory, like a hot tier. Older data will be in an SSD storage. So you're going to get real good performance to recent data. You query the data with SQL queries, and you will it'll manage your data retention policies and where you're going to keep your data from hot, meaning in DRAM, to cold on SSD drives, for example. It's going to give you lots of monitoring and analytics. So next is AWS Wavelength, and that's going to be an edge computing service. So why? So imagine you've got driverless cars that are out there. Imagine you've got all these IoT devices that are there. Many of these things are connected wirelessly via, say, a 5G network. And realistically speaking, we have two options. We can have these devices connect to the 5G network and put servers there and process the transactions right there at the edge of the network, which we do. And sometimes we could backhaul it. So we could connect to the 5G network, and then from the 5G network, create an IPsec tunnel all the way back to our data center, which could be 1,000 miles away. Well, which do you think is going to provide better performance and lower latency? Process it directly at the edge where the users are connecting anyway through the mobile environment, or connect to the mobile environment and then drag it back, say, 1,000 miles away to the cloud provider's data center or your data center. So obviously being closer to the user. So AWS Wavelength gets you closer, your infrastructure closer to the user. So lower latency. So what happens is you're going to see these AWS resources at the edge of the provider's 5G network. So they can be processed directly where the 5G network already is, as opposed to backhauling it to the organization's data center. And basically speaking, wavelength zones are part of the global infrastructure, but you can put your stuff where the 5G networks actually are. So at the edge, they have scalable infrastructure, because your infrastructure will scale just like it would on the cloud. And it'll give you all the integrations to your VPC or your IAM or your encryption strategies. And it really gives your developers some flexibility, where they want to use their stuff and when. The key here is that it's available at various locations worldwide. And you're going to use it for gaming, right? So gaming is where where you've got people playing this low latency thing. And if you can get them closer versus back, it'll give them better performance. Live video streaming. Whoa. Video does not is not a big fan of latency. And what it's really I'm not a fan of is what's called jitter, which is variations in latency. So anytime you can reduce the lag or the buffering of video streaming, you improve the performance. So IoT applications like a self-driving car. Do you want that thing going directly to the edge of the service provider's mobile phone network where your AWS stuff is in San Francisco, if you've got a self-driving car in San Francisco? Or do you want to backhaul it all the way to, say, Ohio or some other part of the world? Well, you want to do it locally because you want that car, if it has to hit the brakes, to do it with as least amount of latency as possible. So that might be another place where you use it. Virtual reality, augmented reality. Lower latency fuels better performance. Machine learning at the edge of your network. Think about how fast you can process the data that way. So what are you really doing? You're setting up a wavelength zone through the management console. You'll create your subnets and your route tables and your security groups. You'll deploy whatever your compute is, like your virtual machines, EC2 instance, EKS, what have you, Lambda functions. You'll configure your networking, and you'll monitor and optimize. So optimize for low latency. Make sure you've got good security and compliance. Figure out your costs, use the cost explorer, that sort of thing. Make sure you use the right size virtual machines. So think about that. So think of it this way in your mind. The phone providers themselves have their data centers, right? And they have all their 5G antennas, and they've got all their switches that route back to their main networks. There's already a data center there. Verizon has them all over the place. AWS has them all over the place. If you could put AWS compute in a data center that's close to you, which could be owned by a phone company or something where your systems are, now you're going to have reduced latency and better performance, and everybody is happy. So I said I would stop at 520. So does anybody have any other questions on the things that we just covered? If not, apologies for keeping you a few minutes late, but it may most likely going to give you Friday off. And we may have some fun, surprising announcements as well. Okay, it doesn't look like there's any questions. So everyone, thank you so much for coming. If you've had a good time, you're learning something, maybe hit the bell, subscribe to be informed and hit the bell and subscribe to be informed of new videos. Give the video a like. Signals the algorithm to send this to more people. And I will see you all tomorrow at exactly 2 p.m. Eastern Time. I look forward to seeing you all. And let's get geeky with more AWS Solutions Architect Associate Training. And this concludes day 6 of our SAA C-3 preparation for the AWS Solutions Architect certification in 2024. Welcome back, everyone. We are here for day 7 of the completely free Go Cloud Careers AWS Solutions Architect Associate 2024 Bootcamp to help you prepare for that AWS Solutions Architect Associate certification and that SAA-C03 exam. And this is an AWS full course tutorial, and it is completely a free AWS course, and we are happy to be with you. So before we begin, tell me where you're from. I am in South Florida today. Today's probably the first non-hot day we've had. It's only about 90 degrees Fahrenheit. So not too bad for what we get here in the summertime. Little cool breeze. So for me, I'm having a great time. Where are you all at? What is the weather like today? Let us know. Love having you all here. So today was going to be day 7 of this program. Yesterday we covered a lot. And today we're going to begin with some of the AWS artificial intelligence machine learning services that are here. So welcome. And we'll get back to the fun in a few minutes. The format is we'll go typically 20 to 30 minutes or so, and then we'll ask some questions or answer some questions related to the content we're covering. And then we'll go back and forth for about 20 more minutes of content. And we're there. So I'm looking at this. I see people in Virginia and Ghana and South Africa and Cameroon and Argentina, all over the United States, which is good to see. I see Nigeria is here as well, which I absolutely love. So I see some people in Georgia. We see some people in Sacramento, and lots of people in Florida, which is really great. So we're here. Richland, Washington. Haven't been out there in a little while. Kenya, I absolutely love this. But so it's really great. So everyone is from all over the world, even Nairobi. I love that. So good to have people at Toronto. This is fun. Maryland. So love this together, and we're all here together to help you guys start off your AWS journey with this free AWS Solutions Architect Associate training. So I want to know you're here. I want to know you're awake. So please give me a hashtag AWS SAA to let me know that you are here for the AWS Solutions Architect Associate training. Please let me know that in the chat box, and then we'll begin. Also want to let you know that if you've just joined us for the first time, we have about 40 some labs for you to actually do on your own time. It's going to take us basically 3 hours a day, every day for the better part of 2 weeks to really cover the technology. What is that technology? How does that technology work? The use cases and business cases for using these types of technologies. And that's what we're focused on today. And I did this because when I interview people, I always ask them about the technology. What is it, how it works, and why do organizations use it? And 99% of the people can't answer that. And sadly, we just can't hire them. So I want to make sure you get some understanding of how it works, but I still want you to get hands-on. So go do that at your own time with those free labs. So go download them. I also wanted to let you know that Thursday morning, we're going to have our completely free How to Become a Cloud Architect. And go out there and get your first cloud architect job webinar. And what we'll do on this is we will talk about what is the role? What do we actually do as cloud architects versus what people think we do as cloud architects? What are those skills you need? And I'm going to tell you right now, at least 50 to 60% of those skills are business skills. And we'll also talk about those technical skills as well. We'll talk about how to bypass HR when it's your first time and to go and directly be seen by the hiring manager. And it's all going to be free. So come join us. It's completely free. And it's on Thursday. It'll be at 11 a.m. Eastern. And you can figure that out where the time zone is in your local time zone with a simple time zone calculator. If you're like me and you just know where all the time zones are because you've traveled too much, you just do the math in your head. So all completely free on Thursday. So now that we've discussed these, let's get into the content. So yesterday, we left off with wavelength. Today, we're going to get into Amazon Kendra. And Amazon Kendra is a search service that's powered by machine learning. So think artificial intelligence. It's going to help organizations build accurate and powerful search capabilities into their applications. And it's going to help users find the information they need quickly and efficiently. And when you start thinking about how do these systems work, in most cases, we want to be able to ask a relatively reasonable question. Go find Cindy the cat photos. So somehow along the line, the AI needs to take what we asked it, understand it, and the context of what it is, and turn that into a user query. And realistically speaking, and also be able to read the content and understand that. So that's typically where we're talking about natural language processing. And Amazon Kendra uses natural language processing. So you can ask a normal question. And that's something we're going to see more and more of. I mean, this is not new, Kendra. And natural language processing is not new either. But you'll see that over time, much more of these AI systems get much more responsive to natural language. So where we might need prompt engineering now, 2-3 years from now, you probably better ask AI the exact question you actually want. And it'll come out because it'll understand you. But that's just more information in this type of world. So whenever you're dealing with any kind of machine learning environment, you're going to have to tune it. It's not just going to come out of the box and great. So Amazon Kendra gives you some tools to provide some relevance tuning, and you'll be able to customize the search relevance based upon the organization's need. And you'll be able to adjust that relevance by tuning it to user feedback or user behavior. So you might start it, and it may give you some stuff that's not really relevant to you or appropriate. But you can tune it and make it what you need it to be, and that's what we're talking about here. Of course, this goes through with any AI system. Amazon Kendra can kind of connect to many data sources that you think out there. You instantly think of things like S3 or an Amazon Relational Database Service, but there's other stuff out there. There's SharePoint, there's Salesforce, ServiceNow, and Amazon Kendra will integrate with those as well. And it'll integrate into your cloud data sources as well as your data center data sources. So it's going to be a customizable search experience when you use Amazon Kendra. And obviously, there's other alternatives as well, but this is a cloud native version. So you might be able to define your document attributes. You may want to add metadata to your results. And it's going to give you the ability to customize the user interface and the search experience so that it works for the organization's needs. It has the ability to provide, say, an FAQ and answer session. So you may find that you've got a lot of questions that typically get asked in a corporate environment. And sometimes having an FAQ page will make it easier. Usually people don't read the FAQ page and still ask the questions, but some people want to just do a search and find it, and Amazon Kendra will help you here. It will extract raw information from documents, FAQs, manuals, and it'll add that to the search. So it can make it easier for people to find what they need. So they don't just say, okay, you've got a FAQ page, but I don't know. Let's call the 1-800 tech support number. Now, whenever you're looking at something, you might be searching for something. You may get 1,000 results. Now, some results are more relevant to what you're looking for than other stuff. And Kendra has the ability to perform ranking of your documents and look at the relevance of each based upon machine learning. So you can use this because it's a machine learning service to provide some analytics and insights. It'll give you detailed analytics into your search performance, the way your users behave, and that's going to give you good information on how others interact with you. And that way you know how you can interact with them better, what kind of improvements you make, if you will. So let's talk about where you might use this. So enterprise-wide search. Employees are looking to constantly find information. And if you can cut the time down that it takes for an internal employee to find something like an internal document or report or other resource, that means enhanced productivity. If the employees do more and they're more productive, the organization has the ability to pay their employees more. If people don't do more work than before, the company can't make more money with the people that it has, and it will need to hire more people to get the same thing done, and that will lower the pay that people get. So anytime you can enhance productivity, it improves profitability and employee earnings, typically speaking. So where else could you use Kendra? Customer support. So lots of times people just call support because they can't find anything. They don't know the answer they need. Now, if Kendra can help people find what they need when they need it, customer support cases can go down. And the person doesn't have to wait on hold to find somebody a half an hour, which gets them frustrated because they were able to find it themselves. So lower cost because you don't need as many customer support people. And the customers have their systems working when they need it. So again, they're going to be happier as well. Knowledge management systems. Here's another use case you may see something like this. So lots of organizations have their own knowledge management systems, but at some point they can get so big that it's actually hard to find what you need. So this can help an organization. Just think of it. If you can find what you need and get access to good information that's relevant to you, it cuts down your search time. It cuts down your research time so people can do more. Again, enhancing productivity. How about e-commerce search? Another use case for something like this. Because what if you wanted to put a product search capabilities into a website and provide relevant information? For example, my cat Cindy loves these things called Bonkers Purr Pops. And no, I'm not paid by them. I bought 50 packs the other day because she loves them. They're these little tuna lollipops. I bribe her to come over with me, sit on my lap, and eat the lollipops. They're great. But I can tell you, I went to search the stores that had these lollipops, and I got basically every other unrelated product that I was looking for. And I was thinking there's got to be an easier way. So I went to the pet store with my wife until I could find them. Now, if you can get a good e-commerce search and you can look for things and you get all these relevant responses, people are more likely to buy more. Again, enhancing an organization's profitability, which puts it back to the same situation of higher profitability, better returns for the shareholders, better take care of the employees. I can personally tell you that Amazon Kendra, a good use case could be healthcare and life sciences. I can tell you from my old days practicing internal medicine when I was a nurse practitioner, trying to find stuff. You either used one of the books that you carried with you that was reliable information, or you bought these applications that were giving you good sources of information versus whatever the fluff is that you might find on a Google search. These were accurate, well-researched information. So if you can research, 50 medical journals or 500 medical journals and a library of hundreds of good and legitimate medical books. When you're trying to care for your patients, this kind of thing can help you find what you want much faster. So improved clinical decision making could result in less medical errors and lower costs because there's less research. So how do you basically set this up? So how would you use it? So for one thing, you go to the management console and you navigate to Amazon Kendra. You basically create an index and configure the basic settings. Now, it's machine learning, so it needs data. So you connect your data sources, either with the built-in connectors or some custom data connectors that you could create. And once your data is connected, you define what the search experience is going to be like. You define maybe custom attributes or metadata or how you would tune it for relevance. You set up your frequently asked questions and document ranking to make sure you enhance the search results. You deploy it. And you integrate Kendra with any APIs you may have in your applications. You deploy any search interface that you want your users to start using, and you start using it. Of course, you're going to collect feedback. Now, with anything else, we're up, we're running, we're going to monitor it. See what's working. What's working well, do more of it. What's not working well, we do less of it, and we optimize. Let's think about some best practices, because remember, it is machine learning. So if you give it garbage information, you're going to get garbage results. So you want to make sure anytime you're using any type of AI system that you optimize your data quality and you perform good data hygiene and you feed it good data. And as the organization has new data sources, feed that into it because you got to optimize your data quality. Now, anytime you create anything, you're going to need to tune it along the way. So look for user feedback. Deploy it, collect user feedback, analyze the feedback, and look for areas of improvement. Typically, that's where the relevance tuning is going to come place, and you're going to have to adjust the search results based upon the feedback of the users, and then you'll tune it. Now, here's something to think about. AI needs data, right? And AI can do scary things with data if it's not designed properly. You could optimize your data and by, for example, removing personally identifiable information. And AI can add the personally identifiable information backed off on other attributes if you don't set up your models and tune your models. So, when we think AI architecture, there's a lot of things to do. But Kendra, like any other service, we've got to secure our sensitive data. Because now you're providing search to something, so we don't want the wrong people getting access to the wrong stuff. So make sure the search is going to comply with the organization's security policies. And really think about how do we make it better? How do we make it better? Look at your search analytics. Look at what's working and which areas need to be optimized. Update custom attributes and metadata to reflect changes in the organization's information landscape because it's all about information. Good information. This is just going to analyze information. If you trained a doctor and you didn't send and you gave them wrong information the whole time during the training, they're going to be a bad doctor. If you trained an airplane pilot and you gave them bad information, the plane's going to crash. With AI, and as we talk about more and more AI services, which we're going to, the quality of the information is going to be everything that you give it. Okay, so now let's talk about another artificial intelligence service on AWS, Amazon Comprehend. Now that is going to another natural language processing service, but this one is going to use machine learning to uncover insights and relationships in text. So I want you to think about it. It's going to be able to read the text. It's going to analyze the text and look at things like various linguistic and semantic features. And it's going to be able to read the text and understand it. So think about where a company might use this. Customers may leave a lot of information. This will give you a chance to analyze what the customer information is. For example, that's something that's pretty great. You can get customer sentiment with this. You could do a focus group and analyze the information. So typically speaking, this is where something like this kind of tool would be great. So it's going to recognize people. So it'll identify categories in text, people, places, dates, quantities, that kind of thing. It can recognize any kind of custom entity that's specific to your business that you need to tell it. It can do sentiment analysis. So When you give a speech, you want to read the audience, right? Can't do that on YouTube, but you do when you give a speech or a presentation to a big audience. And in today's world, there's AI that analyzes the audience sentiment too. The AI will analyze the audience sentiment, and somebody will have a little mini speaker in their ear, the speaker, and they can say, not work, and talk or pivot about this to something else. And if you see big, high-profile speeches, you may see something like that. So here it's going to analyze the text for sentiment analysis. So, for example, if a company is, lots of people are saying bad things about a company's product, it gives the company a chance to go fix it and find out what it is. So, analyze feedback, analyze people's social media posts, analyze product reviews. It's going to be able to analyze the syntax and the structure of the text, and it can identify parts of speech and relationships between words, which, again, a word by itself may be nothing. Taken out of context, it could mean something, but in context, it could mean something else. So, it's going to help with that. It's going to determine the optimal language too. And that's going to be something you need to be able to think about is, what language is it actually coming in? And you may have to analyze multiple languages at the same time. There's lots of countries that have two languages. Cameroon has English and French, right? Canada has English and French. Greece has Greece and English for the most part. You could be on Cyprus and you've got Turkish, you've got Greek, and you've got kind of that Cypriot language, which is, even if it's Greek, is a little different than Greek, because it's a dialect, and that's okay too, but it really doesn't matter. So lots of times you're in a business that you have to analyze multiple languages, and this can do that, like many other great tools. Let's talk about key phrase extraction. So it can look for key phrases in a text. Another thing you could do is something like Amazon Comprehend is summarizing documents and extract some important information. So there's lots of tools to do these, but these are some of the Amazon branded tools. Well, something it can also do is something called topic modeling. And it can analyze a large collection of documents to identify the main topics that are covered. And this is some place where you can group documents by topic and get insights and themes. So, in science, you may be doing, like, say, a meta-analysis where you're going to analyze tens of thousands of documents and other studies by something that can go through and kind of give you an initial summary that's a little better than the abstracts that are on these documents. It can really help with some things in scientific research, those types of things. And another thing that it can do is to identify personally identifiable data information. So there are times where organizations accidentally populate personally identifiable information and make it public. Now, that can be a massive fine. Now, lots of machine learning services can analyze the data and tell you you've got personally identifiable information. Sometimes they're right. Sometimes they see things that is not personally identifiable information. And but at least you know to look there. So any of these tools are going to have false positives and negatives. Just keep that in mind. So where would you use this? And as I went through the features, I kind of talked about it, but let's go through these use cases again. Customer sentiment analysis. Analyze customer reviews or surveys or support tickets and understand the real issues. Identify trends and common issues so you can make your customers more satisfied. Personalize content to the users by giving them content that's relevant to them. For example, I'm constantly buying stuff for my cat because I love Cindy, the cat. Sending me stuff for dogs is irrelevant to me because I don't have a dog. Not that I don't love dogs. I love all animals, furry and feathery. But the thing is, I don't have a dog. So if I'm online at some online pet store, send me more cat stuff versus dog stuff. I'd be more likely to buy it. Social media monitoring. Now, this is pretty important. Monitoring social media channels to be able to gauge public sentiment and identify trending topics. Organizations really need to monitor social media and figure out what people are saying about them. Now, that can get pretty costly, but they need to know what people see as their brand. Because, they may think they know their brand, but the brand is what people say about you or your company when you're not there. So they can do lots of social media monitoring. Fraud. Here's another good use case for it. Look for fraudulent signs of fraudulent activity. You can, if you're going to be able to mine through multiple documents or hundreds of documents or thousands of documents, and you know what patterns of fraud look like in financial documents, you can search for that to try to catch these things. So lots of good things you can do here. I talked about healthcare and life sciences. I talked about some other environments as well. How do you set it up? Pretty easy, like anything else. When you know what you want to do, setting it up is kind of nothing. You go to the management console or the CLI and you click Amazon Comprehend. You choose whatever text analysis features you need, and then you configure them. Then you upload your data because you got to train it, right? So you upload your documents into it and use the API to integrate any kind of text analysis in your applications. Next thing you do is you look at the results. You review the results and you analyze them and use these insights to drive any kind of decisions you need in your actions and the way you would set up your applications. Obviously, you're going to need to customize your models. You may have to train custom models, whether it's related to entity recognition or text classification, should it need be. And you can provide your domain-specific data to prove the accuracy and relevance of the analysis. You integrate it and you deploy it, and you see what works. You look at the test analysis to automate and scale your text processing, and you see how is it working. So those are there. So we'll discuss Amazon Poly, and then we'll take 10 minutes to see if there's questions. So Amazon Poly is a text-to-speech service that converts written text into speech. You see this stuff all the time. You got a chat GPT and it reads to you, for example. There's lots of these that are there. And Amazon Poly uses deep learning technology, again, AI, to synthesize speech to make it sound like a human voice. So there are organizations that will create applications that talk based upon the words that are on the page. We're getting to a point now that there's lots of lifelike voices with AI. And they typically call it this. They would say that they would support standard and neural text-to-speech voices. But the point is, it's reading the data, it's being trained on more natural voice sounds, and that's going to give you a lifelike voice. Now, it's not just language. It should be in the language of the receiver's choice. And ideally, it's in the dialect of their choice. I mean, let's face it, there are multiple dialects that are out there. I lived in Philadelphia as a kid, and they drank soda. And I don't drink a lot of soda, but I was someplace else, and I ordered a soda, and they looked at me like, what do you mean? But they called it pop. So the point is you might even need multiple dialects in English, multiple dialects in any other language. There's lots of them, and this can help out with that, especially to customize it to make it sound like your receiver's used to hearing. So you can do both real-time and batch processing with Amazon Poly. You can convert your text-to-speech in real time for like an interactive application. Maybe you've got a shy person and they want to type something in and have it talk to somebody else. Or you can do batch processing and go through a library of text and make it audio text for people to listen to in the future. One of the good things about Amazon Poly and applications that it gives you the ability to create a custom lexicon. So I might have a back patient who has pain shooting down their leg, and I may call it lumbar radiculopathy. But if we just ask AI to call it, it may not know to call it radiculopathy because it may not be trained on those words. So lots of times we need to create custom lexicons. Lexi comes from it means word in Greek. And, we have to increase the naturalness to get people to adopt these technologies. So we teach it how to pronounce certain words, and that's something else you can do with Poly. Now, you're going to have to determine, of course, Poly supports it either way. Do you store the voice into, say, S3 or object storage? Do you put it in your applications directly? And it can enable you to do either or, streaming audio or just drop it off and dump it into object storage. So where might you use something like Amazon Poly? Well, you might use it to create a voice assistant. I have friends that have smart homes and they've got voice assistants and they want to talk to this thing and it works. Personally, I shut off anything that has that functionality. I don't want to give hackers an opportunity to get access to my systems, but that's just me. You might use Amazon Poly in an integrated voice response. So say you've got a customer service environment and you've got a customer, they're calling in to get tech support, and you may want to constantly update the menu of the tech support. If you're calling about the Windows and CrowdStrike outage today, please listen to the following message. Press 1. If you're calling regarding this, this, and this, please press 2. I meant the Microsoft and CrowdStrike outage at the same time, the same day. So, those kinds of things. You might want to have that system that you call, it's called an IVR system or an integrated voice response system. You may want to tune that very quickly and on the fly. You may want to talk to someone and read some text to them. E-learning is another place. Now, quite frankly, when it comes to e-learning and any e-learning that I provide written content and video and spoken content, because you have to get both, and for a lot of different things. Some people like me prefer to read. Other people prefer to watch movies. So with Poly, you can kind of tune your learning environment. I can tell you when I did my MBA for this, I did 2 MBAs, but I know when I did my MBA, I was driving 4 hours a day back and forth to work and school. So I listened to an ebook every other day. And it would have been hard to be reading while driving. I wouldn't recommend that, and I don't recommend that, but I was able to listen to audiobooks. So if this could have just taken an audiobook that I had, maybe I bought an audiobook and it could just read it to me, that would be great. So not that we would do that with an audiobook, but we can take information and have it readable into audio format. Media and entertainment can literally create any kind of voiceovers for a person's podcast if they wanted to, or you've got a YouTuber that's streaming, I think they stream games, or maybe it's Twitch that they stream games on. I don't play games. My brother does. He loves them, but I don't. But, there's constantly all this stuff going on in the background. That would be kind of cool. And potentially talking on the videos, he or she would type something in a chat box and that could talk on the video and make it sound lifelike. So all kinds of cool stuff. So how would you set this up? You go to the management console and click on, and you go to where you were at, and you go to Amazon Poly, but you could do it on the CLI or the APIs as well. You explore the available voices and language, and you choose the best fit. You take your text next, input it, and it gets converted into the speech and the voice and the language you choose it to. You integrate it with your applications, and then you stream your audio live or directly. You save it to, say, S3 or object storage for later use. You set up any kind of custom pronunciations of certain words, and you basically refine, and refine. And this is really that custom lexicon really makes the difference. For example, last night, my wife picked me up something called the Gyro, Gyro. It's a Greek thing. It's really great. But anyway, neither here nor there. We call it gyro because that's how they say it in Greece. Americans call it gyro. So if we were going to have this and we were going to take something in English and say share it with a Greek audience, we wouldn't want it to say gyro. We'd want it to say gyro. And it's the same word and the same spelling and a completely different pronunciation because it's custom based upon the language. And that's where you would tune it either for a common lexicon or that's where you would tune it for a dialect, that sort of thing. You fine tune as necessary. You should be good to go. So what are your best practices here? And I know I alluded to this the entire time. So best practices are really get those lexicons right. And that's why I harped on it for so long. Anytime we use AI, we've got to get it to as close as lifelike as possible. When we had video conferencing, when we first started out there, the studies we showed that if the person was as big on the other side in video conferencing as they were in the real world, people were more likely to adopt video conferencing. And we were setting up these high definition video conferencing systems that were lifelike throughout the world. Now people have adopted to, being remote and using a computer screen, but they wouldn't adopt it unless it felt like being there, at least initially, because that was the culture. So We had to optimize everything. Same color backgrounds in the room, so it felt like people were in the same room. There was so much that went into it. When it comes to feeling real, it's got to be right. So optimize those common vocabularies, those pronunciations, etc., that you need to do. Constantly monitor these things and tune. Use natural voices. I mean, if you wanted to talk to people, it should feel like a real person. If you choose a robot voice, this is the trade-off here and there. I mean, nobody's going to want to listen to it. So the plan is to make it feel real. So try to go as natural as you can. AI will let you do anything you want, but you really want to make it work for the user. So that's for Amazon Poly. When we get back, we'll talk about Amazon Recognition, another AI service, but let's see if anyone has any questions. Tyrone. Does an AWS architect, when building an architecture, also need to produce a pricing prediction, how much it will cost? So, Maury, a cloud architect or an AWS architect or an Azure architect won't be building anything. I encourage you to come tomorrow to the completely free, on Thursday to the completely free webinar on how to become a cloud architect. But I'm going to make it very clear that's not something that we do or do at all. Here's what we do for real. We meet with the client and ask them about the goals of their business. Where do they see their business now, 6 months from now, 12 months from now, 5 years from now, and 10 years from now? Then we go and evaluate, how does that business operate? What are the key business processes? How is a product made? What's the supply chain look like? How is customer service delivered? How is customer support delivered? How is anything? So we have to figure out how the business works. The thing we do after that is work with that business to design the way they want that business architecture or those new business processes, because those business processes will affect their technology selection. The next thing we do, Maury, is we go in there and we baseline their systems. So we go in there, we bring in a team of engineers. Those engineers will go and monitor those systems. They will look at the performance of those systems, things like network utilization, CPU utilization, DRAM utilization. They'll search through everything to figure out what's working and how the technology is working. We will then go, now that we know the ideal business processes and we understand their current technology, go and build a team of 15 to 50 people for the next 6 to 12 months. And when we build that team is going to go out there and we're going to create the architectural strategy. So if I'm the cloud architect, for example, what we're all going to be doing is I'm going to be coordinating a team. I'm going to have a couple of network architects. I'm going to have some security architects. I'm going to have some AI architects. I'm going to have some DevOps engineers. I'm going to have some cloud engineers. I'm going to have some software developers. I'm going to have some security architects. I'm going to have some IAM architects. I'm going to have a big team of people. And together we're going to say, what are the technology tools and trends that we have to be able to go solve those business problems and goals the customer told us about? After that, the customer will typically issue like an RFI, RFP, or RFQ. We will lead the team that will respond to that RFQ. The team together will design that architecture, and we will document that architecture. Various teams will draw the pictures for the respective reasons. We will then document it, and if it's a big deal, we will take our document and responses, and we will send that response, our architecture documents, to the graphics team and another team of people that are professional editors. They will take the graphics we give them, they will turn them into something beautiful, and say Adobe InDesign. They will create all kinds of beautiful documentation. Our documentation will clean it up, and then we'll deliver it to the customer. The next thing we will do is with that customer, we'll help the sales rep sell it, and we'll help them negotiate the deal. And as soon as that process is done, we will go off to our new client. So we don't build anything. We don't touch the technology as architects. And that's why when I've got cloud engineers with 10 years experience, they take the same amount of training as a nurse. So it's a different job. It's very interesting. So the next question I see popping in is, how much CLI knowledge is required as a solutions architect? None. We don't build anything. We don't touch the technology. We don't code. We don't configure. Now, what you need to understand is, how do I design a system? So, well, you don't need to know the CLI at all. If I asked you and said, We've got an organization. We have 200,000 remote access employees. I need you to design a secure solution to allow those 200,000 remote access employees to now work from home. That you would need to know. You'd have to consider the security, the identity management systems, the types of VPN concentrators that could handle those kinds of things, where you'd put your VPN concentrators, where you need your routing, and you need to understand how to design that. But we don't touch it. There's no CLI. We do not touch the tech. And I do want you to get hands-on and learn the labs, but that is not our job. I just like doing it. And that way, if anybody ever has asked you, yeah, I've done it, I know how it works. But understand, people don't hire construction workers to design hotels. They hire architects to design hotels, because you don't learn how to design by building. So there's no CLI knowledge there. There is an in-depth knowledge of the technology, not CLI. But how does the technology work? How do we put some pieces and parts behind together? How do you make that demilitarized zone to make it sure? How do you architect your end-to-end solution? And it's much more about having a team of people that are going to do it, that are all experts in the things, and it's much more knowledge for you understanding how it works, not how to do it. The best example I like to get is, here is the CLI to configure BGP on a Cisco router. Config T, router BGP 65312, neighbor 192.168, remote AS 65313, neighbor 192.168, activate, or I think it was 1.3, activate. Now, I just turned on BGP, that's it. And all turned on, that's the CLI. Now, as a network architect, do I need to know that CLI? Not at all, but I was a network engineer first. Now, when you do that, let's say you turn that on a router in Japan, that will affect a sales team in Cape Town, South Africa. By the way, it affects the traffic in that organization. That may have a big impact on an HR system that's sitting in California. It may also have an impact of a financial application that's sitting in New York City. So what you need to understand is how do those routers work? How do those protocols work? How do they talk to each other? What is the right technology to use to solve which business problem? But no, we don't use the CLI. And there's a good video of David Lithicum and I last week talking about an AI architect. For those of you that don't know, David Lithicum was the chief cloud architect for Deloitte. He was their head of cloud strategy. He's been an cloud architect like me, and all kinds of architects, but he's been an architect for 35 years. I asked him on this webinar, it's on our YouTube channel, and I said, when was the last time you configured something? And it's like decades, because architects don't configure. But we do have to know how the tech works and how those pieces and parts go together. Good question. What is the LLM behind this service? They can use any LLM they want, and that is their own LLM. But, there's lots of large language models out there. Now, the bigger question is, which one should you use based upon your business's needs? That's the bigger issue. And should you use a proprietary service like we're talking about, or should you build your own? If you build your own, what do you gain? Customization, flexibility, more business relevance. But what do you lose? You got to spend your time to build it. How much time do you when you build it? What do you lose from a business agility perspective? That's the bigger question. And in most cases, they may not publish some of these pieces of information. Do we have a tool that helps plan the architecture? Yeah, there's an AWS pricing tool out there on the AWS website. But you also have to understand that you need your information, because, the way you transfer data, it determines what things cost. So there's a lot of other stuff that's there. But AWS has a pricing tool directly on their website. And as long as you know your traffic models and usage patterns, you'll be able to use it. But if you don't know that, you're going to get something that's very far from the reality. If there are so many architects involved in a big architecture, then the architect role becomes that of a product and sales manager. Not at all. Here's what a sales manager does. They manage 5 sales reps. That's what a sales manager does. The sales rep is the person that owns the sale. They own the pricing discussion with the client, for example. And a project manager, you're going to be working with lots of project managers. So let's say I get an RFP response, a request for proposal from a client. Now, the request for proposal itself could be 300 pages long, and each of questions, and each one of those questions could reply 1 to 3 page answers. So now, what do? You're going to have that lead architect that's going to go to the company. I'm going to go to the management and say, I need these people, these people, these people, these people, and these people. And they're going to say, why do you need these people? Because there's a cost to these people. And you will talk about the opportunity that you have, the financial opportunity, and what you think you can get. And by that, you will build a business case to show this is a $200 million opportunity. And I'm 70% sure we can close it. So that's your expected value of the opportunity. You point that 0.75 times that, whatever you think that is, say 200 million, because you think you're going to win it with that level of confidence. And then you're going to show that I need this many people, and it's worth giving me 4 or 5 millions of people for this $150 million opportunity. And your managers will give you the people. Then you're going to be creating a design, and you're going to basically delegate certain things out. Now, do you have it in you to go out there and ask 50 people every single day, all day long? Did you turn in your document? Did you turn in this page? Did you turn in this page? Did you turn in this page? Do you have the ability to drive people crazy and be effective in your job? So the answer is not. So you basically create the strategy, and the project manager goes out there, the taskmaster, are you done? Are you done? Are you done? And that way they get to be the bad guy or the bad girl as opposed to you. You become the soft, squishy architect, and they make sure the stuff is not forgotten. There could be a proof of concept where I'm going to go bring in 13 engineers, and there's a whole big project plan that's associated with that. I'm going to be managing the relationship, making sure I can solve the engineers' problems that they need. Like, you need me to go to the store? Do you need me to bring in dinner? Do you need me to bring in drinks? And again, the PM's going to make sure that all those things are done. Oh, step 1 is the wiring done? Good. Okay, step 2, what's necessary? Step 3. So you'll build the plan or help the PM build the plan, and they will keep track of it. So no, there's going to be lots of PMs absolutely everywhere too. It takes huge teams of people to really deal with these kinds of enterprise architecture. And if you don't, you end up in the sad situation that 70% of all technology architectures fail. So hope that helps. In order to get certified, is it enough to watch these videos and practice the labs? Yeah. Lots of people have just used our training, but I'm going to recommend one thing. I'm going to recommend you get a practice test. I am. Because the hardest part of an AWS exam is not the questions. They're pretty easy. It's the way they ask the questions. They're very wordy. They're a little bit cryptic. They're not straightforward. That's the challenge on AWS exams. So I recommend getting a good practice test and practicing a good practice test, 600 to 800 questions worth, and go through it again and again. And when you can score like a 95%, you should be good to go. But I don't want you memorizing the questions and the answers per se. I want you, each time where you don't get a question right, to go see why you didn't get it right, and then go look up all those other answers and say, okay, this couldn't be right for this reason. This couldn't be right for these reasons. And that way I want you to build your knowledge on it. But yeah, passing the exam won't be hard. Okay, let's go back to the content. So I know you're awake. Let's do this. So if you're enjoying the content, please give it a like, subscribe, hit the bell to be notified of new videos to help you. If you've just joined us, we've got some free AWS labs for you to do, over 40 of them. Some of them are really, really good too. Some of them get pretty technical, but download them, do them on your own time. Getting hands-on experience, getting used to the technology, getting a feel for the technology is great. So, but you can do them at any time you want. These 2 weeks we're spending completely focused on trying to give you guys some knowledge here. So hope you guys are enjoying it. Let me know you're awake by giving me a hashtag AWS SAA. And then we'll get back to Amazon Poly. So actually, we finished Amazon Policy. So let's get back to Amazon recognition. I was kind of excited to talk about that one. So we've got lots of types of technology to analyze information. So if I was going to give a presentation and I was going to have somebody that's a high profile presenter and they were going to give a massive presentation, maybe someone is trying to launch a new company and they're trying to raise, $75 million. I might want to use some AI in the sentiment to talk about it. And when somebody talks about something that's not exciting, get them to stop talking about it and maybe pivot the conversation to something that is exciting that company's doing. You might want to be looking at that office, saying, audience, say, oh, what's going on? These people are happy. These people are not. So that's the kind of things that we're talking about that, can help a business do things better. We're also talking about going out there and being able to look through the security cameras in England and be able to predict where a problem is because they're looking at something. We're talking about giving a speech and after the speech, being able to analyze the audience responses. We're talking about being able to mine through a lot of data and say, customers really like this product, or they really don't, or they're happy with this, or they're not happy, or new branding messages that's coming out. Does this resonate with you? And you see people looking like this. Even if they say yes, the body language is going to give you some information. So you want to analyze that too. Sometimes people don't say what they mean. So recognition, and there's a lot of cool tools that you can use to do this from a deep learning perspective. Will analyze video. So it gives you the ability to analyze a video, analyze it, and provide, some recognition of what people are doing. And lots of good things you can do from this from a business perspective. So the recognition itself can look at thousands of objects. And it can look for certain things. It could be like a car or an animal or a cat or furniture. It can look at scenes and say, this is a beach scene or this is a forest scene inside of an image or video. It can detect activities and actions to see if someone's running or jumping or dancing. It can look at their facial features and read the body language to give you some knowledge of what people are really saying. It can also do facial recognition. So you might be looking for something, and this can scan through lots of film and find that thing for you. So maybe you're looking for a lost child, and you've got facial recognition, and all of a sudden the child pops up on a camera, and you can find that child and give it back to the parents, for example. It could also be used to find someone that's deemed a risk to society. I'm not saying they should or could be. I'm just saying they could. I'm not saying they should or shouldn't. I'm just saying they could. It could also say look for people. So what if you find that a product's being worn by a celebrity on their social media page? Well, that might be something that could be good for your brand that you may want to talk about that celebrity. Maybe they could be a rep for you, for example. So lots of opportunities here. Content moderation. It'll detect if something is inappropriate. And that can help maintain safety and compliance. And can track things, objects. So we talked about the features, and I gave you some use cases. So identifying stuff in content. You want to be able to look for something in a background. Maybe you're going to be working internationally, and maybe you've got these offices, and there's maybe something on the back wall that's okay in your culture, but not okay in something else, and you may want to remove it. So being able to look for that kind of stuff is a great place to use something called recognition. Retail and e-commerce. So here's a place where a product search can be, augmented by, say, images, because this can search through images. It could be used to create a personalized shopping experience, maybe with a visual search or some recommendations. Lots of opportunities in the surveillance world with this because of the facial recognition. And also you can kind of automate the detection of, say, things that don't look right. So there are certain patterns of behavior that tend to look suspicious, and you can set this up. For example, if it's 99 degrees outside, people typically don't wear a large winter coat and covered from head to toe with gloves and feet. So I'm not saying the person's a bad person or not a bad person, but it's not normal. So you may want to look for things that are patterns of behavior that are anomalies. Likewise, if it's negative 20 degrees outside, you expect people to wear clothing. So they can look for things that are patterns of behavior that could be indicative of something's wrong. Maybe someone's sick and needs help, but it'll give you information. In healthcare, because we're looking at images, so potentially we could use it to augment it with images if it was trained properly. Or lots of times in hospitals, people get lost. Yes, it's the patients that are called elope. They just disappear and you don't know where they went. So being able to find people in their hallways might be a good thing. Advertising. So companies can go look for their logo in videos. They can basically optimize where they place their ads based upon visual analysis and some understanding of people and the way they use it. So how do you set this up? Well, you go to the management console like anything else, or you could use the CLI or the API, and you get started with recognition. You choose what you want it to do. Do you want it to do object recognition, facial analysis, text extraction, what have you? You then analyze the images and videos, basically meaning you upload them, and you specify what type of analysis you want, meaning do you want to extract text, or do you want to detect faces? You review the results when you're done, which are going to include what it detected and what have you. And then you're going to use, they're going to give you provided confidence scores, and you're going to use that to filter results. And you're going to look at it and see, is it really what you want? Then, if it is, you integrate it with your other applications. And then you monitor it. And like anything else, you optimize it. You tune it, you monitor it, you tune it some more. And that's how we constantly improve quality. So how do you make this better? How do you get the results better? Well, our AI is dependent upon data, right? The better the data, the better results. So if I want to opt to give it images and my images look horrible, meaning they're all grainy and their stuff isn't right, the recognition won't work as well as if you've got good images. So try to use images of good quality and good resolution. Try not to overly compress things or use low resolution images, because if you do, the results won't be as good because your data source won't be as good. Leverage custom labels. So use custom labels to train models in your specific objects and scenes for whatever the relevant results are, and regularly update your custom models with new label data because you constantly want to maintain or improve your accuracy. Make sure you use it with integrated security features. That goes without saying. At minimum, use the AWS key management encryption. Use IAM at minimum. Now, when we're dealing with these types of things, let's talk about anonymization and data minimization. When possible, anonymize your data. So get rid of the personal identifiable information to protect user privacy. For example, maybe blur faces in images or redact sensitive information before processing it with recognition. Because if you train it with stuff that you don't want people to see, people will see it. You also want to do what's called data minimization. Like anything else, you only need whatever you need and nothing more, like the principle of least privileges, if you will. So I want you to collect and process the data necessary, and only the data necessary for whatever your use case is. Avoid retaining personal data longer than needed, for example. So make sure you've got good data retention policies and you know what they are that are appropriate for your use case. Utilize the confidence scores. So look at the confidence scores provided by Amazon Recognition to filter out and prioritize results. Set appropriate thresholds based upon what your application's needs are, because at some point you can go real accurate, but it affects your performance. You're going to have to choose where you need to be. So let's talk about another AWS or another AI service within AWS. That's going to be Amazon Texttrack. And that's another AI service that's going to go and extract text from handwriting, scan documents, what have you. So we used to use something called optical character recognition, and that could identify, letters and things and content. But AI can do a better job of it depending upon how accurate it is. So it can extract data from printed text, handwritten text, structured data from documents, see stuff and images. So it's pretty good because it's AI based at being able to pull text out of whatever you're looking for, whatever your source is, if it's a good source. So it can recognize tables and forms and extract that kind of information out of it. Can recognize handwriting. I don't know if I can recognize my handwriting because I've got medical handwriting, but it can recognize handwriting, and it's multi-language. So at the time we researched this, it supported 6 languages. So where might you use something like TextTract? Well, think about automating data entry. Companies pay a lot of people to just put stuff into the computer, but if we can get AI to be accurate enough and pull out the information, or potentially as accurate as people are doing data entry, we can do this with the technology, and those people don't need to be doing that. Maybe we can relocate those people to do something else that's beneficial for the company. Document processing is another use case. So processing invoices, receipts, contracts, that sort of thing, business documents. Content management. So this will make documents more searchable and easier to retrieve. And it's also going to help out in auditing. So you figure when an audit comes in, or a compliance audit, or whatever that is, if you can pull data from a lot of data, you'll be better prepared to give information when it's requested. So let's talk about how to set this up. Obviously, you need an AWS account. You'll have to create a IAM role with permissions to use TextTract. You'll get the TextTract from the management console. You'll upload your documents to basically an S3 bucket, which will then, you have to set it up to call on the TextTract, on TextTract. It will then process the results. And there you go. So we'll talk about Amazon Translate. And Translate is a service that provides translation from one language to another. It uses AI, and that helps it become more efficient and accurate in real time. And because it can do this in real time, people of different languages can communicate despite language barriers. And this is something that's great, especially as the world becomes more international. So Translate uses neural networks to identify and intelligently translate languages. So it'll go from one language to another. Basically, there's 2 components here. There's an encoder here. And the encoder is going to read through the whole text word to process the meaning of the text verbatim. And that's how we set up the message. And then there's going to be a decoder that's going to use some form of a semantic meaning to translate the word for word text into the intended output language. So whenever we communicate, we typically do an encoding form, even human to human. If you actually study speech and communication patterns, they talk about encoding and decoding as well. But we take the words, call it something, and then give the user that something, and then decode it to bring it back to what we started from. So that's the way Translate works. Oops. So it's a machine learning based translation. And as I mentioned, it would cover multiple languages, 75 of them. And you can create custom terminology lists. So you may have specific words or specific brands that need to be the same way and contextually and properly communicated. You can train this for that as well, custom terminology. You can do it real time. You can, like, if you need it immediately, you can do it in batch to translate conversations. So where might you use this? Well, how about your website? Here I am in South Florida. And all of a sudden, someone in China can see Mandarin, for example, off of my English-based website. One day I'd love to put my website in Greek as well. But what if, people in Greece could just read my English website and get it in Greece? Or someone in the Middle East or in Africa that speaks Arabic being able to get our website in Arabic. So I've always thought these kinds of things are pretty terrific. I travel the world and I know what it's like when you can't communicate well and what you do to try to communicate well, and seen lots of wonderful things. But the better we can have our communication, the less mistakes, the less challenges. So anytime you can translate between people, I think it's wonderful, especially as the world becomes more international. I mean, we're at a point where people don't come to the office to work sometimes. So it doesn't matter where they're at anywhere in the world, which gives people all across the world an incredible amount of opportunity. Customer service. Sometimes you call customer service and it's a little hard. But if we had some form of better translation, we have call centers all over the world. That could be a challenge. Or you could be like my family when they came to America from Greece. They didn't speak English. So we had a family member that spoke English and Greek always do the translation. But that made it hard when we weren't there to do the translation. So if you could just call and automatically someone can speak to you in your language, that's great. We could also use translate in content management platforms. So we may have a company and it may have a knowledge base, and maybe it was created in the US or the UK, but we've got a big office in Germany. And we've got another office in Paris, and we have another one in Brazil. And that's, multiple languages already. So big use case for that. Media and entertainment, another good place for this. So lots of times we watch movies and there's subtitles. Being able to translate it into multiple languages. So no matter, you could have your video and your movie in 50 languages, 60 languages, 75 languages technically. I always thought that would be kind of cool too. So how do you do? You set this up. You obviously have an Amazon account. You create an IAM role with permissions to use Translate. You call upon the Translate API. It processes your results. And there you go. So I will next discuss Amazon Bedrock. And I'll probably add a warning or a caveat as I talk about this, not about the AWS service itself. So it's a fully managed AWS service that enables users to build and scale generative AI. It provides access to foundational models from lots of AI companies. So your typical LLMs it could typically work with. And it can enable developers to easily integrate AI capabilities into their applications without understanding or having a lot of knowledge machine learning. So here's the danger. Amazon Bedrock is a great service, and it makes it easy, super easy for companies to use AI, and that is the goal. If you don't know what you're designing, because you don't have deep machine learning knowledge, it doesn't matter how easy is it, the chances of the design actually being right long-term is slim to none. So just because there's a tool that enables you not to know a lot to be able to use it does not mean you should. Again, Amazon Bedrock is great. This is not a comment on Amazon Bedrock. This will be a comment on any service that says, here, you can use this, but you don't even need to know a lot about it. That's where the danger occurs. Not an Amazon thing, not an anybody thing. Because over 50% of cloud projects, and some authorities say 70% of cloud architectures fail. The tech works, but they don't drive transformation, meaning people are spending money and getting nothing back. So just because it's easy to do doesn't mean it should be done without being well thought out first. So Amazon Bedrock has access to lots of the LLMs there. Anthropics, like for example, like Claude 3.5, they're out there. Amazon has some of their own models. Stability AI has some. So there's lots of good models that you can use those. Models for text generation, models for text images, and why there's lots of good LLMs that run with those. It's fairly customizable and enables users to fine-tune and customize models for specific use cases and improve and tune the accuracy and relevance of the results. It's going to scale because it's a cloud provider systems, which are going to be running on their systems, which they typically have lots of excess compute capacity. It's a build it and they will come. There's a movie in America, I think it was called Field of Dreams, build it and they will come. Well, that's what the cloud providers have done. Because Bedrock is an AWS service for AWS stuff, it tends to integrate very nicely into other AWS things, such as S3, Lambda, SageMaker. So where might you use Bedrock? Content creation. So you could use it like you would a ChatGPT to generate, high quality text or images or content for marketing. They say so. You can use it for social media. I don't recommend using AI to create social media content. You're creating content for social media to show who you are and what is your brand. If it's AI and everybody's AI sounds the same, what brand are you building? Bedrock could work out well for customer support. Lots of AI chatbots or virtual assistants you could create with it. You could use it for, say, as a recommendation engine. Maybe for a retailer, you can add a recommendation engine which sends recommendations on that person. While you're here, go check this out. Any kind of data augmentation. So you can look at the data and then generate synthetic data out of it. You can now prototype new ideas and test it out in a generative AI environment. So, like anything else, it's a generative AI, but it's an Amazon branded one, which works with multiple models behind the scenes that you can choose from. So, how would you use it? You'd sign up for an Amazon account. You would use one of the foundational models you would choose from with with Bedrock. You then customize your models and you'd integrate it to your applications. Most of these AI services are not in the Solutions Architect Associate. More of them are in the Solutions Architect Professional, but you never know exactly when these things are going to pop in, so I'd rather give you more preparation than you need. Let's talk about the next AWS machine learning artificial intelligence service, SageMaker. And that's going to be a fully managed service from AWS that enables developers and data scientists to build, train, and deploy machine learning models. Now, obviously, they can create their own models on GPU-enabled instances or CPU-enabled instances based on the models, but this is a managed service. So one of the things that would be a feature of this is it comes with an integrated Jupyter notebook. So lots of people use Jupyter notebooks to basically explore and visualize data, and that service is available with you here. It works with, the main algorithms people would use. So you could customize your own machine learning algorithm to run on any server you want with TensorFlow or PyTorch. And SageMaker will work that with you. But of course, it's a managed service versus you managing your systems. It supports MXNet and others. It has lots of algorithms for common tasks that you might use these types of frameworks for, like classification, regression, clustering, and recommendations. It enables you to tune your models and find the best version of the model by searching through lots of different tools and parameters. It supports some fairly distributed training, so you can train on a large data set with multiple instances. It's pretty easy to set up. So it's almost like a one-click deployment to pretty easily deploy models in your environment. You can create HTTP endpoints for predictions, for example. So it's easy to use. So where might you use SageMaker? Well, it's an AI tool that runs the more common, AI models and the tools that are out there and frameworks. So you might use it to go examine sensors to see when equipment's going to go and predict it so you can fix it before something fails. You might want to use it, say you're a bank, to identify fraudulent transactions and patterns of behaviors that feel like an anomaly. You might want to use a tool like this to look at customer insights and understand consumer behavior. and give you some insights on what your customers are, what they're talking about. Potentially, this could be integrated into a healthcare environment, assuming all the regulations and things were done and you knew it worked, where it could analyze patient data and give their physicians, hey, here's something we notified. Maybe you should think about this at your next visit. So pretty much the steps to use this would be to prepare the data, because if you've got bad data, you're going to get bad results. Build and train your models. Tune your models to optimize them. And then monitor your models. And then optimize as appropriate. So we'll briefly touch on Amazon Personalize. And that's going to be another machine learning service to kind of help create real-time and personalized recommendations to your users. So you're a business and you want to give a tailored experience to your users based upon user behaviors or preferences. So I had a cat that got stressed, so I was searching all kinds of things to relax the cat. If they saw me in the store buying cat treats and cat toys, is your cat stressed? If so, look at these new cat pheromones we have. Look at these cat stress balls. I don't know, but anytime you can personalize it and make it a better shopping experience, typically speaking, the customer is happier and the store earns more. So these are some of the things we can do with Amazon Personalize. It's going to give those really nice personalized recommendations. Lots of recommendation types, product recommendations, personalized search results. So lots of cool things you can do. You can also do it in real time. So while someone's in your store, you can do something like that. So really what it's doing is it's going to automate some of the machine learning for you. It's going to have some data pre-processing, some model training and tuning. It helps you pick the most appropriate models, for you to use based upon your use case. But again, you're still going to have to test this and see if it works. Because it's made by AWS, it's going to integrate into AWS things very nicely. So may integrate nicely into S3 or object storage to pull your data. Integrate with, say, a Lambda function or CloudWatch. It's going to tend to scale very well. It automatically scales to handle data sets. And it knows how to scale to basically provide good quality with regards to lower latency and throughput. So where might we use this? I mentioned some e-commerce environments by recommending things to the customer. Media and the entertainment. So periodically I log into something. I log into Netflix. And I got to tell you, it's pretty good at showing me what I think I want to see based upon the movies I've watched. I log into another streaming service and it gives me recommendations. And it's like, are you kidding me? I don't want to watch any of these things, but thank you so much. So any kind of way you can do it in media or music. So you're going to keep your users engaged and keep them subscribers longer, that sort of thing. Marketing and advertising. The ability to personalize a marketing campaign to a specific type of user or segment of the organization's environment. That's pretty interesting. Because sending the same message to everybody doesn't necessarily work, because lots of different people think differently. Lots of different people have different preferences. And to be able to send personalized recommendations can mean that an ad is placed at a lower cost and it's more effective. Customer service too. So if we've got these tools and they've got the data and they've got the abilities, it can kind of personalize the way we support our customers to come up with, again, higher satisfaction. So let's talk about some best practices for Amazon Personalize. Use good data. It's artificial intelligence, so garbage in, garbage out. Include a diverse set of interactions and metadata to improve the recommendation quality. Because you got to train it, and your data has to be great. Constantly update the data. You've got new data and new things to train it. Experiment with different recipes. So that's really what we're talking about. Try this thing and see which is going to work best for you. When possible, anytime you work with data, if you've got metadata or data about the data, it will make it easier for these systems to mine and make better recommendations. So leverage metadata if you can. The next one is Alexa for Business. And this is the Amazon Alexa tool, if you will, to theoretically improve the usability of a conference room by giving people some Alexa-like tools. If organizations and businesses were to use Alexa, for example, they would have them the ability to centrally manage these things and use them in a shared space like a meeting room or a common area, that kind of thing. We all know about Alexa. We know what Alexa does. So I think that's enough on that. But I will get into Amazon Lex. And that's another fully managed AI service. And this is about building conversations via, say, voice or text. Lex is basically for your chatbots, your virtual assistants, and it kind of uses that natural language understanding where it can read through text to understand what it means, can recognize someone's speech, and could create a speech type response as well. So natural language processing is how you read through. Natural language understanding is more about how do you understand the text. So that's one of its key features. Some other key features here is that it can recognize speech automatically. And it can literally look at the spoken language and turn it into text with good accuracy. And by that, it enables voice-based interaction of applications at some point to make them user-friendly or user-accessible, that sort of thing. It works with multi-languages, so you can build the chatbot in more than one language. It also has that content of custom lexia or lexicons or a custom vocabulary, so you can really tune the terminology specific to the business needs in the industry. So why might you use something like an Amazon Lex? Well, you may want something to say automate customer service inquiries, things like maybe an order status, account information, and troubleshooting. You may want to reduce this kind of a chat type device to reduce wait times and maybe provide instant responses for more smaller things that don't require as much human to human interaction. You might want to create a virtual assistant that says to help you with scheduling things or set up reminders. Lots of times in a content center or like a contact center, we want to be able to put calls to the right person. And a lot of that is going to be based upon getting the right information from the person. If we don't know why they're there, we can't send them to the expert on this versus the expert on that. So there are times where getting the right call and being able to get it right will really aid in the time to fix a customer's problem. And by doing so, faster resolution means happier customers. E-commerce, we could probably use this as well to come up with a conversational shopping assistant. You're at the store, and my wife goes to the store and she says, I'd like to buy new shoes. And she says, sure, the shoes are here, but we've got matching handbags over here. I know that would make my wife happy. So basically, how do you set this up? You go to the management console and you navigate to Amazon Lex. You create a new bot. You configure the basic settings, including, let's say, the bot name and the bot language. You define whatever your intents are. So, like, you create the intent that's going to represent the user action. So, order a pizza, for example, could be an intent. And then you'll define slots to capture whatever information is needed. So, order a pizza. Okay, who are you? I'm Mike. What's your phone number? What's that sort of thing. So, next thing is building and testing the bot. You build it, and does it work? Does it work well? Then once you know it's good, you can integrate it to your other applications. You deploy it, and you monitor. Monitor with, say, CloudWatch, for example. Monitor the results. Is it good? So let's talk about some best practices with Amazon Lex. Maybe start simple. So begin with a small set of intents and gradually expand as you get feedback. First, focus on the most common and impactful, and then other things. So prioritize. Use content effectively. So maintain context throughout the conversation to give it a more natural user experience. Constantly improve. Look at the interaction logs, look at the analytics, and identify areas of improvement. Update the bot's training data based upon the feedback that you've seen. So tune it so users will be happier. And of course, secure your data. So implement any robust security on any data you have and always protect sensitive user information. I think it's probably been enough time for me to go to questions. Tyrone, are there any questions for me? Any questions, Tyrone? In the stage of preparing for the solutions architect exam, what are the key components you should remember? So remember this. It is, how do I want to say it? These exams are basically almost, I want to call it a technician exam. Here's the name of something. Here's how it's configured. And yet they ask you more about specifics of the technology itself. So remember this. Most of it is going to be a cognitive answer. So you really need to understand the tech. What is it and how does it work? More than how to configure it for the exam. Now, if you wanted to be a cloud engineer, you have to be really good at configure this. But for the exam itself, most of it are just multiple choice questions. Most. So you need to understand the core AWS services. So core services, especially at the junior level, are virtual machines like EC2 instances, storage like EBS, EFS, S3, lots of stuff on S3, basic questions on databases, basic questions on the VPC, like where would you use an NACO, where would you use a security group. There is questions on identity and access management, which we talked about yesterday. There are questions, typically speaking, on encryption and what it describes as security best practices. Now, those security best practices are going to be very basic. So if you know security, this is going to be much more basic than that. So this is not like a CISSP level. This is going to be very basic. Here's where you'd put WAF. Here's where you'd put Shield. Here's about a network access list. Here is a security group, that kind of thing. Very basic security. There will be questions with cost management, like when would you use this type of an instance versus this type of instance. There will be a bias on these exams towards putting things like serverless and managed services to be a lower cost. That may be a lower cost to the end customer. In reality, it could be much more expensive. So, and there should be questions on basic troubleshooting. So that's going to be your mainstream of it. Tyrone, we'll go to the next one. Why is Bedrock called Bedrock? What is the significance? So here's the reality. The marketing team chose the name. So from a marketing perspective, Bedrock means strong and foundational layer. So to basically look like you've got a strong foundation for success. But that's a marketing term. I don't really put any stock in what marketing people call anything. I focus on what is the technology in and of itself. What is it really? How does the technology work under the hood? How could I leverage that technology to help my clients? And when should I use it and when should I not use it? Whatever they call it is whatever the marketing people got paid to do. So I don't typically worry about those things. Generally speaking, there's so much fluff in marketing. And that's why we've taken S3 and called it object storage. That's why we got rid of EC2 and called it a virtual machine. Because by the time you're done with all this marketing, you don't even know what the technology is. And how do you architect what you don't understand? Good to see you again, by the way. Do you get billed for using AWS AI tools? You will absolutely get billed, and it can be very expensive very fast. So, and if you want to learn AI tools, where could you learn them? Do you have a computer with an NVIDIA GPU in it? Could you run the model on a CPU of your computer where you can do these things free? So, lots of times it's going to be a lot cheaper to practice off of the cloud, and you're going to get much more knowledge about the cloud anyway. So you'll learn much more by taking a server, installing a hypervisor, creating your virtual machines, building virtual networks in a virtualized environment, setting up virtual firewalls, and really put the pieces together and learn how it works than you ever will by clicking a management console. On any of your PCs, you can use these same PyTorch, TensorFlows, any of those kind of models that we're talking about today directly on a PC, especially if you've got enough horsepower in that PC. So if you want to play with it, you don't have to go to the cloud to do it. The cloud is just going to be selling you the same technology you would ever use on a server anyway. So keep that in your mind. It's just going to be managed for you. Will the real world business partner support such experimentation? Absolutely. In the real world, they know this is going to be part of the process. We're going to take this, we're going to train this, we're going to take this, we're going to train this. Now, if that's included, that cannot be, it's going to be at a lower cost billing than with something else. But all businesses know they're going to need to do experimentations with AI. And that's the big difference to determine, the reality of the real world. I mean, even if we use these AWS tools, which are half pre-made, there's going to be lots of iterations to get it right. If we build these tools on our own, we could potentially build a better one that's more customized to us. But it's going to be a lot harder to build in many cases than using one of these pre-made tools. So yeah, there's going to be lots of experimentations. And that's why most architectures take a good year to design, because you're going to have to try things. And then, when you reach the kind of background like David Lithicum or I would come from, and you've done all these architectures and you've got a great architecture repository of here's what we've done for this client, and here's the business flows in here, and here's of clients, and here's what I've seen, and here's what I've seen here, and here's what worked, and here didn't work. And these were the 80% of our career where you had to go fix somebody else's broken architectures because they missed these things. That's when you understand how to come up with systems quickly. But AI model building, AI model tuning, AI model testing, that are going to be big phases of the architecture project itself. Being an architect, if you want to experiment, cost compare between managed services like Kendra Comprehend versus developing and deploying a model and its AWS endpoint SageMaker. So you will potentially have to explore both options if you're a good architect. And let's be fair, sometimes you would be surprised how much cheaper it is in the data center than the cloud. Surprised. For our architect students one day, I wanted them to understand the difference between reality and marketing. And we went to Dell and we priced out, one of the newest, coolest AMD EPYC servers. I think it had 384 cores and about 8 terabytes of DRAM, and it was less than $500,000. And then we converted it to, and that's basically one of Amazon's servers. And we basically converted that into virtual machines with a certain specific IOPS per month, which was less than they would have had on the server itself. And over the course of a few years, it was like $6 million versus the $500,000 that we spent. So you'll have to understand it. And that's part of why it takes so long. We have to understand that actual workload. How much is it running? What is its utilization? How much is the training time that it's going to take to train them? How many GPUs do we need to do the training? Could we do it on a few? Could we do it on many? What is the speed that we need the model trained? And then we can start looking at all the components that go put together. So you're not going to be able to experiment until you know what the architecture actually needs to be, because you need to compare one thing to another exactly. So the biggest question is not this or this and what it costs, because on the surface, you might not get what you need. It's including all the data and all this, and honestly, that's going to take some time to figure that out, and that's going to take some experience with your clients. But when you actually know what you're working with to start from, then you can actually cost compare. But you can't cost compare otherwise, because how do you know? Is something not running at all, where it's cheap to use serverless, running periodically? Is it running all the time? Amazon thought they had a great idea by making Amazon Prime microservice based and serverless based. And then they went, whoa, this was a huge mistake, because they turned it back into a monolith and saved 90%. And that's just because you got to know what you're starting with. If they knew what they were starting with before they designed the application, they probably would have chosen a monolith in the first place. But it all goes down to lots of experimentations. Most of the architectures I've ever done, somebody made a mistake. So don't pick the tech. Don't experiment with the tech until you know how it's actually going to be used. And that's when you will find out what it will truly cost. For beginners, what are the steps to design the current project to do? That, Alam, is an incredibly good question. And here's the answer. And I'm going to say it this way too, because this is so important. If you wanted to be an airplane pilot, and then you showed me photos of you playing golf and learned how to play golf, would it help? There's a reason I'm asking this question. If you went to law school, would that make you an airplane pilot? And the answer is no. So the first thing we need to know is know what job you want. And if you tell me which job you want, I can tell you the correct projects. But the training and experience for a physician is different than an attorney, which is different than an accountant. And we need to know your end goal. Now, if you are an architect and you set up a bunch of WordPress websites, for example, as projects, and did a bunch of documentation on Linux, I'd say no thank you. You look like an engineer or an admin, not an architect. I would expect you to do architecture things, like create a thought leadership, how somehow some new technology can make an impact on these businesses. That's something an architect would be called to do. Or evaluate some new emerging cybersecurity threat and how organizations could potentially protect themselves from an architecture perspective. That would be an architecture project. Now, if I had a cloud engineer, and engineering and architecture are completely different, I'd want that cloud engineer to build big projects in Linux and projects in Windows systems administrators, and I'd want that person to be writing Python scripts. I'd want that person to deliver Terraform scripts. I'd want that person probably to get some experience on OpenShift and Kubernetes. I would want that person writing some Windows PowerShell scripts. And you can say, wait a second, the architect we're talking about writing in presentations, and the engineers we're talking about building stuff. So the first thing is knowing what you want to be, and then determine what kind of a role it is. So architecture is a planning role. 90% of architects, if they work at a real architecture company like a Microsoft, a Cisco, an IBM, an Accenture, Deloitte, a KPMG, a Capgemini, a PricewaterhouseCoopers, a global bank, will not be allowed to touch the technology. So we are called for our expertise in business guidance. Okay, so for a solution architect role. So here's what I want you to do, Alam. I want you to download, Tyrone, pop the link in this, the link in the chat box to the How to Become a Cloud Architect document. And I also want you to attend our completely free How to Become a Cloud Architect webinar on Thursday. But if you were to give a presentation at a conference on something related to tech or a business solution, that would make you look like an architect. A architectural document or reference type in architecture. So Here's one way that you could create security to protect against this kind of a problem. After spending time analyzing all the data loss prevention strategies that are out there, here's a data loss prevention strategy that I found to work in many kinds of organizations. Note, this works here, here, and here, but should be tuned in this manner for finance, and this manner for here, and this manner for this industry, and this manner. And of course, then talk about the specifics of the different kinds of things. How would an investment bank do something versus a trading firm versus a traditional brick and mortar bank? And that's really what the architecture is about. So join us Thursday. But the key is making sure your projects show that you're doing what you actually be doing in the job. We write lots of thought leaderships. We respond to lots of RFI, RFP, RFQs. So writing, concise writing for an executive audience, business writing, that's going to be things for an architect. But I want you to come and join us on the free webinar on how to become a cloud architect. And we will go over the role. And guess what? After the role, after this webinar is done, here's what we can do. We'll be on Zoom, so you can ask me questions live. Turn on your cameras. We'll have a conversation. I'll do anything I can for you. And it's free. So I look forward to it. You said you're registered for the webinar. Can't wait to see you there. All right. So let me know you're awake. I like to be awake. My wife tells me I bounce off the walls, that I drink too much coffee in the morning, but I like to be awake. So let me know you're awake, alert, and oriented by giving me a hashtag AWS SAA. If you haven't gotten our labs, go get them and go do them. They're completely free. If you're enjoying the video, please give it a like. Hit the bell to be notified of new video, and subscribe and hit the bell to be notified of new videos and new things we have to help you in your cloud computing career. So now let's talk about yet another AWS service that also is AI based. And we're going to talk about Amazon Forecast. And businesses make a lot of forecasts. And one of the main things that businesses are using is AI to make predictions or inferences for the future. And Amazon Forecast is a service to help you do so. So let's talk about ways where business would use forecasting technology. So a business, let's say they produce a product and they need to sell it, right? If they produce too much of the product, they have inventory, and they probably didn't have the money for the inventory in the first place, so they typically have to pay financing charges on the inventory. In addition to that, many products spoil. For example, if we've got a company that makes computers and they make too many computers with this year's processor and GPU, as soon as there's a new NVIDIA GPU next year and a new Intel processor next year or AMD processor, those computers go down in value. But if they don't produce enough, when people want to buy it, they won't have it and they'll lose sales. So demand planning in business is huge. And a service like Forecast can help out a lot with that. Resource planning. So how many people do you have working at your restaurant? You typically on small days have very few, and on big days have a whole lot. What happens when lots of people come in and you don't have the staff? So, those kinds of things are the kinds of things that businesses need to forecast all the time. So kind of keep that in the back of your mind. So Amazon Forecast, it's based on machine learning, and it automates the process of building, training, and deploying models. It selects what it thinks are the most appropriate algorithms or parameters for you. And it can be accurate in the way it generates reports, especially if the data you give it is accurate. And it can use lots of different forecasting models. It's got lots of algorithms built right in. And it helps with, say, time series forecasting. So if you've got data beds with dependencies, it can look at what can happen now for you 3 months from now, 6 months from now, and that kind of projections. It'll help with give you tools for cleansing your data, transforming and preparing your data to use it. Because the better your data is, the better your accuracy will be. And it will integrate with a wide variety of sources that you have on AWS, like Redshift, S3, any of the databases. So where might you use this? Well, inventory management would be a good use case. So If an organization can predict and optimize inventory, it can save financing and it can reduce its cost to carry that. Workforce planning, as I mentioned a little bit earlier. So, how do you have the right number of people? Ever go to a hotel in the middle of the week or on a weekend where they're not expecting a lot of people, and all of a sudden you get there and then lots of people, and then you can't find somebody because they didn't workforce plan. So, where they planned, but they weren't accurate. So, any kind of way where we can analyze data and notice maybe you need more people on these days versus these days, that kind of thing can help an organization staff properly. Financing. Whoa. This is a place where businesses need a lot of predictions. So, what money do they think is coming in? What expenses do they think they have? What's the cash flow going to be coming in? Do they have the cash flow to pay what they need? How do they run their company? Are they overly invested? Do they need a line of credit? So, any kind of forecasting here can really help a business. How about resource allocation? So, what resources are going to be necessary for a product? There's the estimation that we do, and then maybe that needs to be optimized for material, equipment, and personnel. And this can help us there as well. Sales forecasting. So, if a company doesn't know what amount of money is coming in, it'll be in danger of going bankrupt or in danger of losing money and hemorrhaging people and having to lay off. So bad things happen. So the more accurate a company can forecast its sales, the better it will do. So how do we manage Amazon forecast and make it run right? Well, we use good data because if we train it on bad data, we've got garbage. So we want good, accurate, complete data. We got to constantly update our data to maintain our forecast accuracy. If there's external data coming in that we can also use, they can help with our forecast accuracy, like interest rates and what they are, a government spending program, a tax cut, a weather forecast, market trends, an inverted yield curve, what have you, in the bond world. These are kind of things that can predict either things going well or things going really bad. And that can help a business to dissect economic information and make better predictions for the future based upon what it sees market-wise going on. And lots of organizations have economists for these reasons, but the more tools the scientists have, the better they can do, or even the social scientists in the case of economists. So, best practice-wise, really evaluate and tune these models. So, you're going to tune it, and need to tune it again. There may be lots of algorithms. You may need to try different ones. Look at the accuracy. If you're getting good forecast back and it's right, this is great. If you are not, fix it because you don't want to make information on bad. You don't want to take bad information and make decisions on it. Set it up. Basically, it's about prepping data, uploading the data, creating a data set group, and training a predictor. And that's about selecting the algorithms and parameters and then monitoring the data. And then generating your forecasts. Now, when we know the forecasts are good, we integrate them into our applications. And we're good to go. So we have completed the section on AI tools in Amazon. So if you were here when we talked about databases, we talked about queuing systems. And we talked about how queuing could help a database. But now we're going to talk about the Amazon Managed Queue. Now, understand there are queues like Kafka, which you could use in a multi-cloud environment. And if you're in a multi-cloud environment, you'll probably need to use something like Apache Kafka. But if you're just in AWS and you're looking for an AWS proprietary fully managed solution for some reason, Amazon SQS is very simple, it's very elegant, and it definitely fits the bill. So why do we use queuing systems? We use it to decouple and scale systems. If we've got microservices-based applications, distributed systems, We need to be able to store our messages before they ultimately get to their goal. We could also use it to slow or reduce or smooth out the write load coming into a relational database. So Amazon has their own fully managed queue called SQS, or Simple Queuing Service, and it is a message queuing service that provides temporary storage of messages. And it can keep your messages in the queue for up to 2 weeks. And by doing so, it enables you to right size your application. So instead of building your database or application for peak performance, you can build it for an average performance, and then those messages can be added to the system when it's ready. So right sizing applications is critical in the cloud, because if we don't right size them for the cloud, we're going to get scary cloud costs. Something else that's kind of cool is you can leverage it for auto scaling. So you could see I have a certain number of messages in the queue, add capacity, add another virtual machine. And by using it, you're going to have some form of communication in your multi-tiered applications, maybe middleware or some kind of messaging middleware. So SQS can function as that. Now, when we've got queues, we've got two kinds of queues that we're talking about. We've got a standard queue, and here's what a standard queue is. Messages come in, and they get taken out as fast as the receiver is able to. That is a standard queue. And that's going to be the fastest option. And here's the reason. The first message may be tiny. The second message may be huge. And the third, fourth, and fifth message may be super small. So it's quite possible that the first, fourth, and the fifth, fourth, and fifth can be sent out quicker than waiting for the first, second, third, fourth, and fifth. So when we go through this, the messages come in, but the order is not going to be guaranteed out. But that's going to be the fastest performance. And every message will be delivered at least once. But messages may be delivered out of order. The alternative is we can use something called the FIFO queue, our first in, first out queue. Meaning, I go in first, I go out second. Cindy goes in next, Cindy goes out next. Mehdi comes in third, Mehdi leaves fourth. The Gelly comes in fifth, the Gelly leaves in sixth. So it's basically going to be sequential, first in and first out. We also have the option with SQS, and we should typically speaking, create something called a dead letter queue. So what is a dead letter queue? So it comes from the postal system. Basically speaking, if the post office tried to deliver a message or an envelope or a package, and they couldn't find where it went to this queue, and it was called the dead letter queue. And that way, if someone came in and said to find it, at least they could go through those packages. Same thing in tech. We may have a queue that should be sending a message in, but what if it's not delivered? Do we want to lose that message, or do we want to put it somewhere like the post office did? Well, we do just like the post office did, and we create that dead letter queue where we can retain a message if an error occurred. Now, let's think a message coming in could be a sale order. We don't want to lose that. Maybe we find it a day later or 2 days later and process it and send the customer, here's a special coupon, or here's a percentage off because you had to wait 2 extra days or something like that. So let's talk about some good benefits of SQS or any queuing system. Well, in this case, it automatically scales for you because it's a managed service. Where if it was your own, say a Kafka queue, you'd have to manage your own servers and, as necessary, add capacity to the servers. It tends to be reliable. These are pre-made systems by AWS. They tend to run well. It may be very cost effective because you only pay for the messages you send and receive or delete. It may also be completely uncost effective if you've got too many messages going through it, in which case you should build your own. So any time where we talk about cost, it's critical for us to know the utilization pattern to understand what's going to be best for us. And it's pretty easy to use. It's got a simple API and console interface. You can get to it pretty easy. And, here's a way you may actually use something like this. So you may have a customer, let's say you've got a 3-tier website. They place an order. First, they visit the web server. Then the app servers run their business logic. And then the order goes through. And you have a queue on the way to your database to make sure your database doesn't get too many messages too fast so you don't lose any. And maybe you also send it to this simple, one of the simple messaging service like SES or simple email service to then send you a thank you email. That would be a use case where we'd use something like SQS. So how does this really work? The message will go from the computing platform to the queue. And the message will stay in the queue until the receiver can take it out of the queue. Then the message is pulled from the queue and is no longer there. Message can stay in the queue for up to 14 days based upon the configuration that you choose. And the message will be pulled from the queue as it's processed. So here's the way I always visualize these in my mind. In a queue, you've got people that are sending the message into the queue at the top. When the receiver is ready, that message gets taken from the queue and sent to the receiver. And then finally, the message is removed from the queue. And that way the message has a temporary place to store the message until it gets to their end destination. So where might you give me some use cases of a queuing system like this? In microservices, anytime you've got a microservice-based application, you've got all these little independently scaling things. So it can help you decouple them and get the messages to who they need to be. Same thing, might use it in a serverless application. We could have something in an SQL, in an SQS trigger, say a Lambda function to process a message. We might use it in, say, batch processing. We can collect a bunch of messages from the queue and then process them accordingly as fast as we could. We might use them in order processing, so we don't lose orders as they're being written to, say, the database or the transaction log. And we could also use it for, say, asynchronous processing. So we may have a lot of email notifications and data processing and other background jobs that this can kind of fan out or connect to. So when might we use this? So if want to deal with, say, capacity planning, if we've got a database that can only handle so many messages being written, but we've got a queue, if the database is a little bit too small, it might be okay because they might sit in the queue. And if we've got periods of peaks and valleys, we may be able to get away with a smaller system. We don't want messages to be lost, right? If a company is doing sales and they lose sales orders, that's not a good thing, right? So we could use it there. Also very good to use in, say, auto scaling. You got a web server application, all of a sudden a bunch of messages are coming into your queue, and go expand, auto scale, and have more capacity when you need them. Where might you integrate SQS? Well, in any kind of database, maybe to trigger a Lambda function, maybe to process a message on an EC2 instance, for triggering events that maybe send messages to, say, SQS. So now we're kind of in other message queue world. So there's another message queue that we can talk about, MQ, or Amazon Message Queue. And that's going to be a fully managed open source message broker for Apache, say, ActiveMQ or RabbitMQ. And what's happening here is AWS is making it easier for you to use these open source message brokers, because Amazon's going to do the main maintenance on these things. So again, this is MQ is a pay-as-you-go pricing. So users are going to pay for the time the message broker instance runs per hour. So, and storage will be billed monthly. So pay-as-you-go could be great if you don't use it a lot. If you use it a whole lot, it might be cheaper for you to manage your own infrastructure. But again, this is a choice, but you can't make this choice until you actually know. AWS calculates something like this. They look at the total sum or number of gigabytes you used each hour, and then they divide it by the number of hours in the month. And that comes up with a value they call GB months, but they also charge data transfer fees as well. But the key thing to remember here, it's a managed service. So you don't have to think about managing your own message brokers or patching them or updating and maintaining the underlying servers of the system product, because it's managed for you. And it supports popular message brokers like RabbitMQ or Apache ActiveMQ. And because it's managed for you, they typically run these across multiple availability zones. So it's relatively highly available. It integrates very nicely with AWS things like the identity access management systems or the key management systems. Because it's managed, they always auto scale most of these managed things. So it will scale as needed. Now, again, if it scales too much, it might be cheaper to build your own. But knowing that it'll do it for you when you need it, for giving you the chance to figure out the best pricing long term, again, is something great. And it's pretty easy to monitor because it'll integrate with Amazon CloudWatch. And you get some fairly detailed logs and metrics for visibility and to see what's going on. And because it is an open source tool, it makes it easy for a customer that's already in their data center or another cloud using an ActiveMQ or RabbitMQ workload. So minimal disruption along the way in. So where would we use these? Lots of time in a microservices communication because it'll facilitate the communication and coordination between microservices. It enables asynchronous messaging, which again enables discoupling of services. It's great in event-driven architectures. And event-driven architectures that if this happens, then do this. If a user puts something public in S3 and it shouldn't be, kick off a Lambda function and go fix it. It's a message queue. So anytime you want to decouple your applications, you can be thinking of something like this. So where might you want to use MQ? Well, if you're going to have a legacy system and traditional message brokers, or you're going to be in multiple clouds you might want to use something like this because it's open source. So how would you set this up? Well, for the most part, you're going to go to the management console and go to the AWS MQ console and create a broker. And that you'll figure the type of instances and storage and network settings that you need. You'll configure your security settings like your VPC security groups and your encryption. You'll configure your IAM and authentication systems and your IAM policies. You'll connect it to the broker. You'll monitor and manage your systems. Let's talk about some best practices. So deploy these message brokers in multiple availability zones. So when one data center fails, you've got another one. And obviously configure automatic failover. So if one AZ or a data center fails, it'll go down. Secure it. So use strong IAM with this. Enable encryption at rest of your storage. Enable encryption in transit for critical and private information. You're putting them in your VPC, so make sure it's in a private subnet. Make sure you've got an access control list or a network access control list, only allowing the IPs that are supposed to use it. Use strong passwords, the same things you would do for most things, but also make sure your network is secured through whatever other devices you may need as well, or services. So monitor your usage metrics because you may need to know when to scale the broker, or maybe it's time to get off of this and build your own one that's not managed, which is going to be cheaper for you once you understand what you're paying based upon the use. Back up and recover your system, your information. So regularly back up your broker configurations. And, use it. It's a great, if you can do a migration, plan it ahead of time. So use these migration tools, but plan it and test it and see it long before you just jump and migrate. Okay, so now we're going to get into another messaging service. And this is going to be called the Amazon Simple Notification Service. And that is going to be a managed messaging service to deliver messages between systems or between systems and people. It's a messaging service, so we use it to decouple messages between microservice applications. We may use it to send an email or an SMS or push a message to, say, a mobile device. It facilitates a publisher-subscriber model, which we'll talk about. And that's a lot like, joining a mailing list. You join the mailing list, and they push the message to the list, and then you get it. So it works on those types of things that can be used as well with publishers and subscribers. And when you deal with this, we typically have two components of it: a publisher and a subscriber. So a publisher will communicate by sending a message to something called a topic. And a topic is like the email list that you subscribe to. I always thought it was a mailing list. So here you can see a publisher will push this message to an SNS topic. Now the topic itself could be sent to anywhere it needs to go. Maybe we've got this message being fanned out to multiple systems. One message goes to a queue, one goes to a Lambda function, one sends an email notification to people. Some features that you have with SNS is the ability to kind of manage your topics. So you can organize your topics to categorize the messages, meaning you can send some messages to some subscribers, but not others, kind of like good email software would enable you to do. It enables you to filter messages. So subscribers may be able to filter out messages maybe on an attribute in the message. Again, making sure subscribers can receive what they want, kind of like an email list. You know, when you click, I don't want to receive this and this and this, but I'd still like to receive this. It's typically good at what you call durable message delivery. So it's going to store the messages that are going to be sent across multiple data centers or availability zones. So, if a data center goes out, you typically don't lose it. And it will retry the messages if the first attempt fails. So where might you use this? You might use SNS in event notifications. So you can do lots of things with this to maybe push a message to a phone or push in a message to an application. You may use SNS with regards to integrating various applications because it can help decouple microservices and distributed systems with SNS topics for inter-service communication. It tends to lead well into that application integration decoupling environment. You can ensure that a change here can trigger actions in multiple things that are dependent upon it. We might use it for monitoring. So we could have some funny things going on with our systems, and CloudWatch may notice it. And then we can take that CloudWatch event and push it to SNS to then notify or text, say, a systems administrator. We may use it for user notifications. So imagine this. You've got a realtor driving around with clients in the back of the car looking for houses. And as that person is driving, a new listing pops up and the realtor gets told, oh, here's a new house that you're a mile away that maybe you should consider. So lots of cool things we can do with something like this. It's basically configured by creating a topic, having the systems that need to subscribe to the topic, and then messages are published to the topic, and the receiver get them. And of course, with any other system, you'll monitor it, see what's going on. Let's talk about some best practices with regards to Amazon SNS. Filter messages by message attributes. So define message attributes and categorize and filter messages. And that way subscribers can get what they want versus just everything, only relevant messages. Implement some good form of access control. So set up IAM policies to determine who can publish and subscribe to the content, because you don't want it going to the wrong people. Put in some very fine-grained permissions to enhance security. Again, going back to that principle of least privilege, never giving more access than necessary is to get the job done. Ensure reliable delivery. So maybe you combine SNS, the notification service, with the Amazon SQS or the simple queuing service to make sure that the messages are then sent to a queue to be delivered reliably. While we're at it, set up that dead letter queue that we talked about to prevent message delivery failures. Monitor and scale your systems. So if you're going to be running something like this, look and see what's going on. Do you have to adjust your systems for increased load? What do you need to do? How do you need to tune these systems to make them work? Now, when possible, set it up for secure communication. Encrypt the messages at rest and in transit, and use HTTPS endpoints for secure message delivery. Okay, the next service we'll talk about is something called step functions. So remember when we talked about Lambda, and we said a Lambda function runs, and then it's done. So if you had a logic where you wanted this to occur, and then this to occur, and then this to occur, you'd need to find some way to orchestrate. Do step one. After step one, do step two. After step two, do step three. And that's where we come into Amazon step functions. And AWS step functions is a serverless orchestration service that lets you coordinate basically these Lambda functions or things into a workflow of in order. Do this, first this, first this. So with step functions, you can relatively easily build and update applications quickly. And you can create what's called like a state machine, if you're familiar with a finite state machine, which is basically a series of steps that can be executed in order. And here's the way I've always visualized this in my head with the step function. You've got something you want to do, so schedule it. This thing happens, a Lambda function kicks off. Then a next Lambda function kicks off, and then another Lambda function kicks off. So that's a way you may want to use step functions. So one nice thing with step functions is it gives you a visual workflow, which makes it very easy for you to say this thing, and then this thing, and then this thing. So if you can see it, it's going to be much easier to develop, at least for most people. Because it's an AWS service, it tends to integrate very nicely with other AWS services like AWS Lambda, ECS, Fargate, that sort of thing. Because we talked about Lambda functions being stateless, step functions gives us the ability to manage state. So it tracks the progress of each step. It also does some error handling and it can catch errors and define fallback states. So where might we use AWS step functions? Well, we might use it to orchestrate ETL workflows that extract, transform, and load workflow from, say, one source of data into maybe another database. We could use it to coordinate tasks, maybe data ingestion, then data transformation, and then data storage. We could be using step functions to orchestrate microservices. So we may have some fairly complicated interactions between microservices, and we can use step functions to manage that. So we've got a complex business process that's going to span multiple microservices. We can use it for that to help schedule that. We may want to do batch or stream processing. So we've got a lot of information that requires batch processing. This could be a good thing. So let's say I set up a video, kind of video I would record on one of my cameras, that it is a huge, giant video. I can go through a 512 megabyte video card in about a half an hour with one of the cameras that I use easily. So I can't distribute that or stream that on the internet, but if I wanted to take super high resolution photos of my cat for videos of my cat for some reason, I might upload a half a terabyte video file. I could then have that kicked off, for example, to another processing engine to turn it into an MP4 file with an H.265 codec to shrink it down into something very small. I might then have captions burned into that video somewhere along the line, and I could set all those things happen to occur. I could do this with hundreds or thousands of videos at any one time, like you might want to do if you stream video as like a business, like a video streaming service, like to create your own Netflix or something to that effect. I can also do this batch and stream processing for a big workflow, big amounts of data that I might need to deal with. Got a lot of data. The data has been processed, and I'll kick it from one place to another place. Very good place to use this would be, say, application workflows, another use case, because you've got a lot of applications that have multi-step workflows, like an order process, account management, inventory tracking, and step functions can manage state transitions and error handling and kind of help us with all this. What if we had a machine learning pipeline? So we might want to orchestrate machine learning workflows like data pre-processing and then model training and model deployment. And we could use step functions to help schedule out those functions. So basically what's going on here is the person that's going to configure this is going to go to the management console. And they're going to define the state machine. They'll create a workflow, which is step 1, step 2, that kind of thing. But they'll start it by clicking, create state machine. Then they'll add the tasks along the way. Add the workflow that you want it to be. If you know what it is, define the ARN or the Amazon resource number or the service function that you want it to go invoke or do. Test the workflow. Is one thing happening and the next thing and the next thing, is it doing it the way you planned it? If it does, then you deploy it, put it into production use, and then monitor and then tune along the way. Some best practices with step functions are to implement error handling and retries. You want some robust error handling, and you want a good retry policy. So make sure that you set that up. Break down as many complicated workflows as you can into something small and little mini state machines. And that way there are simple things that you're planning out each time. Really want to optimize this like anything else for performance. So optimize your transitions, specifically those state transactions, and task execution times to improve the performance of it. If we have the ability to execute multiple parallel things at the same time to reduce processing time or latency, let's go do it. We want to make sure that we secure access to the system. So use IAM roles and policies to control access to these new state machines you've created. Make sure that you're applying to the principle of least privilege. Monitor these things. So set up logging and monitoring. Really set up your CloudWatch alarms and monitor execution performance. And then that's it with regards to that. So I think it's probably time, Tyrone. I'm going to see if there's any questions that are out there. If there are, we will answer them. If they're not, that's okay. We'll go back to the content. All right, I'll give it about 30 seconds, Tyrone. And see, and in the meantime, if you're having a good time with the video, please hit the like button. I would suggest subscribing to the channel, hit the bell to be notified of new videos because we have a lot of new videos coming and lots of things to help you in your cloud computing career. If you've not downloaded our AWS labs, are not downloaded or not signed up for them, so you can actually go through and work them at any time you desire, please do so. They're completely free. All right, we will get back to the content. And now we will talk about the Amazon API Gateway. And that's going to be a managed service provided by Amazon that's going to enable developers to easily create, publish, and maintain and monitor APIs at, for the most part, any scale. Some key features of the Amazon API Gateway is the easy API creation and management, RESTful APIs. You can create RESTful APIs here when needed, WebSocket APIs for typically two-way communication between a client and a server. It's going to integrate easily to any AWS things because it's AWS, things like Lambda, virtual machines, EC2 instances. It's going to, etc. So where would we use an Amazon API Gateway? Well, we might use it for backend services and the web and mobile applications. We may want to use it with microservices to expose microservices running on, say, AWS Lambda, ECS, or maybe some other platforms. We might want to use this API gateway in data processing. For example, we can use an API to trigger data processing or workflow on another system. We may want to use it for third-party integrations to create APIs to basically connect to external partners. So what goes into setting up the Amazon API Gateway? Basically speaking, you have to define the API, including its resources and methods. Then you deploy the API to a specific area. Are you putting it into development? Are you putting it into production? So, and then, you're going to secure the API. You're going to put in, do we need any kind of authentication, for example? What is the authorization? What are we dealing with that wise? We're going to go monitor the API. We're going to look at it. We're going to look at the logs, look at the performance of the API. And we will update these APIs as necessary. The version and maintain these APIs. We'll briefly discuss app flow. App flow is a bidirectional service that's going to move and synchronize data from third-party applications. Maybe a SaaS application like Salesforce or Slack with AWS. So by doing so, you can create that bidirectional communication, that kind of integration without writing code. And to make this work, all that's really needed is to configure your data transfer requirements, and app flow, will take care of the rest because it's already been predefined. And this way, companies that use some of these SaaS applications, like potentially Salesforce or an Office 365, they can get data from multiple sources, which will enable them to basically aggregate that data, create hypotheses, draw conclusions, be able to pull information for the company's knowledge base. So lots of good things that can happen when we can get our data and synchronize our data and then analyze the data and do stuff to it. And AppFlow really improves the efficiencies of connecting applications and services because it's done without you needing to code. So is that a good thing? Well, if it fits your use case exactly, it is. If it doesn't, you might need a custom application, but this is based upon the business needs, not, the technology is selected after we know what the business needs. So AppFlow can help modernize data governance and move your data back and forth between the applications. So we might use AppFlow to quickly integrate applications, maybe to transfer data at a massive scale, maybe to help automate data security. Well, that was AppFlow. Now we're going to talk about AppSync. And AppSync is going to be a managed service that helps you build scalable, GraphQL APIs for real-time data queries, synchronization, and offline programming. This is going to simplify application development by making it easier to interact with multiple data sources through a single API, an API endpoint. AppSync goes back to using that publish-subscribe model, just like we dealt with SNS, to push or pull data from multiple sources. And a template will be created to define what data is going to be pulled from what sources. And then what do they do and pass to the user? AppSync is relatively a simple solution that enables lots of applications to be connected and synchronized from multiple sources, multiple databases, Lambda functions, and OpenSearch, what have you. And AppSync will automatically manage and update the data in the web and mobile applications. And that way it'll deal with real-time updates of the data, what have you. So makes it easy to get all the data from multiple applications and maybe transform it to the cloud or use it for multiple applications. Some key features here with AppSync is that it is a GraphQL API. So that means it's going to support, GraphQL, which is a very efficient query language for APIs. It'll enable clients to request exactly what they need, and that's going to minimize overfetching or underfetching of data. It works with real-time data AppSync. So we've got some good real-time data synchronization and updates. It enables features like subscriptions to automatically update clients with the latest data as it changes. It also has some offline support. So it's going to provide support for your offline data synchronization. So if the data source comes online and comes offline, it knows how to work around that. And it can work with lots of data sources AppSync. Things like DynamoDB, Lambda, RDS, and all kinds of HTTP endpoints. From a security perspective, features-wise, well, it's AWS, so it's going to integrate directly into AWS systems like the IAM systems that you can use. It'll integrate into Cognito and other API keys that we might have for authentication and authorization. It tends to scale well because it's a managed service, so it'll automatically scale to handle the API request based upon your volume of traffic. And that way you've got relatively good high performance and low latency API operations. And it is a managed service. So think about, you don't need to build the provision. You don't need to scale it. You don't need to maintain it, which has its advantages. If you offload certain things to managed services, you can focus more on running the business or other forms of innovation. So sometimes a managed service is great and sometimes it's not. What is the need of the business? What does it best? So what kind of business benefits would AppSync provide? Well, because it speeds up development with a single API endpoint, it can enable businesses that are really deploying new applications faster, which could potentially be more opportunities for the business to earn or get better or stop losses. It can be used to enhance user experience. So because it delivers real-time updates, it can give a pretty good user experience. It could potentially, because it's pulling and pushing, reduce data transfer and processing costs, potentially. It makes it very easy to manage the data because it's providing that GraphQL API and you can query it. It's going to be very simple when you're dealing with those GraphQL type environments and databases. So where might you use this? Well, how about mobile applications? You might want to build a mobile or a web application that's going to dynamically fetch new data and update itself. By being able to constantly pull new data, that can enhance the user experience. Microservices. So, we might want to use it for microservices integration. AppSync can aggregate data from various microservices into a single API, like a unified API. And that will simplify the architecture and the data flow in some microservice-based applications, which can get fairly complicated. We might want to use AppSync with regards to IoT applications. So we may want to be able to build those kind of IoT applications. And yesterday we talked about things like weather sensors and driving cars and machines that are going to determine when they need to be repaired. So we could use it there. And because it takes real-time data synchronization, this tends to work well for that type of a use case. We might also want to create some data-driven dashboards. So maybe we create some interactive and real-time dashboards with insights and analytics. So you're giving companies leadership. Here's what's going on business-wise today. Here's what's been trending. And they can make decisions to do this or do this to make the business healthier. Let's talk about logging in AWS. And with that, we will talk about CloudWatch. And CloudWatch is going to be a monitoring service to monitor AWS resources, as well as other applications that you deploy on AWS. So logging, monitoring. So CloudWatch will give you metrics to monitor your performance and troubleshoot issues. And CloudWatch can monitor any kind of application you run on AWS. The thing to remember is we've got a couple kinds of metrics, built-in metrics and custom metrics, and we'll talk about it. Visually speaking, here's how I think of CloudWatch. Basically, use it to monitor. You collect all kinds of information. This system had a CPU of 85% and it stayed that way. Okay, maybe it's time to add up more servers or add a bigger system. DRAM utilization is too high. This type of a firewall is getting hit too many times, that kind of thing. Something's going on. Anytime you can pull information. So maybe your firewall is running on a virtual machine and the CPUs are too high. Maybe then to go look at some of the firewall systems, see what's going on. Is it a traffic thing? Is it stopping because there's a pattern of behavior hitting it that's hitting the CPU? Are you being hacked? Is it doing things in real time? So any kind of thing where you can actually look and see what's going on. And logging is not new. If you were a Windows systems administrator, you'd be looking at the page file to see if it's being used. And if the page file is being used a lot, you'd know that system would need more DRAM. So this is standard logging that we've used for 50 years in technology. But this is the Amazon thing that collects logs from Amazon in this kind of environment for you. So now you know what is CloudWatch. So CloudWatch has some built-in default metrics, which include CPU utilization, disk read and write in terms of the IOPS, and network utilization. So that's not a lot. Note, I didn't say DRAM there. I didn't say a lot of things, but the built-in default metrics are CPU utilization, disk read write ups, and network utilization. Like how much of the 2 gig, I've got a 10 gig link and I'm at 8 gigs, that kind of thing. But if you need more, you can add custom metrics. So you can look at the memory utilization on a cache that you might have or an in-memory database, because that's going to be critical there. You may want to look at the API performance of something or other metrics. So we can use CloudWatch for that. It sounds like a hurricane is out there. So hopefully my power cooperates and my 3 internet service providers. Because sometimes where I live in South Florida, when we get these kind of monster storms, they all go out, at least for a short period of time. So CloudWatch has some notification systems. So it can send a CloudWatch event, otherwise known as Event Bridge. And that can send out an SP trigger to send out an SNS text message to notify systems administrators. We can use it to trigger auto scaling or lots of cool things we can get out of CloudWatch. Now, when it comes to monitoring for our virtual machines, our EC2 instances, we've got 2 kinds of monitoring: basic monitoring and detail monitoring. Now, with basic monitoring, you get your data every 5 minutes, and you don't pay extra for it. Now, I want you to think about this because I've seen this. If you get your data every 5 minutes, and it's an aggregate or an average of your data every 5 minutes, what will that not show you? It will not show you the peaks and valleys. So what if inside of that 5 minutes, at 2 minutes, your CPU was at 100%, and the rest of the time it was 0? It will probably show 60% CPU load. Now, lots of times when you have applications that are not performing properly, there are these little performance spikes where either the network's 100% utilized or the CPU's 100% utilized, or something is going on. And if you get your data every 5 minutes, chances are you won't catch it. So you may need additional monitoring of your systems, and that's going to be called detailed monitoring. And that's where you get your data every 1 minute, but you pay extra for it. So if you want detailed monitoring, you can enable it. So let's talk about CloudWatch events, Event Bridge, So that is basically part of the system, and the goal here is to deliver a real-time stream of events that can be sent to system administrators or let you know of anything going on in your environment. So the way it works is you're going to set up rules. If you know you have a memory-dependent application and you set the utilization when DRAM hits 75%, send a message, you can do that. If you've got a CPU application and you've got a CPU that doesn't, an application that doesn't perform well when the CPU is above 85%, you can set a notification As the CPU hits this, maybe auto scale out and add capacity, so your CPUs will be at lower load. And CloudWatch events is kind of cool because it becomes aware of any kind of change as it occurs, and it can enable you to respond to these events and take corrective actions as necessary by maybe kicking off a Lambda function or making changes or even telling you. So we'll talk about Event Bridge, which is really CloudWatch, is the new name for it. And really, it's that real-time kind of thing. If this happens, you get to know about it. And this event can trigger something else. So with regards to Event Bridge, there's a couple concepts in case you see it on a test. I don't think you will at the associate level. You might at the professional level. But let's talk about the terminology. We have events. And that's going to be a real-time change in the system or data or the environment. We'll have basically sources of events or event sources. And that's going to be where the events are coming from. Is it coming from an S3 bucket, an application, a SaaS partner? And then we have what's called an event bus, which is going to be a virtual router that's going to receive the events and distribute those events to their destinations. We also have the concept of rules. And rules are basically going to be a set of instructions created with an event bus to match certain things. If this, then this. And then we're going to have a target. And the target is going to be where you send it. So do we send it to a Lambda function or a Kinesis stream or a message, that type of thing? So how is all this stuff working together? With this CloudWatch event, this Event Bridge, new name, it's going to monitor something and it sees something, and then it's going to notify you. So why would an organization use this? We've probably talked about it a little bit, but let's talk about it a little more. If something happens, you want to be able to do something about it in that event-driven architecture, if you will. If this, then this. If you've got a lot of things going on, this thing can scale. And it's serverless. You don't have to think about how to manage it. It tends to integrate natively into AWS because it's an AWS service, which is great. You can integrate it. It's part of CloudWatch. It's part of AWS. You can use it with AWS X-Ray, which you can then use, which is a tool we'll probably talk about, making it easier to monitor and observe the performance of like your applications themselves. So we've covered the CloudWatch. We've covered the Event Bridge. So CloudWatch is monitoring. CloudTrail is auditing. So CloudTrail is going to be an AWS service that's going to help with the auditing process. CloudTrail gives you an audit log that you can use for risk management and compliance purposes. So especially if you're in a highly regulated industry like healthcare, where I'm from, or banking, where I actually worked in for several years, you need transaction logs, and they need to be good. You need to see what changes have been made, when, how, and where, and why. So CloudTrail is great. So what happens is CloudTrail will track the events that are made by the user, an AWS role, or an AWS service. And CloudTrail is going to be enabled when you create the AWS account. And to set it up, basically you'll start a trail with the CloudWatch console, or the CLI or the API. And then CloudTrail will record these events, and these events will be visible to the user. And you can find them on the CloudTrail console. It'll let you see everything that's happened in the last 90 days, any major events. And if you want to store it longer, you can put it where? Object storage, the backup and archival, S3. So there's two options for the cloud trails you can create. You can create a trail that's local to a single region, so a one region only trail, and it will store your logs in a single bucket. And this is default. But is that going to work if you're multi-region? Now you're going to need to create a cloud trail or a trail that applies to all regions. And this will give you much more comprehensive logging and auditing options, because it'll record all events that occur inside of your organization's infrastructure, not just in the region that you're in. So there's two major regions in the US, at least there used to be. Do you want it to only find out what's going on the East Coast of the US, or do you want the whole US if you're in both? So think about that. So here's the way you can kind of think about it. Something's happening on a virtual machine. Something's happened. An IAM user does something. It'll collect all those things, and it will store it in CloudTrail. Here's what I think. I think now is a good time for me to open it up for questions. I know we stayed a little late yesterday, but we are doing great time-wise, and I want to make sure that we give you some time for questions. So, Tyrone, let's see if there's any questions. And while we're at it, please feel free to ask some. And while we wait to see, if you're having a good time with the video, please hit the like button. If you want to see new videos to help you in your technology career, cloud architect career, AI architect career, enterprise architect career, security architect career, or network architect career, please subscribe to the channel and hit the bell to be notified of new videos to help you. And hopefully my power holds on. If there's no questions, I'll let us end a few minutes early today because we stayed late yesterday. So let me know. Are we going to go through some test questions? It's not something we planned on doing. We planned on giving you a lot of understanding of the tech and having you guys go through test questions at your own time, because I can't share somebody else's certification exams. And our focus as a company is really training architects and getting people hired. We just do these certification training camps for free for the following reasons. I've seen everything that was out there, and honestly, it terrified me. So I wanted to redo it and give away for free because I wanted to make sure all of you had access to quality training and the ability to ask questions. Well, you need to know Python for entry-level AWS careers. So actually, that's a very valuable question. And let me actually give you the reality. I don't think you should think about ever getting an entry-level job. Wait, what did I say? I don't think you should ever get an entry-level job. So I'm going to tell you why. It is going to be incredibly challenging to get an entry-level job, and it will be a lot easier for you to just move into a senior role. Here's the reason why. Most of entry-level jobs are click a few buttons here, type something basic into a keyboard. Here's the thing. I can write with Claude 3.5, a Python script, a Bash shell script, a Terraform script, that entry-level technician work. I can do that at entry level. And maybe you're talking about every level versus entry level, but I'm going to start entry level, and then I'll talk about every career as well. But you can get a more senior role. My first job, they had network engineers 1 through 4, and they had network admins at the company I joined, and I was made immediately a senior network engineer, network enter 4. I can tell you that I've trained people all over the world whose first job is being a solutions architect. And here's the thing. That entry-level thing, I can hire 1 DevOps engineer to replace 15 cloud admins. So there's no reason for me to hire that entry-level person. At the same time, I used to hire entry-level for people to rack and stack servers and install the VMware hypervisor, for example. A lot of these systems are on the cloud. The cloud providers automatically do that. So there's much less of a need for me to hire entry-level people than there are. I hire people without experience all the time, and I've done it throughout my career. And I've got lots of people like Ivan Tambo or Coyote or Jared Kitko, whose first tech job was at the AWS as a solution architect after our training. We have people like Balwinder, who was a stay-at-home mom whose first job was a cloud solution architect at Microsoft. We have people like Wallace Agana, who was a sales rep, who immediately got hired as an enterprise architect, which is one step above a cloud architect at JP Morgan Chase. Or Daniel Bose, who was another example of someone we got hired as a solution architect at JP Morgan Chase. I can give you examples in engineering, and I could give you examples all day. But the point is, it's going to be just as easy for you to train for a senior level career as it would be for you to train for a junior level career. But it's going to take you the same 6 to 12 months. It's just you study the things which talk about how do we leverage the technology for optimization of business or performance, or how do we learn how to configure the tech. It's going to take me the same time to trade you both. So you choose where you start. Most of my clients start with a job that pays 2 to 3 times the entry-level role, and that's how I started my career, and that's why I like people to do it. But that's neither here nor there. So the question of should you do an entry-level role? Now, the next question I'm going to interpret is, how about every role? Well, there's lots of roles you don't need to know Python for, and lots of roles you do. A cloud architect does not need to know Python. An AWS Solutions Architect does not need to know Python. An enterprise architect does not need to know Python, and they all have careers with cloud computing. A security architect does not need to know Python. A project manager or program manager does not need to know Python. A sales rep does not need to know Python. A VP of sales does not need to know Python. The CIO does not need to know Python. So understand that certain jobs require certain skills. By comparison, cloud admins need to know Python. Cloud engineers need to know Python. DevOps engineers need to know Python. So we need to more focus on what is the job we want and what are the specific skills for that job, as opposed to, do I need to learn Linux? Do I need to know Python? I know lots of great working architects that don't know how to use Linux, wouldn't know how to write a Python script, and are getting $300,000 to $500,000 plus architect jobs and maintaining these jobs. At the same time, I know lots of people that are trying to break into tech and they're looking for an entry-level role, and for most of them, they'll need to know Linux and Python. So what is the job you want? And then we have to determine what the skills are. The lawyer does not have to be a great runner, but a special operations warrior does. If you let me know the career you want, then I can help you figure out whether you need it or not. I'm happy to do so. Any others? All right, well, maybe we finished early. So if there are no other questions, then I'll wait a minute to see if one pops in. And, one of the things that I always want to think about is don't always assume all or nothing in your career. Every job is very different. Learning one job doesn't really teach you somebody else's. If somebody is a nurse and they want to be a physician, they still need to go to medical school. Will they be advantaged of what they learned? The answer is yes, but it is a new job. Working as an engineer and learning how to build and performance tune something does not necessarily teach you how to design something to optimize business performance, because it's a different job. Working as an airplane pilot does not make you a better lawyer. And that's one of the biggest challenges I see when people join tech, is they don't know where they want to go. Kind of keep that in the back of your mind. Do we offer AWS DevOps engineering? And we do not train engineers for. We are 100% focused on architecture jobs. Architecture jobs are near and dear to my heart. It's what I've done my entire life. And I love that architecture jobs are not affected by AI, because the whole point of the architecture job is designing systems to optimize the business performance. So what goes into that? Well, lots of conversations, lots of meetings, lots of sales, lots of presentations, lots of negotiations, meeting your clients and playing golf with them, for example. And I'm not joking, taking them out and entertaining them. That's a human to human to human job. So AI cannot replace an architect because all of it, what we do is business. AI can replace some engineers because AI can code. AI can write that Terraform script that a DevOps engineer would do. AI can write a YAML template that you would use in DevOps engineering for a Kubernetes cluster, for example. AI can write a Python script right now, and it's going to be a lot better in 2 to 3 years. AI can render Windows PowerShell script. So will there still be jobs for DevOps engineers? The answer is yes, but we may have less DevOps engineers doing the work of many more people because of AI and its impact on engineers. So that's why we've chosen not to train engineers and focus only on architects. I love engineers. They are the people that build everything I design, but my expertise is architecture. We have David Lithicum teaching with us, and his expertise is architecture. We've got PhD business school professors and MBAs teaching business and leadership because that's their expertise and balance, and executive from tech companies. We're just, none of us are DevOps engineers, and we only teach things that we're good at because we really want to make sure our clients are great. And we stopped doing cloud engineering because of my fear of training people for a job that won't be as strong in the future because of AI. Which AWS can someone with software venture skills develop in? So I love this question, but I want to change your thinking. You know what I used to do in my youth? You know what my degrees are in? Well, my last job prior to becoming an architect, I was practicing internal medicine. I was a paramedic. I became a nurse. I became a nurse practitioner, which is a nurse in the US. They can write prescriptions, do surgery, and have their own office. So I had my own internal medicine practice, but I love tech. What did I do? I got good tech training. I paid for it, and it was expensive, much more expensive than today's training, much more. I studied every day for 9 months. I actually became a CCIE in less than 9 months, and I was a network architect. Boom, it was overnight, less than a year. So the answer is anyone can do anything. So, I mean, Delroy Batt was a student of ours, and he was working on ambulances, and he got hired as a cloud security architect. You know, Jeffrey West, you can see a video of him on our channel, and he was working in some kind of geospatial imaging, a non-tech role. Poof, he became a cloud architect, hired by Kalian. Richard Ferrari was working in banking. We trained him, and he got his first job at MUFG Bank as an architect when he was done. Lenny was our video editor, and now he's working as a solutions architect. So you can do any job you want. You want to become a physician, you can go to medical school. You want to become a lawyer, you can go to law school. You can be anything you want. All you have to do is believe in yourself, know you can do it, build a plan, get the right training from the right people that can get you to your goals, and you can do it. So you can do anything you want. You're not limited to software development. I mean, software development, if you had the right business acumen, could go into application architecture. I've trained software developers and made them cloud architects, but I've also trained mental health techs like Jennifer and gotten her hired, or school teachers, or social workers like Noah Parker, gotten them jobs as social workers. So, or Al Legister, he was selling consumer products, but Deloitte hired him as a senior solution architect after we trained him. I'm not trying to talk about our training here. I'm trying to say you can do anything you want. You can be anything. So I ask you, what would you like to do? And what are you willing to do to get there? That's the question I have for you, because you can be anything. You want to be a surgeon? You can do it. Want to be an architect? You want to do it. Want to be a DevOps engineer? You can do it. You can do anything. What do you choose to do? And I know you can do whatever you want, and I want you to be the best at it and love it. And one thing I learned in life is if you don't love what you do, it's no fun. So go love what you do. I love to teach. Maybe you can tell. I love it. Mark. Oh, Mark, it's always good to see you. I know you're in San Francisco. Thank you, Mike and team, for this training that is worth called. Thank you, Mark. I so appreciate that. Okay, well, thank you all for being here. If you enjoyed the content, please give it a like. We've got a whole lot of AWS services to talk about tomorrow. So lots more fun to go. Can't wait. Welcome, everyone. We are here for day 8 of the free Go Cloud Careers AWS Solutions Architect Certification 2024 program. And this is to prepare you for the AWS Solutions Architect Associate certification. And of course, we've covered much, much more. We added a lot more services in the artificial intelligence and machine learning space. We added a lot more security, which would have come out of the AWS Security Advanced course. We've added a lot more content out of the AWS Advanced Networking to give you a fuller picture of how these pieces and parts work together and how to make them more stable and more secure. So I hope you are all having a good time. Welcome back. I am thrilled that you are here. So let me know where you're from. I see some people in Nigeria, which I love, Cameroon, which I love, New Jersey, Jersey City. I used to work in Jersey City, actually. Ghana, I love it. I know Derek super well in Atlanta. I am so thrilled to see you over there today. I've got people in Cape Town, South Africa, people in Baltimore, Maryland. I love this. I'm pretty sure we have some other countries represented as well, which is always great. And we'll begin in a few minutes. But let me tell you about a few things. Okay, New York, which is great. Worked at One Penn Plaza for a while with Cisco's headquarters in New York City. And did a lot of designs for banks over the years, both in Jersey City and New York City. Turkey. Oh, that's a great place. I haven't spent a lot of time in Turkey recently. My family lived in a place called Bedamos, Turkey. So lots of time I've spent in Turkey, which I've absolutely loved. And IDM in Nigeria, that's fantastic. I see Adrian's over there in Phoenix. So Seattle, Sacramento. So we've got a good part of the world represented today, which I absolutely, absolutely love. If any of you are from Greece, that's great. Tell me too, because I always love seeing other people from Greece. And I know there's lots of Greek people that typically follow our channel because periodically I go and speak Greek. But that is neither here nor there. Welcome, everyone. So before we begin today, I want to let you know about a couple of things that we have. And Kenya too, that's great. And even England. See, this is great. So we have some free labs for you to do on your own time. There's over 40 of them. So please sign up for them. Please do so. So you can get some hands-on experience. Now, tomorrow, we're going to have a couple of things to really help you, and it's all going to be free. We have our How to Become a Cloud Architect webinar from 11 to 1 p.m. tomorrow. And I got to tell you, that is a webinar you should come. It'll be on Zoom, so we can all have a face-to-face conversation. And not only can we have a face to conversation, we will talk about the role. We will talk about what we actually do. We will talk about the skills that you actually need, the certifications which will help you get an interview versus the skills that you need to be hired. We will talk about everything you need to know to be hired, including how to bypass HR so you don't get auto-rejected. And it's completely free. So we'll talk for 30 to 45 minutes, and we'll spend an hour and 15 minutes or more answering your questions live on Zoom. Now, in addition to that, if we finish the AWS course today, and I kind of think that we will, we're going to come around tomorrow afternoon, my team and I, maybe 2 to 4 or something like that. And what we're going to do is we're going to take questions on your career. Maybe you desire to be a cloud architect. We're going to cover that extensively in the morning program. Maybe you desire to be a cloud engineer, which is a completely different skill set than a cloud architect, or a DevOps engineer, or a network engineer, or a network architect, or an enterprise architect, or a security engineer, a defensive security engineer versus an offensive security engineer versus a security architect. We're here to take your questions, and we're going to do it free. I've trained people for the last 20 years that work at Apple and Amazon and Cisco and Microsoft and Google and IBM, Palo Alto, Zscaler, Accenture, Deloitte, KPMG, Capgemini, PricewaterhouseCoopers, JP Morgan Chase Bank, Barclays Bank, the BBC, you name it. If there's a prestigious organization, I've trained people there. So the morning session that we'll have tomorrow is how to be an architect. And in the afternoon, ask us your tech career questions, whether it's about architecture or other careers. I don't really care. I know what managers want. I've interviewed thousands of managers and executives over the years in terms of what they want. So when it comes to getting that first job or transitioning, it's about knowing you get the right skills that the manager wants, not what you think, because they're the ones that do the hiring. So I'll be here again this afternoon with some people from my team tomorrow afternoon, and we'll do career stuff, assuming we finish today. I see some more people in India. That's really fantastic. More in New York City. And fantastic. So now we're going to begin with infrastructure as code. We're going to talk about that today. I'm going to talk about what this means for you. So for example, if your goal was to be a cloud admin, once you see what infrastructure as code actually is, you'll understand why you probably want to start as an architect or an engineer or another position. Because what admins do is typically add usernames and password and click on boxes and deploy things and maintain them. And in this case, I want you to see why that's probably not a good place for you to be. So infrastructure as code, which we're going to talk about. And infrastructure as code is going to be the process of managing and provisioning the organization's infrastructure through a simple script. So instead of manually clicking things on the management console like you would be taught in a certification, here you've got one person that can develop a script, and they can launch thousands upon thousands of systems in a matter of seconds. And, it's relatively easy to write these scripts. You can honestly have AI even help create the base script for you, and I'll show you that just because I want you to think about the implications of that. So infrastructure as code is huge. It kind of supports, the DevOps kind of processes where we make when we push large things out at the same time. It supports automation. So we don't have Nikolaus and Aguilo or Spiros and Apostoli all try to set up the virtual machines and do them differently. So it's going to improve quality. It's going to reduce manual errors, and it's going to save a lot of time, which is one of the reasons organizations love coming out of their data centers to the cloud, because with infrastructure as code, they don't need as many people. So kind of keep that in the back of your mind. So how does infrastructure as code work? There is a simple text file that's basically created, and it's written by your infrastructure as code software, something like Terraform, and it will literally just push the configurations out. And that way, you can automate big changes. You can have a disaster recovery environment where you can basically launch all your tech in another cloud relatively easy. And truthfully, if you're using an OpenStack cloud or a Nutanix cloud, like so many companies are using, or instead of, say, a VMware environment, you could use infrastructure as code to add capacity locally in 2 or 3 other clouds in seconds. So it is incredibly efficient. Now, infrastructure as code uses some automation tools, and they typically come into basically 2 types. There's going to be something called the declarative and an imperative form. Now, the imperative approach basically defines a sequence of commands so that the infrastructure can reach its final result. Now, if any of you came out of network engineering and you basically created a little script in Notepad that would say config t, for example, and then you might put a host name for the router and enable secret and what have you, and you basically template out your router configuration and cut and paste it in, and your routers were set up. That's the way I always view the imperative approach, as a set of commands. Now, there's another approach called the declarative approach. And here's where you basically say, here's the end result of what I'm looking for. And the infrastructure as code tool goes and finishes it. So there's lots of infrastructure as code tools. Terraform is the one we typically think of that works across all clouds. Ansible is another option. AWS has their cloud formation. There's lots of them. But if you're in a multi-cloud environment, you may want to use a multi-cloud tool. So the point of using infrastructure as code is it reduces costs. It reduces the amount of people you need, which reduces costs. It potentially improves the availability of the systems if the people that are using the infrastructure as code know what they're talking about. So kind of think about that. But if you don't know what you're automating and you automate it, you're going to automate it wrong. So never automate until you completely understand what things are, how they work, and why. I always loved infrastructure as code because it is consistent. And the key here is consistency. Is when a lot it's you don't have those variations between people. And if you think about various variations, that's where you've got a problem. This person didn't use a strong enough password. This person didn't use the right encryption. So if you know what you're doing and you're doing it well, it's going to be helpful and very helpful. So I want to show you what it's like. So you may have heard me talk about why I love architecture careers, and I just want you to all see this. I love architecture careers because we can't be replaced by AI as architects. The reason we can't be replaced with AI is we have to speak to businesses and ask about their business goals. We have to give presentations. We have to sell. We have to entertain our clients. We've got a lead team. So the architect can never be replaced by technology. If you're looking for an intro job, I suggest not. I suggest getting better skills and be an awesome engineer or an awesome architect or something. But I wouldn't look for those entry-level roles where you're going to click a bunch of boxes like an admin, because DevOps and infrastructure as code kind of relegates many of those jobs as unnecessary in today's world. Here's how easy it actually is to use AI to create an infrastructure as code script. So let's do one together, and I'll share it for you so you can see why I'm not super, why I'm always cautious, and I always recommend architecture careers versus, say, engineering careers. So let's say we wanted to create a Terraform script that launches 1,000 EC2 instances with 16 cores and 64 GB DRAM with 1 TB SSD based block storage drives. Now, I even made some spelling errors, but look what it's actually going to spit out so you can see it. It's going to tell you the type of system that it's actually using, and it's going to generate that script right then and there. Now, all we need to do is basically install Terraform, configure our credentials, and this is launched. And it'll even tell you, how to do that. So this is why, a lot of clicking on management consoles in today's world isn't going to get you very far, because in pragmatic world, infrastructure as code is going to be the way it's going to be done. So think about that. If you have a job where you have to present, if you have to speak, if you have to lead, if you have to discuss business, you cannot be replaced by AI. But if your goal is to do something like a Python script or a Terraform script or a Bash shell script, and one of those jobs where that's the core of the skills, understand they will still need people, but they will need the best of the best and the most senior and the most senior. So if it's your first job, you can still get a senior role. You just have to be great. So avoid the junior level, intro level roles and go for something more senior, because there's lots of great opportunities for you, lots of them. You just have to be great. And tomorrow's webinar on how to become an architect, we'll talk about how to be great. And tomorrow's afternoon career question and answer session, you tell us your goals and we'll tell you how to be great, so that the world will come to you and you'll have all the opportunities you're looking for. And we're going to do all those webinars tomorrow free. So let's talk about some AWS services, which kind of fall close to this infrastructure as code or either in that. So one of them is called AWS Elastic Beanstalk. And Elastic Beanstalk is a service for provisioning, deploying, and scaling web applications on AWS. Basically speaking, the developer uploads their code, and Elastic Beanstalk will automatically deploy the necessary infrastructure. So EC2 instances like virtual machines, containers, load balancers, and it's automatically auto-scaling. So if you've got a developer and they basically pop it into this, they can pretty much get their entire infrastructure built. So I kind of hope that makes sense. And Elastic Beanstalk is going to give you all the tools that are necessary, and then you'll apply it. So people that are using Elastic Beanstalk can write code for it in the following language: Go, Java, .NET, Node.js, PHP, Python, or Ruby. And this will automatically manage the environment. And if you choose to, you can auto-manage it thereafter or auto-tune it. So it's a code-like way to deploy your infrastructure. Basically, you stick in the code, it hits Elastic Beanstalk, and then it deploys, say, your web servers, your app servers, your cache, your database, your virtual machines, all of what you need based upon what you tell it. So that is an option on how to deploy things via infrastructure as code. Now let's talk about another application thing. And here we're going to talk about Amplify. And Amplify is going to be a service used for the quick development of full stack web and mobile applications. So you typically think of a full stack application as a front end, which is where the user is, and the back end, which is where the servers, code, and databases, and all the stuff behind the scenes that makes the app work. And typically speaking, for a developer to create these things, they've got to create their own virtual machines or storage, or you have somebody create them for them. But Amplify kind of makes it easier for that. So it's kind of like a browser-based visual development interface. And it enables, the developers to have this drag and drop configuration of their front end and their back end. And it provides this command line development, and all the magic happens in the application's back end. So it makes it real easy for people to create an application by just writing a few lines of code. And then there's Amplify hosting. So it can push updated applications to the internet. The code's typically received from a Git repository or an Amplify Studio interface, and it's deployed using AWS, and it can just be pushed to the system. We're kind of in that development and developer tools area now. So now we're going to discuss Cloud9. And Cloud9 is an integrated development environment, and it helps developers save time, as all the tools don't need to be configured separately that a developer might use, and they don't have to learn multiple sets of tools. So Cloud9 also has some automated code generation and intelligent code completion features. So intelligent code completion is kind of like when you use the new Microsoft Office 365, and it automatically finishes half of your sentence for you, and you just choose to accept it or not. So this type of environment makes it very easy for developers to write code. And, developers miss bugs too. And the more tools they have to catch bugs, the better the work output. Kind of like when you write a document in your Microsoft Word, right? And underline something in red, and then, to look at it, is the grammar right? Is the spelling wrong? What did I do here? So that same kind of thing. These tools help developers have a better, more organized workflow. The key to remember here, it's a cloud-based development environment. So it can be accessed from any computer with an internet connection. So often developers would create multiple virtual machines to have a separate environment. Here they don't need it. They just use this environment. Is that better? Well, it depends on your developers, depends on the kind of system they have, it depends on their sophistication. So it's an option. And the key is it's a pre-configured environment. So all the typical essential tools people would use, all the software development kits, support for script languages like JavaScript, Python, PHP, Ruby, Go, that kind of stuff is there. So it basically provides a terminal with pseudo privileges, and you could install additional tools, but it's pre-made for you. Again, you could just make a virtual machine sitting on your computer and then push it down when you're done, or you can use something like this. Cloud9 tends to foster a collaborative environment. And the key is you can take this development environment and share it with the rest of the team so they can collaborate. Much like a Google Documents or an Office 365, where you've got lots of people that can work and edit a document together. It's also serverless. So it integrates very nicely with Lambda, and it enables you to really test your serverless applications. So it helps with serverless deployment. It supports the AWS serverless application model for building serverless applications. And it's deeply integrated into AWS tools, whether they be things like code commit or code pipeline, some DevOps type tools, or AWS Cloud Formation, which is the AWS proprietary version of, say, Terraform. And it's very easy to manage your resources with the built-in toolkit. It's highly customizable. So you can customize your development to suit your preferences. So where might people use Cloud9? Commonly with web and mobile development. It's going to take advantage of pre-installed tools for and development kits. It's the serverless great for serverless because it gives you an opportunity to test things like Lambda functions. It helps with streamlining the debugging tools. It's great for collaborative coding because it's just like that Google Documents kind of thing where you can see what people are doing, and that's kind of helpful. It's also kind of nice in a learning and education environment. So if you're teaching somebody how to code and it does word completion for you and it helps you along the way, this could be a useful tool for something like that. So how do you use it? Well, basically, you go to the management console and you navigate to Cloud9 and you click Create Environment. Of course, you got to name the environment and a description environment, and you do so. Then you configure the environment. Choose whether you want to create or virtual machines for your environment or connect to an existing instance. You select the type of instance type that you're talking about. You set up the environment and it'll open it up in your browser. And right after that, you can start coding immediately and use any of the pre-installed tools. You can test your code with it. You develop it in there and you can test things in the terminal. And of course, you can collaborate with your team. And finally, so let's talk about some best practices with Cloud9. You want to optimize the configuration. So choose the right type and size of your development instances for custom performance. Now, again, if this was on your desktop, you can basically, with your desktop, if you've got extra CPU cores and extra DRAM, you don't need to pay for any of this. So it might make sense to spend a couple $100 extra on your users' tools and not have to pay for any of these things. But it's an option. And it's an option where you don't have to be very sophisticated, which is good. And it's an option to do it and do it quickly. So there's times and a place for this. The collaboration piece is great. Now, when you're using a development tool or any tool, you should secure it. So at bare minimum, use IAM roles and policies, enable encryption at rest, and make sure your environment is secured, what have you, things like access control as security groups inside of your systems. Collaborate. If you're going to use a tool like this and you're going to pay to use a tool like this as opposed to creating a virtual machine on your desktop, please collaborate with others and make use of that team building environment. And of course, manage your environment and shut things down because, you have these systems. Well, they're great at configuring serverless. They run on systems, right? So you're going to pay for that system. So make sure that it makes financial sense. Okay, now we're going to talk about the AWS Infrastructure as Code tool. And that's AWS Cloud Formation. And AWS Cloud Formation is an Amazon-branded, Amazon proprietary infrastructure as code tool for delivering things using infrastructure as code on AWS. So it's going to be just like Terraform and Cloud Formation. Here's a good use of it. It enables you to template known good configurations. For example, you've got an application that requires a bunch of servers, a specific set of packages installed, and patches. With Cloud Formation, you could deploy a whole bunch of them with a simple script. So it enables organizations to provision their applications in a safe and repeatable manner. And it comes with AWS. And it's a great, great, great tool. But imagine you're on 2 different clouds or 3 different clouds, like 98% of businesses. Do you use a different tool for each cloud, or do you use one tool that'll work on all clouds? So these tools become very limited in the real world where 98% of organizations are multi-cloud. In practicality, it's an awesome tool, but we've got to use the right tool for the right job. So basically speaking, you create your infrastructure, you code your infrastructure, you upload it to object storage, and then you run the script, and then all of a sudden your resources are deployed. So I'll show you, we could write a CloudFormation script with AI, and there's other tools that are even better for coding than ChatGPT. In some cases, ChatGPT is a good all-around tool. But if we wanted to do this, and this is why I say architecture careers are going to be some of the best, because you have to talk to people, you have to lead people, you have to sell, you've got to present, you've got to do all these things which you could never be replaced. But on the engineering side, it's not quite as easy. But you can still keep jobs and get great jobs in engineering if you're great. And we'll talk about how to do that. Create a cloud formation script. Maybe I should put AWS just in case. To launch 500 EC2 instances with 128 cores and 2 terabytes of DRAM with 1 TB IO2. Hopefully you'll see this. With 10 IOPS. So you can see what it's actually giving you. It's telling you to create an auto scaling group. You can see that it's naming this. It's telling you how many systems to use. Now, granted, you'll have to change the subnets to actually make it accurate. And you can see that it knows which systems to use by the 128 cores and the 2 terabytes of DRAM. And you can see that we've spec'd out 1 terabyte with 10,000 IOPS, which is going to come from an IO1 or an IO2 device. We asked for IO2. And that's pretty much it. So you may now see why I say these admin jobs, we're going to go click boxes, that we don't need them anymore, because, we can have somebody with limited skill actually use this and create it and then tune it. But architecture jobs never go out of style because they're all about talking to people and leading people and solving business problems. So there's there. So we'll talk about tomorrow, again, how to become an architect. And in the afternoon, we'll talk about if you want to be an engineer, these are the skills that make you irreplaceable. These are also the skills that can add an extra $100,000 or $200,000 to your annual salary. So we'll talk about that if you ask questions about it tomorrow, because I want to make sure that everybody has a job they love and knows how to get there, because I've loved my tech career. So let's talk about some extra features of CloudFormation. It's easy. You define your infrastructure in a JSON or a YAML type template that you would use for, say, Kubernetes, and it's done. You've got version control alongside your application code. It makes it so easy to automate provisioning of your systems. You create a stack, you update it, you delete it. So just so simple and elegant and efficient. As far as it helps you handle dependencies, so it can handle the dependencies between certain resources to make sure that they're created in the appropriate order. If any of you guys are familiar with like the critical path and project management, where some things have to happen before something else. For example, you need the network before you put the servers on, because if you put the servers on before the network, they won't be able to get on the network or talk to each other, and nothing will happen. So network first, server second, that kind of thing. It enables you to roll back. So you made a new configuration change and it's bad, roll back to what worked before. It's also quite good to detect what's called configuration drift. So you may notice that there's a difference between what you see in your environment and the actual template. CloudFormation can help you detect that. It tends to be fairly extensible. And what I mean by that is you can create custom resources to extend CloudFormation's capability and make it support resources that are not natively supported. You can use Lambda functions to perform custom actions during, say, your stack operations. It's used in a lot of environments. So automating your provisioning of your infrastructure. Just asked it to launch 1,000 virtual machines of a specific size with a certain size IO2 hard drive from the EBS VMs. That's 1,000 of them. Imagine how hard it would take you to go to the management console. Click. Wait for the screen to refresh. Click, 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 click. Now, in the old days, do you see why we needed a lot of admin people? Because clicking all those things and waiting was taking forever. But we can now do in minutes what used to take 10 people, a week or two to do. So think about that and the implications of that for your clients and for your career. Where do you want to be? Be on the side where you cannot be replaced. So you might deploy a multi-tier application here, and you can manage the entire life cycle of the application with infrastructure as code. This is phenomenal for compliance and auditing purposes because you just look at the script and you kind of know what you have. You can trap changes. You've got an audit trail. It's elegant. How about disaster recovery? So seriously, think about this. You've got all your information in one cloud because doing disaster recovery to another region in the same cloud is crazy. Because if it's in the cloud and the cloud has a control plane, a network failure, or a hacking event, it can take down the whole cloud. So if you're on AWS, you might have copies of your virtual machines sitting and data sitting in Azure. And all you need is a cloud, not a CloudFormation, a Terraform script. And you could launch your Azure systems instantly with the data that you have and be up and running in a very short period of time. So in this case, we're dealing with AWS CloudFormation, and we can use it for disaster recovery. We can launch systems. Maybe we've got our systems in Azure, and we use CloudFormation to launch them in AWS. So what goes into this? Well, you've got to create your CloudFormation template. So that means defining the resources using a JSON format or your YAML format. We create a stack. So we might go to the management console and navigate to, say, CloudFormation and create a stack. We'll upload our template file or specify a URL for the template. We'll provide any necessary parameters, and we will create the stack. We will then monitor the stack in its creation, make sure that it works. We will then update the stack, and then, when necessary, we'll delete the stack when we no longer need the resources. So some best practices with CloudFormation is to use parameters and output, meaning utilize parameters and custom stacks to make it customized for your environment. Create fairly modular templates. And what I mean by this is break down your templates, complex templates, into small reusable templates. And that way it's easy to tune things. Typically, you want to use nested stacks to organize it more effectively. Make sure you have good version control. So store your CloudFormation templates in a version control system like Git and track those changes so you can collaborate with key members on infrastructure as code. Okay, next we'll go to the Cloud Development Kit. But you know what? Let's see if anybody has some questions with what we have seen. I saw we had some few people. I saw Jawad coming in from the UAE. That's great. I actually set up the first fiber to the home project voice data and video in Dubai Marina in 2000. Or was it 2001? It was one of the first in the entire world. Had a great time over there. See who else is over here. Since we found out where you're all from. And I saw we had Ghana. Fantastic. Okay, Tyrone, you can bring in some questions. What about Terragnok? So we can use any tool that we absolutely desire. So I never have any problem with anything. And what we're really dealing with that is it's a wrapper around Terraform. And that's going to reduce repetitions and configurations. It's going to help manage, the remote state, and it handles, multiple modules. I have absolutely no problem for that or anything that you do. So I want you to think of one quick question and think about it in your career. So when I started my career, I worked for a Cisco competitor. And they had one of the best product sets in the world. But we lost almost every deal. And we lost every deal for almost two reasons. One is the Cisco people talked about business transformation, and we talked about tech. And customers don't care about the tech. They care about what the tech does for the business. But there was another thing I heard all the time. And we would go through a test off and prove that maybe we had a great architecture, we had a good solution, and they would still buy Cisco. And Superior, what they used to say is they said, nobody ever got fired for buying Cisco. And I said, what do you mean? And they said, Mike, if you're a chief information officer and you look at the available technologies and you pick a market leader like Microsoft, IBM, or Cisco, if it doesn't work, you're okay. And the reason you're okay is you chose the leading brand. And that's what most businesses do. And if you chose the leading brand and it didn't work, you didn't do anything reckless. So think about that. Now, any kind of technology that you choose is right is fine, but you've got to be in a position that says, here's why we made these choices. This is what this one software package or hardware packages does uniquely other than the other. And then if it's not the thing that everybody thinks about as the number one player or the number two player, when it breaks, and everything will break, but when it breaks, you're going to be saying, why I chose to use the thing that's not used in 99% of all businesses or 89% of all businesses. And that is a bad position. So it is great. It's just a wrapper for Terraform. And there's no problem using it. But always think about that with every choice you choose. Okay, let's see. What about CrowdStrike locking up desktops? So that's a good question, but here's what you need to think about. And I can tell you why this occurred too, according to Microsoft, and I believe it. So when you own your infrastructure, you have complete control of it. When you go to somebody else, you are at their mercy. So for the character at Google that misconfigured BGP and took the Google Cloud down for hours, you're down if you're on the Google Cloud because you are their partner. How do you deal with that? Put yourself in two clouds versus a single cloud, and you don't have that problem. And don't use these proprietary tools. Now, when you deal with other companies and patches, normally an organization gets a patch, they test it first on a virtual machine, then they test it in a development testing environment, and then they push it out. And then they deliver it to a small percentage of the users, and if it works, they deliver it to the entire set of users. That's the way you do change control and don't have outages. You also update these things at a time where the business is not busy. Now, the systems that were using CrowdStrike were letting themselves be auto-updated instantly without even being able to test it. So that means you are at the mercy of CrowdStrike, their intelligent development processes, and their intelligent testing processes, which you could see some major failures there. So there's a problem. Now, the reality is CrowdStrike kind of is at that kernel level in Windows. And the kernel is the head part of the operating system that manages your memory, etc., like that. So normally speaking, you would not expose your kernel and the security parts of your kernel to anybody other than the people that made the operating system. So when you buy a Mac, stuff doesn't go at the kernel level without you approving it first. It's not going to be automatic. On Linux, things don't go at the kernel level automatically. They're blocked. Now, the European Union went out there and was looking at suing Microsoft for what they called unfair business practices. What unfair business practices were for Microsoft was not allowing people to develop for that kernel. So Microsoft said, well, if we have to do business in Europe, we have to comply to European laws. We're going to open up that kernel. So the European government forced Microsoft to go open a hole in the most critical part of the operating system. And then when CrowdStrike pushed out an update, which it didn't test properly, and the Windows systems were open because they were mandated to be open by the European government, as opposed to necessarily what was right or wrong for the operating system, it enabled that to occur. Now, do we blame the European government? Well, their goals were good. They wanted more people to be able to write security stuff for Microsoft than the Microsoft itself. That seems reasonable. And it wasn't that it was irreasonable based upon what the goals were, but the people that were thinking about openness probably weren't thinking about security. So anytime you try to force something to occur, and any architectural or technology decisions you make, everything that you do is good is going to break something else and be bad. So architecture is not about choosing the great technology or the best. There is no such thing as the best. It's like a medication. You choose the right tool for the job that you need after evaluating all trade-offs. I use this proprietary tool. Okay, it's easier for me to use, but it costs me this, this, and this. But in our business, the speed and agility is worth a proprietary tool. Okay, go ahead. Now, when that's wrong years later, you can fix it, but at least you had a reason for doing it. So the key is, should we allow things to be open in a system like that? The answer is no. But if the governments around the world are forcing it, what can you do? And this is not the first time we've had a major security outage, and it will not be the last time, which is why don't use just one security vendor. Use two security vendors. Don't just use a single cloud. Use systems. And for example, when we made traders and trader systems, trader A would be plugged into one part of the network and trader B would be plugged into the network. And they were next to each other. You could tap the person on the shoulder. And why do we do that? Because if I'm here, the trader Mike, and my system goes down, I go over there to trader Sally and say, Sally, please place my trades for me. And we salt and peppered, as they like to call it. Each user was on a different network. And by doing so, we could lose half the network and the users would still be good. So same kind of things we're talking about here. Should you use LAML and CloudFormation or copy and paste from AWS documentation is enough? It depends on your job. If you are a cloud architect or a solutions architect or AI architect or enterprise architect, there's not going to be any CloudFormation or infrastructure as code or touching the technology in your job. It's not a valuable skill. If you are a DevOps engineer, you better be really good at this, because this is going to be a big percentage of your job. If you are going to be a cloud engineer, you better get pretty good at this as well. And, there's going to be that. Now, should you read the vendor's documentation prior to doing anything? Absolutely. Absolutely. So you should always read the documentation, because commands change over time. But you're really going to need to know what you're actually doing when you're doing this. And you're going to need to know if this is one of your jobs. So the key is really figuring out what job you want and then being great at the tools that you need. So tomorrow morning, we'll have that free thing on architects. Tomorrow afternoon, we will talk about other, other careers if you want. Ask us any way you want to be great at your job. And, maybe your goal is to be a distinguished engineer. We can tell you how to get there. Maybe you want to be an architect. We can tell you how to get there. But all these jobs are different and they need different skills. Derek, can I explain the GitHub repository check and check-in and check-out process? Well, yeah. So checking out is really going to be cloning what's in that repository and pulling it. And checking in is going to be adding it to Git, kind of a Git commit, as they would call it, or a Git push. Now, to be fair, Derek, I'm an architect, and we don't really use Git in our careers. But people that are in that software engineering world or DevOps engineering world, or potentially even some cloud engineers, will definitely be using GitHub repositories. Any other questions? All right. If not, we will get back to the content. So if you haven't accessed any of our free labs, please go download them. They're completely free. My team also wrote a certification guidebook for you as well. I'll pop that in the chat box. And maybe you want to know how to become an architect and you're curious what certifications are going to make you look good. Well, we wrote that book intentionally for you. For example, if I see a SysOps certification on an architect, I tend to be inclined to walk away. The same way if I had an airplane pilot and they didn't talk about having fancy flight things, but they talked about law school on their wall, I'd be inclined to walk away because I didn't think they'd be a full-time pilot. But if they had pilot thing, if they were a lawyer and they had law school, law this, law that, law the other thing, I'm going to say this guy's or girl's great. So same thing with your brand. You can build them in alignment in your career, or you can get them in 10 different people's careers and show yourself. It's like you're a little confused and show yourself as an entry level person in a lot of different careers. Or you can build a serious portfolio, learn something and show people you're great. So that document's on how to show people you're great, because it's hard to do this work. It's hard to get certified. But unfortunately, if your goal is to be an airplane pilot and you got a certification in nursing, nobody cares. Nurses are critical, super important. But being licensed in nursing is good if you want to be a nurse. It's not good if you want to be an airplane pilot or an attorney or something else. Same thing in tech careers. So we're now going to talk about something called the AWS Cloud Development Kit. And actually, let me know you're here by giving me a hashtag AWS SAA. If you're learning something, hit the like button, please. Subscribe to the channel, hit the bell to be notified of new things to help you in your technology career. So let's talk about the AWS Cloud Development Kit. It is another infrastructure as code tool offered by AWS. And it's an open source software framework that's for use for managing AWS-based infrastructure. And it makes it relatively easy for developers to define cloud infrastructure in those familiar programming languages that they tend to use. And that could be Python, that could be JavaScript, that could be TypeScript, C#. So instead of building, your cloud infrastructure using the graphical interface in this or the command line, here you're doing it programmatically using the Cloud Development Kit. Lots of tools do lots of the same things. So it provides kind of this high-level object-oriented abstraction, and it enables developers to create a cloud infrastructure as a set of reusable code. And they call those things constructs. And these constructs are combined together to form stacks and applications. And then you can deploy these stacks and apps in your infrastructure by using a CloudFormation template. So you can look at it kind of in this environment where you've got this cloud development application. And you can see how it gets compiled, turned into a CloudFormation template, and then launched. So it's a pretty interesting way to do things. But there's lots of environments for infrastructure as code. So why might you use the Cloud Development Kit? It tends to make onboarding fairly easy because it helps developers roll out applications even easier. It enables developers to kind of customize those constructs that we talked about to meet an organization's, say, security needs or compliance needs. Now we're going to talk about another application development tool called AWS Code Artifact. An AWS Code Artifact is going to be a managed artifact repository service that's going to make it easy for organizations to secure, publish, and share software packages that they might use in their development practices. So it's going to support common package managers and formats. So it makes it relatively easy and versatile to manage dependencies across different programming languages. So there's some features that you would think about with AWS Code Artifact. It's going to be a managed artifact repository. So by having a repository and an artifact as a piece of something or a creation of something, you can put it there fairly easily, and it scales to meet your needs. So you don't have to think about where you would store it and how you would store it. It takes multiple package formats. So you can think JavaScript, Python, Java, .NET. So you can put lots of packages in a single repository. And then you can use access control. So you can use your identity and access management policies. Nikolaus can access, Peter cannot, Costa can based upon their job roles, for example. And of course, it supports encryption using the AWS Key Management Service. Helps you with version control and dependency management. So it can store multiple versions of a package. And that makes it easier for you to think about and roll back to other packages that may have different dependencies on other packages. So if you're familiar with Linux, for example, and you want to install this application, but this application is developed dependent upon 10 other different packages, and you have to install those packages before the application will work, that's really what we're talking about to make this helpful. So helps with version control, versioning as well. Now, if you're dealing with the CI/CD, this kind of continuous integration, continuous deployment pipelines, it's going to be very seamless. And with those other tools that we're going to talk about, code pipeline, code build, and other CI/CD tools. And that way you can kind of automatically build in some of the deployments using images or the package that you stored in code artifact. It tends to be very compatible with other artifact repositories and package managers. So makes it easy to do proxy requests and cache information from public repositories. Why would you use something like code artifact? Well, package management can get fairly complex. And of course, you could store a folder on a file server and put your packages and put your dependencies in there and create multiple folders. You could, with a really good naming convention, and have no problems. But in a big environment, you got people writing code all over the place. Do they adhere to the right naming convention? And if they don't, do they create the right folders? And how hard is it to find stuff in the versions? Well, it can get ugly if you don't have good practices. So here's a tool that would make it easier for organizations that don't have the best practices to be able to do this in a repeatable way. And honestly, anytime you make things easier and people can make less mistakes, it's a good thing. Great for managing the dependencies of multiple projects, because managing systems and the package dependencies can be kind of ugly sometimes. It can help a lot there. You might want to use code artifact for secure package distribution. And that's great. You can basically encrypt your packages. And of course, you're going to use this from a use case perspective integrated into your CI/CD pipelines. So how to basically use this? Well, you go to the management console and you navigate to code artifact. And you're going to create a domain and a repository. The domain is kind of this big area, and you can create multiple repositories in there where you store stuff. You'll then configure your package managers to use the code artifact repository. Then you'll publish your packages to code artifact. And then basically you can install packages as needed from code artifact from the package manager. Now, some best practices associated with something like this are to use strong identity and access management controls. Really use that role-based access control where you've got good roles and good permissions for each roles, and do it efficiently. Create versions. So versioning is good. Versioning will make version 1, version 2, version 3. You push out a new version, it's bad, you roll back to the other one quite easily. And you can see this. People that were using Nutanix systems after the CrowdStrike thing, they had an easy way to roll back to the original systems without that update, and they were and some of their customers were up and running soon. So versioning, or any kind of versioning, can be highly beneficial, and it can be a good checks and balance for someone else. So of course, if you're going to use this tool or any other tool, you need to monitor it. So enable logging and look and use CloudTrail. So monitor CloudWatch, look at those CloudTrail logs, track usage and access to your repository. Imagine if the wrong people are getting access to your proprietary software and applications. That's not good. So integrate it with those DevOps pipelines to automate building and deployment. And make sure that you cache dependencies from any kind of public repository, because you may have something that you're constantly pulling from a public repository and it might not be there. It could be down for a little while. So you want to cache that information to make sure your development teams have access to what they need when they need it in a fast and efficient manner. So now we're going to talk about another application development service from AWS, and that is CodeStar. And CodeStar is going to be a service that's going to assist in creating, managing, and deploying software applications. It gives you a central console that you can use to assign project team members and the specific roles they need to use. And they enable the people to access tools and resources that are needed through the centralized console. So basically, CodeStar gives you a single dashboard that integrates software development tools, and that's going to make it easier for managers, developers, and people on a team to collaborate. And they can use the console to track software developments from week to week, task to task. Let's talk about AWS Device Farm, another application development thing. So that's going to be a fully managed service to help you guys test web and mobile applications. So it enables you to improve your applications by running the tests on real devices, if you will, by simulating real world environments. So realistically speaking, that's Device Farm. And it enables automated testing because what you can do is you can select the code that you wanted to test. Then you select your devices. So you want it on a virtual iPad, it'll run on a virtual iPad. And you can tell it the iPad operating system version, for example. And you can select as many of those virtual devices you run, and they're running the actual software of the physical device. So you can push content on a bunch of applications, you can on a bunch of virtual systems, you can test them, and that way you can interact with remotely. So here's the thing, it gives you the ability to give a full wide range test on real iOS or real Android devices. Now, they're not physical devices themselves, generally speaking. They are virtual devices, meaning they've got a virtual CPU, virtual memory, but they run the full operating system. So it's going to feel kind of identical to the physical thing. And the only time it won't work is if you've got a hardware problem on the real physical device that it doesn't know about in the testing environment. So that's going to be something else. So you may use Device Farm for testing, and then you're still going to test it on some physical devices when you give it to the user, but it gives you a great environment to test it on. And Device Farm supports automated testing tools. There's lots of them like Calabash, Espresso, there's an XC test, there's others as well. So you can run automated tests without modifying your test scripts on these virtual devices. Of course, you can do manual testing as one, directly through your web browser. You can manually test your applications, debug them, get screenshots. And again, this is going to integrate into CI/CD pipelines, which, the concept of constantly improving your software and pushing software out faster is great, right? But if we push the software out faster without testing it, like that CrowdStrike issue, we can have big problems real fast. So it's not always, you don't always want to speed it up. You want to go as fast as you can while maintaining quality, not just push. So always think about that. So where would you use AWS Device Farm? Typically speaking, to make sure your applications are going to run on a variety of operating systems, devices, and screen size. So you can push it on this phone, this phone, this phone, this phone, this phone, this one, and see if it's going to work. And because you can use like a virtual CPU and virtual DRAM that's going to give you the very similar performance to the real thing, you can do some good testing on it, including performance testing. You'll be able to test web apps on the various browser versions and devices. I'm sure you've seen websites where you tried to use Google Chrome and it doesn't work well, or you've tried to use Safari on Mac and then they tell you got to use Microsoft Edge or Internet Explorer or something like that. Not Internet Explorer these days, but there were lots of applications that were written that would only work in one browser because they never tested or decoded it appropriately. You might want to use it for regression testing, which is a type of QA testing, to ensure that new code changes don't introduce new issues. You can make sure that it maintains the stability of the applications people will be using. You can use this for beta type testing. Test it on these real virtual devices and then give it to people physically to test it on their physical devices. So how might you use Device Farm? Well, you basically set it up by going to the management console, navigating to Device Farm, and creating a new project. Of course, you'll name your project and configure its initial settings. You'll then upload your application, and Device Farm will help you analyze the app and prepare it for testing. Then you'll create your test suite, and that's going to, in there, you'll choose from a variety of tests. There'll be lots of tests, for example, and you can introduce built-in or custom script-based tests, and you configure your test suite to match your testing requirement. Then you'll select your devices. You want Apple devices, you want Android devices, and then you run your test. Now, you can do what's called parallel testing here, and often you're going to want to from a best practice perspective. So run your test on lots of stuff at the same time. Reduces your testing time. From a best practice perspective, create custom device rules. So Focus your most of your testing efforts on the systems you use the most. I've got a friend that's got an iPhone 5 still. If I'm writing code, I'm not going to do a lot of tests on an iPhone 5, even though it's an antique at this point, and my friend likes it just because they like it. We're going to test it on stuff that's actually modern, that the preponderance of our users are on, which, let's face it, if it's desktops, the preponderance of our users are on Windows, because the business applications that people use don't typically run well on other operating systems because they're not built for it. And that's why most business applications and businesses run on Windows. Servers, by comparison, most run on Linux because most server-based applications are hosted on Linux. So it's not that one's better than the other. You've got to use the right tool for the job. But if you've got 3% of your users that are Linux users and 97% of users are Windows users, you spend the majority of your testing time on the Windows users. Same thing here. You look at your most relevant devices and you push most of your testing time there. From a best practice perspective, definitely integrate it with your CI/CD thing. So whether you're using CI/CD tools like Jenkins or CircleCL or AWS Code Pipeline, make sure you integrate it there. Analyze the testing report. So when you test stuff, and you should test stuff all the time, make sure that you have good test reports. Log your tests. When it comes to testing, your testing scripts have a lot to do with how efficient your tests are. So make sure your tests are efficient, reliable, and provide meaningful results. All right, so we cover that application perspective. And let's talk about Amazon Proton. So at the end of the day, Amazon Proton is going to be a managed application delivery service for developers and DevOps team to help automate and manage infrastructure and infrastructure provisioning. So it enables the developers to define a version at a time and distribute their infrastructure templates. And that way they can have a templated infrastructure as code type standardized approach for their applications to be deployed. Proton supports what's called template management. So you define the infrastructure as code using an AWS CloudFormation template. It gives you nice version control and good updates and rollbacks. And that's going to support both environment and service templates. It helps with automated provisioning because it's infrastructure as code. So, let's call a spade a spade. Proton also tends to integrate nicely with CI/CD pipelines like AWS Code Pipeline, Jenkins, or GitLab, the more tools which are more multi-cloud kind of environments. It helps with monitoring and notification. It integrates well into CloudWatch, and it supports SNS notifications. So you can run this thing, you get CloudWatch events and logs, and you can get little push messages as necessary or text messages to tell you that something is going on. And it can help support security and compliance because it'll enforce security best practices through the predefined templates. And that makes it very easy to provide some role-based access control, like systems administrators can access this versus sales reps can access this. So how do you use Amazon Proton? Very easily. You define the template. You define the infrastructure configuration parameters and your deployment scripts. You publish templates to the Proton service catalog. Basically speaking, you upload your templates there, and then you use version templates to make sure that you manage your updates in a single place. You create the environments and your services. So you go to that management console or CLI or software development kit, and you create the environments and the services based upon your published templates. You'll configure any parameters specific to your application's unique needs. And then you deploy your applications. And Proton will provision them for you in an automated manner. And you can monitor the deployment status and through the logs on the Proton dashboard. And like anything else, there's a life cycle to this, right? So we'll use Proton to update it, scale it, and manage throughout the life cycle of our applications. And if we've got a bad one, bad code, we push it out and we roll it back. So let's talk about best practices. Design modular and reusable templates. If they're modular, One of the reasons people use microservices, for example, is they might have a service that's going to be redeployed in 50 different applications. And that's where microservices helps. And that makes it easy. We've already got this stuff, this stuff, this stuff, and this stuff, and this stuff pre-made. Now for this microservice application, we only need these things. Now, obviously, in microservices, if we don't have a lot of reuse of our services, it creates unnecessary complexity and no benefit. But if we're Google and we've got lots of applications and so many of them need this module, this module, and this module, it saves a lot of time, effort, and money. So it's all about the right tool for the right job. But going back to here, it's the same thing. We create our modular templates. And why am I drawing all these connections for you? I want you to understand when you got fundamentals are good and you understand it, it's the same thing everywhere. So hope that helps. Now we're going to create these templates and any kind of infrastructure as code. Add your security here. Implement the principle of least privilege using IAM roles and policies. Use strong encryption. And then implement monitoring and logging. And we'll talk about, because you want to make sure you know what's going on. And, monitor your costs. They'll tell you through a Cost Explorer. I'm going to tell you, if you've got anything on the cloud, you need a FinOps team to truly look and see what's working and what's not working. And then we'll get into Amazon X-Ray. And, Yassine, you put in an incredible question in there. And I'll talk about the reality of tech versus what we think or we'd hope would occur. And that's why when we'll talk about it, when we go to the next time, we'll talk about architectural considerations of what to expect, how to expect, why to expect, and when we get these types of challenges. So I'm familiar with X-rays. I've read a lot of them in my old life in healthcare. And X-rays give me the ability to look at someone's, what do you call it? The radius. And I look at the radius or the ulna, and I can see if there's a fracture there. Makes life easy for me. So I do an X-ray. Well, Amazon has a service that's going to help developers kind of look and see what's going on wrong with their distributed applications, and it's called X-ray. So X-ray is going to provide an end-to-end review of requests that are going to travel through your application, and it's going to help you identify performance bottlenecks and troubleshoot effectively, just like a medical professional might use an X-ray. And X-ray will look at API requests. It will enable developers to analyze and debug their applications. It's going to give them a full picture of the requests and the way they actually occur. How does X-ray work? It basically collects data from the application and services and then aggregates that data into a form that's traceable for each application and service. So it'll create what you could call a service map, which is really just a visual representation that you can use to trace, debug, or troubleshoot each device. And the users can then fully drill down on each service to see the real root cause. So why would companies use this? What are some key features here? It's distributed tracing. So we've got a monolithic application. It's very easy to see where it's at. We know where it's at. It's simple. When we've got some of these applications that are little bits and pieces in multiple data centers, multiple clouds, it gets more complex. Microservices are a lot more complex than monoliths. And sometimes it's worth it, and sometimes it's the worst decision ever. But it's based upon the business needs. So we've got these complicated distributed systems. We need a way to look at it, and X-ray is a good tool that we can use. It's got a feature called service maps. And what you can do is you can generate these service maps that's going to show the relationships and dependencies between your application components. This thing, which is connected to this thing, which needs this thing, and this thing. And you can also look at your applications and you can see where you might have performance bottlenecks. And it's a very useful tool for this. It's also helpful for anomaly detection. So like an X-ray, it'll help detect anomalies and maybe your application's performance. You can set up alerts for extra latency, too much latency, or error rates somewhere along the place. And you can get some good insights. So how do you set this stuff up? Well, basically use the X-ray software development kits, and you use it to instrument your application code. And this works with a lot of languages like Java, Python, Node.js, .NET, Go, Ruby. And of course, you can integrate X-Ray with things like Lambda, API gateways, even like Elastic Container Service by turning on X-Ray tracing in the configurations. So then you deploy the X-Ray daemon. And typically speaking, on a virtual machine or a system, you have something called a daemon. And it's kind of this lightweight thing that runs in the background that collects data or does something. So you deploy that daemon on your systems. If it's a Lambda function, it's going to be automatically managed by AWS. But if it's on a virtual machine or something, you'll have to deploy the daemon. You'll enable X-Ray in your application, meaning tell the application, send information to the Amazon X-Ray service. And we will use that to create segments, subsegments, and annotations inside of your application code. And then we will analyze the data. We'll look at the X-Ray console and the management console. What are we seeing? What do these traces look like? What insights do we see? And we'll use trace analytics and filtering features to search for what we want. Let's talk about some best practices with regards to Amazon X-Ray. Instrument it thoroughly. So make sure that any key critical path in your application is going to be instrumented with X-Ray because you want to get a comprehensive view of performance. Instrument both synchronous and asynchronous components to capture a complete flow of requests. Add annotations, add metadata. And you're going to do this because you're looking for certain things. And make sure you have as much information to provide business contact information. So when you look at your traces, you're going to know something. This will help you filter and analyze systems much more efficiently. If you're going to use X-rays, monitor and alert. So set up monitoring alerts. So you see an anomaly in latency. You need to know about it. You see lots of error rates on an API. You want to know about it so you fix it. So set up CloudWatch alarms so you can be notified of any kind of potential issues that are detected by X-rays. Really tune your performance and optimize it. So you want to make sure that the insights provided by X-ray will help identify and optimize performance bottlenecks in the application. And we're going to focus on high latency segments with error rates, for example. So the next one's going to be an odd one, but I'm going to talk about it, and it's called Amazon Pinpoint. Now, Amazon Pinpoint is going to be a flexible marketing communication service provided by Amazon. So lots of time businesses have an email list. And you see an enterprise and they may have millions of clients on their email list. And they need software to push it because you can't manually have one person going email to 10 million people. I mean, it would be fun, but it just doesn't scale. So there's lots of tools that are out there. There's major packages that are out there in the marketing world. There's lots of companies that do this. But Amazon threw their hat in the ring to have something that can provide email, SMS, push notifications, voice message systems, what have you. So it's used to send targeted email campaigns. Business will have multiple email lists. These people want security, so you send them security information. These people are interested in fitness information, so you send them fitness things. So this supports it like any of the many other industry players which own this space. But this is an Amazon tool that does it. Can deliver SMS messages for marketing campaigns or notifications. Can send push messages to your mobile phone. And isn't she cute? That's my little cat, Cindy. She's that's my little baby girl. But neither here nor there. I like my cat too much. But you can even send voice messages to customers. Now, one of the key with marketing, anytime you market, is you have a segmented market share. Because not all customers are interested in the same things. For example, sending my wife outdoors person information about big packs that you might carry and how to drink, water using a special straw that filters it out of the lake so you don't have to boil your water. That would not be interesting to her. Prior to my foot injury, I would be great to me, and I would go buy lots of packs and, life straws and MREs to keep around the house in case there's a hurricane and there's no power, because that's me. But, they send me what I'm interested in, send my wife what she's interested in, which is usually shoes or something related to shoes or medicine things, because she's incredible at cardiology and internal medicine. So this enables campaign management, so a business can design and schedule their campaign message across different channels. They can have a trigger, sign up, get this download like you can any other commercial email package. It can enable you to personalize messages. So instead of saying, hi, you, it could be, hi, Mike, in the messages like any other good marketing software package could do. And just like any of the many, many commercial email and SMS software packages out there, it can provide analytics and reporting. So you can track, marketing campaigns with delivery rates, open rates, click rates, what have you. And it can also have something, it's got a feature called the Journey Builder. So lots of email campaigns can say step 1, step 2, step 3, or a user does something and that's how you send them information. So very common email package. Again, like other email packages, you can set up A/B testing to push 2 different emails or messages to see which one customers like more. It works with event-driven messaging. So user signs up for something, you can do it. Or how often do you go to a store and you're looking at something, maybe a backpack, an orthopedic one that's not hard on your back that you like to keep around the house, and you put it in the cart and you don't buy it. And then you get an email. You've got a message left in your cart. That's event-driven messaging. So how do you use Amazon Pinpoint? Well, basically you create a project. You define the segments, meaning like this segment, this segment, this segment, customer-focused segments. You define your marketing campaigns and you set them up. Then you send messages. And then you look at it. Okay, we sent out 1 million emails and 1% of the people opened them. Okay, maybe there was something wrong with the subject line. Let's do something else before we send it again. And then you optimize, and you optimize. Tyrone, let's take a break for a few minutes, see if anybody has any questions. And there were a couple of things in there which were really great questions that I thought we should address. Wait, I'm on the wrong window. While we wait for the questions to come in, to remind everybody, we've got free labs free to do, lots of them, over 40 of them. My team will pop the link to those in the description of the videos as well as the chat box. Tomorrow, we have a free webinar in the morning. We're going to talk about how to get your first cloud architect job. What are those skills that you need to learn? How to bypass those HR people that auto reject you? How to go straight to the hiring manager? The certifications that are going to make your portfolio look good and more. And it's free. And it'll be on Zoom, so you can ask us any questions about starting your career. You want an interview from us, we'll give you a little mini interview, see where you're at. So join us tomorrow, and it's free. And if you're having a good time, like the video. Can I explain who should build an SDLC at an organization? So I want to make sure that I know what you mean by SDLC, because there's a lot of acronyms that mean SDLC. You might be talking about a software development lifecycle. So I'm going to work on that, but you might need something more because there's lots of SDLCs out there. So the key with the software development lifecycle is it's a team. And it's going to take a team of people to really create this stuff. And I am not a software developer by any stretch because I'm an architect. But let's typically go what goes into the cycle. We're typically going to have a project manager. And they're going to be the people that say, Joey, you got your code? Billy Bob, you got your code? Sally, did you write the documentation on this code? Mehdi, where's your code? So there's that kind of thing. So you'll also typically have the software architects, and they're going to be the people that design the application. So they're going to be with people, they're your application architect. They're going to talk to the business owners like the C-suite. They're going to ask about the goals of the business. They're going to ask about the business processes. They're going to evaluate the current applications and see what applications are going to be necessary to get that business to their goals. Architects don't code. Architects don't touch the technology. So, but they build the plan. Part of that team, you'll have your software developers. These are the people that write the code. They're your software engineers. And they'll be writing the code. And then you're going to have a QA team. And the QA team or the quality control team or quality assurance team, their job is to try to break your stuff. So in good organizations, you've got really strong QA policies. Many organizations have very weak QA policies. You may see a lot of developers on Google that say, on LinkedIn, just push your code, and if it doesn't work, you can test it later. Well, they terrify architects like me, but you see it all the time. So your QA engineers are the people that'll break it. You might want to test routing code on a virtual router. So an organization may launch 10,000 virtual routers in the cloud. And then they may use traffic generators to try to break it, for example, or try to see, push something to try to destroy a web app to see how far it goes. That's your QA engineers. Then you're typically going to have your DevOps engineers. And they're going to typically help, that with the operations side of this, manage the deployment and the integration of the system. And of course, you're going to have your stakeholders. Stakeholders are going to be the business executives. They're going to be the managers of the departments. They're going to be managers of various business units. And your architects are going to be spending a lot of time managing those stakeholders, leading those stakeholders, negotiating between those stakeholders. And that's why architects, as a general rule, are never allowed to touch the technology. They're so busy managing stakeholders, managing vendors, leading teams, making sure that the business requirements are being met. So that's typically the way that team goes. And that's a great question. And it needs to be sponsored by an executive team, because the executive team are the people that are there. What is the path to the CIO ND? And that's a really great question. So first thing I want you to understand is CIO is an architect. What do I mean by that? The chief information officer is the head person that sets the strategy on aligning the IT systems with the organization's business needs. So it is an architectural role. Now, because the CIO is the chief architect, and sometimes they're an enterprise architect that's called the CIO or CTO as well, we have to understand that they need a lot of executive skills. They need to be able to understand the business. They need to understand the business processes. They need to understand how that business needs to operate, the business goals, the business future. They need to understand all the way that organization connects to other people. They've got to manage the team. They've got to hire the people. And that chief information officer is going to have to manage the people or have the people working for them. So chief information officer is going to have a lot of things that they need to do. So it's mostly an executive. So how do people end up as CIOs? Typically, and not always, they've got a business degree, because this is a business role. And I make it clear there are no certifications for executive roles. Quite frankly, there's almost no certifications for architects, but for that same reason, these are executive roles. There's certifications architects get, but they're completely unrelated to architects. They're related to different things. And we could talk about that at this webinar tomorrow. So there's that. So I could see going from a cloud architect to an enterprise architect to a CIO. I could also see taking a business person that's been a sales executive, and I've seen it for a vendor like Cisco, that all of a sudden is hired as a chief information officer. I've seen people that were IT directors and VPs of IT that are pushed into the chief information officer role. And I've honestly seen some very good non-technology professionals that moved into chief information officer roles and chief technology officer roles, where they basically were really good executives. And they built a team of highly strategic architects that focused on the technology design into them. And then underneath them, they had really good teams of engineers. So the key to this is business acumen. The more business you know, the greater you're there. And that's why when we train architects, we put so much business acumen into the training, because you can't be an architect without the business acumen. And the architecture is a transition role to the CIO role, the CTO role, a VP role. It's a great role, but that's typically the path. Now, could we get someone from engineering in the CIO role? We could. Here's what they would need to do. They would need to go from techie to non-techie. They would need to learn how to communicate like a leader, sell a vision, lead large teams, have lots of business acumen and executive presence. And typically speaking, when I've worked with people that come from a tech background, it's kind of like one of those movies where you do a makeover. You get the person out of their t-shirts or their golf shirts into an Armani suit or a Canali suit, put new shoes on them. You teach them a new walk. You teach them a new way to communicate, a new way to present. You work on getting the person perfectly polished white teeth. You work on that person and their social graces and coach them on leadership and development and sales and the ability to exercise influence. And that's honestly how you get into any of these roles. But great role. It is an architect role. And that's why architecture careers are so good for feeding the C-suite. Good question. What is the best antivirus to use in an AWS environment? So I'm going to first answer that question. There is never the best technology. Never. And the second you think there's a best technology, that's when all of your situations are going to fail. We have to understand the business use case. There are times when Trend Micro has the best solution in the world. There are times where McAfee or Symantec have the best product in the world. And there are times where others do as well. So we have to determine what the needs are because not every product performs the same way. So even though they're antiviruses, they all do different functionality. Which is better, a Lamborghini or a Ferrari? Well, I don't know. Which is better, a Mercedes SUV or a like a GLE 350, for example, or a Porsche SUV? Well, what's your goal? The Porsche probably performs a little better. The Mercedes will go 500,000 miles. What's your definition of better? I don't know. It's different than you need. You might use a certain kind of car to create a limo out of it. You might use a different kind of car for something else. So in every single time you will pick a technology, you will have to look at your environment. You will look at the strengths and weaknesses of each and every application. And in your environment, because you may have one application that doesn't work well with any of these things. You really need to figure it out. It all goes back into the same way you would train a doctor. And I learned architecture when I learned medicine. There's never a best pill. Like, I don't have a favorite pill when I see patients, and occasionally do as a volunteer. I ask them their condition, and when I know their diagnosis and their allergies and any other conditions, for example, this drug may raise somebody's blood pressure, so I can't give it if someone's got high blood pressure, but it could be the best drug at treating it in people with low blood pressure by comparison. So this is all about judgment. What's the goals? What are my opportunities? What are the strengths and weaknesses of each opportunity? And when am I there? So there's that. Other thing that I would caution you, there's no such thing as just an AWS environment. 98% of organizations are multi-cloud. So it's going to be more which works with your clients in their enterprise environment. If you can think about that and always focused on the goal. So here's how you innovate. You look at the end goal and then you work backwards with the tools. You want to build a house. You've determined the house needs to have 6 bedrooms, 4 bathrooms, and 3,700 square feet. You've also determined that you need to build it. Okay, so where I live, they need to make that house out of cinder blocks that are filled with steel and cement, and that's how you build the outside. Why? Because I live in an area where there's hurricanes. Now, to build a house like where I would live costs a lot more than to build it in another place that doesn't get a hurricane. Is the building style that I have in my approach better? No. It's better for Florida. But it might not be as good in New Jersey or Pennsylvania or Kansas. So it's all about choosing the right choices. Hope that makes sense. In the case where there's a new manufacturing company started, is it advisable to present an architecture for their IT infrastructure and operations, or should you wait to be called for? Well, you can't be somebody's doctor unless they ask you. So if you're starting a business, what are the goals of that business? What are the business processes for that business? How do they want to manufacture what they want? Do they have robots? Are they using AI? Is labor cheap where they're at? And they're going to use a lot of labor. What kind of tooling are they going to have? Are they going to do it via an assembly line where each person does one part? Or do they have one person doing the manufacturing process from start to finish? That needs to happen first. When you know that, then you can figure out what you need to do. Just like if you had to hang a picture on the wall, you'd first look at the weight of the picture. Then you would look at what your wall's made out of. Then you would look at what tools are necessary to hang that picture on the wall. Do you need some kind of thing that needs to go into the wall and expand out because it's heavy? If so, you would use it. What if the wall has wooden studs that you could drill directly into that? Then you wouldn't use it. So it's always going to be evaluate the business, evaluate the business, evaluate the business, evaluate the business processes, and then go in there. Because you can't design an architecture for a business that you don't understand how the business is going to run. I mean, you could, but 7 out of 10 times your architecture won't work. Because if I had 3 patients that came to me, I'm going to say Tyrone and Alonzo both came to me. And they both have the same haircut, right? So I say, you both have the same haircut, therefore you're going to get the same antibiotic. But what if Tyrone's allergic to one and Alonzo is not? That wouldn't work. So I'd bring Alonzo and Tyrone into the office. I would do 2 separate visits. I'd ask them what's going on. I'd go through their complete medical history, their diet, their this, their lifestyle, and I'd make 2 different recommendations. So that's what we're dealing with here. I really think if you come into the tomorrow's free architecture webinar, it's going to help you so much. And even if your goal is engineering, and your goal might be to become a distinguished engineer or a principal engineer, I think it'll be good for you to come to that free webinar too. Tyrone, pop in that free webinar, and we'll get back to some more AWS services. But I want to know you're awake, so if you're having a good time, hit the like button, subscribe to the channel, hit the bell to be notified of new videos. Give me a hashtag, like hashtag AWS SAA. And then we will get back to the content. So I know you're awake, alert, and oriented. And I hope you're having fun. I love teaching. So let's talk about AWS Elastic Transcoder. So if the word elastic isn't there, it's probably an AWS thing. So the AWS Elastic Transcoder is going to be a cloud-based media transcoding device. It's designed to be a scalable way to take one form of video and transcode it into another form. So if you think about it, if you've ever worked with raw or uncompressed video, and I do all the time because I love making high quality videos. And if, for example, if I shoot an 8K video of my cat Cindy, yes, I like my cat Cindy just a wee bit too much, but I like my cat Cindy. That file of my cat video, and I'm not joking, could be 50 or 100 gigs for 30 seconds of video. Now, that's not going to work for web-based streaming, because nobody's going to download a 30 gig video for 30 seconds of film time. But when in the studios, that's the level they film at. That kind of detail, and then they convert it to what they need. And that way they can zoom around and zoom in and zoom out and change angles. It's really cool stuff. Always found photography and videography interesting. So, and any kind of telescope thing too. So transcoder is going to be a system that lets you take that raw video and encode it to another form. Maybe encode it to 720p or 1080p in an MP4 file. Maybe use what's called an H.265 codec. It's a relatively new compression algorithm for video that gives you double the resolution at the same size that you might, or double the detail than you might get in a previously at the same size file. So that's what we're talking about. Now, where do you normally transcode video? On your workstation or on a video server. So that's why you typically see video editors with very powerful workstations with 1 or 2 graphics processors in there. And they typically have a big CPU, like an Intel Threadripper with like 32 or 64 cores and 256 gigs of RAM. And they can do this stuff all day long in their sleep. And they buy that Systems One, even if it's $7,000 for the system. They push that system for 3 or 4 years, and it's done. But if you had people that were trying to work off little mini laptops, this encoding process might be kind of challenging. So instead of doing it yourself on your local machines or servers, you could send it to AWS and pay them to do the transcoding for you. So basically, it's a web service for transcoding, and you can basically give it a preset profile, optimized for iPad, optimized for iPhone, optimized for an Android phone, optimized for a PC, and that way you can come up with various formats of your video. And because it's a cloud managed service, it's going to scale based on whatever your video files are. And it's going to give you, because it's got some built in redundancy, some high availability and reliability. So it basically, how's it going to work? It's going to integrate with S3. And you'll store your stuff in S3. It'll take it from one thing, tune it, change it, and then restore it on S3. And it works with lots of formats like MP4 or HLS type videos. It will also give you some metadata about the video and generate a thumbnail for the transcoded files. It'll support encryption and digital rights management of your systems. And where might you use it? So you've got a media and you want it to play back on a lot of devices, smartphones, tablets, PCs. You want to optimize the quality and the file size that you're sending. You might do it for streaming videos. You might take a very high resolution movie and then push it to something that you could stream on, say, a Netflix or a Prime. You could potentially use it for video editing. So you could take a big file and turn it into a small file if you wanted. You could put some kind of watermarks in there or thumbnail generation, which could help you from a video processing perspective. Quite good from a storage and archival purpose, because you can take your storage files, which are huge, and then maybe convert them into something smaller that's going to be cheaper to store. So for the most part, how's this set up? Well, you basically set up your input and output buckets in object storage. So you go to S3, here's my input, here's my output. You do want to make sure that those buckets are in the same AWS region as the pipeline that you set up. Then you create your transcoding pipeline. So you go to the management console, you navigate to Elastic Transcoder, and you create a new pipeline. You can specify the input bucket and the output bucket where your files are going to be placed, or technically objects once they're in S3. Then you configure your transcoding job. So here's your input. What do you want it to be converted into? MP4, for example? And what kind of device? Then you submit the jobs, and then you monitor them like with the management console or the API or the software development kit. So let's talk about some best practices to use with Elastic Transcoder. You really want to optimize your presets for your target devices. So what does that mean? You need to know what kind of target devices are going here. Are you sensing a theme? Learn before you do. What is the use? How will it be used? Why will it be used? Then make a decision. Manage your storage efficiently. So storage gets very expensive on the cloud. Very expensive, very fast. So you're going to make sure you use some kind of a good life cycle policy. So maybe take it, keep it where it's at, then move it to, say, an S3 and frequent access, and then maybe move it to Glacier when you don't think you're going to use it again, so you don't spend a fortune on storage. You really want to monitor these things. You want to monitor your transcoding performance and adjust the pipeline as to settings anytime you need. Set up some good CloudWatch metrics and alarms so you can track the status of your jobs and the resource utilization you have. And then once you've got it done, and secure your media. So these could be important videos to you. So encrypt them and make sure your media content is secure. And of course, secure that object storage S3 buckets with encryption. So I'm going to talk about VMware Cloud on AWS. And whether it's a VMware Cloud on AWS, or it's Nutanix on AWS, or OpenStack on AWS, some of these services are awesome. So VMware on AWS is an infrastructure as a service solution. And it basically gives you a software-defined data center. So picture this. the majority of the data centers out there are running VMware. And VMware is really like a cloud software. I see Mark Trimble's in that chat box. He is an expert on VMware. But here's the thing, and I showed you one of our VMware servers where we created virtual machines. So the enterprise is running on this. So now the enterprise has servers in their data center, which is the lowest cost environment, typically speaking, the data center versus the cloud. They've got a team of people that know how to use VMware. They know how to set up the systems on VMware, and everything's running smooth. And then the organization says, well, yeah, the scalability of the public cloud is awesome. What if we were to push some of our stuff when needed on AWS and some of our stuff when needed on Azure? Now you'd think about it and say, well, now I got to train my users on AWS and I got to train my users on Azure, right? Well, not necessarily. What if on AWS and Azure, you could get access to a bare metal server, the same servers that you would buy in your data center? And you stuck the same VMware on those servers and didn't use the AWS hypervisor, the Nitro hypervisor. And then all of a sudden, you got all these servers on multiple clouds that are speaking to your VMware infrastructure. You want to set up a virtual machine and poof, it's on AWS with using the same commands, the same everything that your team has been using for the last 19 years. That is VMware on AWS. It enables you to use the AWS network, leverage AWS services, be able to get that virtual machine scalability on demand anytime you need it, and not have to learn the AWS cloud because you're using the VMware system and they're just going to be there. So it'll use the same servers. You'll have access to vSphere, VMware Virtual Ascend, VMware NSX for virtualization technologies, and it's in the data center and the cloud with basically no training of your users. And understand, most data centers are VMware. And if they're not, they're typically running some cloud software like Nutanix, which is awesome, or OpenStack, which is also awesome. And this is where you take your data center, you install cloud software, and now you get everything in your data center that you would in the public cloud, like the ability to create a function as a service for serverless computing, the ability to auto scale out, assuming you've got the capacity in your system. So it offers a quick, easy solution for people that are used to it. So you're basically just getting you're getting bare metal systems from AWS. So very simple migration, very rapid disaster recovery, flexible dev test environments. You've got your VMware environment for your data center. You need to spin up 1,000 virtual machines, do it in the cloud real easily with capacity that you don't have. Test it all, move it back to your data center. Simple and elegant. So now we're going to talk about a tool called AWS App Discovery. An app discovery is a discovery tool that's going to help applications migrate and optimize their on-premise applications to AWS. This service is going to reel data about and potentially help with a virtual business case creation, but it's going to help an organization think about the cost of operating in the cloud versus on-prem, the cost of migrating to the cloud, the cost of leaving the current infrastructure, the benefits in the cloud, and the cost of doing nothing. And it's only going to be as good as the information it has access to. So for organizations that are thinking about moving to the cloud, it's going to help, guide from an automated tech perspective. No, it's going to guide from an automated tech perspective. How many businesses do you think make their decisions from an automated tech assessment? How many sophisticated businesses? You think Jamie Dimon invests $1 billion in something because some tech thing says to do so? No. But I'm sure the JP Morgan Chase Bank has lots of tools, and their executives and professionals can look at those tools, and together the people that have the wisdom and the judgment and the knowledge will look at what they see, and they'll look at these tools to make recommendations to a Jamie Dimon. I picked him because he runs a very successful bank. But in reality, nobody's going to use just a tool like this and try to believe it out of this, because it's going to give you valuable information, but it's not going to be enough without the wisdom and judgment to really think things through. But it will collect information like the CPUs and servers you're using, the disk space and performance and network utilization in the data center. And it can use this data to basically help analyze and make good recommendations. So it's a good tool. The question is to know when to completely trust the tool versus using the tool. And that's the area where we architects do our job. So App Discovery will collect information and it will make recommendations on what it will think will give you a lower cost of ownership. So a little more about the migration service. It kind of simplifies the migration. It accelerates the migration because it gives you stuff that you can think of. It makes it very easy to do a lift and shift migration because basically what it does is replicates the entire server, their operating systems, applications, and data to AWS, which means you don't have to modify your systems because it does it for you. Of course, you can manually take your systems and convert your virtual machine into an AWS, Azure, or Google format and controlled tested environment. Application Migration Service does continuous data replication. So it constantly replicates the data from your source server to AWS, which is awesome, especially if you're in two places. And it's going to make it easier to migrate with reduced downtime. It provides automated tools to cut over and test, meaning here's a tool. We tested it all, just move it. If you think a business is going to use one service like this and trust that it's going to move their $1 billion of infrastructure without lots of tests, I've got swampland. That's rare that I could sell you, but keep that in the back of your mind. It's useful. It helps. But big businesses are going to need lots of testing other than automated tests. Automated tests will miss big issues. I think we've seen some big issues quite recently. And it supports a lot of applications because what it's really doing is copying a virtual machine over to the cloud. So the application migration service is a very user-friendly environment. Gives you a console and API that really simplifies moving systems over. Now let's talk about another migration service called the AWS Data Migration Service. And that's a managed service to move your databases over to Amazon. So it can support what's called a homogeneous migration from Oracle to Oracle, or a heterogeneous migration from, say, Oracle to Amazon Aurora. Or you could just launch a new database in AWS and copy your data over and make sure that your data is exactly the way you want it. But it supports database migrations from like on-premise service, Amazon databases. It continually replicates your data moving from point A to point B. And it makes sure that your target database is synchronized with your source database. It helps convert your schema. So you may have a schema that's associated with one database, and you want to move it to another database, and you're going to need to tune and configure your schema. It helps reduce the downtime and minimizes downtime between point A and point B because it's going to give you a tool to copy your systems over. It typically will help transform your data, at least basic data transformations. If you need bigger data transformations, there's ETL tools and things that can do that. And it gives you a report and monitors your systems. Okay, so we're going to briefly talk about cost management. And really, cost management is based upon your architectural choices. Meaning, if I've got a system that runs 24 hours a day that needs high performance compute, for example, a server with 256 physical cores and 6 terabytes of DRAM, it may be millions of dollars less to stick that server in my data center than it is the cloud. Over the life of that server, millions less. But at the same time, what about applications that typically run at very low utilization all year that have huge spikes around periodic times of the year? The cloud is typically much cheaper for that. And the reason it's much cheaper for that is on the cloud, you can size for what you need on average or aggregate, and you can add capacity when you need it. So I might build in a global e-commerce's website to handle 1 million hits in a minute or more in the winter, like for Christmas time. And the rest of the time, it could be dealing with 100,000 hits a minute, sitting at 10%. In the cloud, I can set it up to handle 12,000 hits at all times, 2,000 more than I need, and then set up an auto-scaling policy so I can use smaller stuff all year long and then maximize it when I need it. So that's typically when you're there. Now, when you go from a data center, you've got a capital expense. And when you go to the cloud, it becomes an operational expense. Is that good? I don't know. And what I mean by I don't know is going to depend on that organization's capital structure. In many cases, a capital expense is better than an operational expense for a business. In other business, an operational expense is better than a capital expense. So this is where you're going to need to have your business acumen. You need to understand that organization's capital structure, their weighted average cost of capital and things like that. Because otherwise, you're taking shots in the dark with somebody else's money. And 70% of all cloud migrations fail. There's a reason most people don't know how to do this. That's why we teach these skills to our architects. So data centers themselves typically have high capital costs in that you've got to buy the real estate. You got to bring in a lot of power. I mean, a lot of power. You could be pulling megawatts of power into a data center. You need to buy the infrastructure, meaning you're going to be going on a Cisco or a Juniper and buying all your routers and buying all your switches. You're going to be buying big monster firewalls and load balancers. You're going to be buying racks, and the racks will have power distribution units. The data centers will have generators and battery UPS backups to the generators and power transformers. You will need servers and storage area networks. And of course, you're going to need to cool the systems down, which means big, beefy air conditioners. And I mean air conditioners like you can't even imagine. And these things consume a lot of power. So that's a capital expense. Now, don't think for a second that a data center has to write a check for all this stuff. They can finance it, and many do. And when you compare the financing cost to run the data center, it could be cheaper than the ongoing operational expenditure costs on the cloud. A company can also create an operational expense out of their data center tech by leasing it versus buying it. So, don't just take that certification approach. Oh, it takes you from a capital expense to operational expense and think that's good and try to tell a client that. Because you'll be escorted out of the room by security fairly quickly. So you don't want to do that. So in the data center, we typically have a lot of capital. But we still have some operational expenses. And what are they? The staff for the data center, the people to manage the physical plant, the AC systems, the generators, the backup generators, the batteries, the people that are going to run to the servers and swap out hard drives for you when stuff breaks. We will need the network engineers to make sure the network's doing their thing, the security engineers to make sure the stuff's there. We also will have to pay for our wide area network connections, meaning the cables or virtual cables that we have between our locations. So most of our costs are for equipment, but other costs are for the ongoing operation. Now, in the cloud, everything changes. There's almost nothing to purchase. Almost. But you're going to pay rent on the cloud, and it is going to be expensive. To give you a cost to put it in perspective, AWS has these i3 instances. They're basically Xeon E5 2670 somethings V3s. To pull out 128 gigs of RAM on one of those things and all 48 virtual cores, it's about $1,000 a month. So to use one of those virtual machines for 4 years would be $48,000. Now you can go to Amazon right now and you can buy a server with that capacity for about $500. That same server. And you can run that server for 4 years straight for $500 plus another $150 in electric, so $650 versus $48,000 in the cloud. But do you need that server? Is that the right server for the business? How many people need to manage that server? Not a heck of a lot, especially if it's VMware. But the point is you're always going to have to do these calculations. You're going to find out that the cloud is usually more expensive. But you're going to find out that the agility of the cloud ooh, a business has this thing and we can change this on a dime in a day or a week versus months. That's worth a lot. And that can be a very strong competitive advantage on an organization. So you got to be able to look at the organization and see if that agility is worth it to them. A big blue chip company isn't going to be very agile because they're big and it's hard to get, hundreds of thousands of people to change direction fairly quickly. A little tiny company is going to be highly agile, at least if the tech supports it. Oh, wow, we see a new tool. Poof, we used it. 6 months, 60 days later, there's an impact on their revenue. So we have to think about that. What's the goal? What's the business goal? What's the business need? This is not about the tech. This is about the business. But in the cloud, we have to know that things are going to be very expensive to run. And it has to be because they have to buy the same systems you do. Then they've got to run the same systems the same way you do. Now they need to hire people to sell it, people to market it, and you're dealing with tens of billions of dollars of cost to just sell these things or more for these teams. So you can start to see why cloud computing may get more money, but we have to manage those costs and we have to choose it. Choosing the right platforms, architecting our things intelligently, running them on the right systems, moving what we should move and not moving what we shouldn't move. So step one is determining if we should move it or not. Step two is only provision things that we need on the cloud because we pay for everything. And then we've got to monitor our systems. AWS monitor their systems and when, oh, wait, we're paying 9 times too much by using microservices for Prime than we are with a monolith. They got off of microservices, they got off of serverless, and they went onto a monolith. Because they looked at it, they didn't plan it right, they made a decision to use it, they realized it cost too much, and they went off of it. So imagine how much less it would have cost to design it right in the first place. But, you can't always predict what your needs are. So you could do it right and find out that it's wrong, which means you didn't do it right, and then you might need to change. So provision what you need and monitor those systems and update accordingly. Next, properly size your resources. When you build your own computer for your house, you could be cuckoo like me and say, I'm going to build it so no matter what happens, I'll have enough capacity because I've always been in situations where you run out of capacity. So my workstation may have 64 cores in it and 512 gigs of RAM. And to be fair, an NVMe RAID array that's got 16 terabytes connected to a 96 terabyte external RAID array. Because I don't want to run out of tech. But it's me, and I like having cool tech at home, and I know I will push the tech, so I overbuild for me. Now, you can imagine my workstation probably costs a lot more than it needs to. So if I was designing a system for a business, I'd look at what kind of business they are. If they're a business that says, Mike, I need to have so much performance and capacity because 1 millisecond of latency is worth $100 million a year to us, I'd be like, okay, we're going to overbuild you to reduce your latency. And maybe overbuilding costs $30 million, but they get $100 million extra, which makes it worth it. For normal businesses, properly size your resources, which means size them for average use, not peak use, and leverage auto-scaling. It also means we can do things like decouple when appropriate. Remember when I talked about databases and I talked about putting a queue so we could use smaller, less costly database servers, pop a message in the queue, keep it in the queue until we're ready. That can reduce costs, sometimes decoupling. So decoupling the architecture may, if we decouple correctly, reduce costs. If we do it wrong, it could increase costs. So it's about knowing what we need. Next, it's about using the right platform and purchasing it. So if I'm a business and I know I'm going to go to the cloud and I know I need to keep my virtual machines for 3 years, reserve them, schedule them, and buy it with a discount for 3 years. If I need to run a batch job for 12 hours straight, and it can start and stop as many times as it needs, as long as it finishes in 12 hours or 14 hours or 24 hours, I might use spot instances, which are virtual machines that you bid in an auction-like environment. And if somebody chooses to bid more than you, they shut you down. because it's cheap for a batch job. If it's mission critical, I wouldn't use a spot instance ever. I'd use an on-demand instance. So you're going to use a combination of purchase what you need to know, scale out with on-demand instances, and potentially use spot instances. So think about, allocating the mix of what you do and knowing your needs, because if you know your needs, then you can purchase for long term with a discount. Step 4, think about the right platform. So sometimes it's cheaper to go serverless or managed service. Sometimes it's not. Evaluate all possible options. Next step, reduce the data transfer cost. So this can get very expensive very quickly. So with AWS, normally in a data center, you might have 2 different VLANs. Segregate your users from here to here and create a routing policy to route between them. Many businesses will create a tremendous number of VPCs and route between them. You'll find businesses that have 1,000 VPCs out there, which is great for us network architects. But in AWS, they charge you every time you go from one VPC to another. So if you decide to make your cloud almost as secure as your data center by chopping it into multiple VPCs, then you're going to be now communicating between your VPCs and you're going to be paying for the communication. You're going to pay when your systems grow across regions. You're going to pay for a lot of things that you wouldn't normally pay for. So manage those data transfer costs. Maybe you've got an S3 bucket in 2 places, and instead of having the request from, say, Europe come back to America every single time, if they're requesting the same information all the time, maybe set up cross-region replication for our S3. So you got a bucket in Europe and a bucket in the US, and the users only connect to their region, so they save on interregional transfer costs. Now, how about content delivery networks? That can help out a lot because it can offload the work from your servers. Information can be cached locally, which may reduce transfer costs. Then we have to think about our wide area network. Now, here's the way not wide area networks normally work. You buy a connection. You pay $5,000 a month for the connection, and it's done. You've got a $5,000 a month connection. Let's say it's 1 gig private line from point A to point B. You've got a gig, and you can send as much data as you want it for that $5,000 a month. Now you got a line to a cloud provider. You pay $5,000 a month for the link. Then you pay a daily fee to have the link, and then you pay to send and transfer your data in some cases over that link. So that can get pretty expensive pretty fast. Think about that. So sometimes it's cheaper. They give you a better price on direct connections than it would be a VPN. How will you know which one to use? It goes back to what your business needs are. How much data are you transferring? When are you transferring the data? What kind of latencies can you tolerate? What kind of consistency do you need in your performance? So think about that. Now, you can also create a budget. And a budget can and can't help you optimize your costs. So I'll explain what a budget is. A budget is you go to AWS and it says, alert me when I've spent more than a certain amount. So if you set it up, alert me when I've spent $1,000, and you set a trigger at 500, send you a text message that you spent 500, then send you another message when you've hit 700, 800, and 900, it did that. Now, if you still need to use your systems, it didn't make them any cheaper, but it tells you when you're going to spend a certain amount of money. Now, you can potentially set up a budget, look at that, and this thing was way too expensive. Let's try an alternative in our architecture after the fact and redesign. So I guess it can help, but it's not going to save you money on its own. So here you've got an example. You'd set up a budget, you create and manage it, and then you're going to get notified. Hey, you spent this much money. Hey, you spent this much money. Kind of like when your spouse goes to the store and buys shoes and or whatever sporting good thing they like. We all know what it is. And then you get notified that, your spouse spent this much money buying shoes at Nordstrom, for example. It didn't make it any cheaper because you got the email about it. You still paid for it, but at least you know that somebody bought shoes at Nordstrom or Saks or wherever people buy shoes. I get a lot of alerts. So the next thing that potentially can help you with cost is something called Trusted Advisor. And here is an automated service that's provided by AWS that's going to scan your infrastructure and it's going to look at your infrastructure, which is based upon your client's needs. And then it's going to compare that to AWS best practices and recommendations for a standard customer, not necessarily your customer. And then it's going to give you recommendations. Now, it is just a recommendation. A doctor writes a prescription for an anti-inflammatory for their patient. The patient's over 40 and has high blood pressure, and the pharmacist gets 10,000 screens, alert, alert, alert. You gave an anti-inflammatory for somebody with blood pressure, and it can raise their blood pressure. And the pharmacist calls the doctor and says, do you mean to do this? And the doctor says, I have no choice. And the pharmacist says, prescription filled, and ignores the alert. These kind of automated alerts are going to be automated alerts. They provide information. You evaluate that information and see if it makes sense for you. Same way a doctor would evaluate labs on a patient and lots of different things. So, or alerts out of an e-prescribing system. So Trusted Advisor is an AWS tool that's designed by AWS to theoretically cut your spending down. And it'll look and it'll say you could use it to improve performance, availability, infrastructure costs, because it's going to give you recommendations over your deviations from AWS best practices. But you may have had to deviate from AWS best practices for your architecture. So you're going to take these kind of things with a grain of salt. Good, valuable information, but you take all the information and then you evaluate it based upon your needs and then you see if it makes sense. So there's two versions of Trusted Advisor. There is AWS Basic and developer support plans where users get access to 6 security checks and 50 what's called service limits checks. And then you're going to have people on business plans or enterprise plans. So business support plans or enterprise support plans, they'll get 115 of these Trusted Advisor checks, of which 14 will be cost optimization, 17 will be security, 24 will be fault tolerance, 10 will be performance, and 50 will be something called service limits. So another tool which can theoretically potentially help reduce your costs is the Compute Optimizer. And that's a free management tool that AWS recommends to increase efficiency of their systems and reduce costs. And what Compute Optimizer does is it reviews your previous resource activity to distinguish use patterns from various use patterns, frequently or infrequently, or a stored type of data when it's accessed. It's going to look at the user's activities compared to similar activities on a resource, and it will take a comparison and give you a graphical recommendation, giving you, here's how we recommend in this automated system to tune your infrastructure. Clients are given the option to use something called the look back option to basically renew up to 3 months of history and to take that history to make gut recommendations. Compute Optimizer really enables, resource utilization, understanding to potentially help reduce your costs and improve your performance. And when a user is going to enable these suggestions, AWS will configure the resources that theoretically deliver optimal performance. Service quotas. So service quotas are going to give the users the ability to view, log, and set limits on various services. So this is going to help scale various services as workloads increase. It'll help users adjust service quota values, and they can monitor the service quotas, and they can set up limits and inform the users you're getting close to the limit. So it can be used to help control cost, optimize performance, and improve availability of resources. Now, here's a tool called the AWS Well-Architected tool. And there's a video, Tyrone, if it's easy for you to find, to pop a link between the AWS Well-Architected framework. And here's the thing. There are many architectural frameworks. An architectural framework would be, how do you approach a client for an architecture? So there's lots of them that are out there. Big companies, your big consulting companies, your biggest tech companies typically use something called TOGAF. And TOGAF is something we teach to all of our architects. And TOGAF is a standard framework. And what the TOGAF framework says, start with the customers and their executives and find out the way you want their business. Then look at their business processes, then re-architect their business processes, then look at their data architecture, then re-architect their data architecture, then look at their technology architecture and re-architect your technology architecture based upon their business goals, business needs. Set up your solutions. Here's how you build the governance structure. Here's how you build a change management. And they basically tell the architect, it doesn't provide training on architecture at all, but it tells the architect how they would approach a client in a manner to get where the client should get results from their business. So 70% of all businesses deploy technology and get no results. I'm going to say this again. 70% of all architectures provide zero benefit for the customer. And here's why. Because you got the tech people that say, we need this. And the business people say, why? And the tech people can't answer it. Or the tech people say you need it and the budget business just approves the budget. And then they spend lots of money on a tool that makes things worse, gets in the way of their business. So there are tools and frameworks like the Zachman framework or the TOGAF framework that are how you do approach a client in a manner to learn their business and design a business to get improvements. AWS and other cloud providers have a well-architected framework, and here's what they are about. How to use AWS stuff on AWS. Now, there are some good things about this because AWS is an expert on their own stuff, right? But these things are not really designed for transformation. They're designed on just making the tech work. Unfortunately, in most architectures, getting the tech to work is not a big deal. It's easy. Getting the tech to drive transformation or improve business performance, that's the real skill. So this is going to check across the well-architected tool, which is a great way to check your tech from a tech perspective. But it's going to provide no value to determine if it's going to help provide, the architecture will provide value to the business. It will provide great value if you're using AWS stuff in AWS. It gets less valuable in the multi-cloud environment where you can't use just AWS stuff and you have to use more industry standard tools. And that tends to respond better to a TOGAF framework. But there's nothing wrong with using a TOGAF framework end-to-end and taking bits and pieces of the Azure well-architected framework and the AWS well-architected framework that are more tech-specific when you design your architecture. So this well-architected tool is basically going to give you guidelines and best practices by comparing what you have compared to what AWS would put in the well-architected framework. Now, you might be doing something because you got business reasons, and this will not detect that, and it's not going to be focused on that. So please understand that. So, but it is another tool that you can use, the well-architected tool, and see if that will make recommendations that may or may not reduce your cost. And basically, you document your current state by answering a questionnaire. So all these tools are great. I don't want you to think they're not great. I don't. It's all about when you use the right tool for the right job. Tyrone, we don't have a lot more to cover, but let's take a break and see if anybody has questions. And while we're at it, if you're having a good time, hit the like button. If you're not a subscriber and desire to be, hit the subscribe and hit the bell to be notified of new videos. Any questions there, Tyrone? While I wait to see if you all have any questions, tomorrow morning from 11 to 1 Eastern Time, we will run a How to Get Your First Cloud Architect Job webinar. It'll be free. It'll be on Zoom. We'll talk about the cloud architect role, all the skills that you need, the certifications that you should have to go out there and build your profile. You can ask us questions, and it's all free. We'll teach you how to skip HR, all kinds of things that'll help you get hired. And tomorrow afternoon, because we're going to finish today shortly, we're going to allocate the time that we initially planned to answer any career questions you have. Maybe you want to go from certified to hired in engineering. Maybe you want to know how to earn more in your engineering career. Maybe you want to know how to convince the manager you need it. So those kinds of things that we do. Will tomorrow's sessions be recorded? So the webinar that we will host will be given to people that have registered for the webinar and signed up for the registration form. We typically email it to the people that attended the webinar or signed up for the webinar. We don't typically put them on YouTube, although sometimes we do. But the career question and answer session, Rao, that we will talk about will definitely be live on YouTube. Maybe I'll get in my other media studio and nice relaxed seat and answer questions. It's a bonus round, as Alonzo said. And seriously, like Alonzo said, only 43 likes. We're giving a pure AWS Solutions Architect Associate course. We're covering most of the professional, the advanced networking and security in here, or at least large components of it. If there's any other questions, great. If not, I will get into discussions on high availability. And great question. How about COBIT? COBIT is a very good security framework. And quite frankly, using a TOGAF with a COBIT is absolutely terrific. As far as OWASP, that's not a framework I've typically used in the past, so I can't comment on that. But COBIT is used in a lot of places, along with NIST and other frameworks as well for security. Would I recommend that a cloud architect should learn an architecture framework like TOGAF? Or is that more for enterprise architects? Well, I went most of my life without learning any architecture frameworks, and I was just fine. So if you already know how to do architecture, then architecture frameworks like TOGAF are great because they don't teach you architecture. So here's the thing, and here's where frameworks really come into play. So both my wife and I can practice medicine. My wife spent most of her life in internal medicine and cardiology. I started in internal medicine. And then when I retired, I had a horrible injury where I couldn't walk. So I used to volunteer because thankfully I didn't need to work. I used to volunteer practicing physical medicine and rehab. So here's the reason I'm saying this, Nigel. My wife does internal medicine. So she starts at the eyes, the ears, the nose, the mouth, the throat. Then she checks the lymph nodes. Then she listens to the carotid arteries. Then she listens to the lungs, the heart. She works her way from her head to her toe. And that's what she should do for her world. I deal with physical medicine and rehab, and most problems start with the way somebody stands or walks. So the first thing I do is check the mobility of the big toe or the hallux to make sure there's 60 degrees of dorsiflexion. Then I check the ankle. Then I check the knee. Then I check the hips. Then I check the musculature of the low back, the thoracic spine, the shoulders. And I might not look in somebody's eyes, ears, nose, or throats in the physical medicine and rehab environment. But I definitely are going to look at the orthopedics piece. And the way she starts from the head to the toes and I start from the feet, the toes to the head, there's reasons for that. And the assessment that she does on her patients is going to be different than the assessment that I do on my patients because we have a different goal. Given that 70% of all architectures, and that's McKinsey's numbers, are disasters. And the reason they're disasters is people focus on the tech instead of the business goals. And that's why architects are becoming more and more businessy and more executive-y and more enterprisey every day of the week. I think it's beneficial to know a framework. Doesn't need to be TOGAF. If you work at an Accenture, Deloitte, or a KPMG, they may have their own framework. I just care that you approach every person systematically and that you know to start with the business goals. And you do. That you know to understand the business processes. And you do. Because if you design an architecture without understanding the business processes, you could damage that business seriously. So there's that. Do I like to see a TOGAF on if I look at an architect certifications and I see an AWS Solutions Architect Professional and I see a TOGAF and I see a CISSP, for example, I know there's lots of architecture related things in the CISSP, even though it's a security related thing, but it's in an architectural kind of blueprint, at least high level architecture. And I look at the TOGAF and I say, oh, this person knows to start with the business. I'm not going to be nervous that they're going to do what they were taught in a certification, which is the name of a service, how to configure it. And here's your tech, and you need this tech without looking at the business. So as long as you're focused on improving the business, I don't care how you get there. You know, Hiring managers per se don't care about your certifications. They care about your ability to do the job, your ability to do it well, your communication skills, your leadership skills, your energy, your enthusiasm, your passion for the job, your willingness to go above and beyond, you being a team player, and how do you actually add to the team? What is it about you? But the competency piece is key. And one of the reasons I started using TOGAF was so people actually understood architecture was not engineering. Because I had people that wanted to learn to code to be an architect. And they would spend 6 months learning to code, and they'd say, Mike, I'm struggling. I'm like, yeah, we told you not to learn to code. We told you to learn this, this, and this. Now go back and do what we told you to do. And at least when people see a TOGAF, they don't think they're going to learn architecture by learning Linux or Python or SysOps or DevOps. It keeps people focused on architecture, which is designing systems to optimize business. But do I recommend cloud architects getting it? I recommend 2 to 3 certifications for an architect. And if one of them is related to an architecture framework, I tend to like it. We'll talk much more about that tomorrow in the How to Become an Architect webinar. And that's a very good question. So give me a hashtag AWS SAA, and we will get back to the content. So let's talk about designing high availability systems. And we'll talk about what does availability mean. And honestly, in a certification, we don't have the time to talk about this. I spend hundreds of hours with my architect clients, students in our cloud architect program teaching them this, but let's give you some good pointers. Availability means the system is there when you need it. So if you go to dial 911 for emergency in the US or say 999 in the UK and the phone doesn't ring, you've got a problem because the system is not available when you need it. So when it comes to availability, we typically talk about in nines: 99%, 99.9%, 99.99%, or 99.999%. Some systems need to be 99.999%. Air traffic control. Are you serious? That stuff goes down, planes start falling out of the sky and crashing into each other. That needs to be up. And a healthcare system. We need a high availability system because when those systems go down, people can die. In a bank, a minute of downtime could be $50 million lost or $100 million lost at the wrong time. So we need to keep those systems up. By comparison, one of these days, I'm going to start a My Cat Cindy website. We're going to have photos of my beautiful cat Cindy. And photos of her wearing silly things like T-shirts, photos of her eating her favorite Purr Pops and her favorite snack because she's cute and I like my cat. Now, if that website goes down for 10 minutes, so what? Nobody looks at photos of my cat Cindy. So we have to understand the business needs. To put it into context, 99.99% available is what many organizations would consider high availability. That is 52 minutes of downtime per year. That is a lot of downtime. A 99.999% available system is 5 minutes and 15 seconds of downtime. My entire life has been spent building 99.999% available systems because I've been put on the world's biggest projects. But many businesses will tolerate 4 nines, and most businesses could never get to 99.999%. And it's not going to happen on a single cloud. And whether you can get to 99.99% on a single cloud is questionable. There's been many years where the cloud providers couldn't do it no matter how many regions and availability zones you use. And there's been years where they've done just fine. So what does it take to build a high availability system? The first thing is no single points of failure. If you're only on AWS, AWS is a single point of failure. Can you build moderately high availability systems on AWS? Absolutely. Because they're a great company. They've got expertise in running their data centers, and they're real good at what they do. But, they've had their power failures, which took down the entire cloud for half a day. Azure's had their failures. Look, Google's cloud, somebody took it down with the BGP misconfiguration. Somebody at Google deleted a $240 billion hedge fund. But that's why when you put your systems in somebody else's baskets, you need more than one basket because you don't know what they're going to do. So I hope that makes sense. The next thing is power. You need redundant power. No data center that I've ever worked with, except for AWS, has ever seen a power failure. Why? You bring in two power companies into a data center. You then have different transformers. You then have backup generators, and you typically have battery powers or backup generators. So data centers don't have power outages. AWS claimed that one of its multi-hour power failures was due to a power outage, which is possible. It really is. Maybe they had a power management system, as they said, which didn't work. But again, single cloud, single point of failure. So no single points of failure. That means multiple routers connecting to the cloud provider. That means multiple links. That means backup paths in your routing protocols. That means not one server, but two servers. That means your routers aren't plugged into a single outlet, meaning like a single power distribution unit where they're good for, say, 30 amps at 240 volts. And you hit 30 amps and the circuit breaker blows and it takes down that. So multiple power outlets, multiple power distributions, multiple power circuits. It means when you get a link or a direct connection to AWS, if you need a direct connection, you have one on AT&T and maybe one on Verizon. You don't put two links on AT&T because when AT&T goes down, you go down. It means you don't have a single router connecting your AT&T and your Verizon link to the cloud. Use multiple routers. It means you leverage load balancers and multiple load balancers to load balance across multiple systems when some goes down. It means your DNS is there. It means your storage area network is using some form of RAID. It means your applications are redundant. And it also means that you don't allow Billy Bob to make a change on the system without going through a proper change control system. Because it doesn't matter how good your design is, if you allow somebody to push new code or go configure the network or change the routing during production time without assessing all the value. What happened with CrowdStrike? Somebody made a push and they pushed it out, and other high availability systems which were designed properly all went down because these organizations trusted somebody else. Now, was their architecture correct to trust somebody else? Absolutely not. Now, if they did trust somebody else, what was their backup things and how did they do that? And if they did that right, architecturally wise, it wouldn't have been such a problem. So here's why it should be easy to design high availability in AWS. They maintain redundant power until they don't, like the power failure. They maintain redundant cooling. They have redundant connections to so many different internet service providers and wide area network providers on their background. They have highly redundant routers and switches. And they know how to build a data center. So they have good practices, good change control as a rule. It's very easy for them to design a high availability system because that's their expertise and they're good at it. Now, understand their data centers may or may not be quite as high availability as other data centers if they're managed equally well. And the reason is AWS and Azure and Google and everybody else are hyperscale, which means they have to deal with a tremendous number of providers' traffic. They need to deal with a tremendous number of customers. And there's more things to go wrong in one of their data centers, and there's less security type things they can do. They can't run quality of service. They can't do certain networking things for the average user because they don't know the user's traffic. But they are experts at what they do, and they are incredible at it. So according to how to pass the exam, if you want 4 nines availability or 99.99% availability, put your stuff into availability zones. And unless AWS has a network failure, a major hacking event, or a control plane failure, you'll be quite fine. But we've seen these issues happen taking down multiple availability zones. So at minimum, use more than one availability zone or more than one data center. Now, if you need more than 99.99% availability, use another cloud. But for the exam purpose, just use 2 availability zones in 2 regions. And that'll work great unless there's a hacking event, a control plane failure, or a network failure. And then you're going to lose both regions and you're going to lose all the availability zones. So don't do that. But at least for the exam purposes, please know that. So anything that's important should be in either multiple availability zones or data centers or clouds. So virtual machines, databases, load balancers, DNS, that sort of thing. Redundant network connections. So you're going to need multiple connections. If you need 40 gigs of guaranteed bandwidth to AWS over a link aggregation group of 410 gig links on Verizon, you're going to need 410 gig links as a backup, most likely. And it could be on an NTT or a CenturyLink or an AT&T or any wide area network provider as you want. Most organizations are going to be fine with just a direct connection and a backup. We're two different internet service providers and two different VPNs, but it depends on the organization's needs. But make sure any connections to wide area network providers are on different connections, different service providers, and you're going to have to really look into the fiber optics and the copper coming into the building. There could be a conduit under the ground where an AT&T and a Verizon cable all go through. And here you think, oh, I got two different internet service providers. I got my router on AT&T and my router on Verizon, but they're in the same fiber channel under the ground, and then a backhoe dings under the ground and digs up the fiber, and you've got lose both. So when we network architects look at these things, we need to look at the fiber coming into the building, and are they under different conduits? Do they have different fiber paths? Do we have redundancy in our paths? So think about that. Now you can see why architecture isn't really things that are really covered in the certification. It's looking at every detail. And if you can imagine, you've got to look at fiber paths coming into a 500 building, and you've got to look at the IP addressing plan for 1 million users. And you've got routers with 10, 15,000 routes in the routing table, and you've got 14 internet connections, and you've got 2 petabytes of data, and you need somebody to design your AI, and somebody doing some data science stuff, and somebody designing your IAM, and somebody designing your security. I hope you see why architecture is a team sport. Part of high availability is good security. So that means using the principle of least privilege with regards to your IAM. It means locking down your servers and getting rid of unnecessary services. It means patch your servers with updates after you've tested them. Don't just patch them. It means limit the blast radius of problems by using AWS organizations and separating various parts of the enterprise, or creation of multiple VPCs and route between them. Use next generation firewalls and IDS IPS systems to have really robust security. Keep unwanted traffic out of subnets with a good access control list. Use good security groups. Use good endpoint protection on your devices. Provide good physical security so you can have done everything I talked about, and leave a network port over, and all I need to do is plug my PC into the port and I get on. So maybe some form of a MAC address authentication. So if I plug into the network and I don't have the right MAC address, the port gets shut down. Making sure you've got physical security, making sure that people can't access the room where the routers are. Lock that stuff up. Use good passwords and template good configurations with some form of infrastructure as code like CloudFormation or Terraform. Back up the systems. Consistent backup strategies will prevent data loss. Data loss protection strategies will also prevent against data loss from a security perspective. Create images of your production servers. Add auto scaling into your system. So we're getting hit with a DDoS attack, and you have auto scaling, and it increases the capacity of what you have. If we decouple various components in our architecture, like the database and a queue, we can store messages in that queue to help our systems be up and running. We can cache information. If my photo of Cindy is on the cache in Athens, Greece, or Istanbul, Turkey, for example, and my web server goes down, but a user in Istanbul can go click and still get my Cindy the cat photo because it's cached there, I increase my availability. Use a strong DNS system. So have multiple places that are endpoints that DNS can bind to. So if one goes down, you got another. Use load balancers because they enable you to share the load amongst multiple devices, removing single points of failure. Use good, strong logging and auditing functions so you can see what's going on. Did how the hacker make a change, and how do you revert it back? Constantly take your logs and aggregate your logs. and look for system alerts, maybe a SIEM system in here. Constantly monitor for security breaches, because if the systems are hacked, they could be down. Monitor usage, manage performance. Change management. If you allow Billy Bob to make changes at 9:30 in the morning in a financial firm when the market opens and it's going to have the most traffic, that's going to cause big problems for the bank. But if Billy Bob just said, I'd like to make this change, and then that change was sent to all the key stakeholders, the people that lead the application team, the people that lead the traders, the people that lead to this business, the people that lead to this business, the people that lead this business, all those stakeholders can evaluate the change and say, well, this will help, will not hurt our system, so it's okay, but it's okay to happen at this time. 2:00 in the morning on one day of the month when it's a leap year, when the bank can actually afford the downtime, but that's necessary. So all stakeholders have to approve a change. The change is made, and all stakeholders have to make sure the change is tested and everything's working. So this is kind of what you need to talk about. So I'll briefly talk about passing the exam, and I'll take questions. There's nothing, this is not a complicated exam, but it's going to be challenging anyway. And here's the reason why. Questions are going to be asked in a way that can pretty much pull anything from this curriculum. I mean, any kind of minutia detail point they can find is typically something they tend to look for. So if it's not that complex, but you want to make it challenging, they're going to do that. So it's somewhat challenging. But it's not the content that's challenging. It's the way the questions are asked. So because I said it's the way the questions are asked, get used to answering the questions, i.e. get a practice test. The way AWS writes the questions, they're very wordy. There may not be a clearly great answer, but you'll choose the best answer. Now, I want you to think about this. If you've been in tech for a long time, this is going to be a very hard exam. If you're brand new to tech, it's going to be very easy, and here's the reason why. Associate exams are intro-level exams. So when they give you this exam, it's going to be from the perspective of an intro-level person, which is what you just learned in a certification course. It's not going to necessarily be what people do in the real world. So there's this guy, Mark, on this, Mark Trimble on this session. Mark's got 45 years experience working with this technology. He knows this technology in, he knows this technology out. You get a guy like him taking this test, and he's going to say, what did I know when I just started out in technology? Because that's the real answer. So if you've got a lot of experience, pretend you don't, and think what an intro-level person would do. If you're brand new and you don't know, it's going to be very similar. So those are recommendations I have for you. Here's what I recommend. We went way above what's covered in the certification. We also have a completely free book on passing the certification, which you can also download. I recommend you read it. Certification exams, part of the reasons is to give you technician level knowledge, but also to get you excited about the vendor's technology. They want to get you to love this stuff, because you love it, you're more likely to recommend it. So where do they get these recommendations that are coming from? Well, the white papers. White papers are what company writes, and architects write them all the time to try and influence an agency to buy your stuff. So if you're dealing with the test that's designed to make you like a certain vendor's technology, and all vendors do this, read their white papers, because you're going to see a lot of the exam questions on there. So go do this course, go read our free ebook, take this course a second time, get a practice test, maybe do some of those hands-on labs, even though this is more of a brain thinking exam than an actual doing exam. There might be a couple of questions you could get better by practicing it. And then the day before the exam, take it easy. This is not the time when you spend all night studying. Why? Because the questions are written in a very weird manner. So you're going to need every little bit of noodle work you have to be able to understand those questions. So that means the night before, get a good night's sleep. If you like scotch, don't drink it the night before. Get a good night's sleep. Instead of eating that steak, that filet Oscar, and some kind of a beautiful potato with all kinds of butter on it, and drinking, 2 glasses of wine and having some scotch with your friend, eat some chicken and broccoli or whatever you're capable of eating that's healthy for you. Eat something that you're going to feel good with and go to bed early and get sleep. Arrive early for the exam. Seriously. I will tell you that more stuff is going to go wrong. If you do it from your house, your computer will crash or their computers will crash. So think about that. You don't want to be in that position. Give yourself the time. And, check. I like to frisk myself before I leave the house. Do I have a wallet on? Or a watch on? Do I have a wallet on me? Do I have any necessary tools that I may need to for my daily living? To make sure I have it. So check yourself. Make sure you've got your ID. Make sure you've got everything you need. And if you're going to take this test in a big city, allow time to park. And don't forget your photo ID because you won't be able to take the exam in most cases. So that kind of concludes the AWS Solution Architect training we did here. I can take some questions for a few minutes. Keeping the cloud costs in view for organizations to have high availability systems on cloud or have their own remote. So I'm not sure I completely understand the question. If you're saying from a cloud cost perspective, should you have your high availability systems on the cloud or redundant data centers? It really doesn't matter. All a cloud is somebody else's data center. Now, you have more control in your data center than the cloud. Here's an example. I advised a bank many years ago that they should run something called quality of service on their network. They were dealing with unified communications, IP phones, and we said, you need to run quality of service. You need to prioritize your voice first, then your mission critical traffic, and then everything else. The bank kind of laughed at us and said, we have gigabit Ethernet to the desktop. We don't need that kind of benefit. And I said, from a security perspective, you will need it. Well, here's what happened. 3 months later, they didn't put the quality of service on the network. A worm hit their network, and the worm generated full gigabit Ethernet traffic on every single network port. And basically, that worm traffic took the entire network down and all the voice systems down. So not only could the traders not make a trade, but they couldn't even call anybody unless they used their mobile phone. Now, had they had quality of service, their voice traffic would have gone through at all costs. Their next traffic, which was their mission critical traffic, wouldn't have got through. And the worm traffic would be regulated at the whatever's left over. So that wouldn't have affected them. Now, when we go to the cloud, they can't do QoS on our traffic because they don't know what our traffic is actually going to be. So we lose a lot of these things. We are also at the mercy of other people doing what they're supposed to be. Do we think CrowdStrike did what they were supposed to? No. Poor QA practices. There were a lot of failures that occurred there. CrowdStrike is still a great company. The point is no matter what, no matter how good you are, things are going to happen. So you should design around it. So you could build 2 data centers separated over a distance and really lock them down and have the right policies and procedures and make them both 4 nines data centers. You could do it. Or you could have your data center and you could also be 50% in the cloud. In your data center and the cloud and 2 availability zones, you still have high availability. Or you could have 2 availability zones on AWS and 2 availability zones on Azure. With the high availability DNS situation, maybe you go to F5 and buy your own DNS servers and you put them in all clouds. That works too. So the real question is, what is the actual needs? But I would tell you, I probably wouldn't use a single cloud for many systems. And to be fair, 98% of organizations don't. So hope that helps. But you could do it either way. And I don't think there's one that's better. In terms of cloud costs, it's probably going to be more expensive in the cloud in most cases. But that's going to depend on the utilization. David Lithicum numbers are really good since he saw so many of these. And he said the cloud is typically 250% more expensive than the data center. That's in line with what I've seen, but I've done less statistical analysis on it. But you've got sporadic traffic loads, that cloud's a lot cheaper. And even to be fair, which is better, saving a little money or having agility? If you've got a small and nimble business, oh, wow, there's this new AI tool and they can implement it in 3 months versus, manually making it themselves in 18 months. Maybe that 3 months versus the 18 months gives them 15 months of speed over their competition. Maybe that means a big return for the client. And maybe cost becomes irrelevant at that fact. Maybe it's worth paying more for speed. That's why people used to pay, $5,000-$10,000 to take the Concorde from New York to London, as opposed to a standard flight, because 2 hours is a lot better for 5. And if you're dealing with the CEO whose average time is worth $15,000 an hour, it might have been worth to take a plane like that. Because if they could save 3 hours of flight time, they could generate $45,000 of return on their time, as opposed to, thinking that they spent $3,000 or $4,000 more for the flight. I hope that makes sense. Good question, though, BJ. How do you do an interconnection in a multi-cloud architecture? So, unfortunately, I can't really teach network architecture here like I can in my 800-hour cloud architect program, but I'll give you some options. Option 1 is you'd use a VPN, and you'd put a VPN concentrator on both clouds and you connect your systems. Option 2 is you use a SASE type WAN solution or a software-defined WAN solution. A common SASE solution to do multi-cloud could be something like an Aviatrix solution. There are other SASE solutions as well that could work, but that's one that's pretty well known for the cloud. You could use Cisco or type of a software-defined WAN environment too, but Cisco's not the only people that make it. So the real key when you're doing these things is making sure that you understand your CIDR ranges for each one, creating the tunnels that you necessarily need, and setting up BGP in a manner that the routes and network layer reachability information that you need on one cloud is reachable on the other cloud and vice versa, as well as also making sure that if you're in AWS and Azure and you connect these two via a connection, your VPCs or VNets or what have you, same thing, and AWS gets hacked, Azure will be hacked through that connection if you don't do that connection right. And if Azure gets hacked, the hack can go into AWS. So how do you firewall off AWS and Azure? How do you architect that? That's, again, a network and a security question. So you can definitely do it. And it's not that complicated, but it's something that takes, learning networking and learning security. And it's a great question, Phil. Maybe we'll do some networking things, me and Mark. I love talking about networking. Okay, so we finished today. Join us tomorrow. We got a lot of career-based things. And that morning from 11 to 1 Eastern time, we will discuss getting your first cloud architect job, your first solutions architect job. I'll talk about it, how I started my tech career and what I did wrong and the lessons I learned. We'll talk about what we actually do in the role. We'll talk about the skills that you need. We'll talk about why you need to skip HR or auto so you don't get auto rejected, and we'll tell you what to do instead, and it's going to be free. And again, in the afternoon, around the same time we were going to do this at 2 p.m., we will come out there and we will answer other questions. Maybe you are interested in enterprise architect careers, AI architect careers, cloud engineering careers, network engineering, offensive security engineering, defensive security engineering, security architecture, and we'll give you any guidance we can to help you get to your goals. I hope you had fun. I hope you guys learned a lot. We have some other related content that's coming out for free. We will email you as soon as we are able to do that, but that's also coming up as well related to this content. And I may have some other free stuff for you too. So please subscribe and hit the bell to be notified of new things to help you in your career. If you've had a good time, please give it a like. Renato, I am always so appreciative for your kind words. I know you're over there in Canada via the Philippines, and I'm seeing how much you're learning all the time, and it is such a pleasure to see something like that, and thank you so much. Take care, everyone.